Your boss comes to you on Friday afternoon, as they do, looks you in the eyes and says, "I need you to organize all this data, have it ready and presentable by Monday." You think, "Aha, I know how to solve this crisis and save my weekend. I'll use the world's most widely used programming language, which is Excel." Whoa, whoa, whoa. That's right. We're talking about Microsoft Excel. You're probably thinking, wait, isn't Excel only for boomers? Well, if you think that way, it means you're missing out on one of the most powerful and popular pieces of software ever built, with a massive and widely underappreciated feature set. In fact, Excel definitely has the horsepower and flexibility to play a crucial role in the toolbox of every developer, data scientist, and business analyst. Welcome to our Excel Bootcamp, where you will learn all the skills needed to manipulate data, bending it to your will with nothing but your mind and hands, like a wizard summoning the elements with his wand. But instead of fire, wind, earth, and water, you'll be summoning Excel formulas and functions, charts, pivot tables, VBA macros, and so much more. This course promises to help you launch a career in data analysis and solutions, wow your boss, and be more efficient in both your work and personal life. When it comes to importing, processing, analyzing, and presenting data, in quantities large or small, Excel is often the go-to tool of experts, especially if you're pressed for time to deliver a solution now, as we so often are in the real world. You may not even know that Excel is continually growing as a programming language, with new features being added at a breathtaking rate. Or you can simply use Excel to improve and organize your own life. We're going to have some fun with Excel in this course, including building a personal budgeting spreadsheet to track and control your spending so that you can excel in both your business and personal life. My name is Travis Cusick, and I've spent well over a decade architecting and coding data solutions as a data solutions engineer based in the United States and training others to do the same for some of the biggest companies in the Fortune 500. In that time, I've mastered programming languages such as SQL, VBA, Python, JavaScript, and yes, also Microsoft Excel. But it wasn't always easy. I understand how hard it can be to learn new subjects on your own, and I'm passionate about making this process as efficient, intuitive, and fun, yes fun, for you as possible. So I'm going to teach you Microsoft Excel wizardry step by step, including the exact skills and tools that I use in my role, so that you can apply them yourself and go from zero to mastery in Microsoft Excel. Welcome, and I'll see you inside. Hello, my name's Travis, and I am thrilled to welcome you to the Microsoft Excel Bootcamp. I have over 12 years of experience using Microsoft Excel to crunch numbers for Fortune 500 companies, and training others to do the same, and I want to help you become an Excel power user too. So what is Microsoft Excel, and why should you learn it? Well, the easier question might be, at least when it comes to dealing with data, which since you're here I'll assume that you do, what isn't Microsoft Excel? Data-driven applications can tend to be quite specialized. You might use one application to store data, another to analyze and perform calculations on that data, and still another to present your analysis in a visually appealing way. But Excel, on the other hand, is a true one-stop shop, the data world's ultimate generalist. With Excel, you can store data, analyze it, and then craft visualizations to present it, all in the same file. And it's not just that Excel can do these things. In fact, it does them all extremely well. No wonder Excel is considered by many to be one of the most powerful applications ever built. Excel can clearly do a lot. So what are we going to cover in this course? Not everything. Excel isn't just a big application. It's absolutely massive. If I tried to explain every single Excel feature in this course, we'd both be here a lot longer than we want to. That's why I made this course about zooming in on the 5% of Excel features you'll end up using 95% or more of the time. And don't worry, that's still a lot of material. But I'm laser focused on the things that will make anyone working in a modern business environment, whether as an analyst or otherwise, more efficient and effective at working with data. The course begins with the basics. Excel 101, if you will. If you already have some familiarity with Excel, you can safely skip ahead to the later sections. We'll then dive straight into Excel's massive toolbox for manipulating data. We'll start by learning how to filter and sort data sets, and quickly move on to an area where Excel really shines: formulas and functions. Excel gives programmers and non-programmers alike the ability to apply powerful data transformation and analysis techniques with these functions. We'll cover the most useful ones for calculations and summary statistics, working with date and time data, manipulating text data like people's names, for example, and other essentials for anyone who works with data, like the if function and the legendary VLOOKUP. Next, you'll learn how to build useful models in Excel, which let you rapidly cycle through various inputs to a calculation to see how the output varies. For our example, we'll walk through building a mortgage payment calculator. Accurate data and calculations aren't always enough. Often, we need to present that data in a summarized and visually appealing way that non-technical people can grasp quickly. Fortunately, data visualization is yet another thing that Excel excels at. With the ability to apply nifty visualizations directly to our data values with conditional formatting, as well as a powerful charting engine which lets us paint pictures from our data with a few mouse clicks. This course will teach you everything you need to turn that boring black and white table of numbers into a visual narrative that can be used to actually make decisions. Now, sometimes we need to work with large amounts of data, thousands or maybe hundreds of thousands of rows of it, often extracted from a database. But you guessed it, Excel also has tools for managing this kind of data, but more importantly, summarizing and analyzing it quickly. We'll learn to do this with what is perhaps Excel's single most powerful feature: pivot tables. If you've never used them before, I think you'll be amazed at how quickly they can help you gain insights into your data. You have to see it to believe it. Finally, you'll learn how to automate all the other stuff we've learned with Excel already with macros. If you've ever found yourself repeating the same series of redundant steps in an Excel file every day, macros are your ticket out of the data doldrums. And we'll even take a little peek at VBA, Excel's built-in programming language, to gain more fine-tuned control over our macros. The bottom line is, whether you're a data analyst or data scientist who works with data for a living, or a business person who just needs to get a couple precious hours of your day back by reducing the time you spend on redundant data processes, this course will get you to your goal efficiently and effectively. I'll see you in the course. Hey, welcome back. Let's get our hands dirty and dive into opening the Excel application and creating a new Excel workbook. Let's take a moment to save ourselves a lot of time in the future by pinning the Excel application to our taskbar. That is to say, the list of icons at the bottom of your screen. Since we're going to be opening Excel hundreds of times throughout this course, it makes sense to shave as much time off this process as we possibly can. So to do this, right-click the Excel icon and then choose Pin to Taskbar. Great! Now we can just left-click the Excel icon that now appears in our taskbar to launch Microsoft Excel. Alright, now that we have Excel open, we are presented with a screen that gives us a few options for creating a new Excel workbook, which is where we can actually start doing useful work in Excel. The first option, which is the one we will be using, is to simply create a brand new blank workbook. This will be a completely empty slate for us to work with. The other options are various kinds of templates that Microsoft provides to assist with some of the more common uses of Excel. For example, there is a nutrition tracker spreadsheet template that you could use as a starting point if you wanted to count calories. Instead of needing to create your own nutrition tracker spreadsheet from scratch, you could start with the template and modify it with your own information as needed to save time. But we're here to learn how to build our own spreadsheets, so let's go ahead and click the Blank Spreadsheet option. Alright, now that we have Excel open, you can see that it is fundamentally a giant grid, organized by rows and columns. The rows are ordered numerically, starting with the number 1, while the columns are ordered alphabetically, starting with the letter A. At the intersection of each row and column is what's called a cell. Cells are the fundamental building blocks of Excel. They are where we enter and manipulate the data and calculations that make up the heart of most spreadsheets. Right now, by default, the cell at the intersection of the first row and the first column is selected. This is called cell A1 because it is in column A and row 1. And if we look at this little box above and to the left of the grid, we can actually see the address, as it is called, of the cell that is currently selected. And if we select a different cell, let's say at the intersection of column H and row 7, we'll see that the cell address changes to, you guessed it, H7. So at this point, you might be wondering, just how big is this grid? Right now, we can only see around 20 rows and 20 columns. Well, the answer, it turns out, is pretty daggone big. A single grid can have over 1 million rows and over 16,000 columns. Multiply those two numbers together, and you have an idea of how many cells are contained in this single grid. Don't believe me? Let's scroll around a little bit to get a better idea of the terrain we're trying to explore. So there are a number of ways to navigate the grid. If you just want to scroll up and down, which is probably the most common form of navigation, you can just use the little wheel in between the buttons on your mouse. Rolling that wheel forwards and backwards will scroll you up and down through the spreadsheet. You can also use the scroll bar on the right side of the Excel window to scroll up and down, and the scroll bar at the bottom right to scroll from side to side. To do this, just click the bar, hold down your mouse button, and drag to go back and forth. Now you might be noticing that we're not able to scroll much beyond the portion of the grid that is currently visible to us. This is because we haven't entered any actual data in the spreadsheet that Excel thinks is worth scrolling to. However, by clicking and holding the arrows at either end of the scroll bars, you can scroll back and forth across the grid as far as you'd like, regardless of whether we have any data in it or not. So let's try using this technique to scroll right and see more columns in our grid. So I'll just click and hold this arrow on the right side of the scroll bar at the bottom right, and you can see that we pretty rapidly scrolled quite a few columns to the right. Alternatively, if you don't want to scroll quite so fast, you can actually just single click these arrows, and you can move back and forth in that manner incrementally, a little bit fewer columns or rows at a time. Now you might have been wondering, considering our grid has over 16,000 columns, how this alphabetical sequencing might work once we run out of letters. Well, now that we've scrolled past column Z, you'll see that the sequencing starts over again with column AA and AB and so forth. And this goes all the way to AZ, at which point the pattern starts again with column BA. Okay, now we have a basic understanding of how the Excel grid is structured and how we can navigate it. But what about this big, crazy-looking menu directly above the grid? Well, it's actually not just one big, crazy-looking menu, it's several. If you look at the word Home on the menu, you'll see that it is underlined. This indicates that it is the active section of the menu. So what happens if we click on the neighboring tab, Insert, on the menu? Well, now we get a whole new set of options and commands on our menu. And as you might have guessed, each of the other tabs we see here reveal a whole new category of options to us. Now this may seem a little overwhelming, but it's important to keep a couple of things in mind. First is that Excel is a truly massive application. It is considered by some to be the single largest piece of software ever written. That means it has a ton of functionality, and all of that functionality needs to be organized in a way that won't drive users absolutely crazy. The layout we see here, which is called the ribbon, was Microsoft's best effort to do that. The second thing to keep in mind is that the vast majority of users will only use a tiny fraction of all that functionality. There are buttons and widgets and submenus under some of these categories that are essential to a small percentage of specialized users, say, for example, scientists and engineers, but would have little to no value for a typical user. In this course, we're going to focus on, roughly speaking, the 5% of Excel's functionality that you'll use 95% of the time. 100% of the functionality would probably take the rest of my lifetime to explain and the rest of yours to listen to me explaining, and that doesn't sound like much fun for either of us. So the bottom line is, don't worry about memorizing where to find what command in the Excel ribbon. Instead, think of each tab as a category of commands, and then think about which of these categories the thing you're looking for or trying to do fits best under. Then just look under that tab first. Then once you're on the tab, look at the various subcategories that the commands on that tab are broken up into, which you will see at the very bottom of the menu. For example, on our Home tab, we have subcategories like Clipboard, Font, Alignment, and so on. Now, say I needed some help with a financial calculation in Excel. I might start by clicking the Formulas tab, and then poking around until I saw a subsection that appears to be aligned with my goal. So in this case, there is a Function Library subsection, and then a drop-down menu within that has more information on financial formulas. That's probably a good place to start. Now, navigating the ribbon is an inexact science, and even as an experienced Excel user, I often don't go right to a command without some clicking around. But once you get the general idea of how the ribbon is organized, it normally won't take you too long to find what you're looking for. Okay, so at this point, my goal for you is to have a general understanding of how the Excel interface is structured and how to navigate it. I highly encourage you to click and scroll around and just generally explore, which is a great way to get a better feel for the environment we'll be working in. Up next, we're going to go from exploring the Excel interface to actually entering our own data into a spreadsheet. We'll also look at various options for saving workbooks so we don't lose the data and calculations we have stored in them. I'll see you then. Welcome back. In this one, we're going to pick up right where we left off. So if you don't already have a blank Excel workbook open, go ahead and open one now. So we now have the lay of the land, so to speak, of Excel and its user interface. That means it's time to actually start entering data into an Excel workbook, and then learn how to save workbooks so we can access them in the future. Let's start, in the storied tradition of so many programming tutorials, with the classic Hello World example. So making sure that cell A1 is selected, go ahead and type Hello World and then hit Enter to commit your changes to that cell. So we'll just go ahead and type Hello World and then hit Enter. And our giant blank grid is blank no longer. We have now made our mark on Excel. So let's suspend disbelief for a moment and pretend that we just entered something really cool or important in the spreadsheet. In that case, we probably wouldn't want to risk losing the data we had entered when we close out of Excel. So how do we save this workbook so we can access it later, long after we have closed Excel or even shut down our computer? Well, saving workbooks is such an important task that there are actually many ways to do it in Excel. This is a theme we will encounter often with Excel, that there are often, if not always, multiple ways to accomplish a given task. I'll normally stick to recommending the method I feel is the most straightforward or easiest to remember, but in this case we'll walk through a couple of approaches just to give us an opportunity to further explore the user interface. So if you turn your attention to the little menu at the top left corner of our Excel window, you'll see a funny little icon that is recognizable if you're a person of a certain age, like yours truly, and which will seem kind of bizarre to anyone else. This little square is meant to represent a floppy disk, which for those of you not of a certain age, was a computer storage mechanism popular roughly in the time of the dinosaurs. This icon is part of another menu, distinct from the ribbon we already took a brief tour of, called the Quick Access Toolbar. This menu is meant to contain shortcuts or commands that are used very, very frequently by most users. Saving a file is, naturally, one of those types of commands. And as you might have guessed at this point, clicking this floppy disk icon will tell Excel that we want to save the current workbook. So let's click it and see what happens. As you can see, we are now presented with a dialog box prompting us to enter a name for the file and a location where we want to save it. Pretty self-explanatory. So let's enter a name. I'll go with Hello World, and then I'll browse to a folder on my computer where I can save it. So I'll just type Hello World, and then if I click this Choose a Location dialog box, my machine lists some folders I have recently interacted with. Now let's say I don't want to save the file in any of these folders. In that case, I'll simply scroll down to the bottom of the list and click More Locations. This takes me to the Save As screen, where we again have a number of options to choose from. Let's ignore the menu on the left side of the screen for now, and focus on the middle of the screen, which gives us all the commands relevant to saving a new file with a specified name and location. We ended up here because we didn't want to accept one of the suggested locations for our Hello World file, so the natural option is to click Browse. This brings up a dialog box that will allow us to browse our file system to find whatever folder we would like to save this file to. I've gone ahead and browsed to my Hello Excel Part 2 folder, which I had already created. Now before clicking the Save button, as tempting as that might be, I do want to point out the Save As Type drop-down list right below our file name. This Save As Type drop-down allows us to save an Excel file in a wide variety of formats, as you can see here. The bad news is that there are a ton of these formats, but the good news is we are going to be using the default format, Excel Workbook, 99.9% of the time. So for now, don't worry about all these other formats. We'll cover a few others as needed in future lessons. But enough on that for now. Let's go ahead and click Save to save our file. And if we wait just a moment for Excel to finish, we can now see that the name of the spreadsheet reflected at the very top of our Excel window is Hello World, which means our file has been successfully saved. Now that we have our file saved, let's put our work to the test by closing out of Excel and then seeing if we can reopen our file. As with almost everything in Excel, there are actually a few ways to close the application, but the easiest one, and the most intuitive, is to simply click the big X at the top right corner of the screen. And if we do that, the Excel window should disappear. And now we can reopen Excel using our icon that we added to our taskbar. And we are again presented with the Excel startup screen that we first saw when we launched the Excel application in the last video. This time, we're going to click the Open option on the menu on the left side of this screen, which takes us to another screen that will allow us to open an existing Excel file. Now, if you have sharp eyes, you might have noticed that there is a Browse option here, similar to the one that we saw when we were choosing a location to save our Excel file. And much like when we saved that file, we can use this Browse option to navigate to a location where the file we want to open is saved. Now you might also notice that there is a list of recently accessed files on the right side of our screen here, which includes the file that we just saved. And while that would actually be the easiest way to access the file in this case, I do want to show you how to browse to a file that we didn't just access to open it. So let's click Browse once more. And again, I've navigated to my Hello Excel Part 2 folder where we find the file that we just saved. So now that we've found the file, all we have to do is click it to select it, and then hit the Open button on the dialog box. Awesome. Now we're right back where we started with our Hello World file open. Now let's say we want to modify the contents of our spreadsheet in some way. Maybe we want to express our enthusiasm for Excel and add an exclamation mark to our Hello World message in cell A1. Now we'll cover more techniques for editing data in cells later, but for now, let's just make sure cell A1 is selected and then type Hello World exclamation mark and finally hit Enter to commit the change. So I'll go ahead and do that. So if we want to save this amazing change we just made, do we need to go through that whole process of choosing a file name, then a location, all over again? Absolutely not. Instead, we can simply save the file in place with a single command. In fact, simply clicking the little floppy disk button in our Quick Access toolbar would do the trick. But if we hover over that button, we'll see something interesting. Excel doesn't just tell us what the command does, it also suggests, in parentheses, a keyboard shortcut we can use to execute the command more quickly. Now, if you're not familiar with keyboard shortcuts, they are simply combinations of keystrokes that you can type on your keyboard to perform certain common commands quickly. And while you can definitely go overboard by trying to memorize every keyboard shortcut Excel gives you, and there are a ton, remembering a few of the most useful ones is an absolutely invaluable time saver. So let's take Excel's suggestion in this case and hold down the Control key and the S key at the same time. Just as an aside, most of these keyboard shortcuts in Excel involve holding down two or more keys at the same time. So if I reference a keyboard shortcut as, say, Control A, that doesn't mean press Control and then press A. It means hold down both of those keys at the same time. So let's hold down Control and S at the same time. And now if you look at our file name at the very top of the Excel window, you'll see the word saved after the name. So now you know that our most recent changes to the file have in fact been saved. And going forward, saving changes to our file will be just that simple. You only have to select a name and a location the very first time you're saving a file. After that, you can save each additional set of changes as often as you want by hitting Control S. Now speaking of that, I highly recommend hitting Control S early and often as you are working with Excel. Excel is an application that runs on your local machine, which means it is just as prone to crashing as your machine is. If your machine's memory is bogged down, either with another application or maybe something you're doing with Excel, it's quite possible that the Excel application could crash. In that case, Excel will only keep the changes you have made to your file up to the last time you clicked Save. So let's say you've been working in your file for an hour and you never clicked Save. Well then, when your machine crashes, all of your work will be lost. I would call that a bad day. Excel pros know, save early and save often. Now with that said, sometimes we don't want to keep the changes we've made. For example, let's select cell A1 again, and then hit the Delete key on your keyboard to delete our little Hello World message. Now click the red X at the top right corner of the Excel window to close out of Excel. And my apologies for referring to it as a red X when it's really only a red X when you hover over it. Let's just call it the X at the top right corner that turns red when you hover your cursor over it. So if I click this green/red X, Excel asks us if we want to save our changes to our file. This is because we have made a change to the file since the last time we hit save. Now we don't want to undo all of our hard work in typing Hello World, so let's click Don't Save. That will keep our file in the exact state it was as of the last time we hit save, so our friendly Hello World message will be preserved. So at this point, we know a little bit about how to save our work so we can re-access it in the future. But with apologies to our hello world message, we haven't really learned how to do any work worth saving. That's what we'll begin to explore in the next video, where we will dive into a variety of data entry techniques that let us enter data into the Excel grid efficiently and effectively. I'll see you then. Welcome back. Now that we have our arms around the Excel user interface, let's learn how to put Excel to work by actually entering data into the grid. So if you don't already have Excel open, go ahead and open a blank workbook. Now for our example, let's say you own a food truck, specifically a Hawaiian shave ice truck, and you want to track how different flavors sell relative to each other. Excel, with its nifty grid layout, is perfectly designed for this type of tracking and data entry. So let's say our first customer ordered 1 grape shave ice and 2 cherry shave ices. Well, if you think about it, we really have 2 different data points we're trying to track here: the flavors that were sold and the quantity of these flavors that were sold. In this case, we have 1 grape and 2 cherries. So what we'll do is type our flavors out in column A and the associated quantities in column B. First, let's select cell A1 and type cherry. Now up to this point, we've always hit the Enter key after entering data into a cell to commit the change to that cell. But hitting Enter selects the next cell down. That is to say, the cell in the same column, which would be column A in our case, but the next row. But we want to enter quantities in column B, so we actually want Excel's focus to move from cell A1 to B1 when we commit the change that we're making to cell A1 here by typing in the word cherry. So how do we commit the change in cell A1 while moving to the right to cell B1? The answer is to hit the Tab key instead of the Enter key. This has the same effect as hitting Enter, except that the cell to the right of the current cell will be selected. So if we hit Tab, you'll see the focus moves to cell B1. Now we can enter our quantity for cherry, which is 2, and hit Enter. And look at that. Excel was actually smart enough to recognize that we are entering data into 2 columns, and it automatically selected the next row in the first column instead of the second column, anticipating that we would want to continue this pattern of entering data left to right. Pretty cool. That said, if for whatever reason you wanted to sidestep this default behavior and choose which cell to navigate to yourself, you can always use the arrow keys on your keyboard to do this. You can navigate one cell left, right, up, or down by just hitting the corresponding arrow key. But in this case, Excel was smart enough to put us right where we want to be. So let's get right back to entering data. So for our entry for the grape shave ice order, let's try a slightly different but equivalent method of entering data into the cell. Instead of simply typing with the cell selected, click in the formula bar, which is directly above the grid and reflects whatever value is in the currently selected cell. Then we can type our entry there. So I'll just type grape in the formula bar. And now we can hit Tab, which will navigate us over to column B. And finally, we can enter the quantity of 1 for grape and hit Enter. And that's pretty much it for the very basics of entering data into the grid, and as you can see, at least for simple scenarios like this, it's pretty straightforward. But what if we made a mistake when we entered that data and want to overwrite or change the information we entered into the spreadsheet? In this case, it's not enough to simply enter data. We need to be able to delete the existing data and replace it, or alternatively, edit the data. We'll tackle deleting first since it's a bit more straightforward. Let's say that instead of grape, the second order was actually passion fruit. Well, what we need to do is replace the word grape with the word passion fruit in cell A2. To do that, we can simply select cell A2 and then hit the Delete key on the keyboard. This wipes out all the text we entered in that cell. Now we can simply type in the correct value, passion fruit, and hit Enter to commit the change to the cell. Pretty straightforward. But it's often the case that the mistake we made entering data was only a small one, and merely requires us to slightly modify the value we entered into a cell. In that case, we may not want to redo the work of typing everything we entered into the cell. Instead, we might want to just edit the value slightly and then commit that change. For example, what if our first flavor wasn't cherry, but wild cherry, which is actually one of my personal favorite shave ice flavors? If we want to avoid retyping the word cherry, then we shouldn't delete what we've already typed. It would be better to simply add some text to what's already in the cell. But how do we do that? There are two main ways to accomplish this. You can either select the cell and then click in the text in the formula bar at whatever position you want to begin editing. In our case, we want to begin editing before the first letter because we're going to append the word wild at the beginning of the word cherry, so we would just click right before the C. But for example, if we wanted to add a word to the end, you could again click in the formula bar, but at the end of the word. Now, alternatively, you can actually just double-click in the cell itself, which will place the cursor inside of that cell so you can edit the value in it. Now, I personally prefer editing in the formula bar since I find it a little easier to click directly to the position in the text where I want to begin my edit. So that's what we'll do here. Now, we actually want to begin our edit before the word cherry, as I mentioned. So with cell A1 selected, I'll click in the formula bar before the letter C, and then I'll type the word wild followed by a space. And then finally, I'll just hit Enter to commit the change. Now, you can also modify portions of the text in a cell, as opposed to simply tacking on new text. For example, let's say I wanted to replace my wild cherry entry with the synonymous Bing cherry. To start, I can select cell A1 and then click in the formula bar to start editing. Now, I could either click before the word wild and then hit the delete key 4 times to remove it, or I can click after the last letter of wild and hit the backspace key 4 times to remove it. Then, with that word removed, I can simply type the word Bing and hit Enter. So now we've learned how to enter, delete, and edit data in Excel. But before we go, I want to share a sentiment from one of my favorite old movies. And that is, you should always be able to get out of trouble faster than you got into it. Fortunately, Excel gives you a couple of easy ways to do this. The first method is to simply hit the Escape key to escape whatever mess you've made in a cell that you're trying to edit. So let's say I want to edit Bing cherry back to wild cherry. So I click in cell A1 and delete the word Bing. But then I change my mind and decide I want to leave the cell as is. Well, as long as I hit the Escape key before hitting Enter to commit the change to that cell, Excel will let me off the hook, so to speak, and ignore any edits I was making to that cell. So you can see how the cursor is flashing in the formula bar. That lets us know that Excel recognizes us as actively editing this cell. As long as it thinks we're actively editing this cell, if we hit the Escape key, it's just going to ignore any changes that we've made up to that point and revert the cell back to its previous state. So if I just hit Escape, it's like nothing ever happened. It's like we never even attempted that edit. But what if I've already hit Enter and committed the change to the cell? Well, that's where the undo command comes in handy. Undo will simply reverse the effects of the last change you made to the spreadsheet. So if your last change was entering data to a cell, undo will delete that data. On the other hand, if your last change was deleting data, Excel will reinsert that data. Now, given how error-prone manual data entry is, along with many of the other tasks you can perform in a spreadsheet, the undo command is absolutely essential. So how do we access it? Well, there are two main ways. First, there's this little curved arrow in the quick access toolbar that executes the undo command. And the fact that this command is in the quick access toolbar is indicative of just how useful and frequently used it is. But my rule of thumb for quick access toolbar commands is that anything that's used that often is probably worth memorizing a keyboard shortcut for, because it's just faster for most people to make a couple of quick keystrokes than it is to navigate to a button in the Excel interface. So the keyboard shortcut for undo in Excel is Control plus Z. Now this is definitely one that's worth committing to memory. So let's say we decide to stick with the wild cherry nomenclature over Bing cherry. This means we need to undo the last change we made to the spreadsheet, which was changing wild cherry to Bing cherry. Now you might be thinking that somehow that attempted edit we made just a moment ago that we escaped out of would count as something that would be undone, but it actually doesn't, because nothing was technically done as a result. We attempted a change, but we never committed the change. So because we never committed it, we never made it permanent in the cell, from Excel's perspective, there's really nothing to undo. So if we hit Control Z here, like magic, cell A1 reverts to its previous state. And if we wanted to continue hitting Control Z, we could keep undoing the various changes we've made all the way back to a blank spreadsheet. Now, there are a small handful of changes you can make in Excel that undo cannot reverse, but the vast majority can be reversed by undo. So this is a command to make friends with early because you will use it often. All right, up next, we're going to look at some ways to make our data entry less repetitive and more efficient. I'll see you then. Hey, welcome back. Now that we've learned the basics of entering data into Excel, let's take a look at some ways we can make this process less painful. But first, a quick confession. I hate typing, and I am absolutely terrible at it. I never took a formal typing class, to my eternal regret, which has been both a negative and a positive in my career as a developer. On one hand, my advanced hunt and peck technique is a little embarrassing, but this has also forced me to look for all sorts of efficient alternatives to typing. If there's a way to get around having to type out a word, I'm in. And it turns out that I must not be the only one, because Excel gives us lots of ways to avoid redundant typing when entering data into the grid. So here I have an expanded version of our little shave ice ledger that we worked on in the last video. Clearly, business has been good because we've made a few more sales since then. We're going to use this data as a jumping off point to explore some new methods of data entry in Excel. But before we start entering data, I want you to take note of the way this data is structured. Specifically, that we now have headings above each column of data. So our data is organized in columns, each of which has a heading that indicates what sort of data is in that column. Then, each row in our data pertains to a specific thing, or entity to use developer speak. In our case, the thing in question is a customer order, consisting of a shave ice flavor and a quantity. Then, each column contains some particular piece of information about that thing. So if, say, row 2 pertains to a particular customer order, column A tells us about the flavor the customer ordered, while column B tells us the quantity. And if we wanted to capture more different pieces of information about each customer order, those pieces of info would be stored in their own separate columns. We would simply keep adding new column headings that describe what information is being captured, and then fill that information in for each order. Data organized in this fashion is called tabular data, and it is much, much easier to work with than data organized in a less rigorous way. Time and again throughout this course, We will use features of Excel that are designed to work with tabular data that wouldn't work, or at least work as well, with data structured in a more haphazard way. I want to introduce you to this way of organizing data now because it will make your life much easier if you get in the habit of making your data tabular whenever possible. But back to our exploration of data entry. We've built up a ledger of 10 customer orders representing a variety of flavors. Now, because we sell a limited number of flavors, we see the same flavors being repeated over and over again. We have multiple entries for snow cream, we have multiple entries for blackberry, etc. So the next time somebody orders snow cream shave ice, wouldn't it be nice if I didn't have to type all that text again, but instead could somehow duplicate the text I already typed previously? Well, you actually can with the copy command. So let's say a customer orders 1 snow cream shave ice. Now, I could type that out in cell A12, but a better way is to click in another cell in which I've already entered the text snow cream, copy that value, and then paste it, which is the preferred terminology for depositing whatever data you've copied, into our destination cell, which is cell A12. But how do we copy in Excel? Now, as always, there are several different approaches. If you prefer the mouse, you can always right-click and then choose Copy from the menu that pops up. But because this is such a frequently used command, I again prefer a keyboard shortcut. The one to use in this case is Control-C. So let's select cell A9 and hit Control-C to copy. Then, to deposit that copied value into cell A12, which is where we want to record the sale, I'll select cell A12 and then hit Control-V to paste the value into that cell. Now, depending on how fast you type and how long the string you're typing is, this may or may not have saved you much time. But when dealing with longer text strings, it's definitely a time saver, and it also helps to improve the accuracy of the data being entered. Mistakes are easy to make when manually entering data, and you could certainly imagine several variations of snow cream being typed into our ledger over time. This would make doing calculations and reporting on our data more difficult down the road. So avoiding typing is not just about being lazy, it's also about being accurate. Now, one thing to note about the copy and paste operation we just executed. We could actually continue pasting this value that we just copied into other cells in the spreadsheet as long as we want. So if I wanted to just kind of start clicking around and hitting Control-V again and again and again, we can continue pasting that value as many times as we want. This is because that data we copied remains on what is known as the clipboard, which is where data that is copied is stored in memory. And as long as we see these so-called marching ants around the cell we copied, the data we copied from that cell is still on the clipboard. And that data will stay on the clipboard until we copy something else, which would replace what is currently in the clipboard, or if we hit the escape key. Hitting escape will clear the clipboard. So after hitting escape, our marching ants go away, and we are no longer able to paste anything from the clipboard. So being able to copy and paste data to effectively reuse work we've already done is really cool. But before we go, I want to show you another really efficient method of data entry, one that is made available to us when we organize our data in the tabular fashion we see here, obviously with the exception of the random snow creams I pasted all over the grid. So let's say we have another order come in. This one for 3 passion fruit shave ices. So I could absolutely just copy passion fruit from cell A11, but there's actually an even faster way to enter this data in the cell. Let's try just typing the letter P in cell A13, where our entry will go. And look at that. Excel actually correctly guesses that we are going to type passion fruit. Because of the way our data is organized, Excel is able to make intelligent guesses like this. Specifically, Excel looks at the values above the current cell in the same column and then attempts to guess what we are typing based on what's already been entered. So, of all the entries in column A above cell A13, if we only had one flavor that began with the letter P, Excel is able to correctly guess that we want to enter passion fruit when we type the letter P. So assuming this guess is correct and we're not trying to enter some other word, all we have to do to accept Excel's recommendation is just hit Enter or Tab if we want to go over to the column to the right. So I'll hit Tab, and just like that, we have effectively typed out passion fruit by typing a single letter. And then I'll go ahead and enter the quantity for passion fruit, and I'll clean up my entry for snow cream as well. Now on the other hand, if we type a B in cell A14, nothing happens. Now that's weird. Why is Excel not trying to read our minds this time? It turns out that's because we have two distinct prior entries in the column that began with the letter B. We have blackberry and also blueberry. So at this point, it's not obvious to Excel as to which one of these options we might be trying to type. And then even if we type BL, Excel still isn't able to guess because both blackberry and blueberry start with the letters B and L. But if we then add the letter U, suddenly Excel is able to guess blueberry. So even in a case where Excel wasn't able to correctly guess our intention from the first keystroke, it only took us typing BLU to enter the whole word blueberry. This feature, in which Excel guesses what you're going to type and auto-populates that, giving you the option to either accept or reject the recommendation, is called autocomplete, and it can be a huge time saver, especially if you do a lot of data entry. That's why tricks like these are worth mastering, and it's also why structuring your data in a way that helps Excel help us is a great habit to get into. All right, up next, we're going to take a look at another cool feature that can help us create series of data in Excel in a flash, with barely any of that annoying typing at all. It's one of the best magic tricks Excel has to offer, and I can't wait to walk you through it. I'll see you then. Hey, welcome back. This go-around, we're going to explore the autofill feature in Excel and how it can help us generate series of data in a flash. So what do I mean by series? Basically, it's any logical sequence of data points. A series of numbers like 1, 2, 3, 4, 5, maybe a list of all the dates in the current month, or the days of the week. If you need to enter sequences like these into a spreadsheet, before you're tempted to start typing, make sure that autofill can't do the work for you first. But before we dig into the mechanics of autofill, we first need to learn to think like Excel, specifically to understand how it interprets and handles different types of data. This is important because how a series of values is autofilled by Excel will be influenced by what type of data those values are. So broadly speaking, there are three major types of data that are interpreted and handled in distinct ways by Excel. The first is numbers. Obviously, this could mean dollar amounts, quantities of something, or even percentages. Now note that if I type a number, say 7, in cell B1 and hit Enter, Excel automatically aligns the value in the cell to the right. This is indicative that Excel understands that this value is a number. The second major data type is dates and/or times. Now in the end, dates and times are really one and the same in Excel, as we'll explore in much more depth later. So if I type 1/1/2021 in cell B2 and hit Enter, you'll see that Excel again aligns the value to the right side of the cell, as distinct from, for example, the headings that I've typed out in column A, all of which are aligned to the left. And if you turn your attention to the number section of our current tab on the ribbon, you'll see that Excel has correctly guessed that our value here was a date. Now lastly, text data is pretty much anything that is not a number or a date. For example, if I type the phrase some text, you can see that Excel recognizes that as text because now it's aligning it to the left. The text data type is kind of a catch-all. Any collection of characters like what I just typed, things like people's names, shave ice flavors, etc., could all be categorized as text. You get the idea. So now that we know about the different types of data that Excel recognizes, let's take advantage of that knowledge by creating some sequences of those data types, with some help from the autofill tool. As our first example, let's try to create a series of numbers from 1 to 10 in column D. First, type the number 1 in cell D1 and hit enter. Now is where the fun begins. Select cell D1, the cell we just typed the number 1 in, and then hover your cursor over the bottom right-hand corner of the cell until the thick white plus sign icon turns into this thinner black plus sign icon. Once this icon, which is commonly known as the fill handle, appears, click and hold down your mouse button, and then drag from cell D1 to D10. Okay, so this isn't exactly what we signed up for. I was promising you sequences of data, and all we appear to have done here is copied the number 1 10 times. And while that in and of itself could be a useful task, it's not what we're trying to accomplish here. However, if we click this little box that has appeared at the bottom right of the range of cells we just filled down, you'll see that Excel actually gives us multiple options for how we want the autofill mechanism to work. The copy option is selected by default, which is why the number 1 was simply copied in every cell we autofilled. However, if we select the fill series option, success! We have now generated a series of numbers from 1 to 10 with a couple of keystrokes and a couple of mouse clicks. And while this saved us just a little time on this small series of numbers, imagine if you needed to type out numbers 1 through 100 or 1 through 1,000. The longer the series, the more time autofill can save you. So Excel is smart enough to understand what a number is and how to logically build a sequence of numbers based on whatever value we chose to fill down. But it's also smart enough to recognize more complex types of series than the simple 1, 2, 3, etc. we just demonstrated. Let's say instead of generating a sequential series of numbers, we instead want to generate a series of odd numbers. Our little autofill menu here doesn't have an explicit option for this, but we can give Excel a hint about what we're trying to do that it's smart enough to pick up on. So let's say we type the number 1 in cell F1, and then the number 3 in cell F2. At this point, we have essentially created the beginning of a sequence of odd numbers. Then we can highlight both of these cells by clicking in one, holding down the mouse key, and then dragging to select the other. Similar to before, we'll hover our cursor until we see the fill handle. The only difference between this and what we did previously being is that instead of hovering our cursor over the bottom right-hand corner of a cell, we instead hover it over the bottom right-hand corner of the range of cells we've selected. So finally, with that fill handle activated, we can simply click and hold our mouse key and then drag down as many cells as we want. And as you can see, Excel was smart enough to recognize that we were trying to create a series of odd numbers and was happy to oblige us. Pretty cool, right? Now let's take a look at generating series of dates. I'll start by copying our date from cell B2 into cell H1 using the Control-C and Control-V keyboard shortcuts we learned in a previous video. Then, to create a series starting with this date, we can use the same technique that we used to generate a series of numbers a moment ago. If we just hover, click, and drag, Excel automatically generates a sequence of dates starting with January 1st, 2021. Unlike with the numbers, autofill's default behavior with dates is to generate a sequence as opposed to just copying the same date down. But again, we can override that default using the autofill menu if we just choose Copy Cells as opposed to the default of Fill Series. And Excel's autofill tricks actually extend beyond just numbers and dates. So if I just type Sunday in cell J1 and then hover, click, and drag, suddenly I have a list of all the days of the week. Similarly, if I type January in cell L1 and then again hover, click, and drag, sure enough, we get a list of all of the months of the year. So in these cases, Excel recognizes that the word Sunday or the word January has a special meaning, and it's able to leverage that knowledge to help us generate these series with ease. Now obviously this doesn't work with every type of data. If I just type my name in cell N1 and try to fill that down, nothing really interesting happens other than it gets copied a bunch of times. And if I click the autofill menu, we don't even see that fill series option available because there's no logical way for Excel to create a series starting with my name. Okay, so lastly, let's take a look at a practical example of using the autofill tool in which we can quickly populate a new column on our shave ice ledger from the last video. So if you want to follow along, open up the shave ice file, and then in cell C1 type order number. This is the header of a new column in our little ledger here, in which we'll assign a unique number or ID to each order. The first order should get a 1, the second order a 2, and so on. So we can just type a 1 in cell C2, hit enter, and then select C2 and hover until we see our little fill handle. Now at this point, we could just click and drag like we did previously, but if you're auto-filling data in a column that is adjacent to other data, as is the case here, where the next column over has our order quantities, Excel is again smart enough to guess what we're trying to do, so it actually gives us a shortcut to fill our number down to the end of our data set. So if we simply double-click our fill handle icon, the number 1 automatically populates down to the last row of the little table of data we've created. Now, of course, we can just click the autofill button and choose Fill Series to get our sequence of order numbers. This is just another example of how organizing our data in this tabular way helps Excel help us. Excel really likes structured data and rewards us for it with goodies like autofill. All right, now that we've got lots of tricks for creating lists of data up our sleeve, we can take a look at some ways to efficiently select and manipulate these ranges of values. We'll tackle that in the next video. I'll see you then. Welcome back. With all the tricks we've learned so far for efficient data entry, it hasn't taken much time at all to build up quite a sizable ledger of shave ice entries. And as you can see here, we're now up to 100 customer orders in our ledger. So now that there's more data in our ledger than we can view at a time on our screen, there are some additional considerations we need to keep in mind. Large data sets like this, and to be honest, this wouldn't really qualify as large in the real world, but it'll do for our purposes, can become quite cumbersome to navigate without some really clever techniques, unless you like scrolling and dragging over large portions of spreadsheet real estate. As an example, if you're maintaining a ledger or tracker like this one, it's very common to want to go to the bottom of the list quickly so you can make a new entry. Before that was easy, but now we have to scroll all the way down to the bottom of this list. And the problem is only going to get worse as we accumulate more and more data. But fortunately, there's a keyboard shortcut that will take us straight to the bottom of our data with just a couple of keystrokes. And that is Control plus down arrow. So as long as we've selected some cell anywhere in our data, if we just hold down Control down arrow, Excel will automatically select the cell in the same column, but in the last row of our data, as we see here, our 100th entry in our tracker. Likewise, we can use Control plus right arrow to navigate to the end of a particularly long row of data. So if I just wanted to go to the right of the current row we're in, row 101, I could just hit Control right arrow, and that moves me to the rightmost column of our data. But since datasets tend to be longer than they are wide, which is to say they tend to have more rows than columns, this shortcut is used quite a bit less frequently than Control down arrow. Now, in addition to using a keyboard shortcut to simply select a cell in the last row of our data, we can also use another one to quickly select all the cells in one of our columns. So why might we want to do this? Well, let's say we don't like the order of our columns as we have currently laid our spreadsheet out, and want to put our flavor and quantity columns after the order number column we created in the last video. That means we'll need to select all the data in those first two columns so we can copy and paste it after the order number column. So to do this, click in cell A1 and then hold down Control Shift down arrow. Keep in mind this is a 3-keystroke keyboard shortcut, so you'll want to hold down all 3 keys at the same time. So Control Shift down arrow, and you'll see that all of the data in that column has now been selected. Now the goal here is to move this data after our order number column, so we can Control C to copy it, and now all the cells from A1 to A101 are on the clipboard. It's worth noting, and we will be using this nomenclature going forward, that a collection of cells such as this is referred to as a range. So to paste this range of cells into column D, we'll first want to select the very first cell that we want our copied data to appear in. That would be cell D1, and then just hit Control V. Finally, we can again use our Control Shift down arrow shortcut to select all the data in column A, and then simply hit the delete key to remove it. So again, I'll select cell A1, Control Shift down arrow, and then hit the delete key. So we approached moving the data from column A into column D as a 2-step operation, and there's nothing wrong with this. However, when you want to move data from point A to point B, and you no longer actually want the data to be in point A, there's actually a faster approach than copying the data to a new location, then deleting it from its original location like we did here. This alternative approach involves the cut command, which we can access with the Control X keyboard shortcut, or alternatively, the menu that appears when we right-click in a cell. As with copying, cutting data puts it on the clipboard so we can paste the data to a new location. But unlike copy, cut will remove the data from its original location after it's been pasted. So in this case, it looks like the cut operation is more along the lines of what we need. So let's actually Control Z a few times to revert our data back to its original state, and then see how we can perform the same operation in fewer steps with Control X. So after undoing our recent changes, we'll again use Control Shift down arrow to select all the data in column A. Then we'll hit Control X to cut the data, and finally select cell D1, then Control V to paste. And as you can see, the data disappeared from its original home in column A and moved over to its new home in column D. Now, we unfortunately need to perform this same operation on the data in column B now. This seems a little redundant, so maybe there's a way we could have avoided having to follow these identical sets of steps for 2 different columns of data. And it turns out there is. we actually could have selected both columns A and B at the same time, again using our handy keyboard shortcut. So let's undo our way back to the start once more using Control-Z and see how this would have worked. So after undoing our changes, instead of just selecting cell A1, I'll instead click in cell A1 and then drag right to select cell B1 as well. Alternatively, I could again click in cell A1, then hold down the Shift key and arrow once right to select the cell to the right. And then, for example, if I wanted to keep selecting additional cells to the right, I could keep holding down Shift and just hitting the arrow key again and again. So with that said, using the method you like, let's go ahead and select cells A1 and B1. And then with both of these cells selected, we can employ our same Control-Shift-Down arrow shortcut to select all the data in both columns. Finally, I can simply Control-X to cut the data, select cell D1, and then Control-V to move the data to its new home. So now we have our columns in the right order, but we also have these unnecessary blank columns to the left of our tracker. We need to move our entire data set 2 columns over to the left to complete our realignment, so it would be really handy to have a quick way to select all of our data, not just the data in a single column. And this being Excel, of course there is one. So as long as our data doesn't have any gaps, that is to say empty rows or empty columns in the middle of the data, Excel will actually be smart enough to recognize the range of cells we've entered data in as a distinct entity, set apart from the rest of the grid. So if I just click anywhere in our ledger and use the keyboard shortcut Control-A, Excel automatically selects the entire range. Now it's worth pointing out that this technique does have its pitfalls. As I mentioned, our data needs to be gap-free for this technique to work properly. So if, for example, I select a row somewhere in the middle of our data set and just delete the data, and then I click somewhere above that newly empty row and then hit Control-A, you can see that Excel only selects the data above that gap. So other than clicking and dragging over the entire range, which is a time-intensive process that we want to avoid almost as fiercely as typing, what's an efficient way around this problem? Well, probably the most foolproof way of selecting a large range of cells, regardless of whether there are gaps in the data or not, is to click in the top left cell of the range, then navigate, scrolling if needed, to the bottom right corner of the range, without selecting any new cells just yet, then hold down the Shift key and click the cell at the bottom right corner of the range. This selects everything below and to the right of the top left cell and above and to the left of the bottom right cell. Basically, everything in between, regardless of whether there are gaps in the data or not. If I want to be 100% sure that I'm grabbing everything in a table of data, this is personally my favorite method because I know I'll never be surprised by having skipped over some portions of the data. So now we want to move this entire range 1 column over so that the data starts in column A. And we could certainly employ Control-X to cut the data and then paste it into cell A1. But I want to show you another method that can be more intuitive for some people, especially when it comes to moving ranges of cells around the grid. So with our range selected, hover over the boundary between the selected range and the rest of the spreadsheet. It doesn't matter which side of the range you do this on, as long as you don't do it in the bottom right corner where your cursor will turn into the fill handle. So when we hover over this boundary, the cursor turns into another, different symbol. This time something that looks a bit like, in my humble opinion, a ninja throwing star. So once we see our cursor change to this icon, we can hold our mouse button and then simply drag the entire range of cells wherever we want. Now it'll be a little easier to do if we scroll all the way back to the top because we want to drag all the data to the top left corner of the grid. So let's again hover over that boundary until we see the throwing star, then click, hold, and drag over 2 columns, and now our data has been moved right where we want it. All right, now that we know how to manipulate ranges of cells in the Excel grid, it's time to take our mastery of the grid to the next level by learning how to work with entire rows and columns. Not just where we've entered data, but the whole row or the whole column, all the way across or down. I'll see you then. Welcome back. In the last video, we explored selecting and working with what are called ranges in Excel. Basically, collections of cells on the grid. But sometimes, instead of working with a few cells at a time, it's more convenient to work with entire rows and columns. By operating on rows and columns, we're able to manipulate entire cross-sections of the spreadsheet at a time, as opposed to just a few cells. But before we get into some examples, let's begin at the beginning by simply selecting some rows and columns to visualize what we're talking about here. So here we have a somewhat jazzed up version of our shave ice truck spreadsheet that we've been working on throughout the course. One change you'll notice is that we are now allowing customers to add multiple flavors to their shave ice treats. Instead of just being able to order a cherry, for example, we're now allowing customers to add up to 7 flavors. We've also added a size column to track the size of each shave ice order. So with our example spreadsheet in front of us, let's click around and select a few rows and columns. We won't worry about doing anything constructive with them just yet. So to select, for example, column D, we simply click the letter D. That is to say, the column header itself. Likewise, to select an entire row, we just click the number to the left of the row. So to select row 5, I'll just click this number 5. And in both cases, Excel lets us know that we have selected the row or column by shading it slightly darker than the rest of the grid. And we can actually select multiple rows or columns at a time quite easily as well. For example, to select columns B through D, we can simply click the letter B to select column B, then hold down our mouse button and drag to the right until all 3 columns are selected. We can select multiple rows in this fashion as well by simply selecting one row and then dragging in either direction to select adjacent rows. Or, if you needed to select a whole bunch of rows but didn't feel like doing a lot of scrolling, you can select a single row, then scroll down to the end of whatever group of rows you want to select, and finally hold down the Shift key and then select the last row in the group that contains the rows you're trying to select. Okay, so now we know how to select rows and columns. But why would we even want to do this? Well, one action we can take on a row or column is to delete the data in it. So let's say we decided, just for example, that our flavor column in our order tracker is now redundant since we now have multiple columns capturing all the flavors in each person's order. So maybe we want to delete that data. To do this, we can simply select that column and then hit the Delete key on the keyboard to clear the data. The only problem with this approach is that now we're left with this blank column. So now we would need to select all of our data to the right of this column, cut it, and then move it over to fill the blank space. That is, unless we can delete the entire column and not just the data within it. And sure enough, we can. Let's hit Ctrl-Z to undo our delete from earlier, and then select column B once more and right-click. If we look at the menu that pops up, one of the options is Delete. Now this actually doesn't do the same thing as when we hit the Delete key on our keyboard earlier. The equivalent to that is actually the Clear Contents command. Choosing Delete here will actually remove the entire column and its contents, leaving no blank column in the middle of our data. So let's choose that. And as we can see, our flavor column has disappeared, and all of the other columns in our data have shifted over to the left to take its place. So we basically accomplished the same thing as deleting the data and then cutting the rest of our data to move it over. We can also delete rows in this fashion. Let's say we remembered that the first order in our tracker wasn't an actual customer order, but instead dummy data that we entered into our spreadsheet when we were first building it out. In that case, we can delete this row by simply clicking the row header, the number 2 in this case, right-clicking, and then choosing Delete. The row disappears from the grid entirely, and all the rows beneath it move up to fill the vacuum, so to speak. Now, as we saw before, we can also select multiple rows and columns. And anything you can select, you can also delete. So, say we have decided that 5 flavors are the most we can possibly fit into a single shave ice cup, and we want to delete our last 2 flavor columns. In this case, we can simply select the Flavor 6 column, hold down the mouse key, and drag to the right until the Flavor 7 column is selected as well. And then we can simply right-click and delete, and now both of the columns disappear from the grid. Now, as you might imagine, if we can delete entire rows and columns from our spreadsheet, we can also insert new ones. Something which comes in handy quite often as we're defining and modifying the structure of our data. Perhaps we learned that we failed to track one of our very first customer orders, say the 5th one, and want to add an entry for it in its correct chronological position after the first 4 entries. To do this, select the row that currently contains the 5th order, right-click, and choose Insert. This will insert a blank row above the currently selected row. Now that we have a blank row to work with, we could simply enter the details of the order we missed. We can likewise insert blank columns. As an example, let's say we want to add a column to our data that lets us track the style of the customer's shave ice order. You can either choose Island Style, which includes ice cream and a condensed milk topping, and this is my personal recommendation, or Mainland Style, which is just shave ice and flavoring. If we want to insert this column directly after our order number column, we need to select column B, which will be the address of our new column, and then right-click and choose Insert. Now a new blank column was inserted to the left of what was column B. This highlights a good way to remember how row and column insert operations work. The new inserted row or column will be located in the same slot as the row or column you had selected before the insert. If you're inserting a column, then the columns to the right of the new column will shift to the right to make room. In the case of rows, they'll shift down. So we can delete rows and columns, and we can insert rows and columns. But we can also delete a row from one location of our spreadsheet and insert it somewhere else, much like we learned to cut and paste ranges of cells in the last video. Let's say we want to change the location of our quantity column, moving it right before our 5 flavor columns. To do this, we can select the column, right-click, and choose Cut, or, alternately, the Control-X shortcut we talked about previously for cut. This will put the contents of the entire column on the clipboard. Next, we should select whatever column that we want the data we just cut to appear before. That is to say, to the left of. So in this case, we'll select the Flavor 1 column because we want this quantity column to appear immediately before that column. Then we can right-click and choose Paste. And as you can see, not only is the data now in the location we want, but the column has disappeared from its old slot. Keep in mind that we could have also used the Control-V keyboard shortcut to paste this data as well. Now you can also copy and then insert entire rows and columns, the only difference being the original copy won't disappear from the spreadsheet. But in my experience, this is useful quite a bit less often. Alright, now we have gotten a good handle on manipulating not just our data, but also the grid that contains it. But as we compile more and more data, readability and user-friendliness will become increasingly important. We'll take a look at some ways to make it easier to scan and navigate our data in the next video. I'll see you then. Welcome back. In this one, we're going to take a look at making our spreadsheets more aesthetically pleasing and, more importantly, easier to read and interpret by taking advantage of our ability to resize Excel's columns and rows. Thus far, we haven't encountered a lot of variation in the length or size of data we've been entering into individual cells, so the width of our rows and columns hasn't been much of a concern. But when, inevitably, we encounter larger values, whether they be numbers or text, that we need to enter into the grid, resizing the columns and rows of our spreadsheet to fit our data becomes crucial. Let's say, for example, we've added a new shave ice flavor called purple mangosteen. Yes, that's a real type of fruit. Check the interwebs if you don't believe me. If I try typing that value in our flavor 1 column, so I'll just type purple mangosteen, you'll see that the value is wider than our column and the end of the name gets cut off. Now, while the value is still saved, as you can see if you look in the formula bar, this is a really bad experience for anybody who's attempting to read and interpret our spreadsheet. So how can we resize this column to fit the new value? Well, the old-fashioned way, so to speak, is to select the column we want to resize and then hover the cursor over the boundary between the column's header and the header of the column to its right. You'll know you have the cursor in the right spot because it should change from a little down arrow, which you see when you're hovering just over the column header, to this little black cross icon we see here. Now, once we see this icon, we can click and hold our mouse button and then drag to the right to make the column wider, or drag to the left to make the column smaller. So we'll just drag the boundary out past where we think it needs to be and then let go of the mouse button. And it looks like we didn't drag it quite wide enough, so we'll go a little bit further. And there we have it. But now we know that we could potentially have to enter this extra long name in any of our 5 flavor columns. So wouldn't it be nice if we could resize all of these columns the exact same width simultaneously, as opposed to resizing them all individually? Excel actually makes this very easy. All we have to do is select all the columns we want to resize, which we can do with the techniques we learned in the previous video. So I'll just click the Flavor 1 column and then drag to the right to select all 5 of the flavor columns. And now again, I'll hover my mouse between the headers of the Flavor 1 and Flavor 2 columns until it turns into that little black cross icon, then hold down my mouse key and drag to resize the column appropriately. And then when I let go of the mouse button, all 5 of the selected columns are resized to the exact same width. Now obviously, this is a far superior alternative to resizing individually, since all 5 of the columns need to be able to accommodate the same type of data. Now, while it is done quite a bit less commonly in my experience, it's also possible to resize rows. So if, for whatever reason, we wanted to make, say, rows 1 through 5 of our spreadsheet taller, we can simply select the rows and then hover over the boundary between 2 of them to drag and resize. And then when we let go of the mouse key, all of our selected rows resize to match the height of the row that we had resized. So resizing columns, and to a lesser extent rows, is very helpful. But sometimes it may not be so obvious how wide we need to make our columns. For example, if our tracker here was thousands of rows long instead of just 100, we might not have noticed a large entry like our purple mangosteen getting cut off by columns that were too narrow to accommodate them. Insidious little formatting issues like this are why it's often helpful to let Excel decide what width the column needs to be to accommodate the data within it. The feature that does this is called autofit, and if you use Excel much, I guarantee it will quickly become one of your go-tos. So to demonstrate autofit, I'm actually going to Control Z back to before we manually resized our flavor columns. Now we see that our purple mangosteen value is again being truncated by the column it's contained in. So to use autofit to right size our column once again, we can again select the entire column, which we actually already have done here, and then hover between the header of our selected column and the column to the right until we see the little black cross icon. But now instead of clicking and dragging to manually resize, we simply double click. And poof, like magic, the column automatically resizes to snugly fit our data. And we can apply autofit to multiple columns at a time as well. To demonstrate, let's fill our purple mangosteen value across to all 5 flavor columns in the first row of our ledger. So I'll just grab the fill handle of that cell and fill to the right. So now we need to resize all of these columns to fit the new value. All we have to do here is actually just select all the columns that we want to apply autofit to, and then double-click between any of the column headers. It doesn't matter which one you choose, as long as it's not the boundary between the leftmost column we've selected, column F, and the column to the left of it, column E. Any of these other boundaries are fair game. So we'll go ahead and double-click, and after double-clicking, all of our selected columns automatically widen to the appropriate size. Awesome. And as convenient as this was, the more columns we need to apply this operation to, the more time autofit can save us. Along those lines, we can actually autofit all the columns in the entire grid in one fell swoop. If you want to be consistently sure that all of your columns are fit correctly to their data, this is a great habit to get into. Let's Control Z to undo our autofit of the flavor columns so I can demonstrate this shortcut. Our first step will be to click just above and to the left of the Excel grid, the corner of the grid, if you will. This selects all the cells in the entire sheet, which means all the columns are selected by default. So now, with all the columns selected, you can trigger autofit like we have in every other example. Just hover your cursor between any 2 column headers and double-click. And just like that, all of our columns are automatically fit to their data. This includes a few columns that actually got narrower, like our size column, for example, because the largest values in those columns were still pretty small. Now, one last thing I'd like to point out before we go. Sometimes you may see a strange-looking value in a spreadsheet cell that looks like a bunch of little pound or number signs. If you see this, it most likely means there is a number or date value in a column that is too narrow to accommodate it. So just for example, let me type a number in cell J1 and then resize column J to be extremely narrow. And there is that string of pound signs I warned you about. But if I autofit the column, now we see the number again. Likewise, if I enter a date in, say, cell K1, like 1/1/2021, and then hit enter, and then again resize the column to be extremely narrow, we see the pound signs reappear. Now it's important to note that in Excel, the visual appearance of data is distinct from the actual values of the data. So even though we see a bunch of pound signs right here, if we select the cell and look up at the formula bar, you'll see that Excel still knows the correct value that's stored there. Resizing our columns and rows is not so much about entering and storing our data accurately as it is about making the data we've entered as human readable as possible. But I can tell you that's just as important, since it's humans who will be interpreting our data and making decisions with it. Now, along those lines, up next we're going to look at some techniques that will help us scan and digest the data in large grids more easily. I'll see you then. Hey, welcome back. As we enter more rows and columns of data in our Excel spreadsheets, finding what we're looking for among all these cells can become increasingly difficult. One way we can help ourselves stay oriented as we're exploring our data is to organize our data in a tabular fashion, as we discussed previously, with column headers signifying individual attributes of whatever data it is that we're tracking. Likewise, the values in certain columns can sometimes help orient us as well, functioning effectively as row headers as opposed to column headers. But if we have too many rows or too many columns to view at one time on our screen, and then we scroll down or to the right, we suddenly lose those headers that help give meaning to the data we're looking at. Now, fortunately, Excel gives us a way to maintain visibility into these headers even as we're scrolling through extremely large data sets. This feature is called freezing panes, and it becomes invaluable as our data sets grow larger and larger. Let's take a look at how we can apply freezing panes to help us navigate our Hawaiian shave ice tracker. Now, as we just mentioned, if I scroll down a little through our shave ice data, suddenly our column headers are gone, and it becomes very difficult for me to know what I'm actually looking at when I see a row of values. Unless you're intimately familiar with the data, and maybe even if you are, what was once an intuitive ledger of information has suddenly become a jumble of values whose meaning is not obvious. Without our headers to guide us, we're essentially lost at sea without a compass, and the seas only get rougher and rougher as we have more rows and columns in our data. What we need to do is lock our column headers in place so that even as we scroll down, we can still reference them against the values on our screen. Fortunately, doing this is quite easy. To freeze a row so that everything from that row and above remains fixed in place even as we scroll down the grid, the first step is to select the row below the row or rows that you want to remain locked in place. So if we never want to lose sight of row 1 as we scroll down, we actually want to select row 2. Next, we'll select the View tab on the ribbon, which I actually already have selected here. Remember, navigating the ribbon is largely a matter of commonsensically, if that's a word, thinking about what it is that you're trying to accomplish versus the broad categories represented by the various tabs on the ribbon. And what we're doing pertains to the view that we see when we look at the spreadsheet, so I went to the View tab. So once we're on this tab, if you look in the Window subgroup, you'll see a Freeze Panes button. If you click that, you'll see 3 options, and we'll just choose the first one, Freeze Panes. Now let's see what happens when we scroll down through our spreadsheet. And look at that. No matter how far we scroll down, we can still see our headers, so we no longer need to be confused as to what values in our data actually mean as we're scrolling up and down through the grid. So the most common use of freezing by far is to simply freeze the top row like we did here. But sometimes we may want to lock more than one row in place. All rows above the row you had selected before choosing Freeze Panes will be locked. So if we had selected, say, row 3, then clicked Freeze Panes, both rows 1 and 2 would remain locked as we scroll throughout the spreadsheet. Just to see what this looks like, let's first unfreeze panes by clicking the Freeze Panes button again, and then choosing Unfreeze Panes from the pop-up window. Then, with row 3 selected as we have here, let's go back to the Freeze Panes menu and choose Freeze Panes again. And now if we scroll through our spreadsheet, we see that the top 2 rows are firmly locked in place. Now it's also common, although I would say somewhat less so, to want to freeze columns in place so that we can see the values in them even as we're scrolling across the grid horizontally. Let's say, for example, that we always want to be able to associate the data points in any of our columns with their respective order numbers. So if we always want to be able to see order number, no matter how far we scroll to the right, then we need to freeze the first column where our order number values are stored. This works almost exactly like freezing rows. We first select whatever column is immediately to the right of everything we want to remain locked in place. So if we want column A here to be locked, we will select column B. Then we'll go up to the Freeze Panes button again, where we'll first need to unfreeze panes because we already have our top 2 rows frozen. Now at this point you may be wondering what we can do if we want to freeze both rows and columns. You actually can, but we'll get to that in just a moment. So for now, we'll just choose Freeze Panes. And as we scroll right through our data, we'll see that the order number values in column A remain firmly locked into place. Now we don't have a ton of columns in our data as it currently stands, but you can see how this would become more valuable as we add more and more columns to our data. Now when freezing rows, the most common scenario by far is to simply freeze the top row of the spreadsheet where our column headers typically reside, like we did before. Likewise, the most common scenario when freezing columns is to freeze the first column, just like we did. For this reason, Excel actually gives us convenient shortcuts to do both of these things. So if we unfreeze panes to get rid of the freezing operation we just performed on column A, we can then go back to the Freeze Panes menu without worrying about what cell or row or column we've selected, and simply choose Freeze Top Row. And then if we try to scroll down through our data, we see that the top row is frozen just like we were able to do previously. Likewise, we can freeze the first column in 2 clicks by simply clicking the Freeze Panes button again and then choosing Freeze First Column. And as you can see, our first column is now frozen, just like we accomplished with a few more steps a moment ago. So now, back to that whole issue of being able to freeze columns and rows simultaneously. Thus far, we've only been able to freeze our column headers in row 1 in place, or our first row of values in column A in place, but not both at the same time. Doesn't it make sense that we might possibly want to keep track of both as we're navigating our data? Indeed it does, and fortunately it's very simple to do. The only difference is, instead of selecting an entire row or an entire column before hitting the Freeze Panes button, we instead select a single cell. How it works is, all the rows above the cell and all the columns to the left of the cell will remain locked in place as we scroll across the grid. So if, for example, we want row 1 and column A to remain frozen, we would first select cell B2, since the row immediately above it is row 1 and the column immediately to its left is column A. So if we select cell B2 and then first unfreeze panes to undo the freezing operation we did a moment ago, and then choose Freeze Panes, you'll see that both column A is fixed in place and row 1. Both remain fixed and visible no matter how far down or across you scroll on the grid. And again, you could freeze as many rows and columns as you like by simply moving the cell you select before freezing panes, down or to the right. So if I unfreeze panes again, and then select cell C4 and freeze panes once more, now you'll see that the top 3 rows are frozen and the 2 leftmost columns are frozen. All right, at this point we can proclaim ourselves masters of the Excel grid. We know how to enter and manipulate data in it, create, delete, move, and resize its rows and columns, and navigate its vast ocean of cells like a seasoned explorer. But thus far, we've limited ourselves to a single grid, when in reality, Excel actually lets us create as many of these as we want in a single file. We'll begin exploring this new world of multiple grids in the next video. I'll see you then. Hey, welcome back. In this one, we're going to extend our journey through Excel from the exploration of a single grid to creating and working with multiple grids in the same Excel file. Before we look at some examples, however, it's important to understand just a bit of terminology. Now, I know this is the point where most people will be tempted to stop the video and run the other way. Please don't. This terminology will make some distinctions about the environment we're working in more clear. So the grid, as I have been calling it, that we've been working in thus far, is part of what's called a worksheet. A worksheet is a single grid in an Excel file, but we can actually create more of these. As many as we want to, in fact, only limited by our computer's memory and its ability to store whatever data we're entering into Excel. A worksheet is part of a workbook, which is a distinct Excel file that we can create, open, and close. Now, if you look at the name of our example file here at the top of our screen, that is the name of the workbook, not the worksheet. When you hear the word spreadsheet, this is essentially synonymous with a workbook. Now, you can find the name of the worksheet down here near the bottom left. It's named, blandly enough, Sheet 1. This is the default name that Excel gives the one tab that is open by default in an Excel workbook. Now, as long as we only have one worksheet in our workbook, the distinction between worksheet and workbook is trivial. But many, if not most, workbooks have more than one worksheet. To see what this looks like, let's go ahead and click the plus sign to the right of the name of our Sheet 1 tab. And you'll see that we now have a brand new grid, which has been named Sheet 2. And it's a brand new slate that we could use for an entirely different purpose than Sheet 1. And we can keep going in this fashion as long as we want. You can create as many tabs as you need to organize the data and functionality of your spreadsheet in a way that makes sense for your purpose. Now, with that said, while there are no hard and fast rules for how to divide your data between worksheets or even Excel files, my rule of thumb is that an overall Excel file or workbook, our shave ice file we have open here, for example, should generally pertain to one thing or purpose. In our case, that thing is tracking information pertaining to our Hawaiian shave ice truck. But since things in the real world can get pretty complicated, it often helps to break them down into manageable pieces when trying to track, describe, or model them. So if the point of our spreadsheet is to track and manipulate data pertaining to our shave ice truck, we could have multiple worksheets within the workbook that support this overall purpose in different ways. For example, while we have one tab here that tracks customer purchases, the tab we've been doing our work in, we could have another tab that tracks our product inventory. Things like how much ice do we have, how much do we have of each flavor of syrup, etc. And then perhaps we could create even another tab to track purchases we make from vendors, and so on and so forth. So let's say we want to start by creating a product inventory tab. We already have a second blank tab that we just created here, which we could use as a great starting point, but both of our tabs are named so generically, it's not going to be obvious which one we need to click to view or enter what data. So what we need to do is rename the tabs, which, as it turns out, is easy enough. To rename a tab, you can either right-click it and choose Rename, or you can simply double-click the tab name. Then type in the new name and hit Enter. So I'll just type Product Inventory and hit Enter. And again, to be clear on terminology and these distinctions, the tab is simply the button that you click to navigate to a worksheet. So if I click this tab called Sheet 1, that takes me back to the Sheet 1 worksheet. Likewise, if I click the Product Inventory tab, that takes me back to the newly created Product Inventory worksheet. And while we're busy doing this renaming, we can go ahead and rename our first worksheet Sales Tracker. Next, we can create a Vendor Purchases tab, which we could use to keep track of the money that we spend to keep our little business afloat. Now, depending on where we want this tab to be located relative to the other two, we need to strategically select one of our two tabs before clicking this plus sign. The new tab will be inserted immediately to the right of whatever tab I currently have selected. So if I want our new tab to be inserted after our first tab, but before our second, I would need to select the first tab and then hit the plus sign. Now, if on the other hand, I had had the second tab selected, our new tab would now be in the third position. So now let's give our new tab a name, and we'll call it Vendor Purchases. So far, so good. But now let's say I've changed my mind, and I want to move this tab into the third position. This is actually pretty straightforward. Just right-click the tab, choose Move or Copy, and then select from the list of worksheets presented in this pop-up menu whichever one we want this worksheet to be repositioned before, that is to say, to the left of. Or if, and as in our case, we simply want to move the sheet into the last position, we can choose Move to End, and then click OK. And now our Vendor Purchases tab is slotted in right where we want it. Now, one way to get a head start on the layout and structure of a new tab is to duplicate an existing tab with a similar structure to what you need. Let's say, for example, that we bought an additional shave ice truck that we're letting someone else operate, and we want to track the sales for that one independently. This seems like a good use case for a new tab, but since we're tracking similar data, we're probably going to use the same, or at least similar, structure as our existing Sales Tracker tab. This is where duplication can come in really handy. So to do this, right-click our Sales Tracker tab, and then again choose Move or Copy. As before, when we moved our Vendor Purchases tab, the dialog box that appears asks us which sheet we want to move our duplicated sheet before. And in this case, we would want our new sheet to be directly after Sales Tracker, which means it would be before the Product Inventory tab. However, if you also check the Create a Copy checkbox, instead of the current sheet being moved into that position, a copy of the sheet will be placed in that position, while the current sheet will remain in its original location. So now if we click OK, a new sheet appears with an auto-generated name based on the name of the sheet we copied, which incidentally is pretty close to what we would want to name it. So I'll just go ahead and tweak this and call it just Sales Tracker 2 with no parentheses needed. And there we have it. As you see, we have all of our column headers, all of our structure preserved from the Sales Tracker tab, and all we would need to do to repurpose this is just delete the data below the column headers, and otherwise we've got pretty much everything we need to start tracking sales from our new shave ice truck. Now before we move on, we should consider what to do if we've created a tab that we later realize we don't need. Maybe we've decided that instead of tracking our sales from our second shave ice truck on a new tab, it would be simpler to just add a new column to our first tab that will track which shave ice truck a given sale occurred at. So in this case, we could delete our second Sales Tracker tab, the one that we just created. Now doing this is extremely simple. You just right-click the tab and choose Delete. But there is an important thing to consider before you hit the proverbial big red button. You know how we've been using Control-Z, that is to say undo, to quickly unwind changes to our workbooks? Well, there are certain changes that Excel can't undo, no matter how hard you hit Control-Z. And deleting sheets is one of them. So if we go ahead and delete our sheet here, and you see here that Excel gives us an extra little warning asking us if we're really sure that we want to delete this sheet, which might indicate to you that it's a bigger deal than some changes you could make, and we'll go ahead and click delete. But if we hit Control-Z, nothing happens. Excel is unable to recapture the sheet we deleted. So the lesson is, don't delete a sheet unless you really mean it. All right, now we have made clear, at least I hope, the distinction between worksheets and workbooks, and introduced some tactics for working with multiple worksheets. Now, armed with that knowledge, we're ready to tackle one of the most powerful ways to search and edit data, both within individual worksheets and across multiple ones, that Excel has to offer. That's find and replace, and we'll learn all about it in the next video. I'll see you then. Welcome back. We had barely just learned some techniques for navigating the Excel grid efficiently when we discovered that a single spreadsheet can actually contain many different grids. The Excel universe, it seems, just keeps getting bigger and bigger. And this can make it darn inconvenient when you want to search for things in a spreadsheet. It's one thing when we have a few rows of data on a single sheet, but when one sheet has hundreds or thousands of rows of data, and then we have multiple sheets in our workbook, something as simple as finding every cell where we entered the word blueberry can become extremely difficult. Fortunately, Excel once again comes to our rescue, in this case with a powerful feature called Find and Replace. Find and Replace, as the name implies, really encompasses two pieces of functionality: finding data in our spreadsheet and then potentially replacing it with something else. We'll start by finding values within our spreadsheet and worry about replacing a bit later. So let's say that we want to find all entries for snow cream in our spreadsheet. Obviously, individually inspecting each cell in our sales tracker would be prohibitively time-consuming, not to mention mind-numbingly boring, so we'll let Excel do the heavy lifting for us. To start, use the keyboard shortcut Ctrl+F to bring up the Find and Replace dialog box. Then, type the phrase we're searching for, snow cream, in the Find What text box. Finally, simply click the Find Next button, and Excel will automatically select the next cell that contains the value snow cream. And then if we keep clicking Next, Excel will keep navigating to subsequent snow cream values until we finally run out of values to search for. Note that Excel searches from left to right and top to bottom, relative to whatever cell you had selected when you hit Ctrl+F. So if I close out of the Find Replace dialog box, and then select a cell in a row below, or a column to the right, of a cell with the value snow cream, let's say cell I5 here, and then we do another search for snow cream, you'll see that Excel ignores the snow cream value in cell H5 and moves on to the next one, again relative to the cell we had selected. Now this doesn't mean Excel won't ultimately find the value in cell H5. Eventually, after it has navigated through the rest of our sheet, it would come back around to the very top of the worksheet and scan all the cells above and to the left of where we began the search. So this ability to find values in the vastness of the Excel grid is obviously very convenient. But when we have many instances of the same value, as we do here, navigating through them one at a time can be a bit of a chore. Fortunately, Excel gives us the option to find all, as opposed to simply finding the next value in the spreadsheet. So with our Find dialog box still open, if we click the Find All button, Excel now displays a list of all of the instances of the phrase we were searching for, along with their respective addresses within the worksheet. So now we can simply scroll through these matches and see exactly where the values are located on our worksheet. For quickly getting an idea of how many instances of a value are in your spreadsheet and where they're located, this is a super powerful tool. Looking at this list of matches, you might have noticed that Excel tells us which sheet each match is located on. This is because Excel optionally allows us to search for matches across all the worksheets in our workbook, in which case we need to know not just the cell address of the match, but also the worksheet the match was located on. To demonstrate this, let me quickly duplicate our first tab so that we now have snow cream values located in two sheets of our workbook. So we'll just go ahead and move or copy, create a copy, and move to end, just like we saw in the last video. Then we can once again hit Control F to display the Find and Replace dialog box. And since Excel is smart enough to remember the last thing I had searched for, I'll go ahead and hit this Options button here to see what we can do about searching across all worksheets instead of just the one we have selected. And they certainly weren't kidding around about the options part. We are presented with all sorts of ways to customize our searches. For now, let's focus on the Within Sheet option. So if we click this drop-down box that says Sheet, we see that we have the option of searching within the current sheet or the entire workbook, which is another way of saying all the worksheets within the workbook. Let's go with that option and then choose Find All. And now if we scroll down through our list of matches, you'll see that some come from our Sales Tracker worksheet and some come from our copy of our Sales Tracker worksheet. And now to reset our options back to their defaults, I'll go ahead and change Within back to Sheet, and then I'll click the Options button to hide this Options section of the dialog box. Then we can go ahead and close out of the dialog box. Now we can also reduce the scope of our searches from a single worksheet to a range within a worksheet. If we only have a single cell selected when we execute our search, by default, Excel will search all the cells in that particular worksheet. However, if we select more than one cell, that is to say a range, Excel will only search within that range of selected cells. So if I, for example, select the range E2 through I11, which contains a few instances of the phrase snow cream, and then we execute another find using Control F, and then we choose Find All. Now as we scroll through the results here, you'll see that they're all cells within that range. It's not picking up any matches outside the range that we selected. Now there are just a couple more options on the options screen that I would like to explore. So let's click the Options button again. Now one of these options is to match case, which you can see is unchecked by default. Matching case essentially means that a value in our spreadsheet is only considered a match against our search term if the capitalization is identical to what we typed in. With match case unchecked, capitalization is not considered when evaluating values in our spreadsheet for a potential match. So let's say I do a search for snow cream, but type snow cream in all caps. If I click Find All, I have all the same matches that I had before. But if I check the Match Case checkbox and do another Find All, now we get no results. Excel says we couldn't find what you were looking for. And it even helpfully suggests that we could click Options for more ways to search. Now another option you can employ if you want to be more precise and surgical with your searches is to match entire cell contents, which you can see is right below our Match Case checkbox, which I'll go ahead and uncheck for now. So wait, Excel hasn't been matching our search term against the entire cell contents already? It actually hasn't. In fact, if we simply search for the word snow instead of the phrase snow cream, you'll see that we get the exact same list of matches as before. Now, sometimes this behavior is really handy, and sometimes it's not. Especially when we are replacing the matches we find with some other text, returning partial matches like this can be kind of dangerous. And even when simply finding values like we're doing here, you may or may not be interested in a match if your search term is only contained within a larger piece of text in a spreadsheet cell. It really all depends on what you're trying to accomplish. Now, speaking of replacing values, all the things we've learned about finding are 100% applicable to finding and replacing. In fact, the replace functionality is built into the Find dialog box. So let's first click the Options button again to hide the Options section of the dialog box. We can then click the Replace tab on the Find and Replace dialog box, and we'll see that the options are pretty much identical to before, except that we're now asked to provide text that we want to replace our matches with. Now note that you can also navigate directly to this tab with the Control+H shortcut. So if we close out of the Find and Replace dialog box and then hit Control+H, we're taken directly to Find and Replace. Now let's say, for example, that we want to rename our snow cream flavor to Avalanche. So all we need to do is make sure we have snow cream typed in the Find What text box, and then Avalanche typed in the Replace With text box. Then we'll just hit the Replace button, and you'll see that in cell H5, Snow Cream has been replaced by Avalanche. And then if we keep clicking, we'll see that each subsequent instance of Snow Cream is replaced by the word Avalanche. Now for small find and replace operations, this one-at-a-time approach is perfectly fine. However, this wouldn't work very well over a large data set. As an alternative, we can use the Replace All command, which will replace all matches with our new value in one fell swoop. So if I click that, all instances of Snow Cream in our worksheet have now been replaced with Avalanche. So you can see how this technique could allow us to make wide-scale changes to our data with a bare minimum of typing. But this kind of power comes with its pitfalls, especially if we keep the default setting of returning and thus replacing partial matches. Let's say, for example, that we want to change the name of our apple flavor to apple pie. Now, the sharp-eyed student may note at this point that we did not have an apple flavor prior to this video, and may conclude that said flavor was contrived for the purposes of this example. Such a sharp-eyed student would not be incorrect. But I digress. So first we can dismiss the pop-up that lets us know that Excel successfully replaced 33 instances of Snow Cream with Avalanche. And then in the Find and Replace dialog box, we'll search for apple and then replace it with apple pie. And finally, click Replace All. So Excel tells us that it's all done and 88 instances were replaced. But after we click OK, we see something pretty odd. All of our pineapple entries have now changed into something called pineapple pie, which, while it actually sounds kind of tasty, is probably not a real shave ice flavor or even a real thing for that matter. Because we were searching for and subsequently replacing any instance of the word apple, we ended up replacing the text apple even when it was part of another word, such as pineapple. Sometimes this behavior may be what you want, but if it's not, you can obviously do a lot of damage on a pretty broad scale using Find and Replace. The way around unforeseen consequences like this is to be more surgical with your Find and Replace operation by choosing Match Entire Cell Contents in the Options section of the Find and Replace dialog box. So if we close out of our Find and Replace dialog box and then hit Control-Z to undo our last Find and Replace operation, and then do another similar Find and Replace, but this time we choose Match Entire Cell Contents, and finally click Replace All, you'll see far fewer replacements were made, and our pineapple entries have not been replaced by pineapple pie. Alright, so with Find and Replace under our belts, we now have every technique we need to enter, navigate, and edit the data in our Excel workbooks. The logical next step then is to learn about working with multiple workbooks, completely different Excel files with their own little universes of worksheets. That's up next. I'll see you then. Welcome back. We've now seen that an Excel workbook can be composed of many worksheets. So in the hierarchy of Excel, so to speak, is there anything higher than workbook? Actually, yes. It's the Excel application itself, which can, in turn, contain multiple workbooks simultaneously. Let's take a look at an example to make this distinction clearer. Now here we again have our shave ice truck tracker. If I were to click the X button at the top right corner of the screen, we would close out of Excel completely. So how again is a workbook different than the Excel application itself? But there's actually another way to close out of a workbook. If I go to the File menu on the ribbon, which tends to contain commands that pertain to entire workbooks, like opening, closing, and saving, and then choose Close, we'll see that the workbook disappears, but we still have an application window for Excel open. So in short, Excel is the application that hosts our workbooks. It is totally possible to have Excel open without having any workbooks open, although there's really not much point to this. So to that point, let's go ahead and reopen the file we just closed by going to File and then Open. And then we'll simply browse to where we have the file saved, select it, and click Open. Now that we have our original workbook back open, let's go ahead and create a new one so we can explore how to work with multiple workbooks. Now, one way to do this would be to go back to the File menu and then choose New. But creating a new workbook is such a common task that this is another one of those cases where it's best to learn the keyboard shortcut. In this case, that's Control-N. So to get out of the File menu, I'll just click this arrow pointing to the left here. And then to create that new workbook, I'll just hit Control-N. And suddenly a new blank workbook appears. But how do we navigate now back to our original workbook? Well, since this problem pertains to our view of Excel, quite literally what we're seeing, we'll check under the View tab on the ribbon. And there we'll find a command called Switch Windows. If we click that, we'll actually see a list of all the open workbooks in the Excel application. And Excel lets us know which one we're currently looking at. This is called the active workbook because there's a check mark next to it. So if we want to navigate to the other workbook, we simply select that one in the pop-up menu, and now we're right back where we started. So now let's say we want to go ahead and close that new blank workbook we created. First, we can navigate back by going to View, Switch Windows, and then selecting that workbook. Then, instead of resorting to File Close, we can simply click this X at the top right corner of the window. But wait, isn't this going to close us out of Excel altogether, and then close our Shave Ice Truck spreadsheet in the process? Actually not. If there are multiple workbooks open, clicking the X simply closes the active workbook, the one you're currently looking at, leaving any other workbooks open. Now sometimes, when creating a new workbook, we may not want to start from a blank slate. Much like when we duplicated a worksheet earlier, it can also be useful to duplicate a workbook. There are a couple of ways to do this. One is to save the current workbook as another name. This will make a copy of the current workbook with a new name that you specify. Then you can branch off in your new workbook with whatever changes you want without affecting the original. So if, for example, I'm starting a new food truck and want to use my Shave Ice spreadsheet as a starting point to track information about my new venture, I can simply click File, Save As, and then I'll be prompted to enter a new name for the file. I'll go with Food Truck Tracker, and then I'll browse to a location, and I'll just drop it into the same folder as my other example file, and then we'll hit Save. And we're good to go. Now we can go to File, Open, browse to our folder, select our original workbook, and open that. So now, if we go to our View tab and go to Switch Windows, you'll see we have both of these spreadsheets open, and they have different file names and are completely different files. At this point, we could make whatever modifications we want to one file without affecting the other. So for now, I'll just select our new copy and close out of that so we're left with our original file. Now sometimes you may not want to copy the entire structure of a workbook, but instead just a single tab. To do this, we can simply right-click whatever tab we want to make a copy of, choose Move or Copy, and then check the box that says Create a Copy. Then, before clicking OK, choose New Book in the To Book drop-down list. Then, after clicking OK, we now have a brand new workbook with a single tab that is identical to the second tab of our original spreadsheet. Now sometimes, instead of simply switching back and forth between our workbooks, it can be useful to view them side by side, especially in cases where similar information is being tracked in multiple workbooks and we want to reconcile them against each other. In the real world, this is a fairly common scenario. Fortunately, Excel has an extremely convenient way to do this built in. All we have to do is, again under the View tab, choose Arrange All. The pop-up menu that appears gives us several options for how to arrange the Excel workbooks on our screen, but the one I find most useful by far is the vertical orientation. If we choose that, now our two workbooks appear on our screen side by side. The content of the workbooks remains unchanged. Excel just reduces their width so they can both fit in our screen simultaneously. You can just pretend they went on a diet. We can scroll through, select different tabs of, and otherwise manipulate each workbook independently, just like we were viewing the workbook on the entire screen. And if at any point we no longer need this view, we can simply go to the little square icon at the top right corner of whichever one of the windows we want to maximize, and click that. And now it fills up our screen once more. The other workbook is still open too, and we can always switch back to it using Switch Windows. For now, I'll navigate back to our duplicated workbook and close out of it without saving, so that we're left with our original. Now similarly, you can also view two sections of the same workbook simultaneously, just like we just viewed two separate workbooks side by side. To do that, again under the View tab, choose New Window. This creates a kind of shadow workbook that mirrors our current workbook in every way, the benefit of which is allowing us to see different parts of our current workbook side by side. So if I go to View and switch windows, you'll see that we now have versions 1 and 2 of our example file. Now I can't overemphasize that these files are identical. So if I make a change on one, let's say I just delete the value in cell A1, order number, and then if I were to go to the version 1 of our example file, you'll see that that value has been deleted there as well. Instead of thinking of these as separate files per se, think of them as simply mirror images of each other. Now, one example of where this can come in handy is if you wanted to compare values between different tabs in the same workbook. So if I first select View and then Arrange All, just like we did before, and then make sure Vertical is selected, we can see our workbook views side by side. So let's click OK. And now I can navigate to different portions of our same workbook to view them side by side. In the view on the left side of our screen, I can choose the first sales tracker sheet, and then on the right side, I can have the second duplicated sales tracker worksheet selected. As you can imagine, this sort of thing comes in very handy for reconciling similar data sets against each other that just happen to live in the same workbook. All right, at this point we've pretty much taken the grand tour of the massive application that is Excel. We have a lot more to learn about its functionality and how to apply it, but at this point you should have a solid grounding in Excel's fundamentals and the building blocks that make up the application. Take a breath and pat yourself on the back for learning so much already. I'll see you in the next video. Welcome back. Up to this point, we've mostly been concerned with the speed and efficiency with which we enter data into our spreadsheets. We haven't given much attention, however, to the visual appearance of that data and how to modify that appearance. Now, Excel is very useful as a data storage mechanism, but it's used just as often as a vehicle to present attractively formatted data and visualizations to audiences of all kinds. Therefore, it's crucial to learn the most important options Excel gives us for modifying the appearance of the data in our cells. A crucial concept to understand before diving into formatting is something we touched on earlier: the concept of data types, broad categories of data that Excel recognizes as distinct and which provide us distinct sets of options for both calculations and visual formatting. These three data types are text, numbers, and dates. Depending on what sort of data Excel thinks you've entered into a cell, you will have different options available to you, not only in terms of the calculations you can perform on the data, which we'll get into very soon, but also how you can change the visual appearance of that data. To get a feel for how all this works, let's start playing around with entering different values into a spreadsheet. First, I'll type a text string, the word Excel, just as an example, into cell A1 here, and then hit enter. Now, if we navigate back up to that cell, and then look at the number section on our home tab of the ribbon here, you'll see that the cell is formatted as general, whatever that means. Next, let's type a number into another cell. I'll try the number 42 in cell B1. And now if I navigate back to that cell, we can see that it also is still formatted as general. But wait, 42 is a number. So why isn't Excel acknowledging that this is a different type of data than the text string we entered? Well, this is where it's important to understand the distinction between data values and data formats. Formatting pertains to the visual appearance of the data, but doesn't actually change the underlying values that we entered into the cell. So a number and a text string both being formatted as general does not mean that Excel doesn't recognize that one is a number and one is text. In fact, it does. And you can actually see this by looking at the alignment of the values in the two cells. By default, Excel aligns numbers to the right and text to the left, which is exactly what we see here. But what the heck does the general format actually mean? General is basically Excel's default format. If we navigate to other empty cells around the grid, you'll see they're all formatted as general. And it essentially represents Excel's best effort to format the data that we enter in a reasonable way. If you don't have a strong opinion about what your data should look like, sticking with the general format is usually fine. There are some values, however, that will be assigned a different, non-general format when we enter them into the cell. For example, if I type a properly formatted date into cell C1 here and hit enter, so I'll just try 1/1/2021, and then navigate back to the cell, you'll see that Excel is smart enough to recognize what we typed into the cell as a date, and it assigns an appropriate format accordingly. Now, for each one of these broad data types, text, numbers, and dates, we will have a broad variety of formatting options to choose from, specific to that type of data. What we've seen here thus far: a general format for text and numbers with different alignments to indicate that they're recognized as different types of data, and a separate, distinct format for dates, simply represents Excel's defaults and barely scratches the surface of all the formatting options available to us. Up next, we'll kick off our deep dive into formatting data by exploring some of the options we have for formatting numbers in Excel. I'll see you then. Hey, welcome back. Now that we have the general idea of how formatting in Excel works, let's dive into some of the most common and useful formatting techniques for numerical data. We'll start in a blank spreadsheet just to get some of the basics down, and then we'll apply some of those techniques to our shave ice tracker to see how they work in real-world scenarios. So, for numbers and decimals, for which you don't need any visual flair beyond strictly the number itself, additional formatting beyond what the general format offers is often not needed. I can enter the number 1111 in cell A1, and then the decimal 1111.766 in cell B1, and Excel is able to display both numbers just fine, as long as we just care about displaying the number, nothing more, nothing less. It's often the case, however, that decimals in our spreadsheets are the result of calculations, which can end up producing messy strings of numbers after the decimal place. In these cases, while we don't want to lose insight into the exact value stored in the cell, we often want to format the number such that only a certain number of decimal places are displayed. Most commonly 2, but sometimes less or more. In our case, let's try formatting cell B1 such that only 2 numbers are displayed after the decimal. The easiest way to do this, after selecting the cell, is to click the right pointing arrow on the number section of the Home tab. This arrow reduces the number of digits after the decimal place of a number, but strictly in the sense of formatting, not in terms of the actual value stored in the cell. Each time we click this button, the number of digits that appear after the decimal place will reduce by 1. In this case, we just need to click it once to get down to 2 digits after the decimal. Note that by default, Excel rounded the last digit we're displaying based on the digit after that. Since the third digit was a 6, the true value was closer to 1111.77. Excel chooses to display that instead of 1111.76. But if we look in the formula bar after selecting the cell, we see that our original value is what is actually stored, with all of the precision retained. Now, as you might have guessed, if we click the arrow pointing left, now we'll see more of our decimal places. And we can actually keep going past the number of digits in the original number. Excel will just keep tacking on zeros if we run out of digits to work with. Now, if we have a very specific number of digits we want to display after the decimal, and we don't want to click the arrow that many times, we can alternatively right-click the cell, choose Format Cells, which is selected by default. Here we're presented with a dialog box that gives us the option to enter whatever number of decimal places we like. So if I wanted to reduce the number of decimals we're showing down to 2, I could do that right here. The Format Cells dialog box gives us more options and greater precision than the shortcuts we see on the ribbon. Now, another useful function of this dialog box is the Use Thousands Separator checkbox. By checking this, numbers 1,000 or larger will be formatted with commas, which can make such large numbers significantly more human readable. So if I check that and click OK, you can see that our number now has a comma after the first digit. The larger numbers like this get, the more essential these comma separators become for the purpose of readability. This is an option you're probably going to end up using pretty often. So now that we've formatted a couple of numbers, let's head over to our Shave Ice tracker and see how formatting some of the data in it might make it more readable and useful. Now right away, you may notice that I've added a sale amount column to our tracker, which has the total dollar amount of each transaction we've recorded in our ledger. Right now, the amounts are formatted with 2 digits after the decimal place, which is fine. However, it would be nice if we could format these numbers in a way that distinguished them from ordinary decimals by making it clear that they denote amounts of money. Excel actually has a built-in format for this specific case. As you might imagine, entering dollar amounts in spreadsheets is pretty darn common. So with cell J2 selected, if we just right-click, again choose Format Cells, and then select the currency category, Excel actually shows us a preview of what the number will look like with this format applied. Basically just like it did before, but with a dollar sign in front of it. So if we click OK, now we're making it clear to anyone looking at our spreadsheet that this 19.95 value represents a dollar figure. Now this is obviously a big improvement over what we had before, but now we need to carry this formatting down to the entire column of sales amounts. Now we could select Now we could simply select only the cells that we've entered data into by using the Control-Shift-Down arrow keyboard shortcut, and then format only that range of cells. But I personally prefer to select the entire column before applying the format. This leaves room for future growth in that column as we add more and more entries to our ledger. And in general, as we mentioned previously when talking about tabular data, it's a best practice to only enter one type of data per column. So if we have currency values in column J, we should probably only be entering currency values in column J, except obviously for our column header. So let's click the letter J to select column J, and then right-click, choose Format Cells again, then Currency. But before we click OK, note that the drop-down list next to Symbol says None. But what we want is a $sign. So we'll want to click this drop-down and choose the $sign, which is essentially the symbol of our currency of choice. Obviously, there are lots and lots and lots more varieties of $signs that Excel has built into the application, but for our purposes, we're going to go with the good old-fashioned $sign. We can also customize the number of decimal places displayed, so if we only wanted to show one digit after the decimal, we could change that here by simply clicking the up or down arrows or typing in a different number. But we'll leave it at 2 for now, and then click OK. And now our entire column is formatted as currency, so it's clear to anyone looking at this data that these numbers pertain to dollar amounts. So the third common number format is percentages. Now, mathematically speaking, a percentage is really just a specially formatted decimal. The decimal number 0.25 and the percentage 25% are, in strictly mathematical terms, identical. Fortunately, Excel recognizes this. For an example, let's move over to the Flavor Performance tab, which is new to our tracker. And you'll see here that we have, for each of our shave ice flavors, the proportion of all sales generated by that flavor. Now, unfortunately, these proportions are represented by long decimal numbers, which, while accurate, are not especially pretty to look at, nor easy to read or reason about. So to quickly change that, we can simply select the entire column containing the decimals, and then hit the percentage button on the number section of the Home tab. Sweet! Now all those ugly decimals have been transformed into easily human-readable percentages. And if we want to see a little more precision with our percentages, say 2 digits after the decimal place, we can just use our left arrow button on the number section of the Home tab to add them. Regardless of our formatting choices, however, if you look in the formula bar after selecting one of the values, you can see that the precision of the original numbers has still been preserved. Again, formatting will not impact the accuracy of any calculations done on the values we're formatting. It simply changes what is displayed, not what is stored. Now, it's worth noting that as far as Excel is concerned, these percentages are exactly equal to the values we entered into the cell in strictly mathematical terms. And we can use these percentages in calculations the exact same way that we might have used our decimal numbers previously. Now also, if you don't want to take the additional steps of having to reformat your numbers as percentages after you've entered them, you can actually enter them as percentages directly into the cell. So if I wanted to enter the value 50% in a cell, instead of needing to type 0.5 and then format that as a percent, instead of doing that, I can actually just type 50% directly in the cell. And if I navigate back to the cell, you'll see it's formatted as a percentage, just like in cell E1. Under the hood, so to speak, Excel understands that this value is not 50, but rather technically 0.5, which in mathematical terms is what 50% really is. Just know that when entering percentages this way, do not enter the decimal that the percentage is equivalent to. This throws some people off, including yours truly at first. So if you were to type 0.5% into a cell and hit enter, The value that is actually stored is 0.005, which in mathematical terms is a half of 1%. So the bottom line is, when entering percentages directly into a cell, type them as you would say them. Basically, don't overthink it. All right. Up next, we're going to explore the wide world of formatting dates and times, a rabbit hole that goes even deeper than formatting numbers. I'll see you then. Welcome back. In this one, we're going to learn all about formatting dates and times in Excel. But before we can run, we have to learn to walk. And that means learning how to enter dates into Excel so that Excel recognizes them as dates in the first place. It turns out that dates are a special data type in Excel, which enable us to do all sorts of nifty date-specific calculations, as we'll see in future sections. But if we don't enter dates into our spreadsheet cells in certain specific ways, Excel will interpret what we mean to be a date as a plain old piece of text, no different than a bunch of letters. The safest way to get Excel to recognize our dates as dates is the method we've already used. The month, followed by a /, then the day, another /, and the year. Fortunately, Excel is smart and flexible enough, however, to allow us some measure of flexibility within this pattern. So if I enter 3/3/2021, Excel recognizes that as a date. If I enter 03/03/2021, Excel also recognizes that as a date. And if I even enter 3/3/21, Excel again is smart enough to recognize that as a date. But now if I enter something like, say, March 3/21, Excel doesn't seem to know what to do with that. So there is a limit to its ability to read our minds when it comes to entering dates. Now, even with all of this flexibility in terms of how we can get away with entering dates with different patterns, I recommend keeping it simple and remembering just one way to enter dates to keep things less confusing. But we're here to go beyond Excel's default formatting, so let's explore some of the formatting options we have for dates. So if we right-click one of our cells that has a date, and then choose Format Cells, we'll see that the Date section of the Format Cells dialog box is already selected. And here we have a variety of different date formats to choose from. One popular alternative involves the day and month actually being spelled out. So if we choose that, we'll see we get this kind of nice, very human-readable date format that is also a bit wordy. This may be something that works for you in certain circumstances when readability is at a premium versus brevity. Then we can look at another formatting option for our next date, and we'll see below the one that spells out the day of the week and the month is this other format that puts the year first, then the month, then the day, separated by hyphens instead of by slashes. So if we click OK here, you'll see it's just kind of another spin on how to format a date. So whichever one of these you choose, just remember that the format does not change the underlying date value. And because of this, while you're free to format your date with all of these patterns and more, I again recommend entering your dates only one way, since you can always reformat them to your liking later. So now that we've got dates covered, what about times? Let's say that I want to enter the time 4 p.m. into a cell. I'll just go ahead and create a new worksheet here, so we're starting with a clean slate. So if I just type 4 p.m. into a cell, hit enter, and then reselect, Excel still has our cell formatted as general, so it doesn't look like it's recognizing what we entered as a time. So now in the next cell over, let's try entering 4 p.m. again, but I'll put a space in between 4 and p.m. Wow, so two things happen here. One, Excel clearly understands that I'm trying to enter a time, since it took the liberty of adding the minutes portion of the time value that I didn't even type out. And second, we see that the cell is now formatted as something called custom. So what the heck does that mean? Custom formats are a series of specialized formatting patterns that Excel has up its sleeve to format various types of data. Excel includes several of these out of the box, so to speak, but also gives us the ability to create our own custom formats, as we'll see in a later video. But in this case, the custom format is effectively identical to a format that we can find under the time category. So if we right-click and go to Format Cells, we'll see that the custom category is selected by default, but if we go to the time category, we'll see that one of the formatting patterns here appears to be the same as what we entered: the hour, the minute, and then PM or AM. So if we click OK, we'll see that our format is unchanged. Now if we go back to that Format Cells dialog box to explore some of the other time formats available, you can see that another option is what's commonly referred to as military time, which does away with the concept of AM and PM and instead simply counts hours up from 0 to 23. Now if I reformat our 4 PM value in this fashion, you'll see that it changes to 1600, since 4 PM is technically the 16th hour of the day. Then going back to our Format Cells menu, we also see that several of the pre-built formats allow us to include seconds in our time value formats, just by adding another colon after the minutes value. Now, just as with dates, formatting the value that we entered in any of these ways will not change the underlying value, but simply how it's displayed in the cell. With that said, these formats do offer useful hints as to different ways we might enter times into Excel, so that Excel will recognize them as such. For example, if we wanted to enter 11:11 PM and 11 seconds, I could either use the AM/PM format, in which case I would type 11:11:11, and then a space, and then PM, or I could type 23:11:11 to give us the exact same value in military time. The choice is yours, but as with dates, I would recommend that you decide on a single method of entering times that you can remember the best, and stick with that, knowing that you can always reformat the value as you want to later. Now, dates and times are all very well and good, but it's very often the case that we need to combine them into a single value. A time without an associated date is not often of much use, and a simple date value sometimes lacks the precision we need from our data, since it doesn't distinguish between times of day. Let's go back to our shave ice tracker for an example of how combining date and time values into a single value can be useful. So I'll just switch windows over to that workbook. And you can see in our ledger here that I've created a new column to capture the date and time of each sale. Now I haven't entered any values into it yet, since we weren't tracking this when all of our past sales were made, but let's say hypothetically that I do know exactly when our last 2 sales were made, both the day and the time. If we want to capture both in a single value, we'll have to do something slightly different than we have thus far. But not too different, fortunately. In fact, all we need to do is enter the date, as we've already learned to do, followed by a space, followed by the time in whichever format you prefer, AM/PM or military. So assuming our order number 99 here was placed on March 5th, 2021 at 11:11 AM, we can just type in the 2 components as we've already learned. So over here in cell K100, I'll type 3/5/2021, and then a space, and then 11:11, and then a space, and then AM. And then if I hit enter, so far so good. And then if I reselect the cell, we see that Excel recognizes this as a custom format. So if I right-click the cell and go to Format Cells to bring up the Format Cells dialog box, we see that Excel recognizes what we entered as fitting one of its custom formatting patterns. This one here highlighted that has month, day, year, hour, and minute. but scrolling through these other custom formatting patterns, it doesn't look like any others have all of those components, the day and the time. So does that mean we're stuck with this exact format? Well, let's try entering another date/time in the record for Order 100, but with a time that will be handled differently between military time and AM/PM. So I'll cancel out of this dialog box, and then down in cell K101, I'll type in 3/5/2021, and then 2/22 space PM. And what we see is that despite the fact that I entered the time value as an AM/PM format, Excel insists on formatting it in military style anyway. So what do we do if we're not satisfied with the way our time is formatted here? So as it turns out, there is no dedicated date/time format in Excel. And Excel only gives us this one custom format that combines date and time out of the box. But the good thing is, Excel recognizes multiple input formats as date/times, as we've just seen. But it will format them as date plus military time regardless of how we enter them. I alluded to us being able to create our own custom formats earlier, and that is what we would need to do here to see something other than military time. However, that's a whole different can of worms that goes beyond just formatting dates, but one that we will definitely open coming up soon. Alright, up next, we'll talk about formatting methods that apply to any type of data. Words, numbers, or dates. I'll see you then. Hey, welcome back. Thus far, we've looked at formatting techniques that are specific to the type of data we're applying them to. But some types of formatting transcend data types and apply to anything we can type into a cell. So in this one, we'll explore a set of formatting techniques that most commonly apply to text data, words basically, but can also be used to enhance the appearance of dates and numbers. A good place to start is the column headers in our Shave Ice tracker, which could benefit from some visual pop to stand out from the rest of the data. First up, we'll take a look at the font of our data. Basically, the visual appearance of the individual characters that make up the values in our cells. Every character, whether it be a number, a symbol, or a letter, will have its own distinct look in each different font. Let's take a look at a couple different ones to show you what I mean. So if we look at the font section of the Home tab in our ribbon, we'll see the word Calibri. This happens to be the current default font in Excel. If we don't make any additional adjustments, all of our cells will be formatted with Calibri font. But if we click the down arrow next to Calibri, a drop-down list featuring a long list of other fonts is revealed. Now to see how different fonts can vary, let's scroll down to Arial, which is another common font. If we select that one by clicking it, and then look at cell A1, which we had selected, we see that the appearance of the individual letters has changed just a bit, but the difference is admittedly subtle. To make this distinction between fonts more obvious, let's now choose a different, somewhat more unusual font, Comic Sans, which is a personal fave of mine. Now instead of having to scroll through the entire list to look for it, we can instead again click that down arrow and then just start typing Comic Sans. And after a few keystrokes it pops up. So then we can hit enter to lock it in. And now we see that cell A1 has been formatted in Comic Sans in all of its glory. Now I've been told that designers and those more aesthetically inclined than myself tend to frown on Comic Sans. So if there are any design gurus out there, my sincerest apologies. I just couldn't resist slipping in a little Comic Sans given the opportunity. So to keep everything consistent, I'll go ahead and select all of row 1 by clicking the row header, and then choose Comic Sans to format all of our header cells with that font. Now in all seriousness, deviating from the default font in Excel is probably something you should do only if there's a good reason for doing so. If you're someone with a deep knowledge of design principles, Or if you're trying to stay consistent with design guidelines at your place of business, then by all means, change fonts to fit your needs. But if you're like me, the sort of person who likes Comic Sans, you might be better served just sticking to the default. So speaking of Comic Sans, while I like my new column headers, I sure wish I could make them bigger so I could see my beautiful font more clearly. This will involve adjusting the font size, which we can do very easily with this drop-down list next to the font type drop-down. So if we click this down arrow and just hover over these different sizes, we can preview what the font would look like if it's very small, all the way down to very, very, very large. I think I'll stick with a size 14 for now. And then I'll go ahead and auto-fit my column widths just to make sure we can see all of that beautiful Comic Sans. Now, there are also other formatting methods that apply equally across any font. One of these is bold, which makes text thicker and darker and is used to strongly emphasize something. So we can access this by clicking this B on the ribbon, or alternatively, by using the Control+B shortcut. Bolding text is a fairly common operation in Excel, so this is another one of those keyboard shortcuts that's probably worth memorizing. In fact, column headers are quite commonly bolded, so I think I'll select all of row 1 and then format it as bold. Note that I had to click B twice because I already had 2 cells bolded, so Excel's first instinct was to think that I wanted to unbold those cells. So I had to click once to unbold the 2 cells that were bolded, and then again to bold all the other cells. Now, another way to emphasize text a little bit less strongly is to italicize it. We can do this with the little slanted I shortcut on the ribbon. So just to show you that these techniques work equally well with numbers as they do with text, I'll apply this to our number 1 value here in cell A2. And as you can see, now the number 1 has that kind of rightward slant to it. Now, italics, at least in spreadsheets, are not as useful as bolding in my experience, and we don't really have a great use for them here, so I'll go ahead and hit Control-Z to undo my italicization of cell A2. And up next, I'll take a look at the underline command, which you can probably guess pertains to this U with a line under it. The underline format draws a small line under the text we apply it to. This is commonly used for titles and headings, so I think I'll go ahead and underline my column headers in addition to the bold formatting we already have in place. So I'll select row 1 again and then just hit this U. Now thus far, we've been making our formatting changes exclusively through these ribbon shortcuts. But we can access all of these commands and more via the Format Cells menu, just like when we were formatting numbers and dates. So if I right-click a cell in our data and choose Format Cells, and then make sure that this Font tab is selected, which it already was by default, we see all the options that we've already set, plus a lot more. For example, there's a section devoted to effects, which includes something called strike-through, which is an effect that's useful when indicating that a value should be disregarded. So if, for example, I wanted to maintain a record of my first order, but also provide a visual cue that it shouldn't be considered valid data alongside all my other entries, I could apply this strike-through effect to it. So let's go ahead and see what that would look like. I'll cancel out of this, and then select row 2, which has my first order. Then I can right-click, again Format Cells, and then check this strike-through box. And then if I click OK, we'll see that all the values in this row now have that little line through them. Now at this point, I'd be remiss if I didn't point out that in spite of our lovely Comic Sans font, our spreadsheet is a little, well, boring. Maybe that's because it's in black and white. Fortunately, Excel does not limit us to a black and white color palette. In fact, just about every color you can imagine can be brought to bear on the data we enter into our spreadsheets. To see this in action, with the first row selected, click the down arrow to the right of the letter A that's underlined in red on the font section, and a whole swatch, so to speak, of color options are suddenly available to us. And as we hover over each one, we get a preview of what our cells would look like with that particular color applied. Now we basically have two distinct sets of colors to choose from. At the top of the menu are the theme colors, which tie into Excel's default visual theme. This theme includes things like font styles, colors, and the like. These colors form a color palette, and as such are designed to be pleasing to the eye when used together. The first row here contains the primary theme colors, while the rows of colors immediately below simply contain darker or lighter versions of the primary ones. Then at the bottom of the menu, we have the standard colors, which are closer to your more familiar reds, greens, and blues. My recommendation would be, when you feel a need to apply a color other than black, which as we can see at the top of this menu is the default or automatic color, stick with the theme colors, as they were specifically designed by Microsoft to work with the overall visual look of the spreadsheet. And then choose lighter or darker versions as needed to provide the contrast you're looking for. Now, speaking of contrast, we're not limited to applying colors to simply the text in the cells. We can also fill the actual cells with these colors to provide additional contrast with the data we enter into them. So for example, if I select just the cells that consist of my column headers, which I can do just by selecting cell A1 and then doing Control, Shift, right arrow, I can then click the down arrow next to this little bucket icon on the font section of the Home tab, and then with the same palette of colors I had to choose from when jazzing up our fonts, I can choose a fill color for these cells. So I think I'll go with a nice dark blue. Then we can go back to our font color menu and choose a nice light color that will contrast well with the blue. Now I'd be lying if I said that I know for sure this looks good. Again, full disclosure, I am quite far from a design guru, but hey, it's pleasing to my eye. Now while I can't tell you what color contrasts would impress an artist, I can give you some usability guidelines for spreadsheets. An applicable one here is to make sure there is sufficient contrast between your text and your background colors so that your text is easily readable. If your text and background are both too light or both too dark, it will be difficult for your readers to make out the text, which sort of defeats the purpose of having a spreadsheet in the first place. No matter how cool your spreadsheet looks, the most important thing is that it is readable and usable. But hey, enough preaching from me. Up next, we'll go beyond formatting the text in our cells to explore how that text is oriented within the cells that contain it. I'll see you then. Hey, welcome back. In this one, we're going to explore the relationship between the text in our spreadsheets and the cell boundaries that contain it. In short, how text is laid out or aligned within a cell. Now this is much more of a visual thing than a conceptual thing, so it's probably best to just dive right into an example. So let's say we want to add a couple new columns to our Shave Ice tracker for the purpose of tracking customer satisfaction. The first column will have the text of any review or comment the customer might have left on social media, and the second column will contain any rating that the customer may have left, from 1 to 5 stars. To start, before we even get into text alignment, I'm going to show you a cool little formatting trick that can save you a lot of time. So we would naturally like for the headers of our new columns to match the formatting of our existing column headers. So does that mean we're going to have to replicate the process we went through before, in which we made custom selections for font size, color, and more? Not at all. Thanks to a nifty little tool called the Format Painter. So if we select any cell whose formatting we would like to apply or paint in some other cell, so I'll just choose K1 here, and then click this little paintbrush icon on the left side of the Home tab on the ribbon. That paintbrush is the Format Painter. So I'll go ahead and click that. And then finally click in the cell that we want to apply the formatting to, and I'll click cell L1. You'll see that the visual style is in fact copied. The fact that the font formatting has also been copied over isn't immediately evident, but as soon as we type in a name for our column, which I'll just call customer comment, you can see that the font formatting was retained as well. But if I scroll over a bit, and then click in the cell where our second column header is supposed to go, our trick doesn't work anymore. But that does not have to be the case. Now if we again select a cell whose format we want to copy, in this case that can be L1, and then double click the paintbrush icon, we can then copy that format to as many cells as we want. Then, to turn off the format painter, just click it again. And while I'm in here, I'll go ahead and call our second column header customer rating. And lastly, I'll just go ahead and get rid of these two additional column headers that I don't need. Okay, so now we can get down to the business of entering some data into our customer comment column. Now, as you know, customer reviews tend to be rather lengthy, whether they're positive or negative. People on the internet, it seems, like to use a lot of words. So to simulate this, I'm going to use something called lorem ipsum text, which is basically just a big heap of Latin words that people often use for sample or filler text. So if I scroll back down to the bottom of our ledger and go ahead and paste my lorem ipsum text to simulate our first customer comment, you'll see that the text is much wider than our cell is, so it ends up spilling out of the boundary of the cell. And if we scroll further to the right, you see that our text just keeps going and going and going. And honestly, this is probably much shorter than the average comment left on a review site. And it actually gets worse. Let's say we also got a review of 3 stars for this particular customer order, and we want to enter that value into cell M101. So if I just type the number 3 here, now we can't even see the comment text that's spilled out of the cell. Clearly, something needs to be done if we're ever going to actually read our customers' comments. Now we could try widening column L, but then we would just have a ludicrously wide column in our ledger that would require a ton of scrolling just to read the comments of. So the solution to this problem is something called wrapping text, which basically means formatting text in such a way that it can appear on multiple lines instead of the default scenario in which it only appears on one line no matter how long it is. So we can wrap the text, once we select our cell here, by hitting this little Wrap Text button in the Alignment section of the Home tab. Whoa! So now we can read our text, but the row containing our comment has suddenly gotten very, very tall. So what happened here? Well, hitting the Wrap Text button basically makes our row as tall as it needs to be to display all the text we've entered into the cell, given the width of the column. So the width of the column is kind of the constraint. But now our row is unreasonably high, and it could still be a little difficult to read the entire comment. Now we can try widening our column a bit, but this doesn't seem to help. Our row isn't getting any shorter. That's because wrap text doesn't work on an ongoing basis. It auto-adjusts the height of a row when you hit the button, but it doesn't keep adjusting it as you change the width of the column. So what we need to do here is widen our column a bit, like we did, and then reapply text wrapping. So let's hit the Wrap Text button once to undo the wrap text operation, and then hit it again to rewrap the text, but this time based on the new, wider dimensions of the cell. And now, with a little more horizontal real estate to work with, wrap text ends up yielding a pretty readable block of text in our cell. Now, if we had made our column wider up front, before pasting in the comment text, we might not have had to take the extra step of unwrapping and then rewrapping the text. Alright, so while we're in here, I want to show you one more, somewhat tangentially related trick that can make your life easier. Now thus far we've only looked at copying and pasting entire cells or groups of cells or even entire columns and rows. But sometimes Especially when dealing with large blocks of text like we see here, you may want to copy and paste bits and pieces of the text string, but not the entire value. There can be important information buried in the avalanche of words that make up long-form text like this. So if we wanted, just as an example, to grab just a sentence out of this text, you just double-click the cell as if you were going to edit it, and then just click before whatever piece of text you're trying to grab. So let's say I want to grab this sentence right here. Then you hold down the mouse key and drag until you've selected everything you want. And then finally, we can just use our Control-C and Control-V shortcuts to copy and paste the text into a different cell. But for the second time in this video, I digress. So now that we've got our text nicely wrapped, you'd think our work would be done. But as we look to the left in the same row, you'll see we have another potential problem. Our row is still quite tall to accommodate our comment text, but all of our other values are relatively short, and as such are practically hidden away, sitting on the floors, so to speak, of a bunch of very tall spreadsheet cells. It might help them to be more readable if we could format the cells in such a way that the values were centered vertically within the cells, rather than on the bottom. This is called alignment, and Excel gives us lots of handy shortcuts to align our text however we want to. These three buttons at the top of the alignment section on our ribbon, the ones with the little horizontal lines across them, help us align our data vertically. That is to say, either on the bottom of the cell, the middle, or the top. The default alignment is bottom, which is causing the readability issues we see here. But if we click the middle button with our rows selected, suddenly all of our values are floating in the middle of their respective cells, which seems in this situation to be an improvement. Now you could obviously also go with top alignment, but middle seems to work better for our purposes, so I'll revert back to that. And we're not quite done squashing formatting bugs yet. So if we scroll back right and look at our column header for our customer comment column, we see that it's stuck all the way over at the left side of the cell, which could make it a little bit confusing as to which column and thus data it pertains to. Much as tweaking the vertical alignment of the values in our row helped make them more readable, aligning values horizontally can have a big impact as well. In this case, similar to before, aligning to the middle probably makes the most sense, except in this case we mean middle in a horizontal sense. So instead of using the row of buttons on the alignment tab that we did previously, we'll go down to the next row, which allows us to align text horizontally. The default alignment is left, which is why, obviously, our header is all the way over there to the left. But if we click this middle button, and if we hover over it, we'll see that it says center. Now our column header snaps to the middle, which again seems like a nice readability improvement. Now, as with vertical alignment, we also have the option to align left or right as usability and design concerns dictate. Now, similar to vertical alignment, we also have the option to align left or right as usability and design concerns dictate. Alright, so that's it for alignment. Now that we've got a handle on what happens inside spreadsheet cells, up next we'll turn our attention to the outside, or borders of cells, and how we can melt these borders by merging multiple cells into one. I'll see you then. Hey, welcome back. Now that we've learned all about formatting the interior of cells, let's take a look at some formatting options that apply to the boundary around the cell, not what's contained within it. First up, we'll look at a concept called merging, which is a process by which you can combine multiple cells into one giant cell. So why would we want to do this? Let's take a look at an example to find out. Here we have our breakout of sales by shave ice flavor that we worked on previously. One thing we're clearly missing here is some kind of heading. Now there are only two columns, and it's fairly obvious what each one does, so this isn't necessarily a situation where each column needs its own header. An alternative approach we could take is to create one single header that spans both columns. So how can we go about that? Well, first, we'll need to insert a blank row above the first row of data. Now we have 2 blank cells above our 2 columns of data. If we want to turn these 2 cells into a single header that spans both of them, we'll need to somehow merge them together. To do this, select both cells, then click the Merge and Center button on the Alignment section of the Home tab. And as you can see, both cells have now been merged into a single cell. Now also take note of the fact that with this cell selected, Excel lists the address of the cell as A1. And if we navigate over and select the next cell to the right, its address is C1. Cell B1 has basically been merged into cell A1 and no longer exists as far as Excel is concerned. So now we can type some text for our header. I'll go with sales by flavor and hit enter. So not only does the text we typed span both cells, it appears to be aligned to the center of that cell. This occurs because we chose the Merge and Center command, but it's not necessary to center your text when merging. For example, if we click the down arrow next to Merge and Center in the Alignment section, we see an option to simply merge with no mention of centering. To see what this looks like, let's choose Unmerge to unmerge our cells, and then change the alignment of the 2 cells we have selected to be aligned to the left, which is the default in Excel. Note that the Merge and Center command not only merged our 2 cells, but it also changed the alignment of both to center. So now, with both cells selected, click that Merge and Center dropdown again, and then simply choose Merge Cells. And now our merged text is aligned to the left. Note that Excel took the text in the leftmost cell of the 2 we had selected and made it span both cells. This is the default behavior of merge. If you only have text in one cell, it will make that the value of the merged cell. But if you add text in multiple cells, merge will go with the value in the top leftmost cell in the range. So if I unmerge again, and then add a slightly different header to cell B1, let's just call it Flavor Performance, and then try to merge again, we'll see that Excel helpfully informs us of this behavior. And then if I click OK, you'll see that the value we typed in B1 disappears. Now another, less conventional but still fairly common way of constructing a merged header in Excel is to do so with a vertical orientation instead of a horizontal orientation. In our case, that would mean inserting a blank column where column A currently is, and then merging the cells in that column adjacent to our data into one giant cell. Let's see what that would look like. First, I'll go ahead and delete row 1 since we're going to add a new merged heading in column A. Next, I'll insert a blank column before column A to make room for our header. And now I can select cells A1 through A7, and then select Merge. Finally, I'll type in our same heading name as before, Sales by Flavor. Well, that doesn't look right at all. Our value is too wide to fit into the cell, and it's sitting all the way down there at the bottom of what is now an extremely tall cell. Now I could try aligning this vertically to the middle, and then widening the column to accommodate the text. And while this helps, some might think it's still less than ideal. One way to jazz up the effect of the header is to rotate the text so that it's oriented vertically. Let me show you what I mean. So if I click this little diagonal arrow up in the alignment section, we see a pop-up menu that gives us various options for orienting text. The most useful from my experience is Rotate Text Up. Let's try that one and see how it changes the look of our header. And now our header text has been rotated to read from top to bottom rather than left to right, which matches the tall but thin dimensions of our cell. Now we can actually narrow our column a little bit and the layout of our little table is coming along quite nicely. But there's one other effect that could help clarify the distinction between different parts of our data, and that's borders. Now you may be thinking, our cells already have borders. That's how we can tell the difference between one cell and the next. Technically this is true, but Excel allows us to layer in additional borders that are more visually distinct, which can be a useful visual cue to indicate separation between cells or even different regions of our data. So to start, let's highlight our entire table, and then click the down arrow next to this little grid-looking icon in the font section. And then from all of these border options listed, let's choose All Borders. And as you can see, Excel has drawn in heavier, darker borders between all of the cells we selected. Now, borders of this nature can be useful, but in my opinion, this isn't serving much of a visual purpose in this case. It might be more helpful to draw a border around just the three distinct sections of our data: our header cell in column A, our flavors in column B, and our sales percentages in column C. So how can we draw borders around a group of cells without drawing borders around every single cell within that group? Well, before we can do that, let's highlight our table again, and then go back to the Borders drop-down, and then choose No Border to erase the borders we've already drawn. Now let's select the first area that we want to encompass with a border, our merged cell in column A. Then we can go back to our Borders menu and choose Outside Borders. Next, we can repeat this process on our values in column B, and then again for column C. And now you can see that we've drawn a nice little outline around each of the main sections of our data. I think at this point our borders have definitely improved the readability of our little table by making it clear that it's divided into three main parts. Now, we don't only have control over which cells get borders drawn around them, but also the thickness of the borders. If you want to create special emphasis around one particular cell or section, you can draw a thicker border around it. For example, I might want to draw a thicker border around our sales percentages, since that's kind of the metric that we're interested in here. So to do that, I can select the values we have in column C, and then go back to our Borders dropdown and choose Thick Outside Borders. So if we click away from this, you'll see that the effect is subtle, but also enough to indicate some additional level of significance for this area of our data. All right, that's it on merging cells and borders for now. Coming up, we're going to shift gears away from formatting and towards some more advanced methods for sifting through our data than we've encountered thus far. I'll see you then. Hey, welcome back. Now that we've learned to enter data into Excel, manipulate it, and format it, it's time to learn some methods for efficiently sifting through all the data we've entered to find specific things we're looking for. The first technique we'll look at is called filtering, and it's as intuitive and easy to use as it is powerful. Filtering lets us search through the rows of the data we've entered and selectively display or hide rows based on criteria that we specify. Any rows that don't meet the criteria we've set are effectively filtered out or hidden from view. This technique is handy in just about any case, but it's another one of those methods that becomes more and more useful, if not essential, as the amount of data in our spreadsheets grows. Like so many features in Excel, filtering rewards us for setting up our data in a tabular fashion. If our data doesn't have column headers and consistent types of data in each column, filtering just doesn't work very well. Fortunately, we had the good sense to set up the data in our shave ice tracker in a tabular fashion, so applying filters is a snap. Really, it is just about as easy as snapping your fingers. If we click anywhere inside of our data, then navigate to the Data tab of the ribbon, and finally click on this filter button that looks kind of like a funnel. Now we see all these little down arrows to the right of all of our column headers. Let's see what happens if we click the one next to our order number column. So now we get a new dialog box that pops up. The first few commands pertain to sorting, which is something we'll get to soon enough. But if we look at the lower half of the dialog box, we see a list of unique values in the order number column with checkboxes next to each. All the checkboxes are currently checked, along with an additional checkbox at the very beginning that says Select All. If we uncheck one of the checkboxes, let's say the one pertaining to order number 2, and click OK, let's see what happens. And now we can see that our order number 2 has vanished from view. But never fear, it hasn't been deleted. If we want it back, all we have to do is click the Clear Filters button, which looks like a smaller version of the filters icon, but with a red X on it. So if we click that, our row number 2 reappears. But let's say instead of wanting to not see a particular row, we instead only wanted to see a small handful of specific rows. Now if we click the filter button on our order number column again and tried to uncheck all of the order numbers that we don't want to see, that would take a long time and just generally seems like a very inefficient way to whittle down to a small population. So how should we approach this? Well, if we uncheck the box next to Select All, we'll see that all of the other checkboxes have been unchecked as well. This means that none of the values in our data meet our filter criteria, which in this case is a good thing since we only want to select a few. So let's scroll down and select order numbers 42, maybe 44, maybe we'll go down and grab 55, and then hit OK. And now we can only see those 3 orders. So by unchecking all of the options and then scrolling through the list of unique items in the column and just cherry picking the ones that we're interested in, we were able to get down to those much faster than if we tried to individually uncheck everything we didn't want to see. Now, one really cool thing about filtered data is that we can copy and paste it elsewhere in our spreadsheet without copying any of the rows that we filtered out. So if I highlight our filtered data set here, which I can do using our Control-Shift right arrow, Control-Shift down arrow keyboard shortcut, and then hit Control-C to copy, and then hit our little plus sign down here to create a new worksheet, and then finally hit Control-V to paste, we see that we only have our 3 rows of data that we filtered for, and that none of the other rows that were filtered out have carried over. Now obviously our column widths didn't carry over, but if we click the top left corner of the grid and just double click the boundary between any 2 columns, we can auto fit the column widths. And now we've basically copied over only the rows of data from our sales tracker tab that we were interested in without having to manually scroll through that data and copy and paste the records over to a new tab one at a time. This technique can be extremely useful if you want to work with a filtered subset of your data without having to worry about handling a bunch of additional rows of data you're not interested in. Now, before we move on to more advanced filtering techniques, I want to clarify a couple of things. First is that the values listed in the filter dialog box represent the unique values in the column we're applying the filter to. So if I go back to our sales tracker tab and then first hit escape to undo our copy operation, clear filters, and then click the filter drop down for a column with fewer unique values. Let's say, and let me just auto fit columns here just so we can see our columns more clearly. Let's say the size column. Now there are only 3 options available for us to check or uncheck because there are only 3 unique values in that column. So obviously if our data set has 100 rows in it, there are 100 values in the size column, but there are only 3 unique values that appear. So that's all we see when we click that filter dropdown. We saw so many values when we click the order number dropdown because all of these order number values are unique. They each only appear one time in the data. Another point worth noting is the process by which the filter button decides what data on our worksheet is in scope for filtering in the first place. Now, because we'd organized our data in this tabular fashion, and because our data doesn't have any gaps in it, the filter button was able to accurately guess the boundaries of our data. But there's no guarantee that it will guess those boundaries if our data has gaps, such as blank rows or columns. For this reason, I recommend manually selecting the entire range of data you want to apply filters to before hitting the filter button if you have any doubts at all about the continuity of your data. It's an extra step, but it ensures that the results you're seeing are truly accurate and comprehensive. So just to walk the walk, let me go ahead and clear filters altogether by hitting our filter button once more. Then I'll select the top left cell in our range, A1, and then scroll down to the bottom of our data, and then scroll right to the last column in our data. And then holding down the Shift key, I'll click that bottom right cell in our data, and now I am assured that I've selected every cell in the range that I'm interested in. Then, after selecting all the data, I can click the filter button once more, and now I know that our filters apply to every row that we care about, so when I filter our data, I can do that with confidence. Okay, now that we have the basic idea of filtering out of the way, it's time to look at some advanced filtering techniques. We'll tackle those in the next video. I'll see you then. Welcome back. As with so many things in Excel, advanced filtering techniques are roughly divided into 3 groups, based on the main types of data they apply to: numerical data, text data, and dates. We'll start with number filters, which we can apply to our sale amount column. So if we click the filter dropdown for our sale amount column, we see a long list of sales amounts, which makes sense because there are so many different combinations of flavors a person can order, so we end up with a lot of distinct values. Now, to be sure, it may be possible that we would be interested in filtering for one or a few of these specific amounts by checking or unchecking checkboxes like we did for the order number column in the last video. But that doesn't seem very likely to me. Instead, a much more common scenario might be that we want to see any sales above or below a certain threshold. So if you look just above our list of values, you'll see an option called Number Filters. Excel offers this because it has detected that the values in this particular column are numbers. So now that I've hovered over that, a whole new set of options pops up, specific to filtering numbers. The one closest to what we're trying to do seems to be greater than, so let's click that. And here Excel is doing a great job of spelling out how this filter will work. If you just read through the dialog box, it says, show rows where sale amount is greater than, and then it leaves it to us to fill in the blanks. So let's enter the number 40 and click OK. And now our data has been whittled down to just those 5 rows with sales amounts over 40. And we can easily modify this to view rows below a certain threshold, say for example, under $10. To do this, I can first clear the existing filter on sale amount by clicking the filter arrow and then choosing Clear Filter from Sale Amount. Now I'll click the filter arrow again, go back to Number Filters, and then, just to put a slightly different spin on this one, I'll choose Less Than or Equal To, which works just like it sounds. Now the dialog box that pops up is very similar to the last one, so I'll just fill in the blanks once more with 10 to represent our threshold, and then click OK. And it worked just like before. But what if we wanted to apply multiple types of filters to the same column? Maybe we're interested in extreme values, also known as outliers, and would like to see any sales amounts greater than 40 or less than or equal to 10. Essentially a combination of the 2 filters we just applied. To do this, we'll need to apply a custom filter, but that's actually much easier than it sounds. So let's again clear filters on our sale amount column, and then go back to our number filter menu, and then we'll choose Custom Filter. And it turns out that the dialog box here is basically identical to what we saw before, just without options being pre-selected for us. So it's up to us to say whether we want the value to be greater than, less than, or so on. We'll go with greater than, and then enter 40. But now we need to add our additional criteria. Fortunately, we see another row right here below the other one we just entered our information into, so that looks like a promising place to start. In the dropdown, we'll scroll down until we find is less than or equal to, and then we'll enter 10 for our threshold. But notice that this little radio button next to the word and between our two rows is selected. That's actually not what we want. It's mathematically impossible for a sale amount to be both greater than 40 and less than or equal to 10, so we would never get any results. What we actually need is an OR condition, which will display a record if either of our conditions is true. So let's go with OR, and then click OK. And sure enough, we now only see sales amounts that are greater than 40 or less than or equal to 10. Pretty cool. So next up, let's take a look at some filtering techniques we can apply to text data. That is, basically anything that isn't a number or a date. Our advanced text filtering techniques generally revolve around the concept of pattern matching. That is to say, instead of searching for exact values, we search for values that fit a certain pattern. For example, values that begin with or end with a certain sequence of characters, but could otherwise vary outside of that requirement. For an example, let's click the filter arrow for our Flavor To column, and then hover over the Text Filters option, which again popped up because Excel recognizes the type of data in this column. And now we see a list of filter options specific to text data, just like we saw number-specific options previously. Now let's say we want to filter for any flavors in our Flavor To column that end with the word apple. So if we click the Ends With option, we again see a dialog box, similar to the one we worked with previously, that already has our search method filled out. Ends with in this case. So now we can just type apple in the text box and click OK. And now we can see that our data has been filtered to records that either have the value apple or pineapple in the Flavor To column, both of which end in apple. Another way to apply pattern matching is to filter for values that contain a certain piece of text, meaning it does not have to be in any particular position, not necessarily the beginning or the end, just somewhere in the text. This approach is naturally more inclusive than the ends with method we used previously, or its counterpart begins with. Any value that begins or ends with a given text string also contains it. To see how this works, let's search our Flavor To column for any values that contain a space. We'll follow the usual pattern of clearing the previous filter, then clicking the filter arrow again, and hovering over text filters, but this time we'll choose the Contains option. Then, in the same text box where we entered apple last time, we can simply hit the space bar once to effectively type in a space, and then click OK. And now we see all of our flavor names that consist of more than one word: passion fruit and snow cream. And just like number filters, we can combine multiple criteria using a custom filter. If we only want to add on to the filter we've already applied, we don't even have to clear filters from the column. Instead, we can navigate straight to Custom Filter after clicking the Filter dropdown, and we'll see that our existing filter is already in place. If we want to modify this such that we return any flavors that either end in the word apple or contain a space, we'll simply check the radio button next to OR, then select Ends With in the second dropdown, and finally type apple in the second text box and click OK. And now the records displayed reflect both of the criteria that we've applied. One more thing worth noting here before we move on to date filters. Our Flavor To column contains certain blank rows. This simply indicates that a customer only ordered one flavor, meaning there was no need to enter information for that particular order in our Flavor To column. It's quite common to want to apply filters to blank rows, so let's take a look at how to do that. So first we'll clear our existing filter, then we'll click the filter arrow again, and if we look carefully at the list of values, you'll see that one of the options is blanks. This is basically empty cells, and again something that's quite frequently the target of filtering operations, either to show all rows with a blank value in a particular column or to hide those rows. In our case, we'll show them by first unchecking the Select All checkbox to uncheck all the options, and then simply checking the checkbox next to blanks and clicking OK. And now we only see records that did not have a value entered in our Flavor To column. Okay, so lastly, let's have a go at filtering some dates. First, I'll clear the filters on our Flavor To column. But as we work on our date filters, I'd like for you to keep in mind that our filter on the Sale Amount column is still applied. Now, filters applied to different columns of our data are additive. That is to say, they build on each other, and they all have a say about whether a row will be filtered out or not. The more filters we add to our data on different columns, the fewer rows we'll see, because there will be more and more criteria that each row has to meet in order to be displayed. So as we're applying filters to date values, keep in mind that the rows we see don't just have to meet these new date criteria we're going to apply, but they also have to meet the criteria we've already applied to our Sale Amount column. So for the purposes of date filtering, we'll use our Sale Date Time column. So let's click the filter arrow for that one. Now instead of a list of values like we saw for number and text data, we instead just see 2 years listed with plus signs next to each. Digging deeper, if we click one of those plus signs, we see months rolled up under the year, each of which has its own plus sign. And then going even deeper, if we click one of those plus signs, now we see a list of days that belong to that particular month. And we can keep going, depending on how specific we want to be, from day down to hour to minute and even second. Now we're not going to get that granular here, but the point is that since Excel is smart enough to recognize the values in this column as dates with time components, it organizes the unique values in the column in this tree-like structure that lets us filter for broader or narrower slices of time as we see fit. So for example, if I just want to see data from 2020, I can uncheck the box next to 2021 and click OK. And now we're only seeing rows of data that meet our existing sale amount criteria and also had a sale date time in 2020. Now likewise, I can go back to my filter menu for the sale date time column, click the plus sign next to 2020, and then uncheck November, which means that now my only results will be from December of 2020. And you can keep going in this fashion, down as many levels through the hierarchy as you like, picking and choosing which years, months, days, and so on you want to see or do not. More often, however, we are likely to be interested in a specific range of dates, say before or after a certain date, or from the 15th of one month to the 15th of the next. Let's say we're particularly interested in all sales made after December 1st, 2020. To apply this filter, I'll first clear my existing filter, and then click my filter arrow for the sale date time column again, and then we'll hover over the Date Filters option in the filter dialog box. And then from this very long list of options we're presented, we'll choose After. And we again see our now familiar dialog box, which lets us specify custom filters. Now, Is After is pre-selected, so all we have to do is select our date of interest, which is December 1st. Because Excel is smart enough to recognize that we're dealing with date data, it actually isn't going to force us to type a date by hand. Instead, we get to use this nifty little calendar date picker that we can use to choose a date. So let's click that, and then I'll navigate to December 1st, 2020. But before we click OK, let's think about what Is After really means. We want any sales made on or after December 1st but is after sounds like it would give us anything after December 1st, not including that date. So let's click the drop-down box here and see if there are any other options that fit our need better. And here we see an is after or equal to option, which sounds like exactly what we need. So let's choose that and click OK. And just glancing at the dates we have left, it seems like our filter worked fine. Now let's take a crack at the other scenario I mentioned, in which we might want to filter for sales that occur between two specific dates. Let's say between January 15th, 2021 and February 15th, 2021. So let's clear our last filter, then go back to our filter menu, hover over date filters again, and then choose between from the list of options. And we see that this is once again pretty much the same dialog box we've been working with all along, but it's been pre-filled with some options that make sense for the particular thing we're trying to accomplish. In short, it's saying we should filter for all dates that are on or after the first one we specify, which in this case will be January 15th, 2021. And we see that the AND option is pre-selected for us here, all dates on or before the second date we specify, which in this case will be February 15th. At this point, I hope you're getting the hang of this dialog box and see that most of the advanced filtering options Excel gives us really just involve configuring the options in this particular menu. At this point, it looks like we've got all of our parameters filled in, so let's go ahead and click OK. And it looks like this filter worked as well. Now, there are obviously a whole host of other filtering options, which you can see if you just hover over the Date Filters option in the Filter dialog box. But most of these are relatively self-explanatory once you know how the filtering menu works. Not just for dates, but for text and number values as well. My hope is that at this point you understand the mechanics of this filtering menu well enough to figure out how to apply whatever filter you're looking for without needing to memorize every option Excel gives you. So now we've learned how to hide data we don't want to see to make it easier to spotlight what we're interested in. But sometimes, instead of simply showing or hiding data, it's helpful to rank our data points by some criteria so that the ones we're interested in bubble up to the top without the need for hiding any rows. This approach is called sorting, and we'll dive into that next. I'll see you then. Hey, welcome back. So now we know all about how to selectively hide rows of our data that we're not interested in using filtering. But sometimes filtering isn't enough. We can apply a filter to look at all sales above a threshold, for example, but the results returned are likely to be shuffled around so that the most expensive sale isn't any more likely to be at the top of our results than the least expensive one. Quite often, we're interested in seeing our data sorted in such a way that the most important data, and what important means is the criteria that we need to define, bubbles up to the top. Let's take a look at an example to show you what I mean. Back in our Shave Ice tracker, let's click the Filter button on our Sale Amount column and first apply a quick filter to only look at sales over $35. So we should be old pros at this by this point. We can just hover over Number Filters, go to Greater Than, and then just punch in 35 and click OK. And as you can see, we get a lot of results, but the most expensive sales, our sales over $40, are randomly scattered in with the rest. What would be really nice is to see the most expensive sales clustered at the top. So we can actually achieve this view by clicking our Filter button again, and then choosing Largest to Smallest. So this takes our filtered rows and sorts them by the value in our Sales Amount column, such that the most expensive sale is in the first row, the second most in the second row, and so on. Now obviously we have a few sales of the same amount, so these are all clustered together. Keep in mind that all of the other values in the same row as the sales amounts were moved along for the ride as well. If you sort by the values in one column, but that column is part of a larger range of cells that we've applied sorting or filtering to, the entire row that the value in the sort column is part of will be repositioned, along with that value. Now this sorting was only applied to rows that were still visible based on our filtering. So if we undo the filter we see that our sort order has gone awry. But we can now go back to the filter button and then choose sort largest to smallest again. And now our entire data set is sorted in this fashion. The ability to sort by one column is incredibly useful, but just as we might want to filter by multiple columns in our data, we often want to sort by multiple columns as well. To access this functionality, we'll actually have to go into a different menu that's specific to sorting. We can access this on the Data tab via the Sort button, which is located right next to our Filter button. So if we hit this, we immediately see two things. One is that Excel already recognizes that we have sorting applied to our sale amount column. So we actually see a row on this dialog box that says Sort by Sale Amount on Cell Values in order from largest to smallest. The other thing we see is that Sort has auto-selected the cells in our data range, which is because we have filters in place on that data. Also note that there is a My Data Has Headers option, which is grayed out because data with filters applied is understood by Excel to have headers by default. But now if we remove the filters from our data by clicking this filter button again, and then select the range of cells containing our data, which I'll do by selecting the top left cell in the range, and then scrolling to the bottom right corner of our range, and then holding down the Shift key and clicking that bottom right cell, and finally hit the Sort button again, you'll see that the My Data Has Headers checkbox is no longer grayed out, and it's checked by default. So let's uncheck this box, and then use the Sort dialog box to sort by our Flavor 1 column. So if I click this drop-down, I see that we don't have column headers listed here, just the actual columns themselves. So we'll actually need to figure out which column our Flavor 1 values are in. And it looks like it's column E, so we'll choose column E. And then otherwise we can stick to the defaults, sorting on cell values in order from A to Z. So let's click OK. Whoa, what happened? Our column headers disappeared. So where did they go? Well, if we scroll down through our data, we'll see that our column headers have somehow made it all the way down to row 42. So why the heck did this happen? Well, since we told Excel that our data doesn't have headers, it assumed that our Flavor 1 column header was just another value, and sorted it alphabetically along with all the other values in that column. And you can actually see here how the phrase Flavor 1 slots in alphabetically between cherry and mango. And this also illustrates how sorting by the values in one column, like column E here, will cause all the other values in that row to get moved alongside that value, which you can see since all of our column headers have moved down to row 42. Now, sorting our headers along with our data obviously isn't what we want, and I really just went through this exercise to illustrate to you that as long as the data you're sorting has headers, which if you're organizing your data in a tabular way, it should, that you should leave this My Data Has Headers checkbox checked. So let's hit Control-Z to back our way out of trouble. And now if we scroll up while looking at the values in our sale amount column, we'll see that our sort order from our previous sort was preserved. Let's take a crack at modifying this sort so that the smallest amounts show up on top instead of the largest. So it looks like our range is still selected, so we can go ahead and hit our Sort button again. And then in the Sort dialog box, we'll sort by Sale Amount, on Cell Values, and in order from smallest to largest, all of which are the defaults. Then click OK. And now we see that our smallest sale amounts have bubbled up to the top of our data. Now I mentioned previously that we need to use this Sort button if we want to sort by multiple fields in our data. So let's say we want to sort by both our sale amount, as we've already done, and also our shave ice flavor. So how would we do that within our Sort dialog box? Well, if we click the Sort button again, we'll see that Excel remembers that we already have one sort in place. We already have a row that says Sort by Sale Amount on Cell Values from smallest to largest. But if we look at the top left of this dialog box, we'll see an option to add level. So let's click that. And now another row of inputs pops up below the one we've already filled out. So first, we'll choose to sort then by flavor 1, on cell values, and from A to Z, basically alphabetically, such that flavors beginning with A would come first, and flavors beginning with Z would come last. Finally, I'll click OK. But now looking at our data, this doesn't seem to have had a huge effect on the values in our flavor 1 column. We see lots of examples right away of flavors that seem to be sorted out of alphabetical order. So what's going on here? Basically, when you apply multiple levels of sorting, the data is first sorted by the first column you apply sorting to. Then, your next sorting level only kicks in when there are multiple repeating values, that is to say, groups of equal values, in your first sort column. Now, within these groups of equal values, sorting can then occur on your second sorted column. So our first 5 rows here, all of which have the same sale amount, have subsequently been sorted by flavor 1 in alphabetical order, which you can see starting at blackberry, then mango, passion fruit, and pineapple. But if we move down to the 6th row, we'll see that the alphabetical sorting has reset, since we now have a value of apple in that row. And that's because in the sale amount column, we've moved on from that group of $6.96 sale amounts onto the next value. And it actually gets worse if we don't have groups of similar values in our first sort column, like we do here. If all of our sale amounts were different, our second sort level would be completely irrelevant, since there would be no groups of identical sale amounts to sort within. It really wouldn't be any different than if we just didn't sort by flavor 1 at all. So what's the lesson here? Basically, when you're applying sorts to multiple columns, sort by the column that has the fewest unique values first. If a column only has a few unique values, there will be large groups of similar values within that column that we can meaningfully sort within those groups by the values in our next column, which presumably has more unique values. So let's click our sort button again, and then swap the order of our 2 sorted columns using the up arrow in the sort dialog box. So I'll click our second sort, and then click this up arrow, and now we're sorting first by flavor 1, then by sale amount. Finally, I'll click OK. And now we see that the dynamic has been reversed. Our data is now sorted alphabetically by the values in the flavor 1 column, and then within each group of rows pertaining to a particular flavor, there's another layer of sorting applied, this one based on sale amount. And then the sale amount sorting resets every time we hit a new flavor. So what if we wanted to add another layer to our sort? Let's say the style column. Let's think for a moment about where that should fit in relative to the other 2 columns we've already sorted on. So if you look at the distinct values in the style column, you'll see that there are really only 2, mainland and island. Compare this to our flavor 1 column, which has several unique values based on all the flavors we offer, and it becomes clear that we should sort first by style, then by flavor 1, and finally by sale amount. So let's click our sort button again, and then add a new sort level, in which we'll sort by style from A to Z. Then finally we'll click that row, and then click the up arrow to move it first in the sort order. And now if I click OK, we'll see that all of our island style rows are grouped first, followed by all of our mainland style rows. And then the rows belonging to these groups are subsequently sorted in alphabetical order by the values in the flavor 1 column. And then finally, the rows in these subgroups are sorted from smallest to largest by sale amount. So thus far, we've sorted by a number, sale amount, and a couple of text values, flavor and style. But what about dates? Let's throw in a sort on sale date time, replacing our sort on sale amount. Now, if you think about the types of values in our sale date time column, they're really even more likely to be unique than our sale amounts. Even in our sale amount column, you see some groups of repeating values since we're selling the same types of items over and over again. But it's unlikely that we ever processed a shave ice order at the exact same time as another, so the values in our sale date time column should be almost entirely unique. With more unique values, you should be thinking that this sort needs to be applied last, after our other two. So going back to our sort dialog box, let's select our sale amount sort and then delete that by clicking our delete level button here. Then we'll add a new sort level. We'll sort by sale date time, on cell values as usual, and from oldest to newest, which is a date-specific option that Excel is smart enough to give us because we're sorting on a column with date values. We would also have the option to sort from newest to oldest if we wanted. Now I'll click OK. And if we scroll back through our data again, we'll see that our first two levels of groupings remain unchanged. We still have our rows grouped by island, style, and then mainland, and then within those groups by our different flavors. But now these subgroups of style and flavor are sorted by sale date time from the oldest date to the newest date. Pretty cool. All right, we've pretty much covered the bases of entering, manipulating, and parsing raw data in Excel. And these are, in fact, all things Excel is very good at. But where Excel really shines and separates itself from just about any other application in the world is its ability to make complex calculations and formulas, and I don't just mean math, accessible to non-programmers. With the solid base we already have in Excel, it's time to take things to the next level by exploring formulas and functions. We'll start our journey down that road in the next video. I'll see you then. Welcome back. Now we're going to begin our exploration of the one thing that spreadsheets probably do better than any other type of software: formulas and functions. If you remember the word formula from your math classes, it probably brings to mind bad memories of algebra and trigonometry. And while those algebraic and trigonometric formulas can absolutely be performed in Excel, the word formula has a slightly broader meaning in the world of spreadsheets. In Excel, a formula is basically just an operation on one or more pieces of data that yields some new piece of data. This operation can be performed on numerical data and include things like trigonometric calculations, but it can also be an operation on dates and times or even text data. But since formula operations on numbers are probably most familiar and intuitive, we'll start there. So let's first see if we can get 2 plus 2 to equal 4 in Excel. To write this formula in cell A1, we first need to type in an equal sign. All formulas and functions begin with an equal sign, which signals to Excel that we are not just entering a static piece of data like a number or a date. Now take note at this point of the fact that we now see an equal sign in both our cell and the formula bar just above the grid. You can actually write or edit your formulas in either place, but I tend to prefer the formula bar, as it's a little more visually distinct and can actually be expanded to make room for longer formulas by clicking this little down arrow on its right side. Just know that clicking in the formula bar will allow you to enter either values or formulas in whatever cell you had selected before you clicked there, which in this case was cell A1. Okay, moving on with our actual formula, we'll next type 2, and then a plus sign, and then another 2, and finally hit enter. And there we have it. 2 plus 2 still equals 4 in Excel. Now, there are, of course, a whole slew of other arithmetic operations we can perform in Excel, most of which we'll save for another video. But let's take a quick look at subtraction, which works just like addition. So if I want to subtract, for example, 7 from 11 in cell A2, I can just type equals, and then the number 11, then the minus sign, then the number 7, and finally hit enter. And once again, our answer is 4. Now these sorts of calculations are all fine and good, but you might be wondering at this point how what we've been doing is any different than just punching numbers into the calculator on your smartphone. And in fact, the answer is not a lot. What gives Excel formulas their power is their ability to separate the inputs to the formula, and in this case, that's the numbers 11 and 7, from the actual calculation we're performing on them. This way, we can see the inputs and the result of our operation on them side by side, and more importantly, vary those inputs and see the impact on our result. The key to this is to avoid entering actual values in your formulas, and instead reference cells elsewhere in your spreadsheet that contain those values. So let's go down to cell A4, and there I'll type the number 11, and then I'll tab over to cell B4, and I'll type the number 7. Then I'll tab over to C4, and in C4 we're going to enter a formula, but just a little bit different than what we've been doing thus far. I'll start with equals, as we always should, but then I'll type the address of cell A4, which is just A4. And you see right away that Excel knows that we're referencing that cell because the cell lights up. And then a minus sign, just like we did before. And then you can probably see where this is going. I'll type B4 and then hit enter. And as you see, we got the same result as before. So when you use a cell address in a formula in Excel, Excel uses whatever value is stored in that cell as though you had typed that actual value in your formula instead. So when Excel is interpreting our formula here in cell C4, it looks up the value we've stored in A4, then subtracts the value we stored in B4, and finally returns the result in the cell we typed our formula in. The value of this approach really starts to become clear when we want to change the inputs to the formula. So let's say instead we want to subtract 273 from 1,111. All we had to do was update the values in our input cells, and our formula automatically refreshed with an updated output. So now our inputs and our formula output are side by side, giving us visual insight into the effect of our inputs on our calculation. This is valuable even on a small, simple formula like this. But Excel formulas can get a lot longer and more complicated. We can have as many inputs as we want, for example, and formulas can actually reference the output of other formulas. For example, if I go down to cell A6, I can create a formula that adds all three of our values from row 4, one of which is a formula. So I'll just type equals A4 plus B4 plus C4. Now, as our formulas grow, it becomes more essential to separate our inputs from the calculation being performed in the formula itself. The whole point of formulas and functions in Excel is to be able to vary the inputs to our calculations so we can then see how our output changed. So now I've got a formula that's referencing another formula that's referencing two inputs. So if I change that first input, the value in cell A4, to maybe the number 300, now both of our formula cells update. So if you have actual numbers in your formulas and not references to other cells, this won't work. You can't vary those inputs unless you actually go into the formula and edit the formula itself. So entering data into your formulas, like we did up here in cell A1, where we actually typed the number 2 into our formula, is called hard coding, and it's a big no-no when dealing with formulas in Excel. You should avoid hard coding at all costs, except in cases where one of the formula inputs is something that just doesn't vary, like maybe the value of the number pi, for example. Okay, so enough preaching about that. Before we go, I want to show you an even easier way to reference cell values in your formulas. Up to this point, we've just been typing out the cell addresses, which can get a little cumbersome as our formulas grow longer and we need to reference more cells. But instead of typing out the cell addresses, once you've typed the equal sign in either the cell or the formula bar, you can actually just click in the cell you mean to reference. At that point, Excel will automatically enter the cell address for you. So as an example, I'll actually rewrite our last formula using this technique. So I'll just go ahead and delete my formula in cell A6 where I added A4, B4, and C4. And now I'll again type equals. But instead of typing out A4, I'll just click the cell. And then another plus sign, and then I'll click B4, and then another plus sign, click C4, and enter. Just like that. All right. There's far more to talk about with formulas than we could possibly fit into one video, so I'm going to leave off here. Up next, we'll dig a little deeper into how to perform some of the most common mathematical calculations in Excel using formulas. I'll see you then. Hey, welcome back. Now that we've explored the basics of creating formulas in Excel, let's dig a little deeper into performing mathematical computations with formulas. We briefly looked at addition and subtraction in the last video, but there's actually a whole range of other mathematical operations you can perform in Excel. Let's begin at the beginning by briefly recapping addition and subtraction. In our example workbook here, we have a couple of input cells, B1 and B2, and then a series of cells that we're going to fill in with the results of various types of calculations on our two inputs. Starting in cell B4, we'll add our two inputs by typing an equal sign, and then selecting cell B1, and then typing a plus sign, and then selecting cell B2, and finally hitting enter. Then we can subtract cell B2 from cell B1 in the same way. Equals B2 minus B1, and enter. Now is where things get a little more interesting. We haven't looked at performing multiplication in Excel yet, and if your instinct is to look for the traditional multiplication symbol, which looks like an X, you might be in for some confusion. In fact, the multiplication operator in Excel is the asterisk or star character. As far as Excel is concerned, an X is just a letter in the alphabet, nothing more, nothing less. So to multiply our two values together, I'll type equals B1, and then times, and as you can see, that's the asterisk or star, whatever you want to call it, and then B2, then enter. Up next is division, which again uses a different symbol than you might be familiar with. Excel uses a forward slash for division. So to divide our first input by our second, I'll type equals B1 forward slash B2, and then enter. Now lastly, we'll take a look at exponentiation, a crazy sounding word that really just means taking a number to a certain power. Squaring a number by multiplying it by itself is really just exponentiation, in which the number 2 is the exponent. So what strange character does Excel have in store for us for exponentiation? The answer is the up arrow icon, which you'll place directly after the base number and before the exponent. So if I wanted to square our second input, in other words, raise it to the second power, I would type equals, then click the input cell, then type the up arrow icon, finally type the number 2, and then enter. And there we have 49, which is the result of squaring 7. So all of these calculations are simple enough, as long as we perform them one at a time. But certain formulas you may need to replicate in Excel require you to combine multiple kinds of operations in a single formula. These more complex formulas may give you unexpected results if you don't have a good understanding of the order in which Excel executes formula operations. Let me show you what I mean. So let's say we want to add our two inputs and then multiply the result by 2. Seems simple enough, right? So maybe the most intuitive way to go about this, and I'll do this in cell B14, would be to say equals B1 plus B2 and then times 2. So let's hit enter. Now I'm no mathematician, but 21 plus 7 times 2 is not 35. This doesn't look right. So what happened? So unlike what our intuition might lead us to believe, Excel doesn't simply perform these calculations from left to right. Instead, it follows a defined order of operations that applies to all calculations in Excel. I'll go over what that exact order is in a moment, but for now, just know that multiplication has higher precedence than addition. This means that the first operation Excel performed was to multiply our second input here by the number 2. Then, the output of that calculation was added to our first input, leading to the result we see. The result isn't incorrect per se. Rather, Excel just misinterpreted our request. So how can we override this order of operations to force Excel to execute our calculations in the order that we want? That is to say, to add our 2 inputs first, then multiply them by the number 2. The answer is parentheses, which you will need to make friends with if you want to do any serious formula work in Excel. So by wrapping an operation in parentheses, you can effectively force Excel to perform that operation first, regardless of where it fits into the standard order of operations. In this case, we want to make sure our addition operation is performed first. So all I need to do is wrap our addition in parentheses. So what I'll do down here in cell B16 is type equals, and then an open parenthesis, and then our B1 plus B2 expression, and then I'll type a closing parenthesis. So now our addition operation is wrapped inside of parentheses, and then multiply that by 2. And now if I hit enter, it looks like we got the correct result. So at this point you may be asking, what exactly is this mysterious order of operations? Well, this handy little table here breaks down which operations Excel performs first, as well as the symbol associated with that operation in Excel. Now, as you can see, just like we discussed, any operation wrapped inside of parentheses takes precedence over any other operation, which gives us ultimate power to dictate the order in which operations are performed. Next up is exponentiation, followed by multiplication, then division, then addition, and finally subtraction. Now, do I really expect you to commit this table to memory? Heck no. This is not high school biology. While you should remember the symbols associated with these operations, asterisk for multiplication, / for division, etc., the exact order of operations is more of a nice to know. I say this because we have the ability to control the order of operations with parentheses, and because we should be using those parentheses anyway, since they make the intentions of our formula clear. Even if we don't technically need the parentheses, they can still serve a valuable role in making our formulas easier to read. Let's say in our earlier example, I really did want to multiply our second input by 2 before adding our first input. So going back to our formula in cell B14 here, let's say that the output of this formula actually is what I wanted. I really did want to multiply our second input, 7, by 2, and then add 21 to that. So without parentheses in this formula, that's what the formula does by default. But I can still make my intention here more clear by wrapping parentheses around the second operation. So if I put parentheses around this B2 times 2 operation within the formula and hit enter, the result of the formula remains the same. But just looking at the formula, it's clear to me or anybody else who might be looking at it that I intended for this operation, this B2 times 2, to come first. In a case like this, in which we apply parentheses to an operation that was going to come first anyway, they basically have no tangible effect on the output. But somebody reading our formula will know that we intended for that second operation to occur first, as opposed to thinking that we might have just forgotten parentheses around the first operation. In fact, if I saw a formula like this with no parentheses, my first assumption would probably be that the formula's author intended for the addition operation to be performed first and simply forgot to add parentheses. So at worst, parentheses add clarity to our formulas, and at best they enable us to override Excel's order of operations and dictate our own. The bottom line is, don't hesitate to use them liberally in your formulas. So I alluded to this briefly, but Excel formulas are not limited to merely math. Far from it. We can also use them to perform operations on dates, and even, surprisingly enough, text values like people's names. We'll take a look at formulas that operate on text data in the next video. I'll see you then. Hey, welcome back. So far, we've looked at applying Excel formulas in the most obvious possible way to arithmetic calculations like addition, subtraction, and multiplication. But in Excel land, formulas need not be limited to numbers only. For example, we can also apply formula operations to text. Now with that said, our options for doing so, at least until we start digging into functions, which are a related but distinct entity from formulas, are a bit more limited than those for working with numbers. As you might imagine, there's no concept of things like division or multiplication when it comes to formula operations on text. However, we are able to perform a kind of addition between text values and our formulas. This addition, so to speak, of text values has a special name: concatenation. Instead of the plus sign that we use for adding numbers together, concatenation uses the ampersand operator. But what the heck does concatenating, text really mean? Let's take a look at an example. Here in our example worksheet, similar to the one for our last video, we have some input values that we'll combine and manipulate using formulas to produce certain outputs. For instance, in row 2, we have a first name, a last name, and then a blank cell in which we'll try to add or concatenate those values together. So adding text values really just means combining them end to end. If you add 1 plus 2 arithmetically, the answer is 3. But if 1 and 2 were both text strings, concatenating them would yield 12. Make sense? Alright, so in this example, we want to create a single text string consisting of our last name in cell B2, followed by our first name in cell A2. To do this, in cell C2, we'll type equals, then B2, then the ampersand, and finally A2, and then hit enter. Well, this kind of worked. Our first name and last name values have now been combined into a single text string, and the last name does precede the first. However, what we're missing is the comma that conventionally separates last and first names when they're listed in this order. So how can we go about adding in that comma? Well, just like addition, we're not limited to concatenating only 2 strings in a single formula. As such, we can try concatenating a comma between our last name and our first name. So if we go back into our formula, and then type a comma after our ampersand, and then another ampersand to glue that comma to our first name from cell A2, keep in mind here that just as with addition, you need an ampersand between any 2 text strings you're trying to concatenate together. And then it looks like we can go ahead and hit enter. And Excel does not like this one bit. So what went wrong? So the issue here, which this dialog box is not doing a particularly great job of explaining, is that Excel treats text values as distinct from numbers and requires us to enter raw text values, like a comma, as opposed to text data in cells that we reference, with double quotes around them to set them apart from other types of data. So if we want to include a comma in our text string, we'll need to surround that comma with double quotes. So if we go back into our formula by clicking OK, and then add some double quotes around our comma, and then hit enter, now our formula works. Next, we'll try rearranging our name in a more conventional way, in which first name is listed first, followed by a space, followed by the last name. The real question here is, how do we force a space in between our 2 names? Well, In Excel, a space is treated the same as any other character. So if we want to concatenate a space between our first name and last name, we just need to wrap that empty space in double quotes, just like we did with the comma in the last example. So let's try that. We'll type equals, first name, and then ampersand to concatenate, and then a double quote, and then I'll hit the space bar on my keyboard, and then another double quote, and then an ampersand, and then our last name, and then hit enter. And it works. Now, just to solidify these concepts, we'll apply the same techniques to a couple of slightly more involved examples. If we want to combine last, first, and middle names with a comma after the last name, we can do so by simply adding more inputs and ampersands to our previous formula. So if we want to do last, then first and middle, we can type equals, and then the last name, and then concatenate in a comma surrounded by double quotes, and then another ampersand to glue in the next piece, then the first name, then another ampersand, then more double quotes surrounding a space for our space between the first and middle names, then one more ampersand, and then finally the middle name. Now lastly, we can spell out the full name of proud Kentucky native Billy Ray Cyrus using the same techniques down here in cell D14. So we'll type equals, then the first name, then a space wrapped in double quotes, another ampersand, the middle name, another ampersand, and then another space wrapped in double quotes, yet another ampersand, and finally the last name. And there we are. Now one more thing before we go. Earlier, I alluded to the idea that concatenating the numbers 1 and 2 would equal 12. You might have thought I was exaggerating to make a point, but not really. The trick is, you have to tell Excel to treat the numbers 1 and 2 as text strings. And as we've already seen, double quotes are the way that you signal to Excel that what you're enclosing within them is text. So in cell A18, which is merged, as you can see, if I type in equals 1 plus 2, but then wrap the 1 and 2 in double quotes, so I'll type equals 1, and then I'll use our text addition operator, our concatenation operator, the ampersand, and then 2, and hit enter, you'll see that 1 plus 2 can in fact equal 12. All right. While we've really only explored one fundamental text operation here, I can assure you that Excel provides many, many more ways to manipulate text. Most of these, however, require the use of formulas, which is a topic that we're going to jump into very soon. In the meantime, though, we're going to take a look at formula operations on dates, which have their own unique spin on addition and subtraction in Excel. I'll see you then. Hey, welcome back. So we've looked at how to perform operations on numbers and text with formulas in Excel, so now it's time to do the same with dates. But before we start playing around with date calculations, you first need to get inside of Excel's brain to understand how it processes dates behind the scenes. Trust me, this will help you make sense of quote-unquote date math in Excel later on. First up, let's do a little exercise. Here we have the date April 17th, 2021 in cell B1. Just for grins, let's try formatting that as a number and see what happens. So we'll just format as a number. Very strange. Not only does Excel let us format the date as a number, it also returns an extremely specific number of 44,303. So now let's reverse the dynamic. Next, we'll try formatting the number 1 here as a date. And here we get January 1st, 1900. So what the heck is going on here? Well, the whole key to understanding dates in Excel is the fact that as far as Excel is concerned, time began at midnight on January 1st, 1900. And behind the scenes, Excel looks at every date value in terms of how many days that date is past the beginning of time, so to speak. So April 17th, 2021 just so happens to be 44,303 days after midnight on January 1st, 1900. But why does Excel choose to look at dates this way? The answer is that looking at dates as numbers behind the scenes allows you to perform certain calculations on them as if they were numbers, namely addition and subtraction, which you can perform both between dates and between dates and numbers. Before we move on to examples of these types of calculations, I also want to show you how Excel looks at times. It turns out it's pretty much the same deal as with dates. So first, let's try formatting 1.5 as a date time. So I'll go down to Format Cells, and I'll choose our one custom format that allows us to put a date together with a time, and click OK. And now we see we get the same date as before, but there's also a time component of 12 o'clock or 12 noon. So why do we have a time component, and why is it 12 noon? Well, the thing is, Excel just looks at times in terms of fractions of a 24-hour day. Since 12 noon is exactly halfway through the day, its numerical value is 0.5. So when we formatted 1.5 as a date time, Excel gives us the date, January 1st, 1900, plus the time component of 12 hours past midnight on that date, or 12 noon. Similarly, if we had chosen 0.25, our time component would be 6 a.m. Or if we had chosen 0.75, our time component would have been 6 p.m., or 75% of the way through the day, and so on. Now likewise, if I go down here and format April 17th, 2021 at 12 noon as a number with a decimal component, and click OK, we see that instead of 44,303, we get 44,303.5. Now it's important to understand that all dates in Excel are understood to have a time component, not just dates that we explicitly enter with a time component or decimal numbers that we subsequently format as dates. It's just that this time component is understood by default to be midnight, i.e. 0 minutes after the date. So if you format any plain old date value to include a time component, like our date value right down here in cell B13, so if I just format that as custom, and again our only date time format that's built in, you'll see a time component consisting of essentially a string of zeros. Basically, Excel understands the value we entered to represent midnight on that particular date unless we tell it otherwise by explicitly adding a time component. Hopefully at this point, Excel's perspectives on dates and times is clear. Okay, with that understanding in mind, it's time to look at some examples of date formulas. First, let's try to add a number to a date. So down here in cell C3, I'll add 400 to March 13th, 2020. So I'll just type equals A3 plus B3 and then enter. And we get April 17th, 2021, which, as you might have guessed, is exactly 400 days past March 13th, 2020. Just understand that behind the scenes, Excel is converting March 13th, 2020 to its equivalent number, then adding 400 to that number, then formatting the result as a date. And if, for example, I had added 400.25 instead, you can see that instead of our exact date and time being April 17th, 2021 at midnight, it's now April 17th, 2021 at 6 a.m., or 25% of the way through the day. Next, we can try reversing this calculation by subtracting 400 from April 17th. So I'll just do equals our date minus our number. And just like we'd expect, we get March 13th, 2020. As long as you understand how date math works in Excel, calculations like these actually become pretty predictable and routine. Now you can also perform calculations between two date values instead of a date and a number like we've been doing here, although some of these make more sense than others. For example, down in cell C13, we can try adding two dates together. So I'll try equals and then our first date plus our second date. But what we get is a date ludicrously far into the future. Again, Excel is simply taking the number of days past midnight at January 1st, 1900 that each date represents, adding those numbers up, and then formatting the result as a date. So while adding dates like this is technically possible, it usually doesn't yield outputs that make a lot of sense. Now, by contrast, subtracting one date from another can be an extremely useful application of formulas in Excel. If you want to quickly ascertain the number of calendar days between the two dates, you can simply subtract the older of the two dates from the newer, i.e. the smaller number from the larger number. So we can try this by subtracting March 13th, 2020 from April 17th, 2021. So I'll just say my newer or larger date minus my older or smaller date. And I get 400 just like we would expect. Now you could also subtract the newer date from the older date, but I'm sure you understand what's going on well enough at this point to know that you would, in effect, be subtracting a larger number from a smaller number, meaning our result would be a negative number. So just for grins, I'll try that. So 3/13/2020, and then 4/17/2021 as our second input, and now we get a result of negative 400, which doesn't make a lot of sense in terms of date and times, unless you're in the Marvel Cinematic Universe, I guess. Okay, so now we've looked at how to apply formulas to the three fundamental data types in Excel. And while these are in fact extremely useful techniques, we've really only applied these formulas to a small handful of inputs at a time. In the real world, we often want to apply calculations like these not just to a couple of inputs, but to long columns of data consisting of hundreds or even thousands of inputs that we would like to perform the same type of calculation on. Now obviously, we can't feasibly be expected to write formulas individually against input in thousands of different cells. Fortunately, replicating formulas across different cells is actually a snap in Excel. We'll look at how to do that in the next video. I'll see you then. Hey, welcome back. So knowing how to manipulate data with formulas is great, but if we can only write these formulas one cell at a time, we're going to have a tough time keeping up with the demands of real-world data. So far, we've been working with a few input cells at a time, but a much more common scenario is that we'll have hundreds or thousands of rows of data in which certain values from each row form the inputs to our formulas. Unless you're a fast enough typist that you think it's a good idea to type out a formula for every row of a large data set, we'll need to come up with a better way of replicating our formulas. Fortunately, Excel actually allows us to copy and paste formulas in the same way that it allows us to copy and paste numbers, text, or dates. However, there are a few additional guidelines we'll need to keep in mind when copying formulas. Let's take a look at some examples so this can all sink in. Back in our familiar shave ice tracker, you'll see we added a column called Number of Flavors, and that we've removed the data from our sale amount column. With our Number of Flavors column, we now have all the inputs in front of us to calculate the sale amount ourselves. Doing so, as you might imagine, will involve a formula. First, let's take a crack at writing that formula for our first row of data. So the way our pricing system works is that each cup of shave ice costs $3 by default, and then we charge 99 cents for each additional flavor. Finally, we multiply the cost of an individual shave ice treat by the total quantity that we see in column D. So if we were to write that formula out using the techniques we learned in the last video, we'll do an equal sign and then an open parenthesis because we want to first calculate the number of flavors times the amount we're charging per flavor, and then we want to add that to our fixed price of $3 for each cup of shave ice, and then we'll wrap all of this in parentheses so we can multiply it by the quantity, the number of these that the customer ordered. So then if we hit enter, we get our sale amount. And actually, just to keep the proceedings a little bit clearer, I'm going to remove that strike-through effect that I had originally added to this row. So I'll just format, font, remove the strike-through. All right. So this formula works just fine. The problem is we have about 100 more rows of data that we need to perform this exact same calculation on, except the inputs are going to change from row to row. Now we could try typing this exact same formula out in our third row of data, but that honestly doesn't seem like a very good use of our time. Aside from which, typing errors being as common as they are, most likely at some point we'd end up mistyping a formula and incorrectly calculating a sale amount. So what's a better way? This is where copying and pasting comes in. So without further ado, let's select our cell K2 that contains our formula, hit Control-C to copy, and then select cell K3, and then Control-V to paste. So the number we see looks plausible, but let's inspect the actual formula in the cell to see what was copied. And we see that instead of copying the exact text of our previous formula, Excel actually changed the formula such that all of our references still line up to the current row. You see that instead of referencing cells D2 for the quantity of the order and J2 for the number of flavors, we're now referencing cells D3 and J3. Now this happens to be exactly what we wanted. So did Excel read our mind or what? Nope. This is actually just Excel's default behavior when we copy formulas. Unless we specify otherwise, something we'll get to in another video, formulas use what are called relative references. This means that when we reference a cell in a formula, the cell reference is understood by Excel to be relative to the cell that contains the formula in terms of position. So if I write a formula that references a cell immediately to the left of that formula, like our formula in cell K3 does, and then copy that formula to another cell, like say for example K5, the copy of the formula will now reference the cell immediately to its left, in this case cell J5, not to the left of the cell that we copied. Excel does this because the most common scenario when copying formulas is not that we want to keep referencing the cells that the original formula did, but rather that we want to reference inputs in other rows of our data that are aligned with our new copied formula. So copying formulas one at a time like this is certainly better than typing them out individually, but it could get somewhat painstaking if we have to repeat the process over too many rows. Fortunately, we can actually copy a single formula over a whole range of cells in one fell swoop. So if I copy our cell K2 with Control-C, and then select all of the cells in our data in column K by scrolling down, finding the last cell, and then holding down our Shift key, and then clicking, and then finally hit Control-V to paste, it looks like all of our formulas were copied down. If we go down to the very last cell of our data in that column using the Control down arrow shortcut, it looks like all the cell references in that formula line up with that particular cell. And then just arrowing up through a few other cells, it looks like our formula was copied down fine. So this worked great, but there's actually an even faster way to copy formulas as long as our data is set up in the tabular fashion that we see here, and we're trying to copy a formula down a column that is adjacent to other columns of data. This method uses our old friend autofill, the same technique we used to create series of numbers and dates earlier in the course. To see this in action, let's first wipe out all the formulas in our column except for the very first one. So I'll just scroll back up to the cell right below our first formula, and then Control, Shift, down arrow to select the rest of the cells, and then just delete, and then Control up arrow to go back to the top of the column. Now we'll select our formula cell, K2, and then hover over the bottom right-hand corner of the cell until we see that fill handle, and then finally we'll just double-click the fill handle. Wow! So with 2 clicks of our mouse button, our formula has been replicated down an entire column of data. And this works just as well whether we have 100 rows of data or 10,000. A real time saver by any measure. Now, one thing worth noting about depending on formulas to calculate values in your data. They are only as good or reliable as the inputs they perform calculations on. So if, for example, we were to delete data from one of the columns that our formula references, so maybe somehow by accident I just deleted all of these values from our num flavors column, our formulas no longer produce the correct result. And I'll just Control Z to back us out of trouble here. Now, in some cases, this may be what you want. But in others, you may simply want to store the number once it has been calculated and don't want to risk losing it if any of the inputs are compromised. So if you want to, as we say in the industry, lock your formulas down so that the results remain static, regardless of whether the inputs change or not, the solution is to turn your formulas into raw data, that is to say, values. To do this, we would simply copy the cells containing our formulas, and in this case, we could just copy all of column K. So we can select that column and hit Control C. Now then, instead of just hitting Control V to paste, we'll actually right-click so we can go to the Paste Special menu. So we'll click Paste Special, and this brings up a dialog box that gives us a lot of options for pasting data beyond just the defaults that Excel gives us. Now what we'll want to choose here is values. If we choose that and click OK, and then just click into our first cell that contained a formula, we'll see that the formula isn't there anymore. All that's left is the value. So this Paste Special as Values command basically took the output of our formula and pasted it back into the cell as raw data, so that no matter whether our inputs change or not, the value will remain what it is. Now, sometimes you'll want to use this technique and sometimes not. It really depends on whether you want to prioritize holding on to the data in its current state, in which case you may want to opt to paste the formulas as values, or whether you think the inputs may continue to change, in which case you may want to see how the value returned by the formulas changes in turn. All right, one more note before we go. We've been doing a lot of copying and pasting here, but we haven't talked about the cut operation, which, as you recall, we access with the Control+X keyboard shortcut. So how does the cut command come into play when it comes to formulas? Well, the difference between cutting a formula and copying it is that cutting does not assume we want to keep our cell references relative. Instead, it uses absolute references, simply replicating the exact formula into whatever cell we move it to. In that sense, cutting actually comes closer to actually copying the formula than the copy command. So as an example, we'll cut one of our formulas, but first we need to use Control Z again to undo our Paste Special Values command. And now we'll go down to the end of our data with the Control down arrow shortcut. And what I'll do is cut our formula from cell K101 to cell K102 and see what happens. So I'll use the Control X command, and then I'll select K102 and hit Control V. So now we see that not only was the formula removed entirely from cell K101, which is part of what the cut command does, but also that the formula in K102 is still pointing to input cells from row 101. Now, if we had copied the formula, on the other hand, our copy of the formula would now be pointing to cells in the formula's current row, row 102. Now, in my experience, cutting formulas is generally less useful than copying, since the most common use case for cutting or copying formulas is to apply them across multiple rows of data like we did here. But they're both good techniques to have in your toolbox. So as we've seen, Excel uses relative references by default when we copy formulas. But as I briefly alluded to, we can actually control this behavior and force Excel to use either relative references, absolute references, or even a combination of the two, as our requirements dictate. This ability can be indispensable in a variety of use cases. We'll explore a couple of these in the next video. I'll see you then. Hey, welcome back. We saw in the last video that when we copy formulas, Excel updates any cell references in those formulas to change relative to the destination cell we're copying to, by default. A majority of the time, this will be what we want, which is why Excel does this by default in the first place. But in some cases, we may want our formula copy to retain all, or at least some, of the original cell reference. Fortunately, Excel gives us a fairly straightforward mechanism for overriding its default behavior when it comes to copying formulas. To get a better handle on this, let's look at an example in which we'll need the cell references in our copied formulas, or at least part of the references, to remain absolute, that is to say, identical to the formula from the cell we're copying. So here in our example spreadsheet, we have an outline of a basic investment calculator, which accepts an input of an initial principal amount in cell B1, and then calculates the appreciation of that principal by year in column E, based on the rate of return in cell E1. Our job will be to write formulas to calculate how our money grows based on this rate of return in the blank cells in column E. So let's get started. So in the very first cell, I'll multiply the rate of return by the initial principal. So I'll type equals, and then our rate of return times our initial principal. And then just to make sure this calculation is performed first before anything else, I'll wrap it in parentheses. And then to this amount, which is basically the amount our investment appreciated in a year, we'll add our initial principal amount, and then hit enter. So far, so good. Next, in cell E3, I'll want to reference the amount in cell E2, the output of the formula we just wrote, just like I referenced the initial principal amount in our first formula. As of year 2, our new initial principal, so to speak, is the end of year value for year 1, which is reflected here in cell E2. So just like before, I'll multiply our new initial principal, which is in cell E2, by the rate of return in cell E1, and then I'll wrap that calculation in parentheses. And then finally, I'll add in our new initial principal from cell E2, and then hit enter. And it looks like our formula is working so far. So now let's try copying the formula all the way down through year 15 so we can see how quickly our investment grows. So I'll hover over the bottom right-hand corner of cell E3 until our trusty fill handle appears, and then double-click to copy the formula all the way down. Whoa! It looks like something went horribly, horribly wrong. Let's dig through what we see in our formulas to diagnose the problem so we can try to clean this mess up. So starting in cell E4, our year 3 investment amount, it looks like we're correctly referencing our principal amount from year 2. As you can see, we're adding E3 and we're multiplying our value from cell E3 by our rate of return. But instead of multiplying our principal by the rate of return in cell E1, we're actually multiplying it by the year 1 principal amount in cell E2. So we're basically multiplying about $100,000 by $100,000. No wonder our numbers are so enormous. What we actually need is for our formula to keep pointing to the value in cell E1 even as we copy the formula down. So how can we do this? Well, first let's escape to get out of our formula and then hit Control-Z to back our way out of trouble. And now we can look into how to fix our formula. So it turns out that we can actually signal to Excel that we want part of a cell reference to remain absolute. That is to say, it won't change if we copy the formula around, by putting a $sign in front of that particular part of the cell reference. So if we put a $sign in front of the 1 in our reference to cell E1, which I'll do right now, and then hit enter to lock the formula in. So if I hit Control-C to copy our formula now, and then Control-V to paste it one cell down, we see that the row part of our cell reference hasn't changed. It's still referencing row 1 when we reference cell E1. Meanwhile, the row component of our other two cell references has changed. However, since we didn't put a $ in front of the E, just the number 1, if we copy the formula into a different column, so I'll hit Control-C and copy over to the next column over, you'll see that the column piece of the cell reference changed, since that wasn't locked down. So now let's go ahead and lock down the column piece of our cell reference as well. So up here in cell E3, I'll just put a $ in front of the E so that now our reference to cell E1 is fully locked down. And now I can fill down our new and improved formula through year 15 by hovering over the bottom right corner of the cell until I see the fill handle, and then clicking, holding down my mouse button, and just dragging down. And it looks like it worked. Awesome. So now let's say we want to convert our little investment calculator to a full-blown investment matrix by adding more different rates of return across the top row. So up here in row 1, I'll add more rates of return starting from our 1% and ranging all the way up to 10%. So I'll just type 2% here and then highlight these two cells, and then using Excel's fill series function, I'll just fill across until I get 10%. And then I'll click cell E1 and double click the format painter so I can paint that format all the way across, and then click the format painter one more time to turn it off. And now I can try copying my formulas from column E all the way across through column N. So to do this, I'll just highlight cells E2 through E16, then again hover over the bottom right-hand corner of that range until I see our good old fill handle, and then click and hold down my mouse button and then just drag across until I'm at column N, and then let go. Yikes! Once again, something seems to have gone very awry. So what did I do wrong this time? Well, if you recall, we actually have two different formulas in each of our columns. One in the first row of the matrix, which references the initial principal amount in cell B1, and then the other one that we copied down through the rest of the years, which references the previous year as it is copied down. Let's start by looking at our formulas in the first row to see what issues we can find. So right away we can see one major problem. Our first row needs to reference the principal amount in cell B1, regardless of where we copy the formula. But because we didn't lock down that reference to cell B1 before we copied the formula, Excel, cheerfully trying to give us a hand by using relative cell references, keeps moving the cell referenced by the formula to the right as we copy the formula to the right. So our first step, obviously, is to lock down that reference to cell B1 in the formulas in the first row of our matrix. So let's put $ before the B and the 1 in our formula in cell E2. So I'll put those $ in there. And then hit enter. And then I'll try filling that formula across the first row of our matrix. And now finally I'll highlight these columns and then double click between two of the column headers to autofit. And that appears to have worked. At least kind of. So if we look at our investment appreciation at the higher rates of return, they don't seem to be very different than those at a lower rate of return. I'm no financial advisor, but I would expect a 10% rate of return over 15 years to make me a lot more money than a 1% rate of return. Clearly, something is still amiss. So let's take a look at the formulas we copied in the other rows of our matrix below the first row. Now we see the issue. As we arrow across the formulas in the different columns, we see that our formulas are all still referencing the rate of return in cell E1, 1%. So the only difference between what we're seeing in column E and what we're seeing in column N is that we start with a slightly higher principal amount in column N. This happened because we locked down our reference to cell E1 entirely, making it completely absolute. So when we copy that formula around, that reference could never change. What we actually need is for the row piece of the cell address to remain fixed, while the column reference changes as we copy the formulas across. So now we can capture the rate of return for the given column that we're copying the formula to. So how do we do that? The answer is simply to remove the $ from in front of the E in our cell reference. This will allow the column piece of our cell reference to remain relative, while the row reference remains absolute, since we'll still have a $ in front of that one. But before we actually make this change, I want to show you a little shortcut that can make life easier when you're playing around with mixed cell references like this. So it turns out that mixing relative and absolute cell references is so common that Excel actually created a keyboard shortcut to let us cycle through the various permutations of absolute and relative references pertaining to the two parts of a cell address, the column and the row. So if we go into our formula in the second row of our matrix in cell E3, and then highlight the reference that we want to change, the reference to cell E1, and finally hit the F4 key, you'll see that the reference changes, such that the column is now relative while the row reference is still absolute. Now this is actually what we want, but just to demonstrate how this works, I'll hit F4 again, and now the situation is reversed. We have an absolute column reference and a relative row reference. And then if I hit F4 one more time, now both pieces of our cell reference are relative. And then if I hit it again, we're back to a fully absolute reference. Using this shortcut, you can quickly cycle through all the reference types available to you until you see the one you want. Not a huge deal, but if you end up typing mixed cell references like this quite a lot, the time you'll save with this little shortcut can add up. Alright, I'll hit F4 one more time to get us back to the combination of relative column reference and absolute row reference that we want. And then I can hit enter to lock down our formula. And now I'll just fill down our new and improved formula through the rest of column E with our fill handle. And then again, using the same method as before, I'll fill our formulas across to the other columns of our data. Now that's more like it. Our 10% rate of return gets us from a $100,000 initial investment to just over $400,000 after 15 years. Now I just need to find somebody to give me $100,000 and then maybe something I can invest it in at a rate of return of 10%, and I'll be ready to retire to Fiji. All right, if this all made sense to you, congratulations are in order. You now have a solid foundation in writing formulas in Excel. And more than that, with what you've learned so far, you now have all the tools you need to be dangerous in Excel. But we still have so much more to learn. While we've learned how to create our own custom calculations with formulas, perhaps the biggest power Excel gives us is its own library of built-in formulas, which can do all sorts of cool and complex operations that we could only dream of cobbling together ourselves. These built-in formulas, which are called functions, are the heart of Microsoft Excel, and we'll start our journey down the function rabbit hole in the next video. I'll see you then. Hey, welcome back. As a very brief aside, I want to make you aware of something you can do in an Excel spreadsheet that I generally recommend against, just because you'll probably encounter cases where other people have done this thing. And that is hiding rows and columns. So it turns out that if you no longer want to see, just for example, a column in your data set, but you don't want to get rid of it permanently, you can hide it so that it's not visible to anyone viewing the spreadsheet, but is still there so that if you want to see it again in the future, you can just unhide it. For example, let's say I'm no longer interested in our sale amount column here in column K, but I'm not sure that I'll never want to see it again, so instead of deleting it, I want to hide it. To do that, all I would have to do is just select the entire column by clicking the column header, and then right-click and choose Hide. And the column disappears. The only real evidence that the column is there at all is that this sequence of column headers has a gap in it. We go from column J to column L. Now this may seem like a potentially convenient thing to do, but there's a real problem here. And that is that just hiding a column or row doesn't protect the data in that column. So if, for example, another user of the spreadsheet were to come along and say want to just delete all the data in columns J and L here. And they select columns J and L and then hit the delete key. Now what do you think happened to the data in our hidden column? Was it protected or not? Well, let's find out. So to unhide the column, we just select the two columns that surround our hidden column, right-click and choose Unhide. And there's our hidden column, and all of the data is now gone. I mean for all of this to underscore my broader point that hiding data in rows and columns probably isn't a great idea, generally speaking. If you have data that you don't want to see, but you also don't want that data to potentially be deleted, I would recommend putting that data on an entirely different worksheet and then hiding the worksheet. Or if it's data you're just not interested in anymore, go ahead and delete it. So if I don't recommend hiding rows and columns, why am I even explaining this technique at all? I do this because while it's not necessarily a great idea most of the time, it's also a very common practice. So the next time you see a gap in the sequence of column headers or rows in your spreadsheet, you'll know to be careful not to delete the data around it so as to avoid the scenario we saw here. All right, with all that said, we'll get back to our regularly scheduled Excel work. I'll see you next time. Welcome back. So there are exercises throughout this course that will help you practice the skills you're learning as you learn them. But in addition to practicing your skills with each new feature in isolation, I also want to give you the opportunity to combine those skills in a single overarching project that will enhance progressively throughout the rest of the course. So what we'll be building is a budget and expense tracker spreadsheet that lets you compare your income and expenses, plan your spending habits accordingly, determine what percentage of your income you'd like to save, analyze your spending habits, and more. This project will incorporate formulas and functions to calculate our monthly budget, charts and conditional formatting to give us intuitive visual insight into our budget and expense data, Excel's modeling tools to calculate what we need to save every month to achieve a particular savings goal by a particular date, pivot tables to let us dig deeper into our spending habits, macros to automate the process of cleaning up messy data, and more. Now this may all seem like a lot of work, but we're going to build it out one step at a time, layering in features as we learn about them throughout the course. I think you're going to have a lot of fun building this out, and on top of that, at the end of the process, you'll have built something you can actually use in real life. But you'll also have the foundation of Excel skills you need to customize your budget and expense tracker, or any other spreadsheet you come across really, in any way you see fit. So enough talking from me. In the next video, we'll dive into the first phase of this project. I'll see you then. Welcome back. So our ultimate goal for the course project is to create a fully featured budget in Excel that will also allow us to analyze our spending habits. But for now, we'll start simple. All I want you to do is create a template similar to the one you see here with inputs for monthly income and expenses, and then a third cell containing our cash balance in which you'll use a formula to subtract expenses from income, leaving our remaining cash balance. Now you don't have to format your solution exactly like I did mine, but I would still recommend clear headings for each input and to offset the formatting of the calculation in some way just to clearly distinguish it as an output of our extremely simple model as opposed to an input. For my formatting choices, I either tried a bunch of options until I found one I liked, as was the case with my choice of font, Century Gothic, or relied on Microsoft's built-in cell styles and theme colors. For example, I used the built-in header styles for the labels of each cell and used built-in theme colors for the fonts. These kinds of tools are great for design-challenged people like me, but if you're aesthetically inclined, please feel free to make this design your own. Alright, with that said, now I want you to pause the video and take however much time you need to put this together. Then once you're ready, unpause the video and I'll walk you through my solution. See you on the other side. Okay, so hopefully that went well. So for my solution, I'll first go to a new workbook, and then I'll go down to cell B3 and type in my first heading, which will be total monthly income. And then my second heading down in B5 will be total monthly expenses. And then my third heading will be cash balance. Now my value for total monthly income will be $7,606. And then my value for total monthly expenses will be 5,668. And at this point, I'll go ahead and auto-fit column B just so we can see our entire labels for our input values. Next, I'll apply some formatting to our labels. So I'll select all three of the cells that have our labels, and then go over to Cell Styles in the Styles section of the Home tab, and I'll choose the Heading 1 style. Now obviously this increases the size of the font, so I'll need to auto-fit the width of column B again. And then to offset our cash balance heading from the other two, because cash balance will represent the output of our model here, I'll change the font color of the cash balance cell to orange. And I'll use the variation of orange that is one of the theme colors for Excel. So now it's time to actually write the formula that will calculate our cash balance. So here in cell C7, I'll type equals C3 minus C5, and then enter. And so now we see we have a cash balance of $1,938. Next, I'll go ahead and format these three numbers all as currency. And I'll also change the font to Century Gothic with a size of 14. Now I'll make column A just a little bit narrower, just so we have a little bit of a buffer between our budget and kind of the boundary of the Excel grid. So now that we've got our inputs, outputs, and calculations down, we can go ahead and create a hopefully aesthetically pleasing header row. So to do that, I'll widen out row 1 just a bit. And then with that entire row selected, I'll choose a cell style of accent 1. And then in cell A1, I'll type budget and expense summary. Then I'll change the font size of that cell to 20. And I'll merge cells A1 through E1, and then left align. And maybe I'll make that row just a little bit shorter. Now finally, it's worth noting that Excel tools, like the one we're building here, can often be made cleaner looking and more visually appealing if we remove grid lines from the spreadsheet. That is, those visual boundaries of all the cells in the spreadsheet. So to do that, we'll go to our View tab of the ribbon, and then simply uncheck grid lines. And now our spreadsheet looks a little bit less like a spreadsheet and more like a professional budget and expense report. And as one last housekeeping item, I'll go ahead and bold the amount of our cash balance, again just to offset that as an output of our spreadsheet as opposed to an input that we have to type in. Now, if your solution doesn't look exactly like what you see here, hopefully it looks better, no big deal. The main idea is that you get the general idea of how to apply these formatting techniques, from merging cells to using Excel's built-in styles to number formatting and font formatting and so forth. And obviously also using formulas for basic calculations. Okay, so up next we'll get back to learning new things in Excel. But never fear, this is not the last you'll see of our little budget spreadsheet. In fact, we've just barely gotten started. Welcome back. In this video, we're going to take our first step past the basics of Excel and into the nearly endless landscape of Excel functions, which are basically pre-built formulas in which Excel does the calculations and heavy lifting behind the scenes. Now we've already seen that we can do plenty with formulas, so what do we really need functions for? Pretty much everything we haven't already tried to do, which is a lot. Functions are where Excel really starts to flex its muscle as one of the most powerful applications ever built. Excel has literally hundreds of functions, nearly all of which can be customized based on user input. These functions can perform operations on our data ranging from trigonometry and advanced statistics to financial calculations, complex date math or text manipulation, and so on and so on. Trust me, the list goes on longer than the introduction of a Star Wars movie. The key thing to remember with functions is that we don't need to understand the exact particulars of how the function gets to its result. We simply supply the function with inputs, these are called arguments, and behind the scenes, Excel takes the information we provided the function and uses it as input to whatever calculation the function performs. We don't need to know exactly how to calculate, just for example, the standard deviation of a range of numbers in order to apply that function in Excel. We simply feed the standard deviation function a bunch of data and Excel spits out the result. And with hundreds of built-in functions available, we can perform just about any operation on data you could possibly imagine in Excel. But as usual, we're going to start with the basics. It doesn't get much more basic than simply adding numbers, so we'll first take a look at Excel's sum function. Here we have a series of input numbers in row 2 of our example spreadsheet, and then a couple of cells in which we'll attempt to add these numbers, first with a formula, and then with Excel's sum function. First, let's have a go with the tried and true method, simply adding the inputs together with plus signs. So right here in cell E2, I'll type equals, and then A1 plus B1 plus C1 plus D1, and then hit enter, and that works well enough. But we still had to think about the particulars of how addition between all the numbers worked. We had to put plus signs in between each number, effectively telling Excel how to do what we're asking it to do. With functions, instead of telling Excel how to do its job, the general idea is more to tell it what we want, and Excel figures out exactly how to get there. To see this in action, in cell F2, let's type an equal sign. Now keep in mind, a function is just a type of formula, and then the letter S. Now that's interesting. Excel auto-populates a list of names with this funny little symbol before them, all of which begin with the letter S. Remember how I told you that Excel has a really large amount of built-in functions? Well, this list should give you some perspective on that. When you start typing a formula with the equal sign, and then type a letter that one of Excel's built-in functions begins with, Excel helpfully populates a list of all the functions that begin with that letter. Hence the funny little function symbol before each name here. As you can see, there is quite a long list that begins with just the letter S. Even better, if I continue typing out the name of our function by hitting the letter U, now our list is narrowed to just those functions that begin with SU. And 3 function names down, I see the name of our function, sum. Now at this point, of course, I could just finish typing out the name of our function since it's fairly short, but I want to show you how this feature of Excel, which is called autocomplete, can help us, especially in cases where the function name is quite long or we may not know exactly how to spell it. So using the arrow keys on the keyboard, I can navigate down the list until the function I'm looking for, sum in this case, is highlighted. Then, if I want to select that function such that it populates in the formula bar, I can just hit the tab key. And now we see that the function name is already populated in our cell with an open parenthesis already entered. And there's something else as well. Below the actual text of the formula, Excel is listing out the arguments or inputs that we can supply to the function. We see that there is a number 1 input we can pass in, and then a number 2 input as well, which is enclosed in brackets. These brackets indicate that this particular input is optional, which means that in this case, we need to supply the function with at least 1 input, but we can optionally supply more. So without further ado, let's take a crack at adding our inputs with the sum function. I'll supply the first argument to the function by clicking cell A2. Then, to separate that argument from the next, and keep in mind arguments passed to functions are always separated by commas, I'll type a comma. Then I'll click B2 for our second argument, then another comma. And if you look at the suggested arguments that Excel is now listing below the cell we're typing our formula in, you'll see that the number of optional arguments has expanded. Basically, as long as we continue to supply more inputs, more of these optional arguments will become available to us. Basically, we can keep adding as many different numbers as we want. So now I'll continue the pattern until we have all 4 of our inputs in the function. So again, C2, then a comma, then D2, and then finally we'll type a closing parenthesis, and we'll see this over and over as we work with functions, but all functions in Excel must have parentheses after them whether or not we actually supply arguments to them. You'll get used to that format as we go, but just keep that in mind that even as we encounter certain functions which we'll see in upcoming videos which don't take any arguments at all, you still have to have those opening and closing parentheses after the name of the function. So now I'll hit enter, and we see that we got the same results as before. Now while this did work, you might be wondering what the real advantage was versus simply performing our addition operation with a simple formula using plus signs like we did before. We effectively just swapped our plus signs for commas and didn't really save any typing relative to our previous approach. It's true that the sum function is somewhat cumbersome as long as we're supplying inputs individually like we've seen so far. But where sum really shines is when we apply it across a range of cells, as opposed to individual cells like we see here. So let me go ahead and delete our function, and then we'll access it again through the autocomplete list. So I'll just again type equals S U, and then arrow down a couple times, and then hit tab to select that function. And now, instead of selecting our inputs individually, we'll click cell A2 to select it, and then holding down the mouse button, I'll drag across through cell D2 to select the range of cells from A2 to D2. And now if you look at what we've passed into our sum function, instead of a single cell reference or a series of cell references separated by commas, there is this strange pattern in which the first and last cells of our selected range are separated by a colon. It turns out that certain functions in Excel accept not just individual cells as arguments, but also ranges of cells. And the way to signify a range to an Excel formula is to have the top left cell in that range, then a colon, then the bottom right cell in that range. In this case, our range is contained entirely within one row, so there is really no top or bottom per se, just a left and right. Hence why A2 is considered the first cell in our range, while D2 is the last. Now, instead of actually typing a closing parenthesis, I'm just going to hit enter. You may be thinking that I'm asking for an angry error message, but bear with me. Wait, it looks like it worked. So it turns out that Excel is smart enough to automatically populate the closing parenthesis for us. As long as we're typing a formula and we've supplied everything it needs other than the closing parenthesis, we can just hit enter when we're done constructing the formula, and Excel will take care of the rest. Now, as handy as this syntax for applying the sum function to a range of cells was relative to just entering a handful of individual cells as inputs, imagine if we needed to sum a range consisting of 100 cells or 1,000 cells. You definitely wouldn't want to try to add those cells individually with plus signs or pass them individually as arguments to a sum function separated by commas. So the more cells are in the range that you're trying to sum, the handier this particular syntax is. All right, I hope that you've seen enough already to recognize that we've just barely scratched the surface of the potential that Excel's functions can offer us. Summing a range of numbers is probably the most basic thing we'll try to accomplish with a function. But this doesn't mean that the other functions we'll work with are harder to use. It just means that the logic going on behind the scenes is more complicated. That's really the beauty of functions. They make calculations and operations that would be difficult or even impossible for us to crunch out ourselves relatively straightforward to implement as long as we know what we're trying to do. Now that we have sum under our belts, we'll take a look at a few other basic arithmetic functions in the next video. I'll see you then. Welcome back. Now that we've learned how to add numbers with the sum function, let's take a look at some other functions Excel gives us for crunching numbers. So I've created another tab on our Shave Ice tracker that will let us track some summary statistics on our Shave Ice sales performance. As you can see, we'll be playing a game of fill in the blanks, so to speak, by computing these various metrics with a little help from Excel functions. First up is total sales in terms of dollar amounts. This one should be easy peasy, since calculating total sales is really just a matter of adding or summing the individual sales amounts. And we already know how to sum, right? So let's go ahead and employ our sum function in cell B1. Now keep in mind that we're trying to sum all the numerical values in column J of the Sales Tracker tab. Now we could simply select all the cells in column J that have sales amounts in them, which would amount to the range from cell J2 all the way down to cell J101. But the problem with that approach is that as we add new entries to our tracker, we would have to continue to change our formula reference to keep up with the new data. Now that doesn't sound very fun or sustainable. A better approach then is to apply the function across the entire column, column J. So how would that look? Well, let's find out by first typing in our sum function in cell B1. So I'll just type equals S, U, arrow down to select our function, tab to lock it in the formula bar, and then we'll navigate over to our sales tracker worksheet. Now before we go on, take note of how Excel has automatically inserted the name of the sales tracker worksheet, wrapped in single quotes and followed by an exclamation mark, inside of our function. Since we're referencing a cell on a different worksheet than the one that our formula lives on, Excel needs to precede any cell references in the formula with the worksheet name. Otherwise, by default, Excel would assume that we're referring to column J on the same worksheet as our formula, which obviously isn't what we want. But since Excel has taken care of that piece for us, let's go ahead and select column J the same way we would in any other circumstance, by simply clicking the column header. And now, looking at the reference generated in the formula, we see that it's similar to when we referenced a range of cells, but instead of a first cell and a last cell separated by a colon, we instead just have the column letter, a colon, and then the column letter again. This is actually how Excel understands a reference to an entire column. And if we wanted to reference multiple columns at a time, say columns J through M, we would just type J, colon, and then M. So for example, instead of selecting column J, if I wanted to just click column J and then hold down my mouse button and then scroll to the right, suddenly our reference changes to J, colon, M. Likewise, if we wanted to select all of row 2, we would simply click that row header, and now we see that our reference changes to 2, colon, 2. But back to our problem at hand, let's go back and select all of column J again, and then hit enter to see what we get. And it looks like our formula worked. But at this point, the eagle-eyed among you might be wondering, since our sum function operated over the entire column, how the heck did it handle adding the name of our column header in row 1 to all the numerical values? So if we go back to our sales tracker tab, you'll see that our cell J1 here doesn't have a number, it has a text value, sale amount. Now, as you might imagine, if we tried to add the words sale amount to the number 1995 using a plus sign, our formula would error out. Well, this is actually a great example of the value of built-in functions versus the formulas that we kind of crunch out by hand. Excel's sum function is smart enough to simply ignore any non-numeric values in the input range, meaning we have the luxury of applying it to entire columns that may include column headers or other types of non-numeric data. Okay, up next, let's try to compute the average sales amount. Hopefully Excel has a built-in function to help us here too. So let's go back to our summary metrics worksheet, and you'll see we already have a slot ready for our average sales function. Now, full disclosure, if we simply typed in an equal sign in this cell and then the letters AV, Excel would helpfully suggest the average function right away. But the function names we're looking for won't always be so intuitive, so I want to show you a more systematic way of finding a function to accomplish a task, when you're not sure what that function is called or if it even exists. So on the Excel ribbon, select the Formulas tab. Whenever we're dealing with formulas or functions, this is going to be the tab that has all the tools you need. Next, on the left side of this tab, let's take a look at the different options available to us in the Function Library section. So Excel has a series of drop-down menus that list out functions in various categories. You can see if we click the down arrow under Financial, a long list of financial functions, and then another list of functions under the logical category, and text, and date and time, and so on and so forth. These lists can be useful, but the categories aren't always the most intuitive. For example, you might think that the average function, assuming there is one, would fit under the math and trig category. But if we look there, we go right past all the function names that begin with the letter A and don't see any average function. A better way to look for functions, in my experience, is the Insert Function dialog box, which we can access by clicking this FX symbol all the way over to the left side of the Formulas tab. Now this brings up a dialog box that lets us simply issue a Google-style search for whatever it is that we're trying to accomplish. Now you can also list out functions by category using the Select a Function drop-down list, but this is pretty much just a variation of the drop-down lists we already looked at on the Formula tab. So let's type average in the Search for a Function text box, and then click Go. So up here in our Search for a Function text box, I'll hit Control-A to select all the text, and then Delete to delete it, and then I'll just type average, and then click Go. And now we see a list of recommended functions pop up. And if we arrow down through the list, we'll see that a description of the function, along with a list of the arguments it takes, appears below the function list. Our very first option here, the average function, actually looks like just the ticket. So at this point, we're probably ready to go ahead and insert the function, but first I'd like to show you one more trick that will help you as you're exploring the vast library of functions in Excel. So with the average function selected in the function list, we can click on the Help on this function link in the bottom left corner of the dialog box. And this brings up Microsoft's documentation on this particular function, which will have all sorts of useful information that can help us understand when and how to apply the function. You see that they give a description, they describe the syntax, and they have a variety of remarks that just give you more context about the function and how you'd use it. So the great thing about the Insert Function dialog box and the documentation that it links out to is that they are both amazing tools for teaching us how to fish, so to speak. If I tried to break down every single function in the Excel library in this course, there would be flying cars by the time you finished it. Excel has such a vast library of functions that it's absolutely essential for you to know how to research functions on your own and learn about their usage through the documentation. This is a crucial step towards making the leap from Excel beginner to Excel power user. If you get comfortable with these tools, over time, you'll acquire a greater and greater knowledge and understanding of the Excel function library, and eventually get to the point where maybe you don't rely on these tools quite as much. But in the meantime, I highly recommend that you make heavy use of them as you're getting up to speed. Alright, with all that said, with the average function selected here, let's go ahead and click OK to insert the function into our selected cell. And now we're presented with another dialog box in which we can actually enter the arguments for the function directly without having to mess with the formula bar. Again, this is something that you might not use a lot once you become really comfortable with formulas and functions, but for beginners, this is an absolutely invaluable tool. So for our first argument, we're not going to enter a single number or cell reference, but rather a range of cells, much like we did previously with the sum function. But how would I go about selecting a range with this dialog box? So all we actually have to do is click this little arrow icon to the right of the input box. And now Excel will allow me to click around the spreadsheet and select whatever range I want. So I'll navigate back over to the Sales Tracker tab, and then again, simply click the header for column J to select the entire column. And our dialog box is actually in the way of our column headers, so I can just click the title bar of the dialog box, hold my mouse button, and then drag it out of the way. So after doing that, I'll select the header of column J to select that entire column. And then finally, to go back to the Insert Function dialog box, I'll just click this down arrow to the right of the input box one more time. And now it looks like we have our argument entered properly, so we can go ahead and click OK. And we see that our average function has been inserted into cell B3 and is returning what looks like a very reasonable result. Awesome. Now let's follow a similar process to extract the biggest and smallest sales. So let's select cell B5, and then once again hit the Insert Function button on the ribbon. And now what I'm looking for is a function to return the largest number in a series of numbers. So let's type, for example, maximum in the search for a function text box and then click Go. And right away we see that there's a function called max, and if we look at the description, it says returns the largest value in a set of values. Ignores logical values in text, which sounds like what we want. So let's go ahead and click OK. And now we again need to select our range, which will again be column J on the Sales Tracker tab. So I'll just click our up arrow again, and then navigate to the Sales Tracker tab, select column J, then click the down arrow to go back to our function dialog box, and finally hit OK. And there we have our largest individual sale value. Now likewise, we can compute the smallest individual sale by first selecting cell B7, and then again clicking our Insert Function button. And now we'll search for minimum and click Go. And the first function that comes up doesn't look like what we want. It's called base and says it converts a number into a text representation with the given radix. This is probably a great example of just the sheer variety and breadth that exists in Excel functions. But for now, this doesn't look like the one we want. So let's arrow down once. And now we see a function called min, which says it returns the smallest number in a set of values. Again, just what we want. So I'll click OK to insert that function. And then again, click our up arrow so I can select an input range. And then I'll navigate to the Sales Tracker tab and again select column J. Click our down arrow to go back to the Insert Function dialog box. And then click OK. And there we have the value of our smallest individual sale. Awesome. We've now successfully computed a series of summary statistics on our Shavai sales data. But there's one more thing I want to point out before we go. The great thing about the formulas we've written here is that since they're pointing to entire columns, as we add more data to our Shavai's tracker, the formula outputs will update automatically. So if, for example, I were to add a ludicrously large sales amount below our existing entries in column J on the Sales Tracker tab, so if I go over here and let's just say somebody ordered, 1,000 shave ices and we ended up with a very large order amount. If we hit enter and then go back to our summary metrics tab, we'll see that our biggest sale is now 10,000. We'll see that our total sales have gone up substantially. Our average sales have gone up substantially, just as we might expect. All right, as you can see, we still have a few more metrics to calculate on our Summary Metrics tab. These metrics will involve a couple of wrinkles that we haven't encountered yet with our average, min, or max functions, so we'll give them their own video. That's up next. I'll see you then. Hey, welcome back. Thus far, the functions we've looked at only really make sense when applied to numbers. You can't add or take an average of a list of names, for example. But now we're going to take a look at counting functions, which can, but do not necessarily, apply to both numeric and non-numeric data types alike. This makes sense if you think about it. While it isn't meaningful to average a list of shave ice flavors, it might in fact be useful to take a count of how many we've listed. First up, we'll take a simple count of all of our sales, based on the values in column J of our Sales Tracker tab, the same column of data we worked with in the last video. So with our cell B9 selected, we'll click the Insert Function button, and then search for Count, and then click Go. And now we see a list of seemingly count-related functions pop up. But based on the description, the plain old count function looks like the one we need. It says it counts the number of cells in a range that contain numbers, and column J on the Sales Tracker worksheet contains the sales amounts of customer orders, which are numbers. So let's insert the count function by clicking OK. And then for our range, we'll go ahead and select on the Sales Tracker worksheet, column J, where our sales amounts live. And then I'll go back to our Insert Function dialog box and click OK. And our function returns 100, which if we look back to our Sales Tracker worksheet and scroll down to the bottom of our data, it looks like we have 101 rows, which means we actually have only 100 sales, considering the first row is taken up with column headers. So 100 is exactly the number we would expect. So it turns out that the count function, like the other arithmetic functions we studied in the last video, ignores non-numeric inputs. As such, this column header here in cell J1 was ignored, meaning that we got an accurate count of our customer orders based on just the numeric values in this column. But what if we wanted to count non-numeric values as well? Let's say, for example, that we wanted to compute the count of customers who purchased at least one shave ice flavor, and then maybe at least 2 shave ice flavors, and then at least 3, and so on. If we look at our 5 columns that track the different flavors that customers opted to add to their shave ice, we see that the cells are either blank, if the customer didn't add that additional flavor, or they contain the text of the additional flavors. Clearly, we need to be able to count our text values here to get the numbers we're looking for. So let's go back to our Summary Metrics tab, where I have a section that's devoted to counting the number of customers who opted for each number of flavors, the number who opted for at least 1, at least 2, at least 3, and so on. So starting in the very first column in cell A14, we'll go ahead and click our Insert Function button again, and we'll again search for count functions. And now if I arrow down past the count function we selected last time, we see the count A function. And based on the description, it looks like this one might be the ticket, since the description says that count A counts the number of cells in a range that are not empty, which we could conclude means both numeric and non-numeric values. So we'll go ahead and insert this one. And then for our input range, we'll navigate to column E on the Sales Tracker worksheet, where our first column of flavor selections is stored. And finally, we'll navigate back to the Insert Function dialog box and click Enter. Now, every customer should have had at least one flavor, so our function here should have returned the same number as our count of overall customer sales. However, it looks like our flavor 1 count is actually greater by 1. So how did this discrepancy happen? The answer is that since the count A function doesn't discriminate between numeric and non-numeric values, it actually counted the column header as just another input. So basically, our count A function looked at all the values in column A and counted any cell that wasn't blank, and then included the value of our column header, the actual text flavor 1. So to achieve an accurate result, we'll need to subtract 1 from the output of our COUNTA function. So going back to our formula, I'll click in the formula bar to edit it, and then just tack on a -1, and then hit enter. And now our two counts match. So getting to our remaining flavor counts might be a lot easier than you think if we leverage the power of relative cell references. Because the column reference in our first formula here is relative, I can simply fill this formula across the 5 columns in our little matrix, and for each column we copy our formula over, the new copied formula's column reference moves 1 column to the right in turn. The bottom line is, it just works. Don't you love it when that happens? Alright, we've managed to compute some useful summary metrics on our shave ice data with just a few strokes of the keyboard. But we're not done using functions to play with numbers just yet. Up next, we'll look at some functions that will help us deal with decimals in our numeric values in precise and specific ways. I'll see you then. Hey, welcome back. So I know I promised that we were going to dig into ways of manipulating decimal numbers that have digits after the decimal place in this video, but I felt compelled to introduce one more cool little feature that pertains to some of the calculations we've studied thus far, like sum, average, and count. But don't worry, this is not going to be a long diversion. This may end up being the shortest video in the entire course. So here we have some sample input data in our example workbook, and I want to show you a way that you can quickly calculate some of the more basic summary statistics on numbers like these without using any formulas or functions. So let me just highlight cells A2 through A6, and then if you'll look down at the bottom right-hand corner of Excel in what's called the status bar, you'll see that Excel is actually populating these basic summary statistics for the numbers I've selected for us, without us having had to write any formulas or functions. We see the average, the count, and the sum listed. And then if I were to highlight more cells, let's say I go all the way out to column C, all of our totals update. And you can probably see where this is going. If I highlight all the way out to include all the data entered into our example workbook, the summary calculations update. Now it's important to note that you can't use these values we're seeing in the status bar, these calculated averages and counts and sums, as inputs to any formulas or functions, nor can these values be stored in the spreadsheet unless you were to just type them into a cell. This feature is really most valuable to do quick and dirty calculations where you don't need to store the result or use it as input in some other calculation, but you just need to know the sum, the count, or the average quickly and then move on with your day. For that purpose, this feature can be really useful and a big time saver as well. All right, I promised this would be short, and hopefully that was short enough. So without further ado, we're going to get on with looking at how to manipulate numbers with decimals in Excel. Welcome back. We've seen how we can use Excel functions to perform calculations on quantitative data, but there are also functions we can use to alter how that data is actually stored in Excel. In particular, the precision with which decimal data is stored. So what do I mean by precision? Basically, the number of digits after the decimal place. Sometimes numbers are only meaningful up to a certain decimal place. For example, we can't charge somebody 99.5 cents for a candy bar. We need to either round that value up to $1 or down to 99 cents. So in general, you probably don't want prices with more than 2 digits after the decimal place. Likewise, we may not want a number to have a decimal component at all. In this case, we could either round the decimal component of the number up or down to the nearest whole number, or simply clip off the decimal component altogether. Let's take a look at a few examples of how these operations work in Excel. So here we have the number 1.2346. If I told you that we wanted to only see 2 digits after the decimal place for this value, your first instinct might be to simply use the formatting tools we've already looked at to format the number such that only 2 digits appear after the decimal place. And while that would make it look like our number has changed, behind the scenes, it's actually the exact same value. So if I select our input cell, and then use the decrease decimal tool up here in the ribbon to reduce the number of decimal places we see down to 2, but then look in the formula bar, we see that the actual value being stored is still 1.2346. So if we want to actually change the value that's being stored, we'll need a different approach. This is where Excel's round function comes in. Round reduces the number of digits after the decimal place to a number that we specify, changing the actual value itself as opposed to just the formatting. So let's take a crack at rounding our input value here to 2 digits in cell C2. Now first, I'll actually just go ahead and reformat our input value back to its original number of decimal places, just so we can better visualize the input we're working with. So now in cell C2, I'll type equals R, O, U, and the round function is helpfully suggested by Excel, so then I'll hit Tab to lock that in. Now the first argument to round is simply the input cell, so that's cell A1, which I'll select, and then we'll type our comma, and the second argument is the number of digits we want to see after the decimal place. So for our first example here, I'll type 2, and now if we hit enter, you'll see that our result is 1.23. The remaining decimal places have been clipped off. And if we were to copy the cell using Control-C, and then right-click, paste special as values to lock in the value returned by our formula, you'll see in the formula bar that the true value of the cell is in fact 1.23. This was not just a formatting trick. Now something a little more interesting happens if we try to round our input number to 3 digits. So if we enter that formula into cell D3, so again I'll type equals ROU, hit Tab to select the formula, and then enter our input cell, and then the number 3 for our preferred number of digits, we see that the output is now 1.235. Now that's weird. Unlike last time, our round function didn't simply clip off any digits past our prescribed limit after the decimal place. If it had done that, our function would have returned 1.234. Instead, the round function actually changed the 4 in the third place after the decimal to a 5. So why did this happen? An important thing to understand about how rounding works is how it attempts to preserve the accuracy of the original number as best it can in whatever digits remain in the number. If we round 1.2346 to 3 digits after the decimal place, Excel wants the shortened number that remains to best reflect the original value. So when getting rid of the 6 in the 4th decimal place, the question becomes, which is closer to the original value of 1.2346, 1.234 or 1.235? Well, since the number 6 is closer to carrying over to the next decimal place than it is to 0, the answer is 1.235. Now by contrast, when we rounded our input to 2 digits, the last digit we clipped off, in the third position after the decimal place, was the number 4. Hence why the function rounded down instead. Now you may be wondering, how does rounding handle the number 5, which seems to be right at the halfway mark? The answer is that the number 5 rounds up. So if I were to change our input value to 1.2345, you'll see that our formula output rounded to 3 digits stays the same, because that 5 is still rounded up. Basically, if the last digit being removed by the round function, that is to say the first digit after whatever digits that we're keeping, is 5 or greater, then the digit before that is rounded up. Otherwise, it stays the same. So we've looked at how to alter the number of digits after the decimal place. But what if we want to remove the decimal component of the number altogether? Sometimes mathematical operations yield decimals that don't make any sense in real life. You might perform some calculation on the inventory of cars at a car dealership that yields some number with a decimal component. But in the real world, there's no such thing as a third of a car, at least not one that you'd try to sell. Fortunately, removing or truncating the decimal component of a number is even easier than rounding. You can simply use Excel's trunc function to do this, and that's TRUNC, as you'll see. So in cell E2, if we type equals TRU, you'll see that one of our options that remain is the trunc function. So we'll arrow down to grab that guy, and then hit Tab to lock it into our cell. And then the only argument we need is just our input number, so we'll select that, and then hit Enter. And we see that we're left with the whole number 1. Now, one thing worth noting about trunc versus round. You can actually perform this exact same operation with the round function by simply specifying the number 0 for the digits after the decimal. So I could type round, and then our input, and then the number 0, and we get the same result. The difference comes when the decimal that's being removed is greater than or equal to 5. In that case, the round function will actually round our result up to the next digit, whereas truncate simply removes the decimal altogether regardless of whether it's greater than or less than 5. So for example, if I changed our input value to 1.5, our round function returns 2. But if I change it back to trunc, it's still 1. In short, round cares about what comes after the decimal place and tries to make our modified number as close to the original value as possible while also clipping off however many decimal places we specify. Trunc, on the other hand, simply wipes out anything after the decimal place, leaving whatever whole number remains. All right. With that, we've covered the most basic and foundational formulas for manipulating and calculating numerical data in Excel. However, Excel has way more tricks up its sleeve when it comes to crunching numbers than what we've seen so far. It also has more than you'd ever want me to cover in this course, or 5 courses for that matter, but there are a few statistical functions that are widely applicable in the business world, which can add value for almost any Excel user. We'll start our exploration of those in the next video. I'll see you then. Welcome back. By now, you should be comfortable with performing all the fundamental flavors of summary statistics in Excel: sums, counts, and averages. But there are some other statistical measures that in today's increasingly data-obsessed world are darn near essential for any business professional to have in their toolbox. One of these is median, which serves a similar yet distinct purpose versus average. Now, full disclosure here. If you're already comfortable with the concept of median and how its use differs from taking a simple average, all you really need to know is that the median function in Excel works just like the average function, except that it returns the median of a dataset instead of the average. So if you have a solid understanding of median, feel free to skip this video, or maybe take an opportunity to apply the median function to some sample data just to refresh your memory. But if you're not super familiar with this concept, or have a dim recollection from a math or stats class you took years ago, stick around and we'll explore how the median function is just as useful, and in many cases more useful, than the average function. So median, like average, is what's known as a measure of central tendency. This means that it attempts in some way to describe the middle of our data, so to speak, the typical data point, as opposed to extremes at the high and low end of the spectrum. But average and median each have their own unique ways of going about this. The word average is deeply embedded in our lexicon, and widely understood to represent a typical example in a larger population. But the definition of what typical means is key. Average works by adding all of our data points and then dividing that total by the number of data points we're averaging. And this can yield a result that is fairly representative of the quote-unquote typical item within our data. But not always. Extremely large or small values in our data, relative to the rest of the values, can distort or skew the average of a data set. Median attempts to resolve this by looking at our data as an ordered list of values, sorted from smallest to largest, and then simply plucking out the value that happens to fall into the middle of the pack. As such, median is able to ignore exceptionally large or small values at either extreme, since it's only concerned with the actual values that happen to physically live in the middle of our data. But all that is a lot of theory, without seeing any examples. So let's take a look at how average and median work differently on identical data sets. Now here we have two lists of employee salaries. One with an odd number of salaries, 11, and one with an even number, 10. You'll see the significance of this soon enough. First, let's take the average of the first list of salaries using the average function we're now so familiar with. So in cell B14 here, I'll just type equals average, and then I'll just drag down through my range of cells to select them and hit enter. But next, let's try to take the median of this same list. So using our tried and true technique, I'll type equals MED, and Excel's autocomplete is kind enough to suggest the median function. So I'll go ahead and hit tab to select it, and then I'll enter the argument for this function the exact same way I did for average, just by dragging down across my list of salaries to select them, and then I can just hit enter. And we see that the median function returned a result that was somewhat close to, but still different from, the average. So let's explore exactly how median got to this result. If you look carefully at the list of employee salaries, you'll see that they're sorted in ascending order, from smallest to largest. There are 11 salaries listed in total, meaning that the sixth salary is at the exact midpoint between the first salary and the last. And if we arrow down through our values to the sixth salary, we see that it is the same number that our median function returned. So again, median simply sorts our data behind the scenes and then returns whatever value falls into the middle of the sorted values. Now please note that it's not necessary to actually sort your data for the median function to work. I just sorted it here to make it clear as to how the function works. So we see that average and median take different approaches to get a similar result. But if the results are so similar, why am I going to the trouble of showing you a completely different way of doing things? The answer is that these functions won't always return similar results. That all depends on our data. The salaries we see here are relatively similar. There's not a lot of spread, so to speak, in the data, nor are there outliers, values significantly larger or smaller than a typical one. But let's say we add an outlier. Let's say we make our 11th salary here, just for grins, maybe a cool $1 million. And now we see where average and median really diverge. Our average value jumped significantly in response to just one of our salaries increasing. Meanwhile, the median stayed exactly the same. This illustrates how median is more resistant to extreme values in our data, distorting our view of what a typical data point looks like. Now that's not to say that there aren't scenarios where taking the simple average of data sets isn't also valuable. You may actually want to have visibility into how those large and small values affect your overall population average. But from my experience, in the very common case where you're looking for a single number to capture a typical item within your data, median is the best bet. Now before we move on from median, we still have one little riddle left to solve. How does it handle data sets with an even number of items instead of an odd number? Finding the median of our first list of salaries was straightforward, since there was a data point, our sixth value, such that there were an equal number of other data points that were larger and smaller. But in a data set with an even number of values, like our second list of salaries, there is no one value that slots in the exact middle of our data. So how does median handle those scenarios? Basically, by doing its best to approximate a central value, even though one doesn't technically exist. It does this by taking the average of the two values closest to the middle of the data. In this case, given that our data set has 10 values, that would be the fifth value and the sixth value. So if we just average those numbers off here to the right, so if I type equals average, and then I just average our fifth value and our sixth value, we get around $60,000. And if we then fill our average and median functions from our first set of salaries across to look at our second set, we see that the median we get is the exact same. All right, up next we're going to look at one more statistical function in Excel that is increasingly becoming a prerequisite for fluency in the language of business. I'll see you then. Hey, welcome back. Before we move on from the math stuff, I have one more statistical function to throw at you that just about anyone working in either the business or scientific communities can benefit from understanding: standard deviation. Now, just as with median, if you feel like you've got a good handle on standard deviation, feel free to skim this video. The one part of interest to you will be the difference between Excel's two variations of the standard deviation function, one that applies to an entire population and one that applies to a sample population. So what exactly is standard deviation? Now, unlike most tutorials, I'm not going to throw up a slide here with the obligatory mathematical formula for standard deviation that you'll turn around and forget 5 minutes later. And that's because you don't need to remember the formula. Excel remembers it for you. This is a great illustration of the power of functions in Excel. As long as you have a conceptual understanding of what it is that you're trying to accomplish, Excel can handle the heavy lifting of memorizing what formula input goes where behind the scenes. But the conceptual understanding, the intuition, on the other hand, is in fact very important. So conceptually, standard deviation is essentially a measure of the variability or noise in our data. In other words, how spread out it is. This spread, so to speak, is judged relative to the average, otherwise known as the mean of our data. So if the individual data points in our data set are very close to the overall average of the data set, the standard deviation will be small. But if those data points tend to be very far away from the average, our standard deviation will be larger. Two data sets can have the same average, and even median for that matter, but wildly different standard deviations. For example, if we take the list of numbers ranging from 6 to 10, we see that the average and median are both 8. The standard deviation, meanwhile, is 1.41. But if we subtract 5 from the smallest value, and then add 5 to the largest value, the average and median both stay the same, but the standard deviation increases because now two of our values are further away from the quote-unquote middle of our data. When it came to average and median, the subtraction of 5 from the first value was offset by the addition of 5 to the last value. But as far as standard deviation was concerned, both of these changes mattered because they both involved data points moving further away from the average of the overall data set. To cement this concept further, let's look at some more examples of employee salaries. So in our first list, we have a somewhat equitable range of salaries. So let's try calculating the average, median, and standard deviation on these. First, we'll go ahead and punch in our average and median functions, which is pretty trivial for us by now. So I'll just type equals average, highlight my input range, and then I'll do the same for my median function. And now we can begin our search for the standard deviation function. So I'll type equals S T, and now we see a couple of options. There is an stdev.p function, but there's also an stdev.s function. Now these both seem like they would relate to standard deviation, and if I arrow down over the functions, it looks like they both do. But how do we know which one of these options to choose? Well, I want to make it easy for you. If you're a hardcore stats person and have an easy fluency with concepts like population mean versus sample mean, then you can just make a strategic decision as to which variation to go with. The stdev.p function calculates standard deviation for an entire population, while the stdev.s function calculates it for a sample population. Now, if you're not a hardcore stats person, but rather a business professional trying to get a better read on your data, you're most likely going to want to stick to the stdev.p function, since most of the time, the data you're applying it to will represent an entire population rather than a statistical sample. Since this is a more business-focused course, we're going to stick with that variation of the standard deviation function from here on out. So let's select that one by hitting Tab, and then select our range once more, and hit Enter. And we get around $27,000. So far, so good. We'll get into how to interpret this number in common sense terms in just a bit. Now, our second list of salaries has a lot more variation, or spread, than the first. You can see that the first 5 values are somewhat low relative to the overall trend, while the second 5 are quite high. But spoiler alert, the overall sum of these salaries is exactly the same as our first list. The values are just distributed differently. So what do you think that means for our standard deviation versus our average? Well, let's find out. Since we've already written our functions against the first column of salaries, we can just fill them across to the next column using the fill handle. So I'll just highlight our formulas, hover over the bottom right corner of the range until I see my fill handle, and then drag to the right. And now we see that our median is similar, and our average is identical to our first data set. But our standard deviation has gone up significantly, reflecting the greater average spread of our data. So at this point you might be wondering, while we now understand why the standard deviation may be bigger or smaller based on the variability within our data, how do we actually interpret the number returned by the standard deviation function? What does this number I see here, this $48,219, actually mean? Roughly speaking, you can think of this number as the average deviation from the overall population average. That is to say, the average amount by which an individual salary in our dataset varies from the overall average of the salaries. Now, this isn't an exact mathematical definition. You'll have to refer to somebody else's slide with the standard deviation formula for that. But it's close enough to what standard deviation does to interpret the number effectively. All right. Up next, we're going to return to our familiar and comfortable arithmetic functions: sum, count, and average, but with a whole new spin that we haven't seen before: the ability to apply these calculations conditionally, based on criteria we specify. This opens up a whole new world of possibilities when it comes to calculating metrics, and can elevate your skill set from mere number crunching to something more closely approaching actual business intelligence development. I hope you're as excited as I am to get started. Welcome back. So remember our fledgling little budget spreadsheet we touched on at the end of the last section? Well, now that we've learned how to crunch numbers with Excel functions, it's time to apply some of that knowledge to build out our budget's functionality just a bit more. So here I'm using the solution file from the last iteration of the project as my starter file here. But you should feel free to use your solution from the last iteration as the jumping off point if you feel good about it. But if you'd rather use the starter file, that's perfectly okay. And that will remain true throughout the rest of the project. So what I want you to do in this one is first create 2 lists in our spreadsheet. one for all of our sources of monthly income, and one for our different categories of monthly expenses. And then use an Excel function to sum our estimates for these income sources and expenses to dynamically populate the two main inputs to our budget. Of course, income and expenses. Now, I already have lists of example expenses and income sources in a separate spreadsheet called Income and Expenses, so all you need to do there is copy those lists into their own worksheets in our Master Budget Workbook. Then I want you to use an appropriate Excel function to populate our total income and total expenses input cells with the data from those lists. Now note that while we could technically fit all this information, both our budget that we see here and also our lists of incomes and expenses on this same worksheet, I'm a huge believer in keeping the purpose of each worksheet in a spreadsheet tightly focused to a single purpose, and moreover to limit the clutter on each worksheet such that you can usually see everything you need to see without having to scroll around. This results in spreadsheets with more tabs, but I think the lift you get in terms of usability and readability is worth the trade-off. So without further ado, pause the video here and try to build this out on your own. Then when you're ready, just unpause the video to see my solution. I'll be waiting patiently. Okay, so I hope that went well. Now for the first step of my solution, just a quick housekeeping item. I'm going to rename our main sheet here to Summary since we're going to be adding new worksheets. And now I'm going to create two new worksheets, one called Monthly Income and another called Monthly Expenses. And now I'll switch over to my other spreadsheet that has lists of example income sources and expenses. So first I'll copy the list of income sources and paste that into our monthly income worksheet. And then I'll auto-fit column widths just to clean this up just a bit. And then back to our other worksheet, I'll copy our list of expenses and then drop that into the expenses worksheet. And again, auto-fit column widths. So now that we have this data in our spreadsheet, the next step will be to dynamically populate the cells in our budget containing our monthly income and our monthly expenses using a built-in function that points to the data on our monthly income and monthly expenses worksheets. So that will obviously be the sum function. So here in cell C3, I'll type equals sum. And now I'll go to my monthly income worksheet. And instead of just highlighting the three cells that have data, I'm actually going to select all of column B. That way, if at some point we decide to add more income sources, our function will capture those as well. So I'll close that parenthesis and hit enter. And now our monthly income input is populating dynamically. So next I'll do the same for expenses. And I notice here that my column B is not quite wide enough to accommodate all of my input labels, so let me double click between B and C to widen that out. And at this point it looks like we have everything working, but just to verify, let me modify one of our expenses and make it, well, more expensive to see if our model captures that change. So instead of our miscellaneous expenses being $100, let's say they're $10,000. And now we'll go back to our summary worksheet. And suddenly we see that our expenses are significantly more than our income, and our cash balance is now negative. Yikes. So that's so ugly, I think I'll go ahead and change it back. And now I'm feeling much better about our budget. So as you can see, due to the flexibility in how we set up our solution here, you're free to add or remove expenses and income sources as needed, or even change those values, and our model will still work. Okay, now it's time to dive back into more new Excel features, but we'll revisit our budget project soon enough. I'll see you next time. Welcome back. So now we've learned all about how to calculate a variety of summary statistics on our data. But it has to be said, our analysis to this point has been fairly simplistic. All of our calculations yield one single result which describes the entire dataset as a whole. In the real world, it's much more common to want to segment your data by various criteria, and then calculate your summary statistics over those groups so you can compare them. As the owner of a shave ice truck, it's true that I might be interested in the total amount of sales I've made, but I'm probably equally interested or more in a comparison between sales of the various flavors I offer. That offers me real, actionable information. If I find that 3 or 4 flavors are significantly outperforming the rest, maybe I stop offering the other flavors, or perhaps feature the better performing flavors in various combinations. So how can we go about segmenting our summary statistics so that they only apply to some, but not all, of the records in our data? Fortunately, as usual, Excel comes to the rescue. For 3 of the most common types of summary statistics, count, sum, and average, Excel offers functions that allow us to apply these calculations conditionally, that is to say, based on criteria. So using these functions, I can count all the sales where the first flavor chosen was pineapple or mango or whatever I specify. Previously, we only had the ability to simply count all the sales in the range that we selected. To see how powerful these techniques can be, let's work through some examples of applying conditional calculations to our shave ice data. So back in our shave ice tracker, I'll first create a new worksheet that will be the home of our new summary statistics. So I'll just click the little plus sign down here to create a new worksheet, and I'll name it Summary Statistics. And then, just to get a feel for how these functions work, let's produce a count of all sales where the first flavor chosen was passion fruit. So the function we'll use to do this is called COUNTIFS. That's the word count, the word if, and the letter S at the end, but all in one word. So let's type equals here in cell A1, and then COU. And now Excel's autocomplete function populates a series of counting-related functions for us to choose from. And as we arrow down the list, we see that there's a COUNTIF function and a COUNTIFS function. So which one should we choose? Well, conventional wisdom would hold that I should walk you through the COUNTIF function, which only allows you to apply one criteria to your calculation, and then later move on to the COUNTIFS function, which allows you to apply multiple criteria. However, one of the themes of this course is that given the massive feature set of Excel, it's crucially important to zero in on the most useful and practical bits of functionality that Excel has to offer. Kind of like the famed 80-20 rule, except in this case it's more like the 95-5 rule, in the sense that it's probably 5 or less % of Excel's functionality that you'll use 95% of the time. In that spirit, I'm going to skip us right past the blander versions of these functions and straight on to the if-S versions, which permit us to apply multiple criteria. That's because the if-S functions are just as easy to learn and also allow us to apply a single criteria if that's all we need to do. The bottom line is, these functions give us more value without any extra overhead, so in my opinion, there's no real reason to learn their lesser versions. So with all that said, let's hit Tab to select the COUNTIFS function. And now, let's look at the arguments that Excel is asking for. It appears that we need to enter something called a criteria range, followed by an actual criteria. Note that both of these arguments are followed by the number 1 and then an ellipsis, implying that we can add more criteria ranges and criteria if we need to. So the criteria range is the range of cells that we will be counting. If this was a regular count function, it would just be the range of cells that we want to count. Then, the criteria is what we wish to apply when counting cells in our criteria range. So if, for example, I want to count the values in the Flavor 1 column of my sales tracker data, but subject to the condition that the value equals passion fruit, the Flavor 1 column would be my criteria range, and the phrase passion fruit would be my criteria. So without further ado, let's go ahead and build out this function. So for my first argument, I'll simply select all of column E from my sales tracker worksheet, which has our flavor 1 data, and then I'll hit a comma. And now, navigating back to my metrics tab, we see that Excel has automatically populated the name of my summary statistics worksheet after the comma. It's trying to be helpful, but in this case, we don't actually need the help. Excel is basically assuming that our next argument will be a cell reference on our metrics worksheet, so it's proactively populating the name of the worksheet that would precede the cell. But we're actually entering our own criteria by hand, as opposed to referencing one that lives in a cell, so we can go ahead and delete the reference to our summary statistics worksheet. So I'll just delete that. Now, for my second argument, I'll simply type the value that a cell in my criteria range needs to be in order for it to be counted. That is the phrase passion fruit. Now keep in mind that when using COUNTIFS and its 2 variations that I'm about to show you, your criteria need to be wrapped in double quotes, unless the criteria is actually a reference to a cell. So we'll type a double quote, and then the phrase passion fruit, a closing double quote, and then hit enter. And we get 15. So if I go back to my sales tracker tab and filter for passion fruit in the flavor 1 column, it looks like 15 records were found. Very cool. Now what about summing or averaging based on criteria? There are in fact some if-s and average if-s functions, and they work similarly but not identically to the COUNTIFS function. So as an example, let's try summing all of our sales where the flavor in our flavor 1 column here is passion fruit. So going back to my summary statistics tab, I'll go ahead and delete our first formula. And then to get to our SUMIFS function, I'll type equals SUM and then arrow down until we hit SUMIFS. Then I'll hit tab to select the formula. Now as you can see here, the first argument for SUMIFS is the sum range, which is the range that contains the values we'll actually be applying the sum calculation to. In this case, that range is our sale amounts in column J of the sales tracker worksheet. So I'll go ahead and select our sale amounts column from our sales tracker worksheet. Then, after typing a comma, we're asked to supply a criteria range. This is the range over which we will apply our criteria, which will determine which of the values in our sum range, the sale amount column, will be included in our calculation and which will not. The criteria range can be the same as the sum range, but it's usually not. Now that said, it's important to note that the criteria range needs to align with the sum range. For example, if the sum range spans rows 2 through 100, the criteria range needs to do the same. If there are more rows in one range than the other, the function will error out. That's because SUMIFS works by checking to see if the criteria in a given row has been met, and then applying, or not applying, the sum function to the value in the same row of the sum range on that basis. In other words, for every value in our sum range, we need a corresponding value in the criteria range to test whether to include that value in the overall calculation. So as with our COUNTIFS function, we'll select the flavor 1 column as our criteria range, and then after another comma, we'll finally type passion fruit, again in double quotes, as our criteria. And then hitting enter, we get a result of $410.80. So if we go back to our sales tracker data and filter our flavor 1 column again by passion fruit, and finally highlight the remaining sales amounts in our sale amount column, we see in the status bar that the sum of those values is in fact $410.80. So again, it looks like our function worked. Note at this point that the average if-s function works identically to the SUMIFS function, except that it, well, averages numbers instead of summing them. So I can easily replace the SUMIFS function with average if-s. If I go back to my Summary Statistics tab and then click into the formula bar to edit my formula, and then delete my SUMIFS and replace it with average FS, and then hit enter, we get $27.39 rounded up. And again, going back to our sales tracker, filtering for passion fruit in the flavor 1 column, and then making sure that our sale amounts are highlighted, it looks like our formula produced the correct result, $27.39. Now we can also apply numeric criteria within these functions. For example, what if I wanted to sum the sale amount of all orders with an order quantity greater than 3? Well, let me go back to my Summary Statistics tab, and then get rid of our current formula, and then I'll type equals SUMIFS, and then my sum range will be the same as before, our sale amounts, but now my criteria range is going to be the quantity column, which I'll select. And finally, as my criteria, I'll type greater than 3, just like if you were typing a mathematical formula, but I'll have to wrap that in double quotes. Remember, even when applying criteria that involves numbers, you still have to wrap the criteria in double quotes. So I'll type double quote, greater than 3, double quote, and finally hit enter, and we get around $1,600, $1,616 to be specific. Now once again, going back to our sales tracker worksheet, if I filter my quantity column to only select 4 and 5, the only values we have that are greater than 3, and then look at the sum of the remaining sales amounts in the status bar, it looks like we've got a match once again. Alright, so this one's gone on a little long, and there's a lot more to explore with these functions, so we'll continue building more layers onto our analysis in the next video. I'll see you then. Welcome back. Now the point of the examples in the last video was really just to introduce you to the mechanics of the COUNTIFS, SUMIFS, and AVERAGEIFS functions. Performing conditional calculations like these based on individual hard-coded criteria that we manually enter in the formula, as opposed to dynamic input from a cell reference, is generally more useful for one-off ad hoc calculations, as opposed to summary reports and dashboards that we might want to produce on an ongoing basis. To create something more like that, a much more efficient approach is to create a list of our various criteria in a range of cells, and then fill our conditional calculation functions down adjacent to that list, so that we can reference each of the cells as part of our criteria. Using this approach, instead of calculating the sum of sales for just one of our flavors, we can quickly create the same view for all of our flavors, so we can compare their performance side by side. So to start, I'll go back to our Summary Statistics worksheet and get rid of our formula in cell A1. And now to produce a list of our shave ice flavors, I'm going to show you a cool little shortcut that's super handy when you need to create a list of unique items. So instead of typing out our flavors individually, this would be bad enough with the few flavors that we have, but imagine how much worse it could be if we had dozens of flavors. We're going to use the values in our Flavor 1 column over here on the Sales Tracker tab as the basis for our list. So I'll go ahead and copy all the values in our Flavor 1 column by first selecting cell E2 and then hitting Control Shift down arrow to select all the values in that column, then hitting Control C to copy, and finally I'll navigate back to my Summary Statistics worksheet and make sure cell A2 is selected, and then hit Control V to paste our values into cell A2. Now here's the fun part. With our values selected, as they should be by default since we just pasted them in, navigate to the Data tab of the ribbon if you're not already there, and then locate the button for Remove Duplicates in the Data Tools section. Now depending on your version of Excel, the location of this button may be more or less obvious, but you should be able to find it by hovering over the various buttons and waiting for a tooltip to pop up describing the button's functionality. So if I hover over this guy with an X, we see that that is in fact the Remove Duplicates button. So if we hit that, we're then presented with a dialog box that gives us some options. Now the data we copied does not in fact have headers, so we can leave the My Data Has Headers checkbox empty. And we only want to remove duplicates from our selected data in column A, so that default works fine as well. So at this point, we should be good to go ahead and click OK. And now Excel tells us that 93 duplicate values were found and removed, while 7 unique values remain. And these are the values that will be the basis of our summary calculations. So I'll click OK, and now the fun can begin. So first, let's type column headers in cells B1, C1, and D1, signifying our summary statistics. So I'll type number of sales in cell B1, and then the sum total of our sales, i.e. the total dollar amount, in cell C1, and then finally average sales in cell D1. Then after I widen out column A a little bit to make room for our flavors, I'll use the COUNTIFS function to count our sales for each of the flavors listed in column A. So in cell B2, I'll enter the COUNTIFS function. Then I'll select my Flavor 1 column from the Sales Tracker worksheet as my criteria range. And then, instead of manually entering a criteria within double quotes like we did before, I'll go back to my Summary Statistics tab after typing a comma, and then simply select cell A2. This will insert the value in that cell, which happens to be passion fruit, as the criteria for my COUNTIFS function. Note that when using a cell reference in your criteria, that portion of your criteria does not need to be wrapped in double quotes. So if I now hit enter, we get the same result as we did before. So now I can simply fill my formula down past the rest of the flavors, and I see their relative sales numbers side by side. Very cool. Now next up, I'll conditionally sum our sales in the exact same manner using the SUMIFS function. So just like before, I'll type equals SUMIFS, and then for our sum range, we'll select our sale amount column on the Sales Tracker worksheet. And then for our criteria range, we'll select the Flavor 1 column, then another comma, and then back to our Summary Statistics worksheet where we'll select cell A2 as our criteria, and then hit enter. And if you watched the previous video, that number should look pretty familiar to you. So now all we have to do is just double click our fill handle to drag that formula down. And then lastly, we'll type in our average ifs function, and this will operate the exact same way as our SUMIFS function. We'll select sale amount as our average range, the Flavor 1 column as our criteria range, and cell A2 as our criteria, and then we can fill that guy down as well. Now we can also apply numeric criteria in this same way. Say, for example, I want to segment our summary statistics by order quantity. But instead of using exact values for my criteria, which is somewhat unusual when working with numeric data, I'll instead use ranges of numbers. So down here below our first summary matrix, I'll create a series of numbers from 1 to 5. So I'll just type 1, 2, 3, 4, 5. And our goal will be to use these numbers as thresholds to segment our data by order quantity. But instead of filtering for all records with an order quantity of exactly 3, for example, we'll instead filter for all orders with a quantity greater than or equal to 3. So first I'll just copy and paste our column headers from our first summary matrix. And now we can commence writing our formulas. So we'll first have a go at writing this the hard way. So I'll enter our COUNTIFS formula, then select the quantity column on my sales tracker as the criteria range. So our quantity column right here that says how many of a given order a customer ordered. And then for my criteria, I'll type in greater than or equal to 1 enclosed within double quotes. and then finally hit enter. Then I can fill my formula down. But since I didn't make use of cell references in my criteria, as we arrow down through the formulas, you see the criteria is the same for all of them. So now I'm going to have to edit their criteria in my formulas individually. So I would have to go into, say, my second formula and then change that from greater than or equal to 1 to greater than or equal to 2. Now that's no fun at all. Obviously, the ideal scenario here would be to reference the numbers in column A as we fill our formulas down. But how would we combine the references to these numbers with the greater than or equal to criteria we already have in place? It turns out that all we need to do is concatenate or combine our greater than or equal to sign with our values in column A. And as we learned previously, you can concatenate two values with the ampersand operator. So in our first formula, I'll modify the criteria such that we use the ampersand to concatenate our greater than or equal to, which will still be enclosed in double quotes, with our cell reference. So let's give that a shot. So instead of having this greater than or equal to 1 enclosed in double quotes, I'll reduce that to just greater than or equal to, and then I'll type an ampersand, which will allow us to concatenate this greater than or equal to with the value in cell A12 here, which is our numeric threshold. So then if I hit enter, I get the same result, but now if I fill the formula down again, it looks like it's working. These are just the kind of numbers we'd expect. As we hit higher and higher thresholds, there are fewer and fewer orders that had quantities greater than that threshold. So just to spot check, let's take note of our number for greater than or equal to 3, which is 67, and then go filter out any orders in our sales tracker data set with a quantity of less than 3, i.e. a quantity of 1 or 2. So I'll click my filter button on my quantity column and then deselect 1 and 2, click OK, and it looks like 67 records were found. It would appear that we have a winner. Now that we've got our COUNTFS function working, the last step is just to follow the same pattern for our SUMFS and AVERAGEFS functions, which should be pretty straightforward now that we know how to handle the criteria piece. So going back to our Summary Statistics tab, I'll first tackle SUMFS. So I'll type equals sum, arrow down to our function, and hit tab to select. Then for our sum range, we'll choose sale amount. And then for our criteria range, we'll now choose quantity. And then for our actual criteria, we'll first type greater than or equal to in double quotes, and then the ampersand. And then finally, we'll concatenate in our value in cell A12, and then hit enter. And then I can just fill that down. And then lastly, because I'm lazy, I'm just going to copy the text of this entire formula out of the formula bar, and then select my first cell in my average sales column, and then click back in the formula bar, and then hit Control V to paste that text to the formula. And then I'll just replace our SUMFS with AVERAGEFS because everything else works exactly the same, and then hit enter. And now fill that down. And just like that, we have our statistics broken out not just by the text values of our flavors, but also quantity thresholds. Pretty cool. All right, we've come a long way in this video, but we've still barely scratched the surface of these functions' potential. That's because we've still only applied one criteria to our data at a time when we can actually add as many as we want. We'll learn all about how to do that in the next video. I'll see you then. Welcome back. So far, we really haven't been using COUNTFS, SUMFS, and AVERAGEFS to the fullest extent of their potential. That's because we've only been applying one criteria to our calculations at a time, when these functions can actually accept as many different criteria as we want. While not always necessary, these additional criteria can allow us to add significantly more layers and nuance to our analysis. As an example, what if we wanted to break out our shave ice sales by more categories or dimensions than just flavor? And what if we wanted to see those different dimensions combined forming subcategories that parse out our summary statistics in more detail. Let's say we wanted to break out our sales by flavor and style, island or mainland. To do this, we need to apply 2 criteria to each of our if-else functions, one for each dimension we're interested in. We've already seen that hard-coding criteria into our if-else functions is clunky and inefficient, so our first step would be to create a table of the distinct combinations of these dimensions. So to do this, I'll highlight cells C1 through E1 here, which contain the headers for our style and flavor 1 columns, and then I'll use the Control-Shift-Down arrow keyboard shortcut to select all the data in those columns, then Control-C to copy. Then I'll navigate over to our Summary Statistics worksheet, which I've cleared out since the last video, obviously, and then hit Control-V to paste. Now, we're not interested in the quantity column for this particular analysis, so I can go ahead and delete that. Then I'll reselect our 2 remaining columns with our Control-Shift-Down arrow shortcut. And then, to collapse this data down to just unique or distinct combinations of style and flavor, we can go back to the Remove Duplicates button on the Data tab of the ribbon. Now, the defaults we see on the dialog box here are all fine for our purposes. Our data does in fact have headers, so we'll leave the My Data Has Headers checkbox checked. As a side note, whether or not our data has headers really only matters when removing duplicates if the actual names of our headers overlap with some values in the data. In this case, if we left the My Data Has Headers checkbox unchecked, the value in our data with the same name as our column header would be removed, since both values would be considered duplicates. But again, in this case, all the defaults are fine, so we'll go ahead and click OK. And we see that we're left with significantly more rows than when we removed duplicates from just the flavor column. That's because when we apply the Remove Duplicates feature to multiple columns, its definition of duplicate rows changes from a single value that's duplicated to the values in all the columns we have selected being identical across multiple rows. In other words, if a flavor, say passion fruit, is repeated multiple times in this case, it's not necessarily considered a duplicate. But if the combination of the passion fruit flavor and mainland style are repeated multiple times, those additional combinations are in fact considered duplicates and would be removed by the Remove Duplicates feature. So now that we have our distinct combinations of style and flavor, let's sort these so that our summary view will ultimately be easier to read. So I'll highlight just our data, then hit the Sort button, and I'll first sort by style, then I'll add a level and sort by flavor 1. All right, with all that setup done, we're finally ready to start adding our formulas. So first, I'll add some headers for our various metrics, and to keep the styling consistent with our other headers, I'll actually just fill this header across over the next 3 columns, and then I'll just type in the names of our various headers. So number of sales, dollar amount of sales, average sales, and then I'll click above and to the left of our grid to select the entire grid, and then hover between 2 column headers and double click to auto-fit our columns. Now, in the first column, I'll count all of our orders that had both the style in our first column and the flavor in our second column. The syntax to do this works just like our previous applications of COUNTIFS, except that we just add more pairs of criteria ranges and criteria. So I'll start writing the function just like we did before. I'll type equals count and then arrow down to our COUNTIFS function and hit tab to select it. Then for our first criteria range, we'll select the style column on the sales tracker worksheet, then a comma, and then for our criteria, we'll just choose the style value in cell A2 here on our summary statistics worksheet, then another comma, But now, instead of closing the function out, I'll add another criteria range, our Flavor 1 column. So back to our Sales Tracker tab, I'll now select our Flavor 1 column, then another comma, and then for our second criteria, we'll pick the Flavor 1 value here in cell B2. Then if I hit Enter to lock in the formula, we'll see that we've got a result of 9. Now just to spot check our work, I'll go ahead and filter our Sales Tracker worksheet by Style equals Island, and then Flavor 1 equals Apple. And it looks like our formula worked. So I'll clear my filters here, and then go back to my Summary Statistics worksheet and fill that formula down across the rest of our data. And now we can proceed with the rest of our analysis. First up, we'll sum our shave ice sales based on our two conditions, style and flavor. So in cell D1, I'll start writing my SUMIFS function. So just like before, equals SUMIFS. And then our sum range, as usual, is going to be our sale amount column in column J of the Sales Tracker worksheet, then a comma. Then our criteria range, our first criteria range, will be the style column, another comma, and then our criteria, our first criteria, will be back on the Summary Statistics worksheet, and again will just be cell A2, then another comma. Then we have to enter our second criteria range, which will be the Flavor 1 column back on our Sales Tracker tab. And then finally, our second criteria will be the value in our Flavor 1 column back on our Summary Statistics worksheet. Then I'll hit Enter and fill that formula down. And it looks like we've got it working. And lastly, I can follow the same steps to perform a similar analysis with the average FS function. And like I did in the last video, instead of going to the trouble of writing this formula from scratch, since the syntax of average FS is basically identical to SUMIFS, I'm just going to copy the text of this formula in cell D1 right out of the cell, and then select cell E1, and then paste that formula into the formula bar, and then just delete the SUMIFS function and replace it with average FS. Then hit Enter, and now I can fill that down. We now have a neat little breakout of our shave ice sales with 3 summary statistics broken out by not 1 but 2 dimensions of our data. Now just to make things a little more interesting, before we go I want to add one more layer to our analysis. Specifically, within the groupings we already have, I want to see how many orders had a quantity less than 3 versus a quantity greater than or equal to 3. So the first step, obviously, is to add a new column to our summary matrix to denote our quantity thresholds. So I'll just insert that column to the right of the Flavor 1 column, and I'll call it quantity threshold, and I'll auto-fit that. And now for our first block of data, we'll simply enter less than 3 in cell C1, and then just copy that and paste it across the rest of the cells in that column. Next, I'll copy our entire block of dimensions here, and then paste all of that beneath the original. And the only change I'll have to make is updating the criteria in column C from less than 3 to greater than or equal to 3. So just in these cells, I'll change that criteria to greater than or equal to 3. And likewise, I will copy that value and paste it down through the end of the column. The last piece, of course, is to actually modify our formulas. Now you might have guessed that this will involve adding an additional criteria range / criteria pair. But what you might not have guessed is how easy it will be to add the criteria. So scrolling back up, for our COUNTIFS formula, let's first add the additional criteria range, which will be the quantity column on the Sales Tracker worksheet. So I'll click into our formula, add another comma, and then go back to our Sales Tracker worksheet. And our little formula helper here is actually in our way, obstructing our ability to select the entire quantity column. So I'll just hover over this and then drag it out of the way. Then I'll select our quantity column, then a comma, and then back to our summary statistics worksheet. And now for our third criteria, we can literally just reference the value here in cell C2. Because what we typed in the cell is exactly what we would have entered into the formula as a criteria, less than 3, we're able to reference that criteria in the cell dynamically without needing to use double quotes or concatenation like we did in the last video. So now we can hit enter to lock in our formula, and then we'll hover over our fill handle and drag down until we get to the end of our data to fill the formula down. And it looks like we have it working. So just because I'm paranoid, let me go back to my sales tracker worksheet and see how many orders we had with island style, apple flavor, and a quantity of less than 3. Hopefully we'll see 4. So back over to our sales tracker worksheet, I'll filter for island style, apple flavor, and then for our quantity, we want anything less than 3, which basically means 1 and 2. And it looks like we do in fact have 4 orders that met that criteria. So now it'll be just a relatively trivial matter of updating our SUMIFS and AVERAGEFS functions. So first I'll clear filters on my sales tracker worksheet, and then I'll get to modifying our other ifs functions. So on our SUMIFS, we'll add a comma, and then we'll choose that third criteria range, which is our quantity column, then another comma, then back on our summary statistics worksheet, we'll choose cell C2 again, then enter, and we can fill that down. And lastly, I'll just again copy this whole formula and then drop that into our column for the AVERAGEFS calculation, and then just replace SUMIFS with AVERAGEFS, fill that down, and just like that, we've created a pretty daggone intricate and detailed analysis. And as you might imagine, we could keep adding more and more layers to our summary view if we wanted to. Although I would caution you that while our ifs functions can handle anything you might want to throw at them, that doesn't necessarily mean we should make our summaries and analysis more complicated than they need to be. Once you get past a few layers, even though our functions still work fine, a human being's ability to easily interpret the data starts to break down. And our spreadsheet end user is obviously what we're worried about the most. Alright, we've run the gamut of the most useful functions that calculate summary statistics, so it's time to move on to the wild and wonderful world of date and time functions in Excel. Just like most every other category in this massive application, there are approximately 11 billion such functions to explore, so I've carefully curated the most essential ones for your viewing pleasure. We'll start our exploration of that in the next video. I'll see you then. Hey, welcome back. So once again, it's time to apply what we've just learned to our budget and expense tracker spreadsheet. And this time we're going to be emphasizing the expense tracker part. So let's say that our bank allows us to export, from their website, a list of all the purchases made from our account, including the date of purchase, the amount, and even a description and category for each purpose. This kind of data, which we see an example of here, is pretty commonly available, and it's absolutely invaluable for tracking our spending habits so we can get deeper insight into exactly what we're spending the majority of our money on. If you're like me, you'll be fairly astonished at how much you spend on groceries alone. And down the road, analyzing this kind of historical data can also help us produce better estimates for our monthly expenses across each category. So for this piece of the project, I have the file you see here with a sample export from a fictional person's bank account that lists their individual purchases going back to June of 2019. So my goal for you here will be to use the conditional calculation functions you just learned, like COUNTIFs and SUMIFs for example, to produce a breakout of our total spending by each of the categories listed in the categories column of our data. So after copying this data into a new worksheet in our project file, you'll need to use Excel's Remove Duplicates feature to create a distinct list of purchase categories, and then calculate the total amount spent in each of those categories using one of Excel's conditional calculation functions. Your solution should look something like what you see here. Now, as always, I would recommend putting this on a separate worksheet, which you could call something like Spending Summary. So pause the video here and take your best shot at getting this done. I'll be waiting with a solution on the other side. Good luck. Now, I hope you had some fun with that one. So without further ado, let me go into my solution. So I'll go back to our starter file. And for my first step, I'll create a new blank worksheet at the end of the file, which I'll call Transaction History. And this will hold all of that data that we exported from our bank's website. So we'll go to that file and copy that data out of here and back into our project workbook. And then we'll go ahead and auto-fit column widths. And then right before this worksheet, we'll create a new worksheet, which we'll call Spending Summary. Then I'll go back to my Transaction History workbook and then select all the values in the category column and then copy and paste those back into my Spending Summary worksheet. And then I'll use the Remove Duplicates feature to parse this list down to only the unique categories of our purchases. So I'll go to Data, and then hit this little icon under Data Tools for Remove Duplicates, and then click OK. And now we're down to the 17 unique spending categories in our data. So I'll auto-fit that column, and then I'll create a new column header called Dollars Spent. And now the whole point of all these setup steps is to write formulas against these categories that sum up the amount of all of our purchases within those categories. So to do that, we'll use the SUMIFS function. So I'll type equals SUMIFS, and then for our sum range, I'll go to our Transaction History worksheet and select the entire column containing all of our purchase amounts. And then for our second argument, we'll select column C, which has the range we'll be applying our criteria to. And then for our third argument, we'll go back to our Spending Summary worksheet. And here we simply want to enter the criteria to sum our purchase amounts by. And that will just be the value in the adjacent cell that has a particular category. So we'll select A2, and then close our parenthesis and hit enter. And now we can just fill that down. And at this point, I think this iteration of our project is complete. So while that's it for now, we're definitely going to keep enhancing our project in the sections to come. But for the moment, we're going to get back to our exploration of Excel functions. I'll see you in the next one. Hey, welcome back. So there's a reason why date and time data gets such special treatment in Microsoft Excel. Most business data has at least some date or time component. And as such, managers, analysts, and business owners alike are very interested in being able to analyze their data by these dimensions. From breaking out monthly sales trends over the last year to comparing month-over-month performance and customer satisfaction, date and time-based analysis is everywhere in the world of business. And that's why it's essential to master a select group of Excel's most useful date and time functions. We'll get started with the most fundamental building block of all, the current date. Being able to calculate the current date dynamically is surprisingly important, since many date calculations key off the current date. Consider, for example, the extremely common scenario in which we want to establish a date range encompassing the prior month, so we can compare that month's performance to another one. Our definition of previous depends on whatever the current date is. Now, we're far too advanced at this point to be manually typing in a different date in our spreadsheets every day, so that's where Excel's today function comes in. The today function simply returns the current date. It accepts no arguments, and none are needed. It just returns the current date no more, no less. So without further ado, here in cell B1, let's type equals TOD. And at this point, it looks like today is the only function left on our autocomplete list, so we can hit Tab to select it, and then hit Enter. And the function returns the current date as of when I happen to be recording this. Now, one interesting thing about the today function is that it's what is known as a volatile function. A volatile function is one whose output can change even though its input does not. The other functions we've looked at so far are not volatile because they'll always return the exact same result given the same input. If you apply the sum function to 2 and 2, the answer will always be 4. But if you look at the output of a volatile function like today on multiple different days, you're going to see a different result. Now you might be wondering, how useful is this function if it simply prints the current date as of when I entered it, but doesn't automatically refresh to reflect subsequent dates? Now fortunately, like all other functions in Excel, the today function will refresh every time we reopen our workbook or any time any cell value in the entire workbook is changed. So the only scenario in which my July 2nd, 2021 value here would remain static is if I just left this workbook open and made no changes to it until tomorrow, which is a pretty unlikely scenario. Now before we move on, there's another function quite similar to today that offers a little more detail, the now function. So now works just like today, except that it also returns a timestamp component. So if I go down to cell B4 and then type equals NOW and then hit Tab to select our now function and then hit Enter, you'll see that we still have the date component that the today function provided us, but also the time in hours and minutes. Sometimes you'll need this level of detail and sometimes not, so you can choose which of these functions you need as a starting point for your date/time analysis as the scenario dictates. All right, now that we can use Excel functions to dynamically generate the current date and time if need be, it's time to learn how to apply these values in actual useful analysis. We'll take a look at that in the next video. I'll see you then. Hey, welcome back. So now that we've learned about not only how to enter date and time data into our spreadsheets manually, but also how to dynamically fetch the current date and the current date and time, let's take a look at how to parse pieces of those dates and times, components if you will, out from date and time values. So here we have our current date and time, at least where I happen to be recording this. And what we're going to do here is try to parse out certain components from these values using Excel's built-in functions. So first up, I'll extract the year from our current date value in cell B1. The function to do this could not be named any more intuitively. It is, as you might have guessed, the year function. And it takes one argument, which is simply a date value. If you just plug that date value into the function, it gives you an integer value, which is just the year associated with that date. If you've got the year function down, month and day are even easier. So to extract the month from a date, you just type equals MON, and then as soon as you see the month function pop up, hit Tab to select it, select your input, enter, and there's the month. And then day works exactly the same. The pattern should be pretty obvious at this point, so you've probably already guessed how our hour, minute, and second functions are going to work, but I'll show you nonetheless. So first of all, I actually am going to apply our hour function, and as you might have guessed, that's what it's called. Our functions are actually called hour, minute, and second, but I'm going to apply that hour function not to our value in cell B2, our date that has a time component, but actually our value in cell B1, which just looks like a date with no time component. So if I type equals HOU, there we have our hour function, and then I select our value in cell B1, which looks like it doesn't have a time component, and hit enter, there's no error. we just get the value 0. And the reason for that is, and that's really the point I'm trying to make here, even a date that doesn't appear to have a time component does, it's just that that time component is 0. So if you see the value July 3rd, 2021, just know that that is understood to be at midnight as of that date. That is to say, no minutes, seconds, or hours have passed in that date. It is exactly July 3rd, not July 3rd plus some amount of hours, minutes, and seconds. Now, one other point I want to make before we move on with these functions, and this is something that's going to play an important role as we dig deeper into the world of Excel functions and use functions that refer to the output of other functions, and that is the concept of nesting functions. So right now, when I enter a function like hour, I am referring to a value that lives in another cell. So right now, my hour function is referring to the value in cell B1, and then that value in cell B1 is in turn generated by a formula. Now, if we're just dealing with one input like this, that's fine, but sometimes we may have a function that takes multiple arguments, all of which in turn are supplied as by the output of another function. And in those cases, you may not want to have 3 different input functions in 3 different cells and then have your secondary function referring to all those first 3 cells. Instead, you may want to actually put functions inside of other functions so you don't have so many cells all over your worksheet with intermediate steps of your overall process. So here's how it would look if I wanted to parse out the hour value of my current date and time without having to refer to another cell. In this case, the value here in cell B2. Instead of typing equals hour and then referencing another cell, which has another function in it, I could instead type equals hour, and then instead of referencing another cell, I actually just type another function. And in this case, that's going to be my now function. So what's happening here is the inner function, my now function, will execute, and it will populate whatever the current date and time is, and then that value will be supplied to the outer function, the hour function, as its argument. And finally, hour will just parse that hour value out of the current date and time. So let's hit enter, and it looks like that worked fine. So this is a simple example of nesting functions, but in the upcoming videos, we're really going to explore this topic a little more, not for its own sake, but just to simplify some of the processes we're going to be building, which, if we didn't employ nested functions, would involve tons of intermediate steps in which I have a cell that has one function, and then a second cell that refers to the first cell, and then a third cell that refers to the second cell. If you have to split out every intermediate step into its own cell, your spreadsheets can get pretty messy. So this ability to wrap one function inside of another function and then have the outer function reference the output of the inner function is absolutely invaluable to keeping your spreadsheets tidy and your formula logic streamlined. So with all of that said, I'm going to continue this pattern for minute and second. So I'll type equals minute, and then instead of referencing cell B2, I'll just type now and hit enter. And lastly, second. Now you've probably already gleaned this, but it's still worth noting that even though we're invoking multiple functions within a single formula, you only need to type an equal sign one time before the overall formula. The equal sign isn't specific to a function, which is what second is, what hour is, what today is, or now. The equal sign is for a formula. The formula is what encompasses all of the logic that goes into the overall calculation that yields the output. So the functions are just one component of that. A single formula could consist of multiple functions that interact with each other in some way, or as in this case, feed their output to another function's input. All right, so admittedly, we didn't dig into a lot of practical applications of these functions in this video, but that's just because in this video, we're really laying the foundation for some more advanced work we'll be doing in upcoming videos. both specific to date and time calculations, but also more generally in regards to nesting functions within other functions. So in the next video, we'll get into some more exciting applications of date and time functions. I'll see you then. Hey, welcome back. So now that we know how to parse different components out of a date value and a date time value, let's take a look at doing something interesting with those components. So the first function we're going to take a look at is called the date function. Now the date function allows you to construct a date based on these individual components, year, month, and day. So in cells B3 through B5, we've essentially deconstructed the date in cell B1 using our year, month, and day functions. And now down in cell B7, we're going to put those components back together with the date function. So because this function has a little more going on with it than some of the other functions we've looked at recently that took 1 or maybe even 0 arguments, I'm going to go ahead and access this one through the Insert Function dialog box. So to access that, I'll hit the Formulas tab, and then click the Insert Function dialog box, and then I'll search for date and click Go. And there's my date function right at the top of the list. So I'll click OK to select it. And you see that the Insert Function dialog box tells us which arguments this function takes, but also what type of data goes into those arguments. So it takes arguments for year, month, and day, but the actual data that goes into those slots is numeric. Each of those things is a number. It's the number of the year, 2021. It's the number of the month, 7, so on and so forth. So in this case, we're going to point our function to the values in cells B3 through B5. So I could either just type those cell references right here in the input box. So for my year, I could type B3. Or with one of my input boxes selected, I can just click outside of the Insert Function dialog box over to whatever cell I want to select for input. And then I'll do the same for the day piece, and then click OK. And as you can see, we haven't really accomplished much thus far. We basically took the date in cell B1, deconstructed it into its constituent parts, year, month, and day, and then reassembled it basically down in cell B7. But our goal here is actually to calculate the beginning of the month that our current date belongs to. So our current date's in July, so what I really want to return is July 1st, 2021. So how would I modify our function here to accomplish that? Well, the cool thing about the date function is you can enter whatever you want into any of these 3 arguments as long as it makes sense as that particular component of a date. Obviously, you don't want to enter the number 14 as a month. So for example, instead of entering the current day as my 3rd argument to the date function like I'm doing now, I could instead just type the number 1. And now this function that I just wrote is always going to return the first day of whatever month that my input date belongs to. But we can actually take this one step further. So right now we have 3 intermediate functions, 3 intermediate cells that really don't need to exist. Because in fact, in my function in cell B7, I can actually just swap out these cell references for the actual functions that I'm using to create the values in those cells that I'm referencing. So for example, instead of referencing cell B3 in my date function, I can just go up to cell B3 and take that function that I'm using to produce that result, and then go down to my function in cell B7 and just get rid of that reference to B3 and replace it with the actual function that I was using to produce the result in cell B3. Just like we covered in the last video, this is called nesting functions, essentially putting one function inside of another function and using its output as an input to the outer function. So if we hit enter, it looks like our function's still working. So then the next step is to just do the same thing with the month input. Now this time though, instead of copying the text to the function, I'm actually just going to type the actual function right here in my formula in cell B7. So I'll type month, and then my input will be cell B1, and then I'll close my parenthesis, hit enter, and our function is working just like it was before. But now, because we're not referencing any cells other than our original input cell in cell B1, if I delete all these rows that contained those intermediate steps, those intermediate functions, our final function still works. So that is the power of nesting functions within other functions. You can basically remove some of these redundant intermediate steps that don't really serve much of a purpose in your overall process or model, other than just adding steps which you may not even need if you are comfortable nesting functions inside of other functions. All right, well, we looked at a pretty simple application of the date function in this one, but in the next video, we're going to look at some more sophisticated applications of the date function and its counterpart when dealing with times, the time function. I'll see you then. Welcome back. Now that we've got the hang of the basic mechanics of the date function, let's take a look at some more realistic examples that show how the date function can be applied in the real world. So one of the most common applications of the date function is date offsets. Now that's where you want to take a date and then increase it or decrease it by a certain number of years, months, or days. So here in our example spreadsheet, we have a list of products associated with our shave ice business that require regular maintenance. For example, a truck engine, truck tires, trailer tires, the shave ice grinder, etc. We also have the last date these things were serviced, and then how often they need to be serviced, the service frequency. And what we want to do is to calculate the next service date, basically the next date that we need to service these things, based on the last service date and the service frequency. And that's where the date function can help us. So to get started, I'm actually just going to enter the date function here in column D based on the date in column B, that being the last service date, without any real modifications. I'm pretty much going to do what we did in the last video, which is deconstruct the date in column B into its constituent parts, the year, the month, and the day, and then reassemble those back into a single date in column D. Once we have that in place, we can look at integrating the offset. So I'll start off by typing equals DAT. I'll tab over to select the date function, and then for my year, I'll use the year function to extract the year for my date in column B, and then the same thing for month, and then the same thing for day. Now, we haven't accomplished a lot so far. We've pretty much just recreated our date in an extremely roundabout way, but having deconstructed it into components like the date function does gives us the flexibility to offset those components individually. So recall that each of these arguments we pass into the date function, the year, the month, and the day, are really just numbers. And the cool thing about numbers is you can perform arithmetic on them. You can add to them and you can subtract from them. So if I want to add 3 months to the date that I'm building with this formula, all I have to do is just add the number 3 to the month argument of the function. And then if I hit enter, you'll see our last service date in column B has now been offset by 3 months into the future. But of course, now I can make that dynamic by replacing that hard-coded number there in the second argument with a reference to our service frequency in column C. So if I enter that and then lock in the formula, now I can fill it down, and you'll see that in every cell, our new date is offset from the last service date by the number of months specified in column C. Now, obviously, in this case, we just applied this offsetting to the months component of the date, but we could just as easily have offset by years or days, and we could also have offset our date with negative numbers. So if we wanted to offset our date 3 months in the past, we would just subtract 3 from our month argument instead of adding 3. Now, Excel has another function quite similar to the date function that also allows us to perform offsets in this manner, and that's called the time function. Now, as you might have guessed, the time function lets us perform these types of offsets on time values instead of date values. But otherwise, the mechanics in the process are extremely similar. So for an example of how that works, let's select our estimated wait time worksheet over here, where our goal will be calculate the estimated time of a shave ice order being completed based on the current time, the number of orders currently in queue, and our average time to complete an individual order. So what we're really trying to do here is offset our current date and time by the amount of minutes we expect it to take to complete or fulfill all the orders currently in queue. So right now we've got 12 orders in queue. We average 6 minutes per order, so we need to offset our current time by 72 minutes, 12 times 6, to get to an estimated completion time of a new order that a customer places. So the process for doing this is going to work almost exactly like with the date function. So in cell D2, I'll type equals TI, and there the time function is suggested by autocomplete, and that's the one we want, so I'll hit tab to lock it in. And then for the hour argument, just like I would for the year argument with the date function, I'll actually use the hour function to parse out the hour value from our current date time. And then for the minute argument, same deal. I'll just select the minute function to parse the minute value out from our current date time. And then the same thing for the second value. Now, obviously, at this point, we haven't solved our problem, but we have set ourselves up for success. Because again, by parsing this time value out into its individual components, we can now add or subtract from those components to offset them. So what I really need to do is offset our time value in terms of minutes by the amount of minutes that we expect all the orders we currently have in queue to take. And that number is 72. It's the number of orders in queue by our average minutes per order. So I could just type plus 72 after our minute function in the second argument of the time function, and that works just fine, but obviously we want our solution to be dynamic. So instead of adding 72, we're actually going to add a calculation, essentially a formula within our overall formula, that multiplies the value in cell B2 by the value in cell C2. Our orders in queue multiplied by our average minutes per order. And I'm going to wrap this calculation in parentheses just to make sure it's executed first before we perform any addition. And then if I hit enter, we'll see that my offsetting still works. But then if I reduce my orders in queue to say 5, suddenly our estimated order completion goes down to 4 p.m. And again, just as with the date function, you can offset all three components, hours, minutes, or seconds, and you can offset them into the future with positive numbers like we did here, or in the past with negative numbers. All right, up next, we're going to take a look at a somewhat mysterious function that Excel, for reasons that aren't fully understood, likes to sort of keep under wraps. But it's so useful, I want to make sure you know how to apply it, even if Excel doesn't. I'll see you then. Hey, welcome back. In this one, we're going to take a look at a couple functions that we can use to calculate the elapsed time between two dates in different ways. Now, the first of these functions is called the dateDiff function. And there is something about this function that's a little different. And that is that Excel doesn't seem to want to acknowledge the existence of this function, which is a little bit weird. Up to this point, whenever we have searched for a function, Excel has been more than happy to populate that function in the autocomplete list, suggest arguments that we could use in the function. There's also the insert function dialog box that helps us with a lot of the mechanics of constructing a function, but you'll get none of that help with the dateDiff function. It's almost like it's been swept under the rug by Excel, so to speak. There's a lot of speculation for why this might be, but regardless, it's such a useful function that even if Excel doesn't want you to know about dateDiff, I do. So what does dateDiff do for us? Basically, it lets you calculate the elapsed time between two dates in terms of an interval that you specify. So it could be days, but it could also be months. It could also be years. So if you want to know the number of months between two dates that are very far apart, instead of having to calculate the number of days and then divide by 12, handle the remainder in some way, DateDiff does all that work for you. And it can do the same thing with years. Now, obviously, when it comes to calculating the number of days between two dates, we're able to do that with just simple date arithmetic by subtracting the older of the two dates from the newer. But when it comes to months and years, DateDiff is super handy. So let's take a look at an example of how we could use DateDiff. So here we are back in our service schedule worksheet, in which we have the last service date listed for a variety of the equipment that we use as part of our shave ice business. So in column C, what we're going to try to calculate is the number of months since that last service date. This is a perfect use case for the DateDiff function. So to put DateDiff to work, I'll type equals DateDiff, and note that Excel makes no effort whatsoever to suggest this function via autocomplete. It's up to us to remember how to spell it and what the arguments are and in what order they go in. But hey, that's why you're watching this video. So keep in mind that the diff in DateDiff only has one F. That occasionally throws people off. So the first argument for DateDiff is the start date of the interval. So that's the older of the two dates. In this case, that would be the last service date over here in cell B2. The second argument is the last date, the end date in our interval. Now, since we're calculating the number of months from the last service date to the current day, for my second argument, I'll just use the today function, which will return the current date where I am dynamically. Now, the last argument for the DateDiff function is what sets it apart from the kind of date math we've seen thus far. The last argument allows us to define the interval of time in which our answer will be calculated. So if I want to see the number of days between these two dates, I would type the letter D in quotation marks. If I wanted the number of years, I would type the letter Y. But in our case, we want the number of months, so I'll type the letter M. And then hitting enter, we see that it has been 0 months since our last service date. Now, hold on, before you think this is an error, keep in mind that where I am, it's July 6th, 2021, so there has yet to be a single full month elapsed since that last service date. But let's see what happens if I fill this function down. And now suddenly we see reasonable numbers for elapsed months between these various dates and my current date of July 7th, 2021. Now again, keep in mind that you could have just as easily used this function to calculate elapsed days or years, but in my experience, it's probably most commonly used to calculate elapsed months. So another spin we can put on this calculation of elapsed time in between two dates is to only consider work days that have elapsed between those two dates. Now, this is something that would be incredibly difficult to do without a function doing the heavy lifting of excluding weekends for you. So it's just another great example of where Excel's built-in functions wrap a whole lot of powerful functionality in an easy-to-use interface. So let's say I wanted to know the number of business days or work days since the last service date. And again, by elapsed work days or business days, I mean excluding weekends, so Monday through Friday. To calculate that, I would use the net workdays function. Now contrast this with what would happen if I tried to calculate just the number of elapsed days between a given date and the current date. So for example, if I just wanted to see the number of calendar days between last service date and the current date, I could say equals today minus the last service date. And I get an answer of 20 days. But with the net workdays function, I can actually exclude all the Saturdays and Sundays that occurred within that interval. So now I'm just capturing those workdays. And this is a use case that comes up more often than you might think. A lot of times businesses want to judge themselves or perhaps judge clients, not in terms of how long it took something to do in terms of calendar days, but rather in terms of days when that business was actually operating, which quite often is just Monday through Friday. So to perform that calculation in this case with the net workdays function, I would type equals net workdays. And then my first argument is, just as with the date diff function, the start date of my interval, which in this case is going to be the last service date. And then the second argument would be the end date of that interval, which in this case is just going to be the current day, which I'll extract with the today function. And then if I hit enter, we'll see that instead of 20 days elapsed since the last service date, we now have 15, because in that interval there were five weekend days, 5 Saturdays or Sundays, which are now being excluded from the calculation. So now I can just go ahead and fill this function down. But before we go, there's one additional wrinkle we can throw onto that net workdays function. So right now it's just excluding Saturdays and Sundays, but what it's not considering are holidays. In order to make the net workdays function exclude holidays from its calculation, we actually have to supply the function a list of holiday dates in a range of cells. This is because holidays can vary so widely by not just country and culture, but even from company to company, that Excel couldn't realistically come up with a universal list of holidays that would work for every purpose. So just as an example, I've got a single holiday date listed over here on my holidays worksheet. Now this technically isn't the 4th of July holiday, but this is the date that it was observed this year. And I'm going to plug this in as a third argument to our net workdays function so you can see how it impacts the output. So if I go back into my function here, and then for my third argument, I go over to my holidays worksheet and select my July 5th quote-unquote holiday. And then if I lock down that cell reference, so as I fill the formula down, the formula will continue to point to cell A1 on this worksheet, and I'll do that just by hitting F4, and then hit enter. You'll see that the number of workdays since the last service date dropped from 15 to 14, because that July 5th date is no longer being included in the calculation, even though it actually occurred on a Monday. So now I'll go ahead and fill that modified formula down, and there we have it. So now you're armed with two pretty powerful techniques for calculating elapsed time between two dates in Excel that you can apply to a variety of use cases. All right, up next we're going to look at a couple more functions that we can use to transform our date and date time values into potentially more user or business friendly formats. I'll see you then. Hey, welcome back. In this one, we're going to take a look at a couple of Excel functions that can help us transform our date and time values in ways that can make them more meaningful to us or useful for our purposes. First up is the trunk function. Now that's trunk with a C, not trunk with a K. We actually looked at this one a little earlier in regards to transforming decimal numbers into whole numbers. So for example, if I had a number 2.567 and I wanted to transform that to just the number 2, I could use the trunk function to do that. Well, if you recall, Excel stores a date as just the number of days since January 1st, 1900, and then whatever time component a date value has just represents a fraction of a 24-hour day. So 6 a.m., for example, would translate to 0.25. So given that the time component of a date time value could be looked at as just a fraction added on to the date, a decimal, if you will, we can also use the trunk function to clip off that time value from a date time, just leaving the date instead. So let's take a look at applying this technique on our sale date time data in our Shavai sales tracker. So right now that data is stored as dates with time components, basically a date and a time. But if we only wanted to see just the dates and we weren't interested in those time values, in the next column over, I could type equals TRU and then arrow down my autocomplete list to get to the trunk function, hit tab to select it. And then if I just select that first cell in the sale date time column and hit enter, you'll see that the timestamp component of that date has been removed, and all we're left with is just a date. So I'll go ahead and fill that down. And now we have a sale date column to go alongside our sale date time column. Now, assuming we are no longer interested in our sale date time column, before I delete it, I'm going to want to lock in these formulas in column L, our new sale date column, so that those formulas don't break or error out when I delete the cells that they're pointing to. So I'll highlight that column, right-click, copy, paste special as values, and now you'll see that the formulas have gone away and we're just left with raw values. So now I can delete my sale date time column, and then I'll paint the format of my column header into my new column. All right, so now we have pretty quickly transformed our sale date time values to just dates. Now the other transformation trick I wanted to show you is when we might want to transform a date into something other than a date, namely a text value, a name. So what if we wanted to filter or sort our data by day of the week, or perhaps month of the year? Now, to be sure, we could use the month function to parse out month as a number, but that's not necessarily as business-friendly a view as the actual name of a month. And if you were to try to parse out the day of the week as a number, that's even more cryptic. Now, there is a weekday function in Excel that does return a number 1 through 7 of the day of the week, but that output's just going to be confusing to most people. It's much more intuitive to transform that date into an actual word that people recognize as a day of the week or as a month. So the function we can use to do that is called the text function. The text function takes a value, some numeric or date value as an input, and then it transforms that value based on some format pattern that we provide the function into a text value that presumably is more human readable or user friendly than the number or date value we're transforming. So there's a ton of different formats that this function accepts, a ton of different ways that you can transform your date values, but I'm going to zoom in on just 2. So the first one is transforming a date into just the name of the month. So to do this, we can type equals text, and then the first argument of that function is just the value we're transforming. And then the second argument, again, is that format pattern. So this is going to go in double quotes because it's a text string. And the format pattern to transform a date into the name of a month is 4 M's. 1, 2, 3, 4. Put that in double quotes. And you'll see that the date has now been transformed into the name of the month that that date belongs to. And rest assured that this text is an actual value. It's not just a format whose underlying value is still the date. The value in this cell is literally the text string November. Now likewise, we can also extract the day of the week using the same function with just a slightly different formatting pattern. So if in the next column over I type equals text, and then again I select my sale date as my input, but then for the second argument, the format string, I supply 4 D's, 1, 2, 3, 4, surrounded by double quotes. You see that now the function returns the day of the week that particular sale date was on. So now if I fill that down, now I'm breaking my sale date out by both the month and the day of the week in a very easy to read, easy to interpret fashion. And lastly, I'll just type in some user-friendly headers to our new columns. And then I'll auto-fit those guys and paint formats. And it looks like we're good to go. All right, so this foray into transforming date values into text segues nicely into the next phase of this course, where we're going to look at built-in Excel functions that can help us manipulate and transform text values. We'll start our journey down that road in the next video. I'll see you then. Welcome back. So armed with Excel's date functions, we're ready to add some extra coolness to our budget and expense tracker project. Our goal for this iteration of the project is to add another new worksheet, which will contain a savings calculator like the one you see here. The 3 inputs to this are pretty straightforward. We'll first enter our long-term savings goal, then the target date by which we want to achieve this goal, and the amount we currently have in savings. But next is where things get a bit more interesting. What I want you to do is calculate the amount we need to save each month to achieve our long-term savings goal, based on our target date and the amount we currently have in savings. Now, I'm not going to tell you exactly how to do this, but I will give you some hints. Basically, you'll want to calculate the difference between our savings goal and what we currently have in savings, in other words, what we have left to save, and then divide that amount by the number of months we have left until our target date. This last part is really the rub. I suggest using the dateDiff function to calculate the number of months between the current date, which you can also get to with another date function, and the target date. Once you've got that down, the last calculation should be straightforward. Simply divide the monthly savings goal by our calculated monthly income on the Summary tab to get the percentage of our income that the savings goal represents. Now, as you can see here, the formatting of my example worksheet is pretty much identical to the summary worksheet you worked on earlier, so you can either mimic my styling choices or make your own. No big deal either way, as long as your solution works. So now, as per usual, go ahead and pause the video and see what you can do with this exercise. Then play it again to see my solution whenever you're ready. Okay, so hopefully you had some fun with that. So let me go back to our starter file, and now I'll get to work building out our savings calculator here. So first I'll add a new worksheet just to the right of our Summary tab, and I'll call it Savings Calculator. So I'll start by typing savings goal here in cell B4. And for now, I'll set that goal to $59,000. And then down in cell B6, I'll type out target date. And then for our target date, I'll enter June 22nd, 2028. And then for current savings, I'll enter $3,750. And then I'll format our three labels as heading 1, and then autofit column widths. And then I'll format our three input cells as Century Gothic, and increase that font size to 14. And then I'll format our dollar amounts as currency. So next I'll create labels for monthly savings needed and percentage of monthly income. But I'll just copy and paste our existing headings so I can just change the font color. So I'll say monthly savings needed, and then percentage of monthly income. And then I'll format these two cells with a font color of orange. And then autofit once again. So now down here in cell C10, we'll need to enter a formula for monthly savings needed. So the first piece here will just be to calculate the difference between our savings goal and our current savings. So I'll start just by writing that very simple formula. So there's the amount we still have left to save. So now what we need to figure out is the difference in months between the current date and our target date. And that's where the dateDiff function comes in. So instead of nesting that function in our existing formula already, I'm going to go ahead and write that out in a separate cell, just so we can focus on the mechanics of the function. So out here to the right, I'll type equals dateDiff. And remember, again, because of some strange weirdness, Excel does not offer autocomplete for this function, despite how useful it is. But we should know the arguments pretty well, so we won't need to rely on autocomplete. So our first argument will be the start date, and that is just going to be the current date, which I'll get to with the today function. And then our second argument will be our target date here in cell C6. And then the last argument will be in what time increments we want to see this difference expressed. And in our case, that's months, which we can specify just by typing a capital M in between quotes. So then we'll close that parenthesis. And there we are. It looks like it's 78 months from today, as of when I'm recording this at least, until June 22nd, 2028. So now that I know this formula works, I'll actually just copy the text of the formula right out of the formula bar, and then I'll plug that in to our monthly savings needed formula. But just to make sure the order of operations work properly, I'm going to surround this C4 minus C8 with parentheses, and then divide that by the result of the function that we just wrote, and I'll get rid of that equal sign. So now let's hit enter and see what happens. And there we go. It looks like we need a monthly savings of $708 to hit our savings goal by June 22nd, 2028. So just to clean things up a little bit, I'll get rid of our rogue date diff function out here. And then I can fix the formatting of our monthly savings needed cell just by using the format painter. So I'll select my current savings amount and then go up here on the home tab to this little paintbrush that has the format painter tool. I'll click that and then click here. And now I've copied that format over. Now the last piece of this is much simpler. We just need to figure out the percentage of our monthly income that this savings represents. So we'll type a formula that says equals our monthly savings needed divided by our monthly income on our summary tab. So now we hit enter. And now we'll need to reformat this number as a percentage. So we'll right click, format cells, percent. And then just to keep this in alignment with the rest of the sheet, I'll format a Century Gothic 14. And there we are. It looks like our little savings calculator is working. So all that's left to do at this point is just some simple formatting. We can create a header for our savings calculator to make the purpose clear. So to do that, I'll widen row 2 here. And then I'll merge cells B2 through J2. And then I'll type savings goal calculator. And then I'll format as accent 1. And then change the font size to 20. And finally, I'll remove grid lines from this worksheet just to make it look a little bit cleaner. And at this point, I think we're done. So that's it on our budget project from now. But we've still got a lot more features to add. We'll pick up where we left off after the next section. See you next time. Welcome back. So in this one, we're going to take our first crack at using Excel's built-in functions to manipulate text data, as opposed to the numerical or date data that we've been working with thus far. Now, ironically, that text data that we're going to work on consists almost entirely of numbers. As you can see here, we have a list of randomly generated phone numbers. Feel free to try to call any of these. Who knows, one of them might actually work, but these were completely randomly generated. But even though these phone numbers contain numerical digits, they can actually be classified as text data, just like maybe a person's name, for example. And that's because other characters are mixed in. You have these hyphens separating the area code from the first 3 digits, and then the first 3 digits of the phone number from the last 4. So what we're going to try to do is split this phone number out into its constituent parts using Excel's built-in text functions. First, we're going to split off the area code into its own column, then the first 3 digits of the phone number, and finally the last 4. So let's get started by pulling out the area code. So what we need here is a function that will allow us to grab the first 3 characters from the left side of this text string. And Excel actually provides us a function called left. So the left function takes 2 arguments. The first is whatever text string we're trying to extract something from, and the second is how many characters we want to peel off the left side of that text string. So here in column B, if I click in cell B2 and type equals left, and then for my first argument, just supply the value in cell A2, And then for my second, the number 3, because we want to pull the first 3 digits from the left side of that phone number, and hit enter. You'll see that it pulled out the area code from the phone number just like we wanted. So I'll go ahead and fill that down. Now, instead of grabbing the first 3 digits of the phone number next, I'm going to cheat ahead and grab the last 4, because the method for doing that is so similar to grabbing the first 3 or the first however many characters from a text string. So I'm actually going to give you 5 seconds to guess what the function to pull the rightmost n characters from a text string in Excel is. Here you go. Okay, I think that was 5 seconds. I'm not sure, but I hope you got the answer right. It was right. And congratulate yourself if you got that right. If so, valuable prizes are on their way to your doorstep. So the right function works just like the left function, except, you guessed it, it extracts text from the right side of a text string. So if I want to grab the rightmost 4 characters from this phone number, I can type equals right. And then the first argument is again the text string we're trying to parse. And the second argument is just the number of characters we want to parse. That would be the number 4. And I'll hit enter. And it looks like that worked perfectly as well. So now the last step is going to be just a little bit more complicated. And that is extracting the first 3 digits of our phone number. Not the area code, but the 3 digits in between the area code and the last 4 digits of the phone number. So we can't use left here, and we can't use right. And that leads us to the third function of our trio, which is called mid. Excel really got creative with these names, by the way. So the mid function takes one additional argument that the left and right functions do not. And that is the starting position within the string that we're trying to parse that we want to grab our characters from. By definition, the left function starts parsing from the very first character of the string. And then the right function works in the exact opposite direction from the very end of the string. So what we need to do in the mid function is tell Excel, we want to grab this many characters from the string, but starting at this particular position. So if you look at the pattern of our phone numbers, it looks like it's the 5th character in each phone number that we want to start our extraction of characters from. You've got the first 3 characters, which are the area code, and then the 4th character is a hyphen, and then that 5th character is really where we want to start parsing. So up here in cell C2, I'm going to type equals mid, and then my first argument, just like our other 2 functions, is just going to be the text string we're trying to parse. Then that second argument is going to be the start number, where we're going to begin our text parsing. So we're going to punch in 5 for that. And then the last argument is just the number of characters we want to extract, starting from that start number. And that is going to be just 3. So now if I hit enter, it looks like that worked as well. So now I'll just go ahead and fill down our 2 formulas. And now we've successfully parsed out a list of phone numbers into their 3 constituent parts. Pretty cool. But things can get a little bit more complicated when the text strings we're trying to parse don't all have predictable lengths. For example, if you're dealing with international phone numbers, sometimes these components don't always have the same number of characters. And the methods we've looked at so far really only work if we always want the same number of characters from the left side, the right side, or the middle. If instead we potentially need to grab a variable number of characters from any position within the string, we're going to have to get a little bit more creative and bring some new techniques to bear. We'll dig a little bit deeper into that in the next video. I'll see you then. Hey, welcome back. So in this one, we're going to resume parsing components out of phone numbers, but with an extra twist beyond what we explored in the last video. And that is that we're going to be working with international phone numbers, which both have more components than domestic phone numbers, and those individual components can also be of variable lengths. So without getting too deep into the weeds of exactly how international phone numbers are constructed, at a high level, you have a country code, which is the first few digits you see after the plus sign in our phone numbers in column A. And then inside of the parentheses, you have the national direct dialing prefix, and then the digits between that and the hyphen are the area code. And finally, the number is anything that comes after the hyphen. But as you can see just from a few examples, all these components can potentially be of variable lengths. In row 2, we have a phone number with a 3-digit country code, but down in row 5, we only have a 2-digit country code. And likewise, our area codes and phone numbers could potentially be of variable lengths. So we're not going to be able to simply clip off the first 3 or first 4 characters or the last n number of characters to split this phone number up into components. We're going to have to be a little bit more strategic and bring a couple of new functions to bear on this problem. Now, I'll introduce these functions kind of as we go, as they're required in the course of parsing these components out of the phone number. So we'll start with country code. And again, that's the numbers immediately following the plus sign, but before the number inside of the parentheses. So the number itself isn't at the very beginning of the phone number. So we really can't use the left function because the left function starts from that very first position. So given that we're starting somewhere in between the beginning and the end of the string we're working with, that tells us we should probably use the mid function. And we know that we should start at that second position in the string, right? Like we don't want to include the plus sign, so our starting position will be 2. So really the only question that's left is, how many characters should we pull out of the string starting from position 2? In our very first phone number, we'd want 3 because we have a 3-digit country code. But then in our fourth phone number, here in cell A5, we'd only want to count forward 2 characters. So how do we determine what that number is that represents the number of characters we need to extract starting at that second position to get our country code? Well, this is where Excel's find function comes in. So find lets us locate the very first position in a string that a particular character is located. So if you look at the pattern of these phone numbers, there's always a space after the country code. So what if we could find the position of that space? Well, let's take a crack at that with the find function. So here in column D, which I've labeled space position, I'm going to type equals find, and then the find function takes as its first argument the text that we're looking for. So in this case, we're looking for a space. But a space is still considered a type of text information, so we still have to wrap it in double quotes, just like if we were looking for the letter A, for example. So I'll type a double quote, and then crucially, I'll hit my space bar to create a space character, and then another double quote, and then a comma. And then the next argument is simply the text that we're looking for this space in, which will just be our phone number over in cell A2. So now if I hit enter, we see that the position of that space is 5. So the space is the 5th character in that string. So now the question is, how do we translate that number into the actual number of characters that we want to parse out for just that country code? Well, if you think about it, we don't want to include the space in our country code, so you could subtract 1 from this number 5 here, because that number 5 is including the space. It's basically saying the space is the 5th character in the string, and we're not interested in that, so we could subtract 1 from that. Now we're down to 4. But we also don't want to include the plus sign as the first character. So what we really need to do is just subtract 2 from whatever the position of the space is, and that should get us to the number of characters that we need to feed the mid function so we can get that country code. Now, just to make this clearer, let me fill down this formula down to cell D21, and you'll see that for our phone numbers that have 3-digit country codes, this space position is 5. But if you go down to row 5, where we have a 2-digit country code, now the space position is 4. So if we subtract 2 from that value, now we get an answer of 2, which in fact is the number of characters we need to pull out of the phone number to get our country code for that particular value. So now at this point, we're ready to use our mid function. So over here in the country code column, I'll type equals mid, and then our text input will just be, again, our phone number. Our start number will be that second character because, again, we're not interested in the plus sign. And then finally, for number of characters, and this is the question that we've been trying to answer thus far using the find function, we'll just enter the number in column D in the same row, that space position, minus 2. And now if I hit enter, it looks like I have the right country code for my first phone number, but let's see what happens if I fill down and see how that handles cases where the country code is less than 3 digits. And it looks like that worked as well. All right, so far so good. So instead of tackling area code next, which is going to be a little more complicated than our other two components because it's sort of stuck in the middle of this whole mess that is our international phone number, instead we'll take a shot at the actual phone number component of the overall phone number. That is to say, everything after the hyphen. Now, since this component is the last several characters of the overall phone number, we can use the write function here. The only problem is we don't know how many characters we need to clip off the end of the string. This is because the overall international phone number varies in length. The individual phone number components vary in length. So we can't just say we want to grab the rightmost 5, the rightmost 10 characters. Instead, what we need to do is key off the location of that hyphen that comes directly before the phone number component. So we'll start there. So let's again use our find function here in column C to locate that hyphen. So we're going to search for the hyphen, and again we'll put that in double quotes just like we did the space, and we will search for that within our phone number, and then we'll just fill that down. So just like with the space position, you can see that that position of the hyphen varies depending on the lengths of the various components of the phone number. So this is what's going to help us determine how many characters to peel off the right side, that is to say the end of the overall phone number, to get just our phone number component. So now the question is, since we know the position of the hyphen, how do we translate that knowledge into being able to calculate the number of characters in that phone number component, which is everything after the hyphen? Well, the answer is, if we can also calculate the length of the overall phone number, that is including the country code and the area code and everything else, and then subtract the position of that hyphen, suddenly we've got the number of characters in the phone number. Fortunately, Excel has a built-in function that lets us calculate the length of a string, and that's called len, L-E-N. So here in column B, I'll type equals len, and len just takes one argument, which is the text string that we're trying to find the length of. And you'll see that the length of our first phone number is 20 characters. And I'll just go ahead and fill that down. And so if you subtract the position of this hyphen, which is the 13th character, from the overall length of the phone number, what you get is the number of characters left after the hyphen, which just happens to be the number of characters in our phone number component. So now we have all the information we need to extract that phone number component. So now over here in column H, I'll type equals write, and then my text, of course, is still the phone number. That's my text input. And then for the number of characters, I'm going to subtract the position of the hyphen from the length of the overall phone number. So cell B2 minus C2, and then hit enter. And once again, it looks like our text functions worked perfectly in conjunction with each other. So now the last piece, and probably the most difficult, is the area code. And this is everything between that number in parentheses and the hyphen that comes before the actual phone number component. So for example, in cell A2, our area code is 8287. Now getting to this one is going to be a little bit more of a doozy than the last two, but we'll take it slow and systematic and work through it step by step. So this text string is in the middle of the overall phone code, so that should tip you off that we're going to need to use the mid function. So mid asks us two things. It asks us for a starting position in the string, and then it also asks us for the number of characters we want to extract starting from that position. So right away we can see that this area code is always preceded by a closing parenthesis. So we can key off the location of that closing parenthesis to derive the starting point of our mid function. So first I'm going to do a find on that closing parenthesis. So as my first argument, I'll just enter a closing parenthesis in double quotes. And then my second argument, of course, will just be the phone number itself. Now I'll fill that down. So now to get the starting position of our mid function, all I need to do is just add 1 to that position, because we want to start with the digit that comes after that closing parenthesis. So now we've got problem number 1 solved. Now problem number 2 is, how many characters are in our area code? Well, this probably seems pretty daunting, but the cool thing is we've already parsed out the positions of so many special characters within this phone number that we have the building blocks we need to get to that information right now. So we already have the position of our hyphen, and we already have the position of our closing parenthesis. So if I subtract the position of the closing parenthesis, which obviously comes before the hyphen, from the position of the hyphen, I get 5 here for my very first phone number. Now that's 1 more than the number of characters we need to extract to get our area code. But if I subtract 1 from that, now I should have the number that we need. So let's take a crack at that. So in column G for our area code, I'll type equals mid, and then of course my text will be the phone number. And then my start number is going to be the position of this closing parenthesis plus 1. Because again, we're not starting from that closing parenthesis because we don't want to include it in what we're extracting. We want to start with the very next character. And now for the number of characters, we're going to subtract the position of that closing parenthesis from the position of the hyphen to get the number of characters in between. So I'll select C2 minus E2, but that's going to give us 5 in the case of this first example. So we actually need to subtract 1 from that. And now if we hit enter, it looks like we pulled the area code out successfully. But again, we're not going to know if this worked until we see how it works on an example that has a different number of characters in the area code or different numbers of characters in the other components. So let's fill this down. And if we go down to an example of a phone number that has a shorter area code, like down here in row 7, it looks like we were able to parse that area code out successfully. Now keep in mind that you don't necessarily have to split out all of these find functions into their own columns. You could just as easily have nested these individual find functions inside of the formulas that we used ultimately to extract the text strings from the phone number. So for example, here in column F where I extracted country code, instead of referring to my space position formula here in cell D2, I could actually just copy the text of that formula, not including the equal sign of course, right out of cell D2, and then go back over to my formula in cell F2 and replace that reference to cell D2 with the actual function that I had in cell D2. And then if I hit enter, we'll see that it still works. So why would you want to do that? Basically just to reduce clutter in your worksheets. If you're more comfortable with breaking out complicated processes like this into multiple steps and having different columns hold each of your intermediate steps, that's totally fine. But you may find as you get more and more comfortable with formulas and functions that to save space in your spreadsheets, to make them a bit less cluttered and to have fewer columns, you might find that you start nesting some of these intermediate steps inside of the overall function that gives you your result. All right, I know that was a doozy, and I apologize if that was a little tough. I would highly encourage you to take some time to review these formulas in the example workbook and maybe take a shot at redoing them on your own. So up next, we're going to take a look at a couple more text functions that we can use to clean our text data. In the real world, it's very often the case that the text data we work with is messy and inconsistent, but fortunately, Excel offers us some functions that can help us clean up this messy data. We'll take a look at that in the next video. I'll see you then. Welcome back. So when working with real-world data, you'll find all too often that inconsistencies can hinder your ability to perform meaningful analysis on your data. variations in spelling, variations in capitalization, and other general purpose messiness can serve to cloud your insights into the data. As an example here, I have a list of names that have some inconsistencies that I can tell you are fairly common when you're dealing with real-world text data. For example, some names are capitalized, others are lowercase, still others are formatted in what's known as the proper method, in which the first letter of each word is capitalized, and then some names have spaces in between, but others have periods and others have commas. So our goal here will be to clean up these names such that they all fit a standard format. In some cases, you may want all your text data to be uppercase or lowercase or proper case. You may want words separated by commas instead of spaces, but the key is all your data should fit that format, whatever format you choose. And that's what the functions we're going to look at here are all about. So let's say, for example, we want all of our names to be entirely uppercased, kind of like the name we see down here in cell A7. So to do that, we can use Excel's upper function, which just takes one argument, which is the text that we want to transform to uppercase. So here in cell B2, I'll type equals upper, and then I'll feed that my name in cell A2. And as you can see, this was converted into an entirely uppercase format. And I'm actually misusing the word format here because this is not a format you're applying. This is actually changing the value of that cell to now consist of entirely uppercase letters. So now I'll fill that formula down. And now in the next column over, I'll do the opposite. I'll convert my names in column A to be entirely lowercase. And I can do this using Excel's lower function, which works exactly like the upper function. So if I type equals lower, and then feed my value in column A to that function, you'll see that it did the exact opposite of the upper function. Now finally, I'll use Excel's proper function to convert our names to proper case, which again is where the first letter of each word is capitalized, and the rest are lowercase. So here in cell D2, I'll type equals proper, and again feed the function my name from column A. And now if I fill that down, we'll see that all of the words in our names, that is to say each part of the name, has its first letter capitalized, but the other letters are lowercase. Personally, I prefer this look when it comes to dealing with names. So one other inconsistency that often creeps its way into our data is leading or trailing spaces. So if you look at the first two names in column A, you'd think that these values are identical, but they're actually not. So if we select the first one and then click in the formula bar immediately after the name, you see that the cursor is blinking right after the last letter of the name, the N. But if we do the same thing to the second instance of this name down in cell A3, we see that there's now a little bit of daylight in between that letter N and our flashing cursor. And what that means is that we actually have a space character that is part of that text string after our last name. Now these kinds of trailing spaces, and in many cases there are also leading spaces that precede the text string, can cause all kinds of problems when you're trying to group and sort and do summary statistics on data, because in those situations, these two names would be counted as two distinct names, even though they're obviously the same person, because technically a name with a space at the end of it is a different value than a name without a space. But fortunately, Excel gives us a function which is specifically designed to clip off those leading and trailing spaces, and that is the trim function. So here in cell E2, if I type equals trim, and then select our first name as the input, and now I fill that down, and then lastly, if I just select the whole column, right-click to copy, and then right-click again, paste special as values to lock in the output of the trim function in as an actual value into the cells. So now if I select cell E2 and then click in the formula bar after the last name, we see there's no space between the last name and the cursor, which is good. But then if we do the same thing in cell E3 for our second instance of this name, again, there's no space. So our trim function got rid of that trailing space. And just to reiterate, if you had leading spaces, that is to say spaces that occurred before the name, trim would have clipped those out as well. Now, if we look at our list of messy names, we see one more issue, one more inconsistency that we need to take care of. And that is that some names are separated by spaces, but others are separated by periods and still others by commas. And what we really want to do is standardize that so that the first and last components of the names are all separated by the same character. And in our case, we'll just choose the space, which is the most conventional. So what we really need to do is replace every instance of a period in each of these names with a space character and do the same thing for commas. So how do we do that? Well, Excel has yet another function express built for this purpose, and that's called substitute. So the substitute function takes 3 arguments. And we'll go through these as we write this function out in column F. So first we'll find the function, we'll type equals substitute, and now the first argument the substitute function takes is just the text value, the text string we're trying to transform. So that'll be the value in cell A2. And then the second argument it takes is whatever text string, whatever character or characters that we want to replace with something else. Now in this case, we're trying to replace, just as an example, the period character, the dot. So in double quotes, because we're typing out a text string, we'll just enter a period, and then a second double quote. And then our last argument is what we want to replace that character with. So wherever we see a period in this text string, we want to replace it with a space. So our final argument will just be a space enclosed again in double quotes. So double quote, space, double quote. And now if we hit enter, nothing happened to our very first value because our first value didn't have any periods in it. But if we fill our formula down, and then if we compare a name in our transformed column to a name in the same row in our original column that had a period in it, we'll see that that period has been removed and replaced with a space. So now we've replaced our period characters, but what about the commas? Well, there's a couple ways we could approach this. One is that in yet another column, I could add another substitute function and then use the output of my substitute function in column F as input to the substitute function in the next column over. So for example, I could type equals substitute, and then I'm using the output of my first substitute function as input to this next function because I've already solved the problem of getting rid of the periods in that first function. So I could use F2 as my first input, and now I'm going to replace commas with spaces. And now if I fill that down, it looks like we have successfully gotten rid of both types of punctuation in those names. And this is a perfectly valid approach if you're not comfortable, again, with nesting functions inside of other functions. But I would say it's more conventional and a little bit more convenient in cases like this to just nest the output of one substitute function inside of another. So let's take a look at how to do that. So in cell F2 here, I'm actually going to type another substitute function before my current one. You'll see how this makes sense in just a second. So I'll type equals substitute, and now my old substitute function is basically the input. It is being supplied as the first argument to my outer substitute function. So what's really going on here is this inner substitute function is executing. It's returning my transformed text that has had all the periods replaced with spaces. And now that is fed as an argument to my new outer substitute function. And then my second argument can just be the comma that I'm trying to replace. And then the final argument will again be the space that I'm replacing the comma with. So now if I hit enter and then fill my new function down, you'll see that both types of punctuation have now been replaced with spaces. All right, now that we've taken the grand tour of text functions in Excel, we're going to change gears a little bit and look at a type of function in Excel that is also a fundamental construct in pretty much any programming language in existence today, and that is the if function. This will allow you to take the knowledge you already have of formulas and functions in Excel to an entirely different level. I'm excited to dive into that next. I'll see you then.
Hey everybody, I want to take a quick break here. Go grab a coffee, grab a tea, just take a break from all the learning that you just did. And I want to talk to you quickly about imposter syndrome. It's this idea that you're not good enough, that things are too complicated for you to ever achieve what you want to achieve. You look at other people, at other industry experts, and you say, I will never get there. But it's just a symptom of learning. This idea of you not being good enough simply means that, well, you're just not there yet. Things take time. If you want to learn a valuable skill, well, it's hard work. That's why it's valuable. Remember how you felt on the first day of going to school, first day on a job. It's the same experience. But over time, with repetition, with practice, you get comfortable, you get experience, and you slowly start to lose that imposter syndrome. Now, this idea of an imposter syndrome is great. It means you're doing something worthwhile. So don't use it as a negative. Use it as an encouragement that you're doing something good, that you're learning and you're stretching your limits. So with this break, I want to propose that we do a quick exercise. I want you to stop the lectures. Again, grab a coffee, grab a tea, and head on over to our Discord. Now, in our Discord server, if you've used it up until now, that's great. If you haven't, head on over to this server, and I want you to do something that I think it's super important to learning. And that is using what you've learned up until now to actually teach someone or help someone. So you can go all the way to, let's say, the coding and courses section and pick a topic that you want to help somebody in. So let's say you go to the Python channel. And in here, you'll have other students that are asking Python-related questions. Now, you can scroll through here and see if you're able to help someone. Even though you may not have the experience or the knowledge yet, this idea of practicing and explaining what you've just learned to other people, even if you're not 100% certain, actually is beneficial to your learning. Because if you're never teaching, if you're never explaining and vocalizing and showing what you've learned, you'll always be a beginner. This idea of teaching what you learn is a very important concept. So moving forward, as you go through the lectures, anytime you feel like taking a break, hop on over to Discord and help somebody. Our motto here is that we're always kind. We don't judge anybody. We're all just beginners here. We're all learning. So don't be afraid to answer things because you got to remember, nobody's perfect except for Yoda. Yoda is pretty perfect. All right, I'll see you in the next one. Bye-bye.
Hey, welcome back. In this one, we're going to look at an extraordinarily powerful function that gives you the power to take your formulas in one of two or potentially even more directions based on logical tests that we define. This is Excel's if function. The basic structure of the if function is this. We feed it a logical test, most typically, but not always, a comparison between two values, and depending on whether or not this test returns a result of true, our function can return one or the other of two expressions. And by expressions, I simply mean either a value or a formula or function that returns a value. I make this distinction because both the logical test and the values that the function returns can all in turn be the output of functions themselves. To get a better idea of how all this works, let's start by reviewing the most fundamental logical tests that we can use in our if functions. So here in our first example spreadsheet, we have a list of some basic logical tests and some input cells that we can apply these conditions to. So up first is the test for equality, which, as you probably guessed, just tests to see whether two values are equal to each other. So if I type, say, the name Travis in the first input cell, and then Todd in the next, and then now over in cell D2, I write out the formula equals B2 equals C2, and this formula is literally saying, does the value in cell B2 equal the value in cell C2? If I hit enter, the value is false. But if I change input 1 to be Todd, now the value in cell D2 is true. And this works on numbers as well. So if I enter 2 in the first input cell, and then the second, now we have a value of true. But then if I change the second input to 3, we're back to false. So this probably doesn't seem too groundbreaking or earth-shattering thus far, but this ability to write a formula that returns a value of true or false is key to setting up an if function. Because the first thing the if function needs is some kind of a logical condition that can evaluate to true or false. So now what I could do here is set up an if function that returns potentially two different things depending on the outcome of this logical test. So over in cell E2, I'll set up our first if function. So I'll type equals if, and now you see that first argument is a logical test. So strictly speaking, all that's required here is just a value of true or false, which, by the way, aren't just like text strings. These are actual unique values in the world of Excel. So if you just type the word true, it's not the same as a value of true in the logical sense. So basically, we need either a value of true or false, or much more commonly, a function or formula that evaluates to either true or false. But since we have a logical value right here in cell D2, I can reference that. And then the second argument the if function takes is the value that it should return if that logical test is true. So just for the purposes of demonstration, I'll type out just something like, I'm true. And then the third argument the function takes is the value that should be returned if that logical test is false. So I'll just say, I'm not true. So as you can see, our if function is now returning, I'm not true. But if I were to change, say, my input 1 to be 3 so that it matches my input 2, now my if function returns, I'm true. Now, while you can point an if function to another function that evaluates to true or false like we're doing here, it's much more common to have the logical test itself embedded inside the if function. So instead of the if function referencing a cell like I'm doing here, referencing cell D2 for the logical test, we would actually have the formula that's here in cell D2 inside the if function. So let's actually go ahead and refactor our formulas here to work that way. So in cell D2, instead of just having this equality formula, instead I'll say equals if B2 equals C2, I'm true, I'm false. And now, again, if we change one of the inputs so that they're not equal anymore, it looks like our function still works. Next, we'll take a really quick look at some of the other logical tests that we can use in our if functions. So the next one down is the equality logical test, which is the exact opposite of equality. So if 2 equals 2 returns true, then 2 does not equal 2 returns false. So first, just to save myself some typing, I'll go ahead and fill my formula in cell D2 down. And then I'll enter a couple of inputs in cells B3 and D3 just to illustrate how the does not equal to operator works. So I'll say 3 and 4. And right now, our formula is saying I'm false because it's still using the equality operator in our logical test. But if I change that to be the inequality operator, which is essentially a less than sign followed by a greater than sign, and hit enter, now you'll see that the function returns I'm true because these values do not equal each other. But if I change the first input to 4 so that they match, now it says I'm false because they are not equal. And then the last two operators are pretty self-explanatory. It's just greater than and greater than or equal to, and then less than and less than or equal to. So I could just type 2 and 3 as my inputs, and then in D4, I'll say if B4 is less than C4, which is to say if 2 is less than 3, then I'm true, otherwise I'm false. And as you'd expect, it says I'm true, but if I change my first input to be 4, now it says I'm false. And you know what? I'm confident at this point that you know how all this works, so I'm just going to skip ahead. So I'm just going to skip the less than operator and move on to a more realistic demonstration of what the if function can do. So back in our shave ice tracker, I've added a column called discount price. And what this is going to do is allow us to calculate a discounted price based on our sale amount that a customer will receive only if their purchase exceeds some threshold. So we want to reward our customers for making large purchases. So if somebody makes a purchase over $35, we're going to give them a discount of 10%, and that will be the discounted price. But if they don't make a purchase greater than $35, they just pay the normal amount. Sounds like a pretty good application for an if function. So here in cell K2, I'll type equals if. And now my logical test is going to be if that value in column J is greater than 35. So I'll say J2 greater than 35. And then if that is indeed the case, we want to discount that price in cell J2 by 10%. Now, a really convenient way of doing this is just multiplying the price by 0.9. It's basically logically equivalent to taking 10% off the price. So we'll say if that logical condition is true, if the sale amount is greater than 35, we'll just multiply this price by 0.9, and that's the value we'll return. And then if that condition's false, we'll just return the regular sale amount by default. So now I'll hit enter, and then fill my formula down. And the effect isn't immediately obvious if we look at our first couple of values because those values are under $35. But if we go down to our third sale amount of $39.80, lo and behold, you'll see that that amount has been discounted to $35.82. But now this raises the question of how we could potentially add multiple levels of discounts based on different sale amounts. So what if I wanted to reward customers who paid over $25, but not quite as much as those customers who paid over $35? Maybe I want to give them a 5% discount. How can I incorporate that into my if function? Well, scenarios like this call for a somewhat dreaded construct in the world of Excel called the nested if function. And this is where you essentially put an if function inside of another if function. And while that can be as hairy as it sounds, as long as you limit yourself to maybe 2 or 3 levels of nesting, it's not too hard to keep track of. So basically, when you're nesting if functions, the second if function, the interior if function, takes the place of this final argument, this value if false. So the logical flow of a nested if function goes something like this. The first step is we test to see if this first logical test is true. If it is true, then this first value of true is returned, and nothing else happens. Everything stops at that point. But if this logical test is false, we skip past this value of true, and we go to the value of false. But with a nested if function, instead of that value of false just being a value, it's actually another if function. So now we have a whole nother logical test, and then another value of true, and then another value of false. So here, instead of saying the value in cell J2 is my default if that logical test is false, instead, I can type another if function. And then my new logical test will be if J2 here is greater than 25. And then if that's the case, we're going to discount that price in J2 by 5%. So we'll multiply the value by 0.95. And then if that logical test is false, which by proxy means both tests have been false because we wouldn't have gotten to the false condition of the first if function if that first test hadn't been false, and now we're at the false condition of the second if function. So we know both of those tests have failed. Now we can just return the regular sale amount by default. But something funny is going to happen if we try to hit enter here. Microsoft Excel says we found a typo in your formula and tried to correct it too. And while their recommendation is correct, I'm not going to accept this correction because I want to show you what's going on and why there is in fact an error. So Excel accurately tells us that this formula is missing an opening or closing parenthesis. So the reason it's missing one is that every function that we nest requires an opening and closing parenthesis, just like if we wrote that function independently in its own cell. So right now, this inner if function does have a closing parenthesis, but that closing parenthesis was originally the closing parenthesis for our outer if function. So now our inner if function has sort of hijacked that closing parenthesis, so now the outer if function doesn't have one. So what we need to do is add just one more, and now Excel's happy. And you can actually kind of keep track of which opening and closing parentheses align to each other based on color coding that Excel provides. So you can see that the opening and closing parentheses for this inner if function are red. And then when we type that second closing parenthesis, now it's black, just like the opening parenthesis for the outer if function. When it comes to nested if functions, keeping your opening and closing parentheses aligned is probably the thing that gives people the most trouble. The rule of thumb I follow to make it as easy as I can is that for every opening parenthesis, you've got to have a closing. And more to the point, for every if function we have, for every nested if, you have to have one additional closing parenthesis. So now here we've got two if functions. We've got one if function inside of another. That means we need two closing parentheses. Now you're not limited to just one nested if function. We could, in fact, replace this value of false argument, this last argument, in our inner if function with yet another if function, and then keep going in that manner as long as we wanted. But at that point, these nested if functions get kind of hard to read. But the bottom line is, if you have two if functions, one nested inside of another, you need two closing parentheses. That's kind of the rule of thumb I would follow when writing out these nested ifs. So with all of that said, I'll hit enter. And then if I fill that down, now we see that sale amounts less than $35, like our one down here in cell J6, are still getting a discount, just not as big of a discount as sale amounts greater than 35, like the one up here in cell J4. Now, one last note about nesting if functions before we go. The order in which these logical conditions are applied is very, very important. So imagine that our outer function had the condition of J2 is greater than 25, and then our inner condition was J2 is greater than 35. Well, the problem with that is anything that's greater than 35 is also greater than 25. So basically, none of our sales over $35 are going to get their special discount because they'll all be lumped into that wider, more inclusive group of sales greater than 25. So it's important that we put the logical condition of sales being greater than 35 first, before testing whether they're greater than 25. In general, when you're nesting if functions inside of other if functions, you want your more restrictive criteria, your more restrictive logical tests in the outer function, and your less restrictive, broader logical conditions, like in this case, greater than 25 as opposed to greater than 35, in your inner if function. All right, so we've already gone pretty deep on the if function in this video, but up next we're going to take it even further by looking at how we can combine multiple logical tests in a single if function. I'll see you then. Hey, welcome back. So thus far, our if statements have been limited to considering one single logical condition or test to determine which of the two values it will return. Basically, if the condition is true, we return one thing, and if it's false, we return another. We haven't yet seen how we can combine multiple conditions in a single if function. Fortunately, Excel provides us with a couple of functions, which are categorized as logical functions, called and or, which will help us consider multiple criteria in a single if function. And or both work by considering multiple logical conditions themselves, and then, depending on which of these are true or false, the overall function, and or returns true or false in turn. The difference between them is that and only returns true if all of the logical tests we provide it are true, whereas with or, if any of the logical conditions we provide it are true, the or function itself returns true. Let's take a look at a couple of really basic examples to kind of cement this concept before we move on to some more practical demonstrations. So first up, I'll create a couple of inputs here, which will actually be logical values, either true or false. And these in turn will be based on the output of some logical condition. So for my first input, I'll say equals 2 equals 2. So this is basically just a logical test to see if the number 2 equals the number 2. And as we would expect, that should be true. And then for my second input, I'll enter equals 4 is less than 3. And that is false. So now let's see what happens if we feed these two inputs into the AND function. So here in cell D2, we'll enter our first AND function. So I'll type equals AND. And the arguments the AND operator takes are very straightforward. It's just a series of logical tests or conditions, each of which must return true or false. So here we're going to feed the AND function the output of formulas that we are storing in two different cells, but quite commonly, those formulas that yielded the true or false output would be nested within the AND function itself. But for our purposes here, my first argument will be the value in cell B2, the true, and the second argument will be my false in cell C2. And if I hit enter, we'll see that the AND function returns false because it requires that all logical conditions supplied to it be true in order for it to return true. So if I go into my cell C2 and change this 4 is less than 3 to 2 is less than 3, now both of my inputs are true, and as a result, my AND function also returns true. Now when it comes to OR, you're probably able to guess at this point how it's going to differ from AND. So if I make my first condition true, say equals 1 equals 1, and I make my second condition false, equals 10 is greater than 11, and then in cell D3, I enter equals OR, which works just like AND in the sense that it accepts one or more logical conditions as its inputs. But if I enter B3 and C3 as my inputs and then hit enter, OR still returns true, even though one of the inputs is false. And that's how OR works. As long as even one of the inputs we supply it is true, OR itself will return true. Now if I change my first input to be false by saying 1 equals 2, now OR returns false. So on their own, these functions aren't super useful, but where they can come in really, really handy is as input to an if function. So now instead of being limited to a single condition, we can feed our if function either an AND function or an OR function as the logical test, knowing that these functions will always return a true or a false, which is what the if function requires for its condition. So now let's move on to a more practical application of these functions. So back in our shave ice tracker, I've decided I want to create a column to flag any order that I define as a favorite combo. For the time being, I'm going to define a favorite combo as an order in which a customer ordered at least 2 flavors, hence combo, and ordered at least 3 total shave ices as defined in our quantity column over in column D. In short, I now want to return different values depending on not just one, but 2 different criteria. One being how many flavors did a person include in their order, and the other being how many total shave ices did the person order. Since this is an AND condition, in other words, we want both of these conditions to be true, we're going to feed an AND function into our if function to flag these favorite combos. So first, to get to the number of flavors that a person ordered, I can actually use the COUNTA function, which if you recall, counts any non-blank cells in a given range. So for example, if I type COUNTA and then apply that to columns E through I, I'll get the number of flavors that were entered in those columns for that particular row. And if I fill that down, you can see we get a 4 for the order in which we had 4 different flavors, a 5 for the row in which we had 5 different flavors, etc. So now that we've got that working, we'll go ahead and set up our if function. So here in cell J2, I'll type equals if, and then what I'll supply to my logical test argument will actually be the output of an AND function. And then it's my AND function where I'm actually going to be entering the logical conditions we just discussed. So my first will be quantity is greater than or equal to 3. And then the second condition will be that count A of all the flavor columns in this particular row is greater than 1. And then, of course, considering AND is a function in its own right, we have to close that off with a closing parenthesis. And now we're just back to if function business as usual. First, we specify our value if true, which will be yes. And then our value if false, which will be no. And now if I close off that last parenthesis and hit enter, and then fill that function down, we'll see that we got a yes on our third order, which did in fact have 3 flavors and 5 total shave ices were ordered for that order. And then for orders with only 1 flavor, or orders with small quantities like down here in row 12, we get a no. So it looks like our function's working. But now, just to incorporate OR into the mix, I'm going to add yet another layer to our logic. So instead of requiring that we have a quantity greater than or equal to 3, I'll say that we can consider a combo a favorite if either the customer ordered a large size or they ordered 3 or more of that particular combination of shave ice flavors. So instead of simply saying quantity greater than or equal to 3, what I really want to say is quantity greater than or equal to 3 or size equals large. But then my other condition, that the count of flavors is greater than 1, is still mandatory. So what I'm actually going to do is nest an OR function inside of my AND function. So right here after the opening parenthesis for AND, I'll type OR, and then my first logical condition is fine as it is, but now I just need to add a second one. So I'll say the value in our size column equals large. And of course I can't forget my comma. So now what's going to happen when this function executes is that the OR function is going to evaluate whether either of those conditions, either the size of the order is large or the quantity is greater than or equal to 3, is true. If either of those conditions is true, the OR function overall will return true. Then the AND is going to take that true or false and then combine it with whether our second condition, which is that the number of flavors is greater than 1, is true or false. If both of those conditions are true, then our overall function will return yes. If even one of them is not, it'll return no. So now if we hit enter, and then fill this function down, if we scroll down to our 20th order here in row 21, we'll see that that was flagged as a favorite combo, even though it only had an order quantity of 2. And that's because that size was large. But of course, our other mandatory condition that the order consisted of at least 2 flavors was also met. All right. I hope at this point that you not only see the potential and power of the if function in Excel, but also the nearly unlimited flexibility that combining these logical and OR functions with the if function can provide us. With if, and OR at your disposal, and especially considering the ability to nest if functions inside of each other, your ability to transform your data is really only limited by your imagination. Now up next, we're going to tackle perhaps the most famous or infamous of all Excel functions, and that's VLOOKUP. Mastery of this one is often what separates Excel power users from everybody else, and my goal is for you to become a true VLOOKUP master. That's up next. I'll see you then. Welcome back. So in this one, we're going to tackle perhaps the biggest, baddest Excel function of all, and that is the legendary VLOOKUP. If you can get the hang of this one, I assure you your popularity around the office will skyrocket. You'd be surprised at how many hours people waste performing mundane tasks that VLOOKUP could solve in seconds. So just knowing how and when to use this function can make you an indispensable resource around your office. Now, unfortunately, and this is part of why people who know VLOOKUP well are in such high demand, VLOOKUP is not the most straightforward or intuitive function to understand. For lack of a better way of putting it, there is a peculiar geometry to VLOOKUP that throws people off. And that's why we're going to break down exactly how this function works, step by step, before we dive into any practical examples. So first, let's do a quick rundown on what VLOOKUP is and why we would use it. VLOOKUP is used to look up information about some input value, but in a separate table. So the function works by searching the first column, and that's very key here, as you'll see in a moment, of the lookup table for a match to that input value. So since we're searching a column, we're essentially doing a vertical search, and VLOOKUP starts with the very first value in that column and then works its way down. Then, when the function finds the very first match, it jumps over a specified number of columns in that same row as the match that it found to fetch the value that we're looking up. So what are some common applications of VLOOKUP? Well, one is to streamline your spreadsheets by allowing certain data to be stored in lookup tables. And that's still within Excel, just perhaps on a different worksheet, where that data can then be pulled back in to any data set of your choosing using VLOOKUP. Also, VLOOKUP is very commonly used to fetch values from a secondary data set based on some matching field. An ID number is a great example. It's something like a customer ID or a product ID or a student ID, and then identifying either matches or mismatches potentially if that lookup value isn't found in the secondary data set. So that's the 10,000 foot view. But how does VLOOKUP really work? Well, step one is we have a lookup value, and in this case our lookup value is a person's name, Todd. And then we're trying to look up something about that value in some secondary table. And here we have a table that consists of names in the first column, emails in the second column, and phone numbers in the third column. So we're trying to look up Todd's phone number from this table. So VLOOKUP starts its work by scanning the very first column, and in this case that's the name column, of whatever table or range of cells we feed it, for the lookup value that we're looking for. And it starts this search from the top and works its way down. Then, at some point, assuming our value is somewhere in that secondary table, VLOOKUP finds a match. And again, it stops when it finds the very first match. If there was another row further down in the table that also had Todd as the name value, VLOOKUP would ignore that second record in favor of the very first one that it found. Now, once VLOOKUP has found a match in that first column, it moves right across the row that that match belonged to a certain number of columns that we specify. So in this case, we're looking for phone number, and we know phone number is the third column over, so we want to go 1, 2, 3 columns over. Now finally, VLOOKUP finds that value in the same row as the match, the specified number of columns over, and returns that value to the cell where we had the VLOOKUP formula. So now that we've got the basic concept of how VLOOKUP works down, we'll take a look at the actual syntax of the function. So here in our example workbook, I've actually got the exact same example that we just worked through in the slides, the only difference being I'm actually going to write out a VLOOKUP function to perform that lookup that we saw in the slides. So here in cell B2, where I've got some question marks, we're going to return Todd's phone number from our lookup table in columns G through I. So without further ado, let's delete our question marks and type equals VL. And lo and behold, it looks like VLOOKUP is the only Excel function that starts with VL. So I'll hit Tab to select it. And now the first argument that it asks for is a lookup value. This is the value that we're going to search the first column of our lookup table for. So in that case, our lookup value will be Todd, or the value in cell A2. Now the second argument is the table array. This is the lookup table that we're going to be scanning for our lookup value. So that is the range of cells from G1 through I10. And now this third argument is one that confuses a lot of people, the column index number. So this basically just says, of the columns in our lookup table, which one do we actually want to return a value from? So once we find the row in this table that belongs to Todd, which of the values in that row are we trying to pull in? Is it the email, which is in the second column, or the phone number, which is in the third? Well, we know we're looking for the phone number, so we want the third column over. So we'll type the number 3. And then finally, the last argument is one that I would suggest you just commit to memory for now. You'll want to choose false here 99% of the time. There is also a variation on the VLOOKUP function in which you can do what's called an approximate match, but from my experience, the vast majority of the time you're just going to want to do an exact match. So you can arrow down to select that argument, and then hit Tab to lock it in, and then finally we'll hit Enter, and success. We were able to pull in Todd's phone number from our lookup range without knowing exactly what row Todd's information was found in. So now that we've worked through a really basic example, let's apply VLOOKUP to a slightly more realistic scenario back in our Shave Ice tracker. So here in our Shave Ice tracker, you'll see that I've added a column called Flavor Description. I wanted to add this column to our ledger so our employees at the Shave Ice truck can describe what these flavors are actually like to prospective customers. The problem is I don't want my employees to have to type out that description every single time they enter an order or have to remember the description off the top of their heads. So this seems like a great scenario for a lookup table. And I've actually created one over here on the Flavor Descriptions worksheet. So you'll see that I have a small table that consists of one column with just the name of the flavor, and then a second column with a description of that flavor. So again, instead of having my employees type out each of these descriptions every time a customer enters an order, or even have to memorize these descriptions, I just want to be able to look these descriptions up from this lookup table every time we type the name of a flavor here in column E. So what I'll need is to use the VLOOKUP function here in column F to look up the flavor from column E over here in my flavor descriptions table, and then return this description. So let's get started on that. So first I'll type equals VL, tab over to select my VLOOKUP, and then my lookup value is just going to be the flavor in column E, so I'll select E2. My table array will now be my table of flavor descriptions over on my second worksheet. So I'll highlight that. And then for my column index number, my lookup table really only has 2 columns, and I'm interested in the value in the second column, so I'll enter 2 for that third argument. And for the fourth one, again for now, we'll always choose false for an exact match, and then I'll hit Enter, and it looks like it's working. So now let me try to fill this down. Ooh, and something weird is happening below row 6. So why is my VLOOKUP no longer working? Well, if we look at the table range that's being referenced in this first formula that gives an error, it's the range of cells from A6 to B13 on the flavor descriptions worksheet. But I thought my table started in cell A1. So going back to my worksheet to confirm, sure enough, my table ranges from cell A1 to B8. So what's going on here? Well, this is a case where we need to use absolute references on that table so that I continue to reference the same range of cells even as I copy this formula down. So back up in my first formula, I'll highlight that range, A1 through B8, and then I'll just hit F4 to make the reference to that range absolute. And now I'll hit Enter again, and then fill that formula down one more time. And there we have it. It looks like our VLOOKUP is working like a charm. But this was just one application of the VLOOKUP function. Perhaps a more common one, as we briefly referenced earlier, involves pulling in values from a secondary data set and possibly identifying matches or mismatches between our 2 data sets. We'll dive into that and also how to handle the errors that occur when we can't find a lookup value in the next video. I'll see you then. Hey, welcome back. So now that we've got a handle on the basic mechanics of the VLOOKUP function, I want to take you through an example of perhaps the most common sort of scenario it's applied to. Here in our shave ice tracker, we have a new worksheet that contains a ledger of the number of ounces of syrup flavoring we've used for each customer order. So while the employee working the cash register is responsible for making a ledger of customer sales, our other employee who actually makes the shave ice is responsible for tracking the amount of syrup we've used per order. Now in theory, these two ledgers should match up perfectly. For every order number in one, there should be a matching order number in the other. But if you've dealt with real-world data at all, you know that this is almost never the case. If two separate people, or teams, or organizations are tracking the same data, there will almost always be discrepancies, often substantial, between these independently compiled datasets. VLOOKUP can help us both merge and combine values from such datasets so we can compare them side by side, and also, crucially, to identify those mismatches in which values exist in one dataset but not the other. Let's take a look at how VLOOKUP can help us do that here. So back in the sales tracker worksheet of our shave ice tracker, we see that we now have an ounces used column. So in this column, we're going to pull in the actual value for ounces used from our new worksheet using VLOOKUP. So to get started, I'll type equals VL and then tab over to select the function. And now my lookup value is going to be the order number for this particular order, which is over in column C. So I'll just select C2. And now my table array is going to be my table on my other worksheet. So I'll select the top left cell and then Control-Shift right arrow and then Control-Shift down arrow to select the whole range. Now just to reiterate, note that my order numbers in this table are in the leftmost column, which is necessary in order for the VLOOKUP function to work properly. VLOOKUP is going to look for that particular order number from our sales tracker ledger in the first column of this range. So it's crucial that that first column contain order numbers. So after typing a comma, I'll scroll back up to the top just to reaffirm which column in our table I'm interested in, and that is actually the third column, the ounces used column. So I'll type 3, and then as usual, I'll select false for my final argument and hit enter. And our VLOOKUP appears to have worked. But before we go to the trouble of making this reference to our lookup table absolute, I'm going to show you a more straightforward way to handle that issue that also accounts for possible growth, that is to say, new records being added to our lookup table. So I'm actually going to wipe out our entire second argument to our function, and then I'll go back to our lookup table, and instead of just selecting the range, I'll select all the columns in the range. So using this method, we don't have to worry about making cell references absolute, and we also don't have to worry about modifying our formulas if new records are added to our inventory ledger. Since these column references encompass all the cells in those columns, our formula will now pick up any new orders that are added. So having made that modification, I'll hit enter, and then fill our formula down. And it looks like it worked, but if we scroll down just a bit, we see that we have a few errors. And if we use our filters on our ounces used column, and then filter for just errors, it looks like we have quite a few, 13 in total. So what exactly is causing these errors? So this #NA error is one of several types of errors in Excel, and this particular one means that a value cannot be found or identified. So in this case, that means these particular order numbers that we see here in column C couldn't be found in our inventory tracker. So right away, we've identified a discrepancy. And for some purposes, you could be fine to leave our analysis at that. However, it's quite common to want to replace this ugly error message with something a little more user-friendly. So to do that, we can use another function called ifError. So ifError essentially takes the output of another function, and if that output is an error, it returns some value that we specify. And then if the output of that other function is not an error, it just returns the output of that function. So let's go ahead and use if error to return a somewhat friendlier error message here. So first I'll clear my filter, and then back in my first formula, before my VLOOKUP but after the equal sign, because again, this is still just one formula, we're simply adding another function that we're going to nest VLOOKUP inside of. We'll type if error, and then our value is just the VLOOKUP function, or rather, what the VLOOKUP function outputs. So that's our first argument. And then the second argument is simply what we want to return if that VLOOKUP function returns an error. So I'll just return the message, order number not found. And then I'll close out my if error. And then if I fill that down, we'll see in the cells where we formerly had an error that we now have this much more descriptive, much more user-friendly error message. Now before we go, I want to consider the possibility that it wasn't just our employee who makes the shave ice and tracks the amount of syrup used per order who made some mistakes on their ledger. In the real world, when you're comparing data sets like these, it's very often the case that there are discrepancies on both sides. But the VLOOKUP functions we've written so far are only going to identify cases where there was an order number on our sales tracker worksheet that was not found in our syrup inventory tracker. But what if we want to do the opposite? What if we act on the assumption that the person maintaining our sales tracker also might have missed a few orders? So to do that, we're going to have to write VLOOKUPs against our new data set consisting of the number of ounces used per order. So back in our new worksheet, I'll write another VLOOKUP, this time against our original sales tracker data set, to pull in the sale amount per order. So here in cell D2, I'll type equals VLOOKUP, and then my lookup value will of course be the order number. And now our table array will be my sales tracker data set. But before we blindly select this whole table, I want you to think carefully again about the geometry of the VLOOKUP function and how it always looks at the first column of whatever table array we feed it for our lookup value. So just from scanning our column headers here, you see that our order number column is actually in column C. So we need for the first column of our table array to actually be column C, not column A. If we selected the entire table, the VLOOKUP would try to look for our order number in column A where we have sizes stored. And as you might imagine, that would result in a column full of errors. Just keep in mind that when writing VLOOKUPs like these, you need to cherry pick the range of cells in your table array such that the column your lookup values match up to comes first in the order. So here I'll begin my table array in column C, and then I'll select all the way over to my sale amount column, which is the one that I actually want to pull in. And then since sale amount is the fourth column in the table array I selected, which just has 4 columns, I'll enter 4, and then I'll choose false for my last argument as usual, and it looks like that worked. So now if I fill this guy down, we don't see any errors yet, but if I scroll down, aha, we have an error. So it looks like we don't have as many discrepancies in our other data set because we've only been able to find one order number on our syrup inventory tracker that wasn't in our sales tracker, but there's still a discrepancy nonetheless. So this just emphasizes the need to write VLOOKUPs against both data sets when you're trying to reconcile two data sets against each other for possible mismatches and discrepancies. All right. Up next, we're going to look at a function that is perhaps even more purpose-built for identifying mismatches and discrepancies between data sets. I'll see you then. Hey, welcome back. For the next few videos, we're going to explore some techniques for modeling in Excel. So what do I mean by modeling? Well, don't worry, we won't be doing any walking down a catwalk or anything like that. In the world of Excel, a model is basically a flexible type of calculation, which accepts one or more inputs and produces one or more outputs. Excel is an incredibly powerful calculation engine, so modeling is something that Excel, well, excels at. Of course, you might say that this doesn't sound any different in general than the formulas and functions we've studied thus far. And it's true that models are in fact built on formulas and functions. So beyond that, what makes a model a model? Fundamentally, models are defined by the variability of their inputs. The point of a model, then, is to study how the output of a calculation changes when we vary one or more inputs to that calculation. A good model should allow us to vary the inputs to our calculation quickly, across a wide range of values, so that we can see the impact those changes have on our calculation. The calculation itself can either be an Excel function, a custom formula, or a formula that combines multiple Excel functions that ultimately produce our output of interest. You can think of the calculation piece as a kind of black box that accepts our inputs, then spits out a desired output. Especially in the case of an Excel function, we don't necessarily need to know exactly how the calculation gets to its result, but we do need to know how to interpret that result. So how are Excel models used in the real world? All kinds of ways, in fact. The most common examples that most people might recognize involve financial calculations. An investment calculator that outputs projected investment returns based on variables like our monthly contributions and the rate of return, or a loan payment calculator that returns a loan payment amount based on the size of a loan and its interest rate, are just two examples in this category. But models are also widely used across the world of business operations, for things like forecasting demand and planning staffing levels. And this is to say nothing of how they can be applied to scientific and engineering problems, which are outside the scope of this course. The case study we'll use to illuminate the modeling process in Excel is a mortgage payment calculator that will return either the monthly or annual payment we would need to make on a mortgage, given variables like the size of the loan, the interest rate, and the amount of our down payment. We'll dive into that in the next video. I'll see you then. Welcome back. Now that we have a basic understanding of what an Excel model is, let's start building out one of our own. Now here in our example spreadsheet, we have a number of inputs with which we can calculate a recurring payment, either monthly or annual, for a home mortgage loan. For example, the mortgage amount, the interest rate, and the term in years of the mortgage. Now, this calculation is certainly something that we could execute with a complex combination of formulas. But as is so often the case, Excel provides a built-in function that does all the computational heavy lifting for us. And that is the PMT, or payment function. Let's take a look at the arguments the PMT function takes using the Insert Function button. So we'll go to our Formulas tab, and then click the Insert Function button, and then we'll search for PMT and click Go. And then if we double-click that to select it, now we can see all the arguments that this function takes, and a brief description of what these arguments are. So the first argument here is rate, which basically means the interest rate of the loan. The second argument, NPER, which stands for number of periods, is basically the term of the loan, which means the number of time periods over which the loan is expected to be repaid. By default, this is understood to be years, but we can tweak that, as we'll see later on. The third argument, PV, is the present value of the loan. You can just think of this as the total amount we have to pay back. The other two arguments are optional, and we won't worry about them for the purposes of this model. So looking at our example spreadsheet, it seems like we have all of our inputs that we need to let the PMT function do its thing, so let's go ahead and build out the function. So for our rate argument, we'll enter our interest rate here in cell C6, and then for our number of periods, we'll enter our term in years in cell C8, and then for our present value, instead of entering our mortgage amount, we're actually going to enter our mortgage amount minus the down payment, because that's the actual amount that we owe that we need to pay back. So instead of just clicking a cell reference, I'll type C2 minus C4. And now if I click OK, we'll see that our payment amount is negative $32,465. So a couple notes about this number. One is that this is assuming we want to make annual payments, which is what the PMT function assumes by default. Now, since that's very often not the case, we'll look at a way to modify the way we write out the PMT function so that it works with a monthly term as well. Now, the other thing that probably looks a little weird to you is that minus sign, but when it comes to financial functions, Excel looks at any amount of money that we're paying out, that we're losing, taking out of our bank account and putting into someone else's bank account as a negative number. Whereas money that we're getting, revenue or income, for example, would be a positive amount. You can think of a negative dollar amount as a debit and then a positive dollar amount as a credit, so to speak. So just to demonstrate how sensitive even a simple model like this one can be to changing our inputs, let's change the term in years from 10 to 30. And now our payment amount went down to $14,680. But then if I raise our interest rate from 3.5% to 10%, suddenly our payment amount basically doubles back up to over $28,000. Now, as I mentioned, monthly payments when it comes to mortgages are much more common than annual payments. So let's look at how we can tweak our function to make it work with monthly payments. So there's really two changes we'll need to make. One is dividing our interest rate argument, which is the first argument the function receives, by 12. That translates the annualized interest into a monthly interest. And then the second piece is to multiply our second argument, which is the term in terms of years, by 12. That translates the number of years that the mortgage is over into an equivalent number of months. So if I multiply that guy by 12, and now hit enter, now we see what would be a monthly payment for a mortgage of the same amount with the same interest rate. Now, as we've already talked about, models are all about being able to vary our inputs to analyze the impact to our output. So let's actually try to modify this function so we can toggle back and forth between an annual payment frequency and a monthly payment frequency. And we actually have an input here in cell C10 where we currently have the word monthly typed. But what I'd really like to do is to be able to type either annual or monthly and then have our payment function dynamically switch from this monthly configuration that we see here to the annual configuration we saw before. So to do that, let's use an if function. So before my payment function, but after the equals sign, I'll type if, and then my condition is basically just going to look at the value here in cell C10, my payment frequency value. So I'll say if that value equals monthly, then return the payment function that we currently have written out. Otherwise, we'll assume that we want to calculate an annual payment. So we'll write the function like we did originally. So PMT, and then our interest rate, and just our straight number of periods in terms of years, and then our mortgage amount minus our down payment as the total amount that we owe. And then I'll close the parenthesis on my second payment function, and then finally the if function, and hit enter. And now, if I type annual in my payment frequency input instead of monthly, you'll see my payment amount reflects that. And then if I go back to monthly, you'll see the payment amount updates accordingly. Now, this ability to see how so many different factors can impact our mortgage payments is really cool. But the process of changing these inputs has been, especially in our last case, somewhat clunky. Ideally, we wouldn't want to have to type out the words annual or monthly every time we want to see this change. Fortunately, we don't have to. Up next, we'll look at an Excel feature that can save us from all this annoying typing and protect our models from faulty input values as well. I'll see you then. Welcome back. In the last video, we got a glimpse of how powerful Excel formulas and functions can be when we team them up with flexible input parameters that let us analyze how the outputs of our calculations change in response to changing inputs. But we also saw that the process of changing these inputs can be a little inconvenient and involve more typing than we might like to do, certainly more than I would like. Even worse, Merely typing these values into a cell potentially makes our model vulnerable to nonsensical inputs that would render our model output useless. Anybody who's done much manual data entry knows that it's not a matter of if you'll eventually make a mistake, but when. And it doesn't necessarily even have to be a mistake. For example, a mortgage term of 21 years is technically valid, but that is an exceptionally uncommon mortgage term that probably shouldn't even be considered as a potential input. Fortunately, Excel has a feature that lets us get around this problem by selecting a value for a cell from a predefined list of valid values which makes sense for that particular input, with no typing required. This feature is called data validation lists. So let's put these data validation lists to work on our mortgage payment calculator model here. The first pain point we identified at the end of the last video was the need to type in either the words annual or monthly to specify our payment frequency. As efficient Excel users, we certainly don't want to type these out if we don't have to. And as analysts interested in an accurate model output, we also don't want to mistype these values, since that would break our formula. Check out what happens if I misspell monthly here. So if I just remove the O, and as you can see, our payment amount shot through the roof. And that's because our formula is now calculating an annual payment instead of a monthly payment. Since our if statement is checking for the exact text string monthly, mistyping that word caused the if statement here to default to the else condition, which was the annual mortgage payment formula. Hence, even though we didn't see an explicit error message, our model is now producing an incorrect result. What we need here is a list of valid values for the cell. In this case, just the words annual and monthly. Now we could create this list in the same worksheet here, but generally speaking, it's good practice to separate lists of valid values like this from the model itself. So let's create a new worksheet called valid value lists. So I'll go ahead and create a new worksheet, and I'll call it valid value lists. And now in column A of this worksheet, we'll type out our two valid values for payment frequency and throw in a column header just so we know what these are for when we refer back to them. So I'll call my column payment frequency, and then my valid values will be monthly and annual. And now the fun begins. So back in our model worksheet, I'm going to actually go ahead and set up my data validation list. So first I'll delete my value here in cell C10. And now, to insert my data validation list, I'll make sure I have my data tab selected on the ribbon, which I already do. And then over here under data tools, I'll click the drop down arrow next to this little icon that has a red circle with a line through it. And if you hover over this, you'll see that it says data validation. So what we want to choose is just data validation. And now in this dialog box that pops up, we'll see a few options, and we're not going to mess with every possible configuration here. We're going to stick to the most important elements of this feature. And the real key here is, under this label allow, to choose list from the dropdown. And what that's basically saying is, we're only going to allow a value to be entered in this cell if it is contained in a list of values that we specify. So how do we specify that list? Well, that is where this source dialog box here comes in. So if we click this arrow, now we can actually navigate back over to our valid value lists worksheet and then just select our two valid values. And then if I click OK, you'll see that we now have a little button to the right of our cell. So let's see what happens if we click that. Awesome. We now have a list of just the two values that should only ever be entered into the cell. And regardless of which one I want to enter, all I have to do is just click the value and it's entered. No typing required. And if I were to try to enter something else in this cell, something that wasn't one of those two valid values, let's say I just mistyped monthly again, and then hit enter, Excel actually won't let me type in that value because it's not in the list of valid values that we specified for that cell. So again, not only is this technique saving us typing, it's also preventing us from entering bad data into our model. And the awesome thing here is now I can easily toggle back and forth between annual and monthly and see the effect that that has on our bottom line, which is that payment amount. So another input that could be both streamlined and safeguarded by this feature is our mortgage term here in cell C8. As I alluded to previously, the vast majority of mortgages have one of a very small list of terms, typically either 10, 15, 20, or 30 years. So to prevent ourselves from entering unrealistic input values for mortgage term, and to save ourselves a little typing in the process, let's set up another data validation list for mortgage term. So to again save typing, I'll actually just copy my header here and then move back over to my valid value lists worksheet. And then I'll copy that into cell B1. And then for my valid values, I'll just type 10, 15, 20, and 30. And then back over to my model, where I currently had typed the number 30, basically my input cell for mortgage term. I'll again go to my Data tab on my ribbon. I'll click the drop down next to Data Validation. I'll choose Data Validation. And then I'll allow a list. And then my source will just be my 4 valid mortgage term options over on my valid value lists worksheet. So now if I click OK, and then click the drop down in my mortgage term input cell, you'll see that I only have those 4 options available to enter. And I can quickly and easily toggle through those to see what kind of impact a different mortgage term has on our payment amount. Now these data validation lists are awesome, but they become a little less useful when the list of potentially valid input values is quite large. Take, for example, interest rates. These could potentially vary percent by percent from 0.1 all the way to 11.1, if your bank is a real jerk, or even higher. That's potentially more than 100 different interest rates. Now, we definitely don't want to list out all these potential interest rates, nor try to pick one out of the world's longest drop-down list. Now, of course, we could always just type in the value manually, but Excel actually gives us a much slicker and more powerful technique for varying an input with lots of unique values quickly. We'll take a look at that up next. I'll see you then. Hey, welcome back. So we've seen how embedding lists of valid values in our input cells can make our models cleaner, more convenient, and less prone to data entry errors. But we can also see some limitations to these lists. For inputs that might vary, tiny increment by tiny increment, between very small and very large values, like, say, the size of a down payment on a mortgage, there's a superior tool to streamline and control our data entry, and that is the scroll bar. Scroll bars allow us to quickly, and in a visually intuitive way, vary a value between a minimum and a maximum we specify. For ranges of values, like, say, 1 to 100, this approach is much better suited than the list of values that a data validation drop-down list would give us. But before we use scroll bars, we're actually going to need to change up our ribbon a little bit. Scroll bars are found on the Developer tab of the ribbon, which most of the time is not visible by default. Fortunately, it's very easy to unhide, and it's something we'll be using later on in the course anyway. So let's go ahead and make that Developer tab visible. So to do this, you'll click the File tab on your ribbon, and then click More, and then Options. Now keep in mind that depending on your exact version of Excel, the path you take to get to this Options dialog box might vary a little bit, but the dialog box itself should be more or less identical. So once you're on this dialog box, choose Customize Ribbon, and then under this list of tabs on the right, look for the Developer tab, and then just put a check mark next to it, and click OK. And now, to the right of our View tab on the ribbon, we see there's now a Developer tab. So now that we have our Developer tab, let's take a look at applying a scroll bar to one of our inputs. The first one we'll tackle is our down payment. This is a good fit because our down payment could take any one of a very wide range of values, Just imagine trying to create a drop-down list with all possible down payments we could make on a mortgage. So let's get started by first simply inserting a scroll bar onto our worksheet. So as you might have guessed, we'll do this on the Developer tab of the ribbon. So let's first click this arrow under the Insert button on the Developer tab. And now we see two sets of controls we can choose from. These ActiveX controls require a lot more configuration and setup, so we'll stick with the form controls for now. Now these icons you see might not mean anything to you, and admittedly they are quite cryptic. So the easiest way to figure out what each icon actually means in terms of a control you can add to your spreadsheet, just hover over them and wait for the tooltip to appear. So if I hover over a few here, finally I see one that's called a scroll bar, which is what we want. So let's click that. And now if I move my cursor down over the grid, you'll see it's turned into a little plus sign. Now that means if I click my mouse button, hold it down, and then drag down and to the right, I'm actually drawing out the boundary of that control. And as soon as I let go, now you see that we've successfully landed a scroll bar on our grid whose dimensions were defined by how far down and to the right we dragged that little plus sign. So now that we have our scroll bar in place, the next step is just to configure it. So I'll right-click the scroll bar and then choose Format Control. And here we see all the parameters we can use to configure this scroll bar. And in some cases, the defaults are fine. For example, the current value of 0 is fine. The minimum value of 0 makes sense. But for our maximum value, for now, we'll enter the down payment we currently have entered, $20,000. It turns out that the largest maximum value you can enter for a scroll bar is $30,000. So you might be wondering how we can handle down payments larger than that, but don't worry, we'll get to that in a minute. So for now, we'll set our maximum value to $20,000. And then the incremental change just dictates the rate at which that number changes based on our scrolling of the scroll bar. And the default of 1 here is fine. And then the last piece is our cell link, which is actually the cell whose value is going to change based on when we actually manipulate our scroll bar. So as I scroll the scroll bar to the right, the value in our linked cell is going to increase from 0 all the way up to 20,000. So for now, I'll just choose our down payment input cell in cell C4. And I'm fine with all these other defaults like 3D shading, so I'll just go ahead and click OK. And now if I click away from my scroll bar to deselect it, and then hover my cursor over this little vertical bar, and then just click my mouse button, hold it, and then drag to the right, you'll see that my down payment increases sequentially as I drag to the right from our minimum value of 0 all the way to our maximum value of 20,000. And if you watch the payment amount cell as I do this, you'll see that it constantly updates to reflect the changing value of the down payment. Now this is all fine and good, but what if we want to vary our down payment based on some percentage of the mortgage amount, which honestly is a much more realistic scenario, as opposed to a fixed range from 0 to 20,000. Right now, we have that maximum value that our down payment could ever take set at 20. But if we have a mortgage of $800,000, a down payment of $20,000 just doesn't make a lot of sense. And even if our scroll bar could accommodate values larger than 30,000, we wouldn't want to have to reconfigure the maximum value of our scroll bar every time we change our mortgage amount. Well, instead of making our scroll bar output represent the down payment itself, we can instead just increment a number from 1 to 100 and then translate this number as a percent from 1% to 100% by dividing it by 100. Then we can simply multiply this percentage by our mortgage amount to get our down payment. So if we increment to 20, divide that number 20 by 100 to get 20%, and then multiply that 20% by our mortgage amount, we get 20,000. Now in a case like this, where our scroll bar output is an intermediate step rather than the direct output, it's best to keep it separate from the rest of the model. So we'll create a new worksheet for it. So I'll create a worksheet down here called Linked Cells. And now that I've created my Linked Cells worksheet, I'll again right-click my scroll bar to configure it, and I'll choose Format Control. And now instead of our maximum value being 20,000, it's just going to be 100, because these values are essentially going to be proxies for the percentage that we're multiplying our mortgage amount by. And then for our cell link, instead of pointing directly to our down payment input cell, I'll instead point to cell A2 on our linked cells worksheet. And then, just so if we ever need to re-engineer the inner workings of our model, I'll go back to my linked cells worksheet and just type in a header for that linked cell. And I'll just call it down payment. And then back on my model worksheet, instead of just having a number in my down payment input cell, I'll instead have a formula where I divide that linked cell value by 100 to get a percentage, and then I'll multiply that percentage by our mortgage amount. So first I'll type equals, and then the value in our linked cell, which currently is blank because we haven't used our scroll bar since we changed the cell link, divided by 100. And now since this is just going to output a percentage, we need to multiply this by our actual mortgage amount. And to make sure our order of operations are what they should be, I'll enclose this in parentheses, and then multiply that by our mortgage amount input on our model worksheet, and then finally hit enter. And right now we see the down payment is 0 because we haven't adjusted our scroll bar since we changed the cell link, so that value that the scroll bar is outputting is 0. But if I start adjusting this scroll bar to the right, we see that our down payment amount starts increasing all the way up to the maximum possible mortgage amount. And then if I change our mortgage amount to, say, 300,000, now I can manipulate our down payment all the way from 300,000, which is 100% of the mortgage amount, all the way down to 0. And you can see that our payment amount adjusts accordingly as we are changing the down payment. Now lastly, before we move on to adding another scroll bar to our model, I'll just adjust the size of this one so it aligns a little more cleanly with the rest of our model. So to do that, you want to right-click the scroll bar, and then left-click again to dismiss this dialog box. And now you can just hover over any one of the corners of the scroll bar, click, and then hold down your mouse button and just drag around to resize it however you want. So I'll generally try to resize it to align with the same row that our down payment input cell is in. And that looks about right to me. So now that we've streamlined our down payment input with a scroll bar, let's do the same for our interest rate input. So again, just like with our down payment, our interest rate could potentially vary between a wide range of values, and we would like to quickly analyze the effect of changing the value across that range on our payment amount. That's why a scroll bar is the right tool for the job in this particular case. So first up, just to make life easy on ourselves, instead of recreating a brand new scroll bar, I'll right-click this scroll bar and choose Copy, and then click down next to our interest rate input, and then just hit Control-V. Then I can hover over our scroll bar until I see this little cross icon, and then left-click and hold down the mouse button to drag it until it's in the position that I want. And now to configure the scroll bar specific for our interest rate, I'll right-click again and choose Format Control. And for now, I'll make my minimum value 0 and my maximum value 10 for a 10% interest rate. And then I'll make my cell link our interest rate input cell here in cell C6. And everything else should be okay, so I'll go ahead and click OK. Now right away we see an obvious problem, which is that our cell is somehow returning an interest rate of 1,000%, which I think even the worst bank probably wouldn't charge us. So that is because we're entering a whole number into a cell that's formatted as a percent. So mathematically speaking, the number 0.1 translates to 10%. The number 1 translates to 100%, and the number 10 translates to 1,000%. Our scroll bar here is set to the maximum value of 10, so instead of seeing a 10% interest rate, we see a 1,000% interest rate. But the problem is, if we go back to our control configuration, that we don't have the option of incrementing our value by less than 1. So we can't increment from 0.1 to 0.2 to 0.3. We have to increment by whole numbers. And this creates another problem as well. Even though the range of rates we're interested in only goes from 0 to 10, we actually need to see far more distinct values than just 0 to 10. Mortgage interest rates quite often have at least one digit after the decimal. So for our purposes, we'll need at least 100 distinct values, 0.1, 0.2, 0.3, all the way to 9.9. You get the idea. So as we're configuring our scroll bar, we now know that we'll need a maximum value of 100, not 10. So I'll go ahead and make that change. However, the smallest possible increment that we can work with using the scroll bar, as we've seen, is 1. So how do we turn these whole number increments into percentages that range from 0.1 to 10%? Well, since a percentage is just a fraction of a whole, and we know that we want our interest rate to be no more than 10%, we need to divide our scroll bar output, which will have a max value of 100, by 1,000 to make sure that our max value of 100 represents 10% of that whole, and we want 10% to be our maximum interest rate. So without further ado, let's get to work configuring this scroll bar. So we've already made our maximum value 100, so the next step is changing our cell link from our actual input cell here on the model worksheet to another linked cell on our linked cells worksheet. So I'll click my cell link arrow here, and then navigate over to my linked cells worksheet. And then here in cell B2, I'll create a link to our scroll bar, and then click OK. And then again, I'll go back to my linked cells worksheet and just create a header for our linked value, which will just be interest rate. And now the real trick is, back in our model worksheet, instead of just having a value in our interest rate input cell, kind of similar to what we did for down payment, we're instead going to have a formula that's going to be based on our linked cell value on our linked cells worksheet. So our formula will just be equals, and then the value of that linked cell that's coming from our scroll bar, divided by 1,000. And then if I hit enter, we'll see that we currently have an interest rate of 1% based on our scroll bar's current value of 10, because 1% of 1,000 is 10. And now if I start scrolling this value up, you'll see that our interest rates start varying increment by increment all the way to 10%. And here at the maximum value of 10%, our scroll bar output is 100, and 100 divided by 1,000 is 10%. So at this point, we have all sorts of levers that we can pull to control that final payment amount. I can change my payment frequency to monthly, which obviously substantially reduces the payment amount. And then I can see the impact of reducing the interest rate of our mortgage on our payment amount. And I can similarly see the impact of increasing our down payment on our mortgage amount. All right, I know that was a lot of work and might have even involved a little bit too much math for some people's comfort, but I hope you can see the value of this flexible, dynamic approach to entering inputs to a model. The setup is admittedly a bit of a pain in the neck, but it pays for itself every time you use the model and are able to cycle through wide ranges of input values in a flash. Up next, we're going to look at yet another way to optimize our model. This one focused more on how we can tweak the internal workings of the model to make it more maintainable and reliable, even as it inevitably changes and evolves. I'll see you then. Welcome back. In this one, we're going to look at a technique you can use to make your models, and any spreadsheet that makes use of formulas really, less brittle and error-prone and more easily maintained. And that is named ranges. Named ranges are exactly what they sound like. They allow us to assign a business-friendly, easily human-readable name to a cell or range of cells in an Excel spreadsheet. Not only does this make our formulas far more intuitive to read, it also makes maintaining references to cells and ranges of cells in our formulas far more straightforward and sustainable. Let's take a look at an example to see just how useful named ranges can be. So here in our model, we have an input cell for mortgage term, which is currently being populated with a data validation list that we added in a previous video. This list, in turn, is sourced from an actual list of values stored in a range of cells on another worksheet. But what if we found out there's another common mortgage term besides the ones we already have listed out? Say, for example, a 25-year mortgage. Not only would we have to add that value to our list of valid values here, we would also have to update the source of our data validation list to include the new cell. Note how if we go to configure our data validation list here by going to Data and then Data Validation, we see that it points to a specific range of cells, in this case from cell B2 to B5 on our valid value lists worksheet. Hence, if we add a new value to that range, we'll have to repoint our data validation list to include that new cell, and then do the same for any other data validation lists that point to the same data. Not a huge issue with the simple model we have here, but in a more complex model that makes use of the same list in multiple places, this would become a major problem fast. A situation like this is where named ranges come in. With a named range, we can simply assign a name to these cells that contain our mortgage term values, and then point our data validation list to the name of that range. Then, if we need to add a value to the list, we simply add the value to the end of the range of cells that contain our valid values and update our named range to include that additional cell. Then, the data validation list will update automatically because it's sourced from whatever range that name happens to be assigned to. So let's go ahead and set that up. First up, I'll create a named range from my valid term values. So first I'll cancel out of my data validation dialog box, and then go back to my valid value lists. And then to create the named range, I'll first highlight these values, and then go to my Formulas tab on the ribbon, and then choose Define Name. And that brings up a dialog box that lets us define the name for this particular range of cells. And as you can see, Excel already was smart enough to guess what we want to name this range. But I'm actually going to change that recommended name to just lowercase term years with a single underscore between. So I'll type term years. And we already have the range that that name will refer to, that being cells B2 through B5 that contain our valid mortgage terms. So now I'll click OK. And then the next step is to point our data validation list over here in our model worksheet to that named range instead of just a range of cells. So with our term input cell selected, I'll go back to Data, Data Validation, and then for my source, if I just reselect those same cells that currently make up my source data, so going back over to my valid value list worksheet, I'll reselect these cells, you'll see that Excel now recognizes that range as our named range. So instead of saying equals B2 through B5, it just says equals term years because we've given a name to that exact range of cells. So now I'll click OK. Now here's where we can really see the advantage of named ranges kick in. So now that we have our named range defined, we can use it to add a new valid value to our data validation list without needing to configure the data validation list in any way. So I'll go back to my valid value lists worksheet, and then I'll just add a new term after 20, but before 30. So I'll move my 30 one row down, and then I'll just add 25 above that. And now, to incorporate this additional cell into my named range, I can click this Name Manager button on my Formulas tab of the ribbon, just to the left of the Define Name button that we clicked earlier to define the range. So I'll click this Name Manager button, and then I'll click Edit to edit the range. And now we'll click the arrow next to our Refers to input box. And instead of just selecting B2 through B5, we'll select B2 through B6. And then click OK. And then close. And now if we go back to our model and hit our drop-down list for term, we'll see that we have that 25-year value. And again, one of the biggest advantages this approach provides is when we have multiple formulas or multiple data validation lists that refer to the same range, and then we want to add a new value to that range. By pointing all these formulas and data validation lists to a named range instead of just a hard-coded range, like B2 to B5, if we just update that name once in our name manager, that update will propagate to anything that refers to that name. In short, you make a change in one place instead of a bunch of different places. Now, it's not just data validation lists that can benefit from named ranges. Input cells in our model, especially ones that are referenced multiple times, are also great candidates for named ranges. Converting model inputs to named ranges can make our formulas more readable, as well as making our models less prone to breaking, especially when many formulas reference the same output. Without named ranges, if we want to change the location of one of our input cells, we have to find every single formula that points to that cell and update the cell reference accordingly. But using named ranges, we can simply update the cell reference in the named range itself, and all the downstream formulas will be updated automatically. There's really no downside to adding named ranges for each of our model inputs, so let's go ahead and walk through that for each one. So first we'll do mortgage amount, and I'll go back to define name, and in this case I'll just go with the name that Excel recommended and click OK. And then I'll do the same thing for down payment and interest rate. And then for my term, just to distinguish this from my list of valid term year values, I'll call this term year input. And then the same thing for payment frequency. And I'll call that payment frequency. And now if we go into our formula for payment amount, we can actually change these various cell references to their corresponding named ranges. So we know that our C10 cell is actually called payment frequency. And if I just start typing the name of that range, Excel is kind enough to recommend it to me via autocomplete. So I can tab to select that. And then we know C6 is our interest rate. So I'll start typing interest, and there it is in the list. And then C8 is our term input. And there it is. And then again, C2 is our mortgage amount. And then C4 is our down payment. And then C6 is again our interest rate. And then C8 is our term in years. And then C2, again our mortgage amount. And then finally, C4 is again our down payment. Now, of course, you might be noticing that this has made our formula a lot longer, but I would argue it's also made our formula quite a lot more readable by making it clear how the inputs of our model fit into the overall calculation. Now, if you want to see this formula in its entirety, all you have to do is click this down arrow to the right of the formula bar, and now you can see the entire formula. And as you can see, this kind of reads like English. If payment frequency is monthly, then populate the payment function with our interest rate divided by 12, the second argument being the term year input times 12, and then the mortgage amount minus the down payment being the final argument. Even if you're not super familiar with Excel, you might be able to glean the basic logic of our model just from reading this formula. Now if I click OK, it looks like we have the same result as we did before, so our formula still works. So at this point, you might be asking yourself, how will I know when and when not to use a named range? I would say that knowing when to use this technique, as with so many techniques that are oriented more towards optimization and maintainability, is more of an art than a science. My general guideline is, if I have a cell or cells that function as some kind of an input to a formula, a data validation list, etc., and that input has any potential at all for being referenced in more than one place, which, by the way, is usually the case, that's a good candidate for a named range. That's not to say I always add a named range in these cases. In the analytics world, things move fast, and you don't always have time to optimize your spreadsheets in the way that you would like, but it's definitely a technique I employ as much as time constraints allow. Alright, now that we've optimized our model from a technical standpoint, it's time to add some visual flair. I mean, let's face it, for all the fancy widgets we've added over the last few videos, our spreadsheet here still looks pretty vanilla. We'll try to fix that in the next video. I'll see you then. Hey, welcome back. So when it comes to our model, I've saved the fun stuff for last. And that is making our model look pretty, so to speak, at least to my extremely limited abilities as a very poor visual designer. Not to belabor that point, but if you have any background in visual design at all, you might be horrified by the color combinations I'm about to choose here. Just know that in addition to my lack of visual style and panache, my focus is more on readability and usability versus creating a visually beautiful product. Although that would certainly be nice too, so if you have the design chops to do it, please take your best shot. So first up, what we'll do is try to create a canvas, so to speak, for our model, and then frame it within a different color to set it apart from the rest of the worksheet. So for the canvas, we'll make the background color of our entire worksheet a light blue. So to do that, I'll just click above and to the left of our grid to select all the cells in the grid, and then under the Home tab, I'll click the down arrow next to this little icon that kind of looks like a bucket of paint being poured, and there I'll be able to choose a fill color. And for our background color, I'll choose a nice light blue. Then, to set the model itself apart from the rest of the worksheet, we'll make its background color a light green. So I'll just highlight this area directly around the model, and then go back to my little paint can being poured icon. And for my model background color, I'll choose this light green. And then finally, just to keep things nice and symmetrical, I'll make the width of column G here just a little bit narrower. So you may be wondering why I opted to use these kind of light pastel colors to shade our worksheet. Well, people who work in visual design tend to agree that lighter, softer colors often work better in modeling, analytical, and reporting contexts, since they don't detract a user's focus from the most important thing, which is the data. Also note here how I have narrowed the width of the columns on both sides of the model, and I've highlighted those columns even though they don't contain any data of interest to the model, in addition to the rows immediately above and below the model. That's just to provide an extra little bit of framing, so to speak, for the cells that actually make up our model. So the next step we can take is formatting the various cells of significance in our model in ways that call attention to their unique role in the overall system we've set up. Now we could try to invent our own combination of styling properties, font weights, font colors, background colors, and so on, to define the distinct roles that a cell could be categorized in. But that sounds like an awful lot of work, especially for a design-challenged fellow such as myself. Fortunately, Excel has done the work for us with a feature called Cell Styles. Cell styles are pre-built combinations of style properties that are intended to be applied to cells that play certain specific parts in our overall spreadsheet architecture. So you can find these styles up here under the Styles section of the Home tab of the ribbon. So if we click this Cell Styles button, now we'll see a whole range of pre-built formatting combinations that are intended to be applied to give additional meaning to a cell. For example, there are header styles meant to be applied to cells that are used as column headers. Now in our case, the cells we'd like to apply styles to all play different roles in a model, namely as inputs, outputs, and sometimes intermediate calculations. And looking at the cell styles available to us, there's actually a whole section devoted to data and model styles. And it looks like all the categories we need actually have pre-built styles. So rounding out the formatting of our model should be a piece of cake. So for example, we could characterize our mortgage amount here as an input. So I'll click that cell, and then go to my cell styles, and choose input. Likewise, we could also characterize our mortgage term as an input, so we'll format that one the same way. And then the same for our payment frequency as well. Now our down payment and interest rate cells actually contain calculations based on our scroll bar output that subsequently function as inputs to our overall model. So I'm going to style these just a little differently to set them apart from our other inputs that are just straight numbers. So first I'll select my down payment cell, I'll go back to my cell styles, and I'll look for a style that fits the role these cells play. And I think the best one here is calculation. So I'll format our down payment cell as a calculation, and then I'll do the same for our interest rate. And then finally, our payment amount cell down here is really just the output of the entire model. So back under cell styles, I'll choose the output format. Now, while this might not win any design awards, I think you can agree it's a substantial improvement over what we had before. Now, lastly, we'll take a look at one more way to improve the look and feel of our model to end users. And this actually doesn't involve making anything look better at all. Instead, it's simply hiding parts of our model that just don't have any value for an end user. In our case, that basically means our two supporting worksheets. The one that contains lists of valid values for our data validation lists, and the other which contains the cell links to our scroll bars. We, as the developers of the model, still need to be able to view and potentially modify these worksheets. But an end user of the model, who's just concerned with seeing how changing interest rates and down payment amounts might affect a mortgage payment, probably wouldn't have much interest in the low-level mechanics of our spreadsheet. The solution, then, is to simply hide these worksheets from view. They'll still be accessible to all the formulas and functions that reference them, and we can always unhide them if we need to modify them later. But the average end user will never even need to know they're there. So let's go ahead and hide these worksheets. And to do that, you just right-click the Worksheet tab and choose Hide. And then we'll do the same thing for our Valid Value Lists worksheet. And poof, like magic, they're gone. But if for any reason you wanted to go back into those worksheets to make some kind of a change, all you have to do is right-click our remaining Worksheet tab, and then choose Unhide, and then just pick whichever of these worksheets you want to unhide, and click OK. But for now, I'll go ahead and put it back under wraps. So this extremely brief foray into applying visual pizzazz to our model segues nicely into the next section of the course, in which we'll explore some of the most widely applicable visualization techniques Excel has to offer. Excel is one of the most powerful visualization tools ever created, seriously, so we'll have our work cut out for us. That all starts in the next video. I'll see you then. Welcome back. So our little savings calculator here is already pretty cool. But as with any model, which is basically what this is, it would be nice to be able to vary the inputs with something a little less clumsy and more reliable than simple manual user input. For example, our if statement we added in the previous phase of the project depends on the user correctly typing either yes or no into this cell. Now, if you're as bad a typist as I am, you know that over the long haul, that may be a bit of a tall order. A better solution would be to use a data validation list, so the user only has to select one of two valid values from a drop-down list, just like you see here. Similarly, instead of putting the burden on the user to type in a target date or our savings goal amount, we can set up slider controls, like the ones you see here, to give the user the power to easily vary these inputs over a wide range of values. No messy typing required. Now, as we've seen, slider controls require a bit of engineering, so you'll want to be very strategic in how you implement your solution. A couple of suggestions. First, I'd recommend locating the sliders cell links on a separate worksheet, and then assigning those cells to named ranges, so they'll be easier to incorporate in formulas. Then, you can use formulas in place of the current input values, here in cells C4 and C6, based on whatever value is produced by the sliders. Now keep in mind that the slider's max value is 30,000, so if we're going to allow for a goal savings amount greater than that, our formula will need to multiply the slider output by some factor. I opted to vary the slider value from 0 to 100, and then multiply the cell link value by 1,000 here in what was the savings goal input cell. This allows me to vary the savings goal from 0 to 100,000 in increments of $1,000. Obviously, feel free to tweak these parameters as you see fit. Now, as for the target date, you'll have to be even more creative. My approach was to vary the slider value from 1 to 120, and then use that value in a date function. Now, not a date function, but the date function, here in cell C6, to offset the current date by that number of months. So basically anywhere from 0 to 120 months from the current date. So if the user moves the slider to the halfway mark, the cell link value will be 60, and my target date will be the current date plus 60 months. Now that should be a decent amount for you to chew on, so I'll get out of your way and let you get to putting this together. So pause the video, and then I'll walk you through the solution I arrived at once you've built yours. I'll see you then. Okay, so I hope you had fun putting that together. So now I'll walk you through my solution to this problem. So first I'll go back to our starter file. And now before I do anything else, I'm going to create a new worksheet in this workbook called Behind the Scenes. And that's going to hold our slider outputs and the basis for our validation list for our yes/no cell. So I'll call this Behind the Scenes. And I'll start off by just creating a very simple list that says yes or no. And then I'll go back to our savings calculator. And then here in cell J10, where we're currently prompting the user for input, I'll create a data validation list by going to Data, and then clicking this little icon here. And then I'll choose Allow List. And then for my source, I'll go back to our Behind the Scenes worksheet and highlight those two cells, and then OK. And now we see that we're able to toggle back and forth between yes and no without needing to type anything. Now, just a little bit of formatting housekeeping. I'm actually going to increase the font size and also bold this cell just to make it stand out a bit more. So I think I'll increase the font size to 14 and then bold it. And now it stands out just a little more clearly. Now my next goal is going to be to add sliders for our savings goal and target date inputs. So I'll start with savings goal. So I'll go to my developer tab and then insert, and then I'll select this slider control. And then I'll drag from, say, cell E4 over to maybe H4. And then when I feel I've got that in the right shape and proportion, I'll let it go. And then to make life a bit easier, I'll just select that and hit Control-C to copy and Control-V to paste. So now I've got matching slider controls for savings goal and target date. And now to make accommodations for our cell link for each of these sliders, I'm going to go back to our Behind the Scenes worksheet and create headings to denote those cells. So here in cell C1, I'll type savings goal. And then in cell E1, I'll type target date. And then I'll auto-fit those columns. And now I'll go back to our savings calculator worksheet and configure our sliders. So starting with our savings goal slider, I'll right-click it and choose Format Control. And for this one, I'll stick with the default of the minimum value being 0 and the maximum value being 100. So the only real modification I'll have to make is updating the cell link. So let's go back to our Behind the Scenes worksheet. And then I'll just select cell C2 here as my cell link, and then click OK. And then just to test that out, let me drag the slide over just a bit, and then go back to our Behind the Scenes worksheet, and we see that the value in cell C2 has updated. So now let's follow some similar steps for our target date slider. So I'll right-click that control, hit Format Control, and here I'm going to range our values from 0 to 120. And then I'll choose a cell link again on our Behind the Scenes worksheet, right below our target date heading, and then click OK. And then our next step will be to update our current input cells in cells C4 and C6, where we had been typing in our savings goal and our target date respectively, to instead be formulas that point to our cell links on our Behind the Scenes worksheet. But to make referencing those cells easier, and in case we ever decided to move those cells for some reason somewhere else, I'm going to go ahead and assign those two cell links named ranges. So back to our behind the scenes worksheet. I'll first choose our savings goal cell link, and then go to Formulas, Define Name, and because we have that heading there, Excel is smart enough to guess the name that we want to assign to our cell link. So I'll just click OK, and I'll follow similar steps for our target date cell link. So again, Define Name, and I'll go ahead and stick with that default that Excel is recommending. And so now when we want to reference the values here in cell C2 or E2, instead of having to remember exactly what cell address that we assigned those cell links, instead we just type the name of that cell. So I'll go back to our savings calculator, and then in place of our current savings goal input, we'll type equals savings goal. Remember, that's our named cell, our named range that has the cell link for our slider, times 1,000. And now that we've got that formula in place, we can use our slider to vary that input. Pretty cool. So now things are going to get a little bit more complicated for our target date. We're going to need to make use of the date function to offset whatever number of months we're specifying in our slider from the current date. So I'll type equals date, and then for our year argument, we'll simply take the year of the current date, but then for the month argument, things will get just a bit more interesting. So I'll start with the current month using the month function around the today function, but then I'll add to that the number of months specified by the output of our slider. So I'll say plus the value in our target date named range, which is just the cell link for our slider. And I'm noticing that because Excel is not automatically recommending the next argument of this function, that I must have made a typo. So if I look back to the very beginning of the function, it looks like I didn't close my parenthesis on the year function. So I'm not wrapping the argument of the year function in parentheses. So I'll click right after that today, and then close that parenthesis. And now Excel is recommending that third argument of the date function to me. So for that day argument, I'll just take the day component of the current date, and then close out a parenthesis for my day function, and then finally for my date function, and then hit enter. And yikes, that is not what we expected. So the problem here is that because my slider is currently at its default value of 0, our target date is the same as the current date. So if you recall, down here in our monthly savings needed formula, we divide our current savings by the number of months from the current date that our target date is. But if our target date is the same as our current date, then the number of months from the current date is 0. So basically we're dividing by 0. Now it isn't really logical for our target savings date to be today. At the very least, it's probably going to be at least a month in the future. So what we need to do is reconfigure our slider such that the minimum value is 1 and not 0. So now we'll click OK, and our problem is solved. Now as you can see, our monthly savings needed here are pretty aggressive, as is our percentage of monthly income. And that's because our target date is very near into the future, at least relative to when I'm recording this, and our savings goal is also pretty high. But if I adjust that target date by moving my slider, now we have a target date about 6 years into the future, so even with a savings goal of $45,000, our monthly savings needed aren't so aggressive. Okay, so now that we finally got this working, I'll go ahead and hide our behind the scenes worksheet. After all, it is called behind the scenes, and we don't really have any need to read the information on this sheet or interact with it on a day-to-day basis, so I'll go ahead and hide it. And at this point, we should be good to go. So for now, we'll dive back into learning more new Excel features that we can use to enhance our budget and expense tracker even more down the road. I'll see you in the next one. Welcome back. Now that we know how to do all sorts of useful things with our data in Excel spreadsheets, let's turn our attention to methods we can employ to make that data look good. It turns out that, in addition to being an incredibly powerful modeling and calculation tool, Excel also has some pretty incredible visualization features up its sleeve. Now, when you think of visualizations, the first thing that comes to mind is probably splashy charts and graphics. Now, don't worry, we're going to get there, probably minus the splashy part due to my aforementioned extremely limited skills as a visual designer. But first, we'll explore a formatting technique that works in plain old black and white: custom formats. We've already seen how to apply Excel's built-in formats to various types of data, text, numbers, and dates, but Excel actually gives us the power to define our own formats for situations when the built-in options just don't meet our needs. While we can create these formats for all the major categories of data in Excel, the most common application in my experience is to date and time data. For example, Excel only gives us one formatting option for the combination of date and timestamp out of the box, and that is the date followed by the time in military time. But what if we wanted to see the time component formatted as AM and PM time instead? Let's take a look at how we can create a custom number format to do just that. So here in our example spreadsheet, we have a variety of formatting patterns. Don't worry if they look a little confusing. I'll explain how they work as we go, that will apply to the current date and time. So first up, I'll retrieve the current date and time by entering the now function here in cell C2. So I'll type equals now. And as you can see, sure enough, Excel formats this value as the current date plus the current time in the military format. So for comparison's sake, let's type another now function in the next row down here in cell C3. And now, to change this to AM and PM formatting, we'll first right-click the cell, and then go into our Format Cells menu. And we need to have our custom category selected, but that is actually already selected by default because the format that Excel applies to date time values by default is considered a custom format. So if we look at the format that's highlighted, which is the format that's currently applied to our value, we see that it's really just a combination of a series of symbols. More specifically, the format is really just a pattern, consisting of codes that represent individual components of a date and time in a certain way. For example, the single M before the first slash translates to one-digit month, which basically means for the months of January through September, the first 9 months of the year, the month will be formatted as a single digit. But we can actually change this format to use 2 M's instead of 1. And I can do that right here in this text box just above the list of custom formats. So if I add that second M, and then if we look at this preview directly above our custom format pattern that shows how our value will be formatted based on the change we made, we now see that the current month is formatted as 07 instead of just the number 7. We can similarly change the hour formatting, here represented by the letter H, to always show 2 digits, even for hours of the day less than 10. So I can just add another H right here. And just because we're later than 9 a.m. in the day, that's not going to have an impact on the formatting of my current date time value. But the main reason we're here is to add the AM and PM component to our timestamp. So it turns out that all we have to do to switch to that particular flavor of formatting is simply add AM/PM to the end of our formatting code. So let's do that. So I'll type a space, and then in caps, AM/PM. And note here that there are other built-in custom formats that have this exact same pattern at the end of them. They're just specific to times. So the third custom format listed here is hour, minute, and then AM/PM, which would format a time using AM and PM rather than military time. So you can often get little clues as to which components you can combine to create your custom date and time formats from the other built-in custom date and time formats. So now let's click OK. And you can see that in contrast to Excel's default date and time format, our newly formatted timestamp is expressed in AM/PM time and has a 2-digit month and a 2-digit hour. So now that we've got the hang of the basics, let's change up our format once again. So down here in cell C4, I'm going to again type another now function. And this time I'm going to format it according to the code you see immediately to the left in cell B4. Now this code has the year first, then the month, then the day, followed by hour, minute, second, and AM/PM. So there's a few differences here between the other formats we've looked at so far. The first is that I've changed the order of the components such that year comes first. I've also changed the separator between the components of the date to now be a dash or hyphen instead of a slash. Third, I've added a seconds component to the time piece of our date time. And then lastly, I'm now using 3 M's instead of 2 for the month. So what sort of change will that make? Well, let's find out. So first, I'm actually just going to copy this whole formatting pattern onto my clipboard, and then I'll go into my date time value in cell C4, and then go to my Format Cells menu. And then in my text box where I can enter a custom format, I'll just paste in what I just copied. And you can see that the first component is just the year, but the second component of my date, instead of returning the number of the month, actually returns an abbreviated name of the month, specifically the first 3 characters. Then of course we have the day, the hour, and the minute, but because I added that :SS after the time value, our date time now has a seconds component as well. So let's click OK. And there we are. The exact same value, the same date and time, but formatted in yet another way. So for my last custom format, I'm going to do something really interesting, at least by the standard of doing custom formats in Excel. So first I'll enter another now function down here in cell C5. So now my last formatting pattern here has 4 D's instead of 2 D's for the day, and then a comma, then 4 M's instead of 2 or 3 for the month, and then again 2 D's, possibly again for the day, then a comma, and then the year. So what the heck is this going to look like? Well, let's go ahead and grab that formatting pattern, and again go into Format our new date time, and replace the default formatting pattern with our new one. And now if you look at the preview, you see that those 4 consecutive D's return the day formatted as the name of the day of the week. And then we added a comma, which just underscores how you can integrate a variety of punctuation and separators between the components of your date. You're not limited to a slash. You can use commas, hyphens, even spaces. And then 4 M's for the month, which returns the full name of the month, not an abbreviated name. And then a space. And then the 2 D's simply return the day of the month as a number, as opposed to the 4 D's, which return the name of the weekday. Then finally a comma and the year. So now I'll click OK once more. And there we have it. That's another pretty slick custom format that is arguably more human readable and user friendly than most of the other built-in custom formats, especially if you don't need a timestamp. All right. Up next, we're going to take our formatting from black and white into full color and learn how we can apply our formats conditionally, depending on the individual values within our data. I'll see you then. Hey, welcome back. So the ability to apply formatting to our data is great, but quite often it's useful to be able to apply different formats to cells within our data based on their values. Perhaps, for example, to draw attention to values that are unusual in some way. Extremely bad, extremely good, or just plain weird. Now, of course, we could simply sift through our data manually and apply distinct formatting, maybe bold text, maybe a red background, you get the idea, to any values we deem worthy of calling out. But this would be quite a chore even for a small data set, and darn near impossible for a larger one. So what we need is a way to apply formatting intelligently, based on logical conditions, so that Excel can do the tedious work of finding the cells that meet our criteria and formatting them distinctly for us. So here in our example spreadsheet, we have some employee-level performance data for employees working at a call center. As an aside, if you do reporting and analytics long enough, at some point you're probably going to come across call center data, as most larger companies have call centers, and reducing costs at those call centers is usually a big concern. So the two primary metrics that we're grading our employees on are customer satisfaction, which is the percentage of customers who are satisfied with their call experience, and average handle time, which is the average amount of time it takes an employee to complete a call. Given this data, it would be very useful to call out any performance statistics that fall above or below a certain threshold of interest. For example, let's say that our company has decided that any employee whose customer satisfaction rating is less than 75% needs additional coaching and training. To call attention to these values, while still retaining visibility into the overall data, which we would lose if we simply used filters, we can actually apply what's called conditional formatting to make these cells stand out. So the first step is just to highlight the range that contains my values of interest. So that will just be all of our customer satisfaction percentages here in column B. Then, on our Home tab, we want to look for the conditional formatting button, which we see right here in the Styles section. So if I click that, I see a number of options pop up. Now the category that best suits our problem here is Highlight Cells rules. So if we highlight that one, we see a number of options that allow us to apply specific formatting to a cell based on logical criteria applied to the cell's value. For example, we can apply formatting if the cell value is greater than some threshold, less than, between, equal to, contains certain text, or perhaps has a date that occurs within a certain range. Now in our case, we're interested in values that are less than 75%. So let's choose this less than option. Now Excel is helpfully attempting to make a guess at what our threshold should be, but we're going to modify that from the suggested 82.1 to just 75. And then on the right side of this dialog box, we see that Excel has again suggested a format to make these values pop on the screen. But if we click this drop-down list, we see that there are other options we could choose that are pre-suggested by Excel. Or we can go down to the bottom of the list and choose Custom Format, at which point we're brought to our familiar Format Cells dialog box. So using this, we could format these cells that meet our specific criteria any way we want. But for now, I'm actually just going to go with Excel's original suggestion and click OK. And now in a few mouse clicks, we've achieved easy visibility into our employees who might require a little bit of coaching without losing visibility into all of the other employee records. Now, when it comes to conditionally formatting cells based on logical criteria, there's another category of approaches you can take. And that is to conditionally format the top or bottom number of records or percent of records based on their values. So in this case, perhaps we're interested in calling out the bottom 20% of performers based on customer satisfaction. So let's see how that would work using Excel's conditional formatting features. So first, I'll actually clear the existing conditional formatting rules. To do that, I'll again just highlight all of our cells that we've applied conditional formatting to, and then go back into my conditional formatting menu, and then at the bottom choose Clear Rules. And then Excel asks me if I want to clear the rules from the selected cells or the entire sheet. I just want to clear them from the selected cells. And now, with these same cells selected, I'll go back to my conditional formatting menu, and now I'll hover over the category Top Bottom Rules. So as you can see, we have categories like top 10 items or top 10%, and that 10, by the way, is just an example number. If you choose the top 10 option, you can make it the top 2, the top 5, the top 20, whatever the case may be. Now in our case, we're interested in the bottom 20%. So we'll go down and select bottom 10%. And now we see a dialog box quite similar to the one before. The difference being we just need to specify that bottom percent, whatever percentage we're interested in seeing. So I'll change that 10 to a 20. And just for variety's sake, I'll choose another one of these pre-configured styles that Excel suggests. Perhaps I'll just choose light red fill, and then click OK. And as you can see, this had a fairly similar effect to the threshold we applied before, wherein we called out any values below 75%. But since this formatting rule is based on a percentage of our total number of cells we're applying the conditional formatting to, there is no hard and fast threshold like 75%. For example, this value here in cell B13 of 73.6% isn't called out because while it is on the low side, it's not among the worst 20% customer satisfaction scores. These types of conditional formatting rules are a great way to highlight values of interest in your data without hiding the rest of your data like you would if you tried to accomplish the same thing just with filtering. All right, up next we'll take a look at another flavor of conditional formatting, which provides us with a slick visual representation of how each and every data point fits in relative to the others. I'll see you then. Welcome back. Now that we've gotten our feet wet with conditional formatting by applying distinct formatting to specific values of interest, let's turn our focus to a couple of conditional formatting techniques that apply to all the cells in our selected range. First up is data bars. Data bars are a visual representation of the size of the number in a cell relative to all the other values in the same range. The biggest value in the selected range will be formatted with a bar that fills the entire cell. Then, the bars in all the other cells will scale down relative to the largest value. So let's take a look at applying data bars to our average handle time values here, so we can get a feel for where each of our employees' handle time fits in relative to the others. So our first step will be to highlight our values of interest, which are here in column C. So I'll just highlight from cell C2 to C21, and then I'll hit our conditional formatting button again. And now I'll roll down to data bars. And if I hover over that, Excel gives me a number of predefined formatting options. And if I hover over these, I actually get nice little previews in my data of what these data bars would look like. So just hovering over a few of these, I think I probably like maybe this guy best. So if I click that, now if we scroll down through our data, we see that the two largest values here, 19.8 in rows 19 and 4, both have the longest data bars. And then some of our shortest values, like here in cell C11, where we have an average handle time of only 5.2 minutes, have the shortest bars. So this is a great way to just get a sense of where the values in your data fit in relative to each other at a glance. Now let's take a look at another conditional formatting technique called color scales. Like data bars, color scales apply to all the cells in our selected range and give us a visual sense of how each value fits in relative to the others. However, while data bars convey this information via the size or length of the bar we see here, color scales instead vary the shading or background color of cells to indicate where they fit in relative to the other values in the selected range. It's quite common for these colors to vary from a cool color, like blue or green, to a warm color, like orange or red, or vice versa, depending on whether a higher number is considered to be good or bad. So now let's take a crack at applying a color scale to our average handle time values here in place of data bars. So my first step will be to just clear out the conditional formatting from our average handle time values. So I'll highlight those values and then hit my conditional formatting button and then go down to clear rules and then clear rules from selected cells. And now, with those values still selected, I'll again hit my conditional formatting button and then roll down to color scales. Now here I'm again presented with a number of pre-configured options which apply different color combinations or palettes to different values, again depending on where they fit in relative to the other values in the range. But looking through all these, I don't necessarily see any one that I particularly like, so I'm going to go down and select More Rules. Now incidentally, doing that brings up this new dialog box, which you can actually think of as kind of the master dialog box for conditional formatting rules in general. All the menus we've used thus far, you can think of as friendly menus that provide an easy interface to apply a specific type of conditional formatting. But from this one dialog box here, you can actually apply and edit all the different types of conditional formatting that are available in Excel. The analogy I would use is, you know how there are shortcuts to formatting data as currency or percentages that we can access directly through a button on the ribbon? But there's also the Format Cells dialog box, which has all those options in one place. This dialog box is basically the Format Cells dialog box of conditional formatting. So in the case of color scales, we're formatting all cells based on their values, which is the first option listed. And then for that particular category of conditional formatting, our currently selected format style is 2-color scale. But if I click this drop-down list, I see that we can also select a 3-color scale or data bars, which we've already seen. So if we select a 2-color scale, the background color of our cells will vary from the color listed under the minimum heading to the color listed under the maximum heading, depending on the value of the cell. If, on the other hand, we choose 3-color scale, there's a third color that our background colors will transition to on their way from the lowest value to the highest value. So our maximum value in our range will have this green color here, the minimum value will have this red color, and whatever value is exactly in between our highest and lowest values, that is the midpoint or the value at the 50th percentile, will have this yellow color. But if we don't find this exact color palette to our liking, we can always change it. So I could change my minimum color to, say, this orange, and then I could change my midpoint color to some sort of blue. Full disclosure, I am not arguing that this color palette makes particular sense. I'm just giving you an example of how you can customize these color palettes to your particular liking. So now if I click OK, we'll see that we do, in fact, now have shading conditionally applied to our cells based on their values, with our lowest values being shaded closest to that orangish color, and our highest values being shaded closest to the green color we selected. So the problem here, aside from my obviously extremely limited ability to pick an attractive color palette, is that when it comes to average handle time, higher values are worse and lower values are better. Obviously, we want our employees to spend as little time on the phone as possible while still maintaining a high rate of customer satisfaction. But the color palette we chose, where higher numbers are shaded green and lower numbers are shaded orange, kind of implies the opposite. So what we need to do is reverse this color palette so that our highest numbers are shaded in some kind of a warm color and our lowest numbers are shaded with some kind of a cool color. So let's go back into our conditional formatting menu and edit this rule. So again, I'll highlight all these cells and then hit our conditional formatting button. And now I'll choose Manage Rules, which will allow me to edit an existing conditional formatting rule applied to the cells that I've selected. So this is the only rule that we've applied to this range, so I'll select it and then click Edit Rule. And now we're back in our familiar dialog box. So for our lowest color, since a low average handle time value is a positive, I'm going to choose a light shade of green. And then for the background color of our highest average handle time values, I'm going to choose red. And then for our midpoint, perhaps I'll choose a light yellow. Now if I click OK, and then one more time, you'll see that our new color palette makes the highest average handle time values pop, while also giving scale to all the other values in between. Now just to underline the point that the conditional formatting dialog box we just saw can be used to create and edit conditional formatting rules of any kind, I'll actually use it to go ahead and edit the conditional formatting rule we applied to our customer satisfaction scores. So let me highlight these, and then go back into our conditional formatting dialog box by choosing Manage Rules under Conditional Formatting. And now we see the rule that we had applied to that range. So if I select that and hit Edit Rule, we'll see that while we are in the same general menu, we now have a different option at the bottom of the dialog box because we had applied a different type of rule to these cells. In this case, the category of rule is Format Only Top or Bottom Ranked Values. So we had elected to format the bottom 20% of values in a particular way. But let's say I just wanted to conditionally format the bottom 5 values regardless of where they fit in a percentile sense. All I have to do is uncheck where it says percentage of the selected range, and then change that 20 to a 5, and click OK, and then OK once more. And now we'll see that we actually have an additional value that was highlighted, because the bottom 20% of our 20 values here was 4. But this time we chose to conditionally format the bottom 5 values in an absolute sense, not a percentile sense, so one additional value was highlighted. I also wanted to introduce you to that master conditional formatting menu to teach you how to fish, so to speak, in the event that you want to apply some different type of conditional formatting. There are far more flavors of conditional formatting available to you in Excel than it would make sense for me to try to present to you here, which is why I've chosen to focus on the varieties that I think are most useful to the largest number of people. But there's always the chance that your particular needs might be different, which is why knowing how to navigate that conditional formatting dialog box is so important. All right, up next we're going to take our visualization skills to the next level by starting our exploration of perhaps the most powerful visualization tool Excel has to offer, charts. I'll see you then. Welcome back. So conditional formatting has shown us how adding some visual effects to our data can help us gain insights and draw attention to relevant values. But sometimes the raw data itself isn't the best mechanism for conveying these insights or understanding. Computers are great at processing large tables of numbers quickly, but human beings aren't computers, and sometimes the meaning of our data gets lost in a forest of individual data points. You know the saying, a picture is worth 1,000 words? Sometimes a picture can also be worth 1,000 data points, and that's where charts come in. Charts are basically visual representations of data that are actually entirely separate from the data itself. A good chart should tell a story about the data it's based on, that provides summary and insight that a human being can easily grasp and use to make decisions. Excel has extremely powerful charting capabilities, and a wide variety of charts that we can use to visually describe our data. However, there are a handful that are used more often than others, so we're going to focus on those. So without further ado, let's paint a picture of some data with a little help from Excel. Now here in our example spreadsheet, you'll see that I already have a chart that shows a comparison between sales of different flavors at a Hawaiian shave ice truck. I chose this particular type of chart, called a column chart, because column charts are best at helping us visualize a comparison between different things, which is essentially what we're doing here. I wanted to start with a finished chart because the process of building a chart in Excel can seem a little magical, so to speak, if you don't understand how all the individual components of the chart fit together. So before we dive into creating a chart of our own, let's walk through the individual components of this column chart. I first want to call attention to what's called the vertical or y-axis of the chart. And that's these numbers you see going up in a vertical column here on the left. That axis gives scale to the values being plotted visually in the main chart area. And Excel actually chooses this range of values represented in the y-axis automatically based on the values that we're charting. So because our largest sale amount happens to be $502.28, Excel chose a range of values on this vertical axis between $0 and $600. And now all of our total sales amounts are represented visually in these blue bars relative to that highest number on the y-axis. Next up, I want to call out the horizontal or category axis. And this just lets you know which of these columns is associated with which flavor from our data. So without this axis, we might identify a bar that's taller than all the others and has an associated value of $502, but we wouldn't know just from looking at the chart which flavor that bar was associated with. Now the bars themselves are part of what's called a data series, which is really the most crucial aspect of the chart. And then that data series is contained within what's called the plot area. So if I click anywhere between these grid lines and then hold down my mouse button and drag around, I can actually move this central plot area within the larger frame of the chart. This can be useful if you want to expand the overall chart area to take up more space, but then shrink the plot area to create a larger frame around it. And then lastly, up top, we have our chart title, which is obviously useful in conveying an overall summary of what the chart is about. So now that we've surveyed the general structure of a column chart, I want to demonstrate how we can recreate this chart from scratch. So first I'll use Control-Z to undo my maneuvering of the plot area within the overall chart. And now I'll actually duplicate this entire worksheet just so I can keep my original as a reference as we work through the steps of creating this chart from scratch. So now I'll go on to our new worksheet, and then I'll click the chart to select it, and then hit delete. So now our chart is gone. So we know that we want to create a column chart from this data, but where do we begin? Well, first I'll select a cell near where I want the chart to go, although we'll always be able to move the chart around later once we create it. And then I'll go to the Insert tab of the ribbon, and then above the Charts section, I'll hover over these icons until I see the category of chart that I'm interested in. And if I hover over this guy, it says Insert Column or Bar Chart. So then I'll click the down arrow next to that, and then I'm presented with a wide variety of column charts that we could choose. Now, as with so many of Excel's features, there's a billion different directions you could go, but the first simplest option presented is normally more than sufficient for your needs. So I'm just going to click this first 2D column chart here. And now we have this blank canvas on our worksheet. But note that if I click that, we now have a brand new tab on our ribbon. So this is what's called a contextual or context-specific tab that only pops up in the ribbon when we've selected an object that has a whole new set of commands that apply to it. So when we select this chart, now we have a whole new set of commands that we can use to add elements to the chart, format those elements, and otherwise configure the chart to our needs. So the most important of these commands under the Chart Design tab is the Select Data command. This is where you're going to choose the data that will actually make up the chart and the role that data will play in each chart element. So I'll click that, and now this Select Data Source dialog box pops up. Now, ironically, we can actually ignore this very first text box, which looks very, very tempting to just go ahead and start entering cell references into. And while you can just indiscriminately select a range of data and let Excel figure out how the various columns within that data should be used in a chart, especially when you're first getting the hang of creating charts, I find it a lot more useful to be more explicit about which part of your data will be used as the basis of which chart component. So in short, we're going to ignore this chart data range input box, and instead we're going to click Add under this Legend Entries heading. So when we click Add there, Excel prompts us to edit a series. And if you recall, the series is actually the visualization within the overall chart. So what we're really interested in here are the series values. The series values are the data that is being visually represented within the chart. So in our case, that is the total sales numbers in column B. So to select those, I'll click this arrow to the right of the Series Values text box, and then I'll just highlight my sales values, and then click OK. And already we've got a nice visual representation of how each of these values fits in relative to the others. And it looks like our vertical or y-axis is already in place. The problem is we still don't know which of these columns corresponds to which of our flavors. So that is where our horizontal or category axis labels come in. So we'll click Edit under that heading, and now we're prompted to select the axis label range. And that's just going to be the labels that we want to be assigned to each of these columns, which is basically just our flavors in column A. So I'll select those flavors, and now click OK again, and I'll move our dialog box out of the way. And look at that. We've basically got the structure of an effective chart already set up in just a few clicks. So at this point, I'm satisfied with how our data is being structured within the chart. We just need to add a few formatting tweaks before it's ready to present to an audience. So I'll click OK in my Select Data Source dialog box. And now, just to see what we're missing from the chart we are trying to recreate, I'll go back to our first tab. And two things that stand out right away are these numbers above each column that tell us exactly what number that column represents, and also this title above the chart area. So let's try to reproduce those. So back to our new worksheet, I'll first select the title to bring up that contextual tab on the ribbon again, and then I'll click that Chart Design tab. And now, to add a new element to the chart, not surprisingly, I'll navigate all the way over to the left side of the Chart Design tab on the ribbon and click this Add Chart Element button. And this gives us a list of all the elements or widgets, so to speak, that we can add to the chart. So one thing we can add is data labels. So data labels are just those numbers that appear above the columns that tell us what that exact number that column represents is. So if I hover over these options, we actually get a preview right in our chart of what this would look like. So I think I want my numbers to be directly above the columns, so I'll choose Outside End. Now next, I want a chart title. Now Excel's already given us an example chart title here, so all we have to do is just click inside of that and edit it to say Total Sales by Flavor. Now at this point, we're getting pretty close to having successfully reproduced our example chart, but there's definitely some visual pizzazz that's missing. Now, me not being a graphic designer, it would probably take 20 years to go through each and every chart element and configure its color and shading and gradient and so on to produce a visually attractive end result. Fortunately, Excel gives us a number of built-in chart styles that make these decisions for us in ways that make sense to bring the different elements together into a coherent whole. So if you look at this section on the Chart Design tab called Chart Styles, you'll see a series of images representing how our chart would look with a different set of styles applied. So if I click this down arrow to the right of those images, now I can actually just hover over these images to get previews of how our chart would look if we applied this particular set of styles. And some of these look better than others, at least to my untrained eye, but I think I like this guy, so I'll click that. And now if I do say so myself, our chart's looking pretty good. Now one more aspect of the chart formatting you can play with without being an expert designer is the color palette that is applied to the chart. So if you click this Change Colors button over here, Excel provides a rather extensive list of color palettes that you can use to change the look of your chart. And again, if I just hover over these, I can get a preview of how they would change how my chart looks based on this particular chart style. But I happen to like the very first one, the default option, the colorful palette one, so I'll just stick with that. And now if we just navigate back to our original chart to compare, it looks like other than sizing, we have successfully reproduced it. So I'll click my chart, hold down my mouse button and drag to move it further up and to the left. And then to resize the chart, I'll hover over the bottom right-hand corner until my cursor turns into this little diagonal arrow, and then click and hold down my mouse button and drag down and to the right until the dimensions of my chart are what I want them to be. And of course, you can always reverse that process by dragging up and to the left to make the chart smaller. Okay, I know that was a lot of information for one video, but we're not done with charts yet, not even close. In fact, we're not even done with column charts. They can actually do a lot more than I had a chance to show you here, but we'll explore some of their additional capabilities in the next video. I'll see you then. Welcome back. So in the last video, we saw how column charts can be used to visualize comparisons between data points. But they're also highly effective at visualizing how numbers change over time. Take, for example, this little sample data set that lists the number of calls received at a call center for each month of the year. Seeing a comparison between months might be useful, but the real value here would be in showing how the numbers change over time. Let's see how we can accomplish that with a column chart. So first, as usual, I'll go to my Insert tab on the ribbon, and then I'll hover over the type of chart I'm trying to create in the chart section, which is a column chart. And then I'll select the first 2D column. And now I have my blank canvas here, which I'll reposition a little closer to the data. And now that I've selected the canvas, my Chart Design tab on the ribbon appears. So now I can click my Select Data button, and I'll add a series. And my series values will just be the calls here in column B. And we're looking good so far. So next I'll choose the labels for our horizontal or category axis, and those will just be the months of the year. So now if I click OK, and again, not only do we see a comparison between how each month performed relative to the others, we also see a trend in how many calls came in per month over time. This can be especially useful if you identify a clear trend in which a certain number or metric is increasing or decreasing over time. That kind of information can inform decisions about things like marketing, operations management, staffing levels, and so on. So now we've introduced the element of change over time into our visualizations, but what if we want to compare how different values change over time? Let's say, for example, that our monthly call center statistics were further broken out by the 3 call center sites our company operates. How can we show a comparison between the numbers for each of these sites while also showing the month-over-month trending we had in our previous chart? Well, it turns out that column charts make this sort of thing pretty simple. So let's dive right in to see how. Now first, I'll follow my usual set of steps for inserting a blank column chart. And now I'll select the data for my chart. So first I'll add a series. And for my first series, I'll just select the calls for my Aurora, Colorado call center. And right away, this begs the question of how we're going to add our data points for our Spokane, Washington, and Jacksonville, Florida call centers, and how we can distinguish those numbers from each other, which is the whole point of this chart. We're trying to see how the call volume at each of our call centers changed over the 12 months of the year. So this actually turns out to be pretty easy. So first I'll click OK to lock in that series for our first call center. And then to add another series for our Spokane call center, I'll just click Add here to add a new series. And then I'll simply select the values for our Spokane call center. And now you've probably got a better idea of how this is going to work. Our second data series is plotted in a different color, so we can easily compare the two side by side for each month of the year. So now I'll follow the same steps for our last call center. So I'll add a new series, and then select the values for our Jacksonville call center. And then finally, we need to add our category axis labels, so I'll select the months of the year, and then click OK. And while this seems like a pretty good start, one problem we obviously have is that there's no obvious way to connect the colors of these columns with the individual call centers they represent. So what our chart needs is what's called a legend. No, not a legend as in the Legend of Zorro or the Legend of Chuck Norris, but rather a mapping between the colors of these columns and the category of data point they represent. So let's look at adding that. First, I'll select my chart again so I can get my Chart Design tab on the ribbon back. And then because I want to add a chart element, I'll go over and hit the Add Chart Element button. And then I'll go down to Legend. And now I'm given some options as to where I want to position that legend relative to the chart. To me, the most logical position is below the columns, so I'll choose bottom. And here again, we have an issue. While we see how the legend is supposed to work, these names that it's assigning to each color, Series 1, Series 2, Series 3, don't really have any meaning to anyone. So how can we change those names so that we can meaningfully associate them with our different call center sites? Well, the trick is in how we configured our data series to begin with. So let's go back into Select Data and then edit our first series. So up to this point, when we've created our data series, we've been leaving this series name field blank. Well, it turns out that a chart legend keys off of this series name. So if I select our column header for our Aurora, Colorado data series, sure enough, you'll see down in our legend, instead of series 1 for the color blue, we now have Aurora, Colorado. Awesome. So now all we have to do is just replicate the step we just took for our other two call centers. So I'll add the name for our Spokane call center, and then I'll edit our third series for our Jacksonville call center, and then add that site name for our series name, and finally click OK. And there we have it. Now I'm easily able to compare call volume at our 3 sites by month and see how that volume trends for each site over the course of the year. So at this point, the only thing left is just to modify our chart title to something meaningful. So I'll click there, double click to edit, and then change it to call volume by site and month. All right, so now that we've seen what we can do with column charts, up next we're going to explore a different kind of chart that is actually even better at conveying change in numbers or metrics over time. And we'll also look at how we can combine multiple types of metrics and multiple chart types in the same chart. I'll see you then. Hey, welcome back. In this one, we're going to explore another chart type called line charts, which are even better than column charts at conveying change in numbers over time. And later, we'll even look at adding new layers to our analysis by combining these two chart types in a single chart. So let's get started by seeing what it would look like if we converted this column chart to a line chart. Now, as it happens, Excel makes this extraordinarily easy, especially if the types of charts you're converting between are very similar in structure, which line charts and column charts are. So let's click our chart to select it and bring up our contextual chart design menu. And then over here we see a button called Change Chart Type, which does just that. So let's click that. And now we're presented with a huge variety of options of charts we could potentially change our chart to. But we're going to select Line, the line category. And then of the available line charts, we're just going to pick the very first one that's offered and click OK. And now we see that instead of Excel generating a distinct column for each data point, it instead plots these data points essentially as dots and then connects them with lines, which is a format that is generally a little bit more useful for conveying that change or trending in our metrics or numbers over time. So converting a column chart to a line chart is obviously a snap, but creating a line chart from scratch is a simple process in its own right and really works just like creating a column chart. So let's take a look at another data set to see how we can create a line chart from scratch. So here we have two call center metrics, total calls and customer satisfaction percentage, broken out by day of the month. So this more granular breakout of a time frame by day rather than by month will further illustrate how good line charts are at conveying change over time. So first, we're just going to worry about plotting our total calls, and we'll get to customer satisfaction percentage in just a bit. So the steps I'll follow will be just like the ones for creating a column chart. I'll go to my Insert tab, and then instead of inserting a column chart, I'll hover over my icons until I see some indication that I'm hovering over the line chart. And there it says Insert Line or Area Chart. So now I'll click the down arrow, and I'll just select the simplest form of a line chart, the 2D line. And now, just as before, my next step is to select data. So I'll hit my Select Data button, and then I'll add a series. And we learned our lesson in the last video about adding a series name in case we want to add a legend to our chart later. So let's go ahead and select the column header for our total calls taken as the series name. And then for my series values, I'll just select the actual call statistics in column B. And now we'll scroll back up so we can see our chart. And right away, we've got a picture of how our call volume trended across the month. But of course, the missing piece is our horizontal axis labels. So let's click OK here, and then edit our horizontal category axis labels, which will obviously be our actual days of the month. All right, so far so good. So you can see here that Excel did not plot every single one of our dates on that horizontal axis. It's actually plotting every other date. Our first date marker is January 1st, our second is January 3rd, and so on. And it does this by default just to avoid that axis being overly cluttered. But if you were to expand the chart to be wide enough, suddenly Excel perceives that there's enough room to fit all of those dates in there comfortably, and it does so. But either way, no matter how large or small the chart is, it still conveys that same sense of trending over time. So now our next step here is to integrate our customer satisfaction percentage into the same chart. Now this is something we haven't tried thus far. Up to this point, we've always been plotting the same type of metric onto an individual chart. So let's see what happens if we try to plot a second series with our customer satisfaction percentages. So again, I'll hit my Select Data button, and then I'll add a new series, and the series name will just be the name of our metric here in cell C1, and then my series values will be my actual customer satisfaction percentages. And then if I click OK, and again, and scroll up, something has gone horribly wrong. So instead of this neat little squiggle that indicates trending over time that we got with our first series, our second metric is literally flatlining. So what's going on here? Well, the problem is the scale of our vertical axis. Our vertical or y-axis here is scaled based on our first data series, which is call volume. Now, our call volume ranges all the way up to around 1,500 calls a month. But our customer satisfaction percentages are all decimal numbers less than or equal to 1. So obviously, if you plot a number that's less than 1 on a scale that ranges from 0 to 1,600, it's barely going to even register on our chart. It's like if you tried to plot my vertical leap on the same chart as LeBron James's. Mine is barely even going to register. So the solution here is to add a second vertical axis to our chart that will provide an appropriate scale to our second data series, our customer satisfaction percentage. So this axis would have values that range more along the lines of somewhere between 0 and 1, since our customer satisfaction rating is a percentage that varies somewhere between 0 and 1. So to add this second axis and associate it with our second data series, first we'll select the series in the chart by clicking it, and then we'll right-click and choose Format Data Series. And right away we see an option to plot the series on a secondary axis instead of a primary axis. So let's choose that. And right away we see that our problem is mostly solved. Now our line that plots our customer satisfaction percentages is varying in a way that genuinely conveys the change in that value over the course of the month. But I still have a couple of quibbles here. One is that our vertical axis for customer satisfaction ranges all the way to 120%, which really doesn't make a lot of sense considering it's impossible to have a customer satisfaction score greater than 100. So let's click this axis to select it, and then right-click and choose Format Axis. And if we look under the Bounds heading, we'll see that the minimum is 0 and the maximum is 1.2. Now Excel selected this value automatically, and Excel is usually pretty smart about selecting these things by default, but in this case it didn't recognize that we were dealing with a metric that just doesn't make sense if it's greater than 1 or 100%. So let's change this to 1 and then click out of the menu, and now you see that the bounds of our second vertical axis have changed from 0 to 100 instead of 0 to 120%. Now another issue with this chart is that we can't easily distinguish between what these two lines mean. I don't know if the orange line pertains to the percentages on the right or to the call numbers in my leftmost vertical axis. So it sounds like we need to add a legend. So I'll go to Add Chart Element and then Legend, and I'll choose to place that below the chart. Okay, and now that is a big improvement So now we can see that the blue line represents our calls and the orange line represents our customer satisfaction. But it would still be nice if we could make the distinction between these two metrics on the same chart even clearer. One way we can do that is to convert one of them to a column chart. Yes, it is in fact possible to have two different chart types within the same overall chart, and sometimes it's a very effective method for drawing distinctions between two different metrics that you're plotting on the same chart. So let's try to change our customer satisfaction series to a column chart. So first I'll click the series to select it, and then right-click, and then choose Change Series Chart Type. And now I'm in the same menu that we saw earlier for changing chart types, except the category that Excel chose is Combo. And that basically means a combination of two different chart types in a single chart. So both of our series are listed here, our calls and our customer satisfaction, and we have the option of changing either of those series to whatever chart type we like. And lastly, we have the option of plotting either one on the secondary axis. Now we want our customer satisfaction plotted on the secondary axis, and we want our calls to be plotted on the primary axis, so that's fine. But what we will do is change our customer satisfaction series to be a column chart. And right away, Excel gives us a nice preview of what that's going to look like. So I'll go ahead and click OK. Now our chart is already looking a lot better, but this color combination is a little harsh on my eyes. So I'm actually going to, with the chart selected, go over to my Change Colors button and see if I can find a color palette that I like a little bit better. I think I'll choose this second one here. And then let's see if we can find a built-in style for our color palette that looks kind of cool. So let me hover over my chart styles here. And I think I might like this guy right here, our style 3. So as part of this style, Excel added a second horizontal category axis that we don't need because we have two chart types in our chart. So I'll go ahead and click that to select it and just hit the delete key to get rid of it. So now I think we're just missing one last thing, which is labels on our chart. Namely, given that we have two different scales that we're plotting our data against, one for calls and one for customer satisfaction, it would be nice to assign labels to our two different axes. So I'll go to Add Chart Element, and then Axis Titles, and then for my primary vertical, which is our calls, I'll add an axis title of Total Calls. And now I'll also add a title for my secondary axis, and I'll just call that Customer Satisfaction. And then lastly, I'll give our chart a title. So I'll click my Add Chart Element button again, and then choose Chart Title. And I think I'll place it above our chart. And then I'll just call our chart Calls and Customer Satisfaction by Day. And there we have it, a slick visual representation of how not one, but two metrics trended over the course of a month. Pretty cool. All right, I think that's enough on charting for now. So up next, we're going to dive into some techniques that we can apply to large structured data sets, the type that tend to come out of databases, which is especially useful in business intelligence, analytics, and reporting. I'll see you then. Welcome back. So sometimes it's important to remember that the users of our spreadsheets, even if the only user is us, are human beings, and that human beings process information very differently than a computer. We are a very visual species, and people are often better able to interpret and draw meaning from focused visualizations, as opposed to just tables of numbers. Even with something as simple as a comparison between two numbers, like our monthly income versus our monthly expenses, can benefit from a visualization to give scale and perspective to the numbers we're seeing. So in this phase of the course project, the goal will be to create a couple of intuitive visualizations on our summary tab, which will deepen our intuition about what's going on with our money. First up, you'll create a simple column chart comparing our monthly income versus monthly expenses. Now, one hint here. Even though this is a relatively simple chart consisting of just 2 data points, you'll still need to add 2 data series since we are measuring 2 different quantities against each other. And that, of course, implies that you'll also need to add a legend, as you see in the example here. For our second visualization, we have a bar chart that compares our spending across different categories. Now, conveniently enough, we've already set up the data you need for this chart back when we created a summary of purchases by category with the SUMIFS function. As such, creating this chart should be relatively straightforward. Since this worksheet is now being used as the basis of a chart, I'd recommend renaming it accordingly and then hiding it once you've created the chart. Now, as to design details, I've opted to use one of Excel's built-in styles for each of the charts, and I've also taken the step of removing some unnecessary components, aka chart junk, as needed, so more of our precious screen real estate is used on actual important stuff. And finally, I also tried to make everything fit on the screen in such a way that scrolling around isn't necessary. In my opinion, this helps significantly in making spreadsheets more usable. Oh, and just one more non-chart related visualization I'd like you to throw in. Try adding some conditional formatting to our cash budget and daily budget cells, such that if the values in those cells are negative, the cells are formatted in some visually striking way that connotes a negative state of affairs. Basically, we just want to call attention to any scenario in which our expenses outweigh our income. Okay, so without further ado, go ahead and pause the video and take a crack at putting all this together. Then when you're ready, hit play to see me walk through my solution. Okay, so hopefully that went well. So now I'll go ahead and walk you through my solution. So first I'll go back to our starter file. And first up, I'll create our column chart that compares monthly income and expenses. So I'll go to Insert, and then this icon here to insert a blank column chart. And then I'll go ahead and add my 2 data series. So I'll hit Select Data, and then Add. And then my first series name will just be my total monthly income label. And then my value will just be that value. And then I'll click OK. And then I'll add a second series for total monthly expenses and follow the same steps. So I selected my label as the series name, and I'll select the corresponding value as the series value, and then OK. And now because we have 2 series, I'll want to go ahead and add a legend to the chart. So let's click OK here. And then over on the left, we'll hit Add Chart Element. And then we'll roll down to Legend. And then we'll opt to add that legend at the bottom of the chart. And next I'll choose one of Microsoft's predefined chart styles for a column chart. So let's click here to see the options we've got. And just scrolling through some of these, I think I like style 5 the best. So now that we've got our style in place, I can see that we don't really need this horizontal axis here, so I'll go ahead and select that and delete it. That's basically an example of what we would call chart junk. It's pretty much just taking up space and not adding anything to the narrative that we're trying to communicate to the user. Now we should probably also add a title above the chart just to make its purpose clear. So we'll go back to Add Chart Element, and then Chart Title, and then Above Chart, and we'll just type Income versus Expenses. And now our last step will be to just resize our chart to make room for our second chart, which will be that bar chart that compares all of our expenses by category. And we'll also want to resize it such that we're taking the maximum advantage of the screen real estate available. So I'll actually resize it to make it a little bit bigger in a vertical way, because that's space we have available without the user having to scroll. And then I'll make it a little bit taller here as well. And then I'll pull it a little bit from the left so it's not obstructing any of our numbers. And then I'll pull it a little bit from the right. So now we should have some room to add our bar chart. So I think this looks pretty good. So our next step will be to add that bar chart. So again, I'll go to Insert, and then click here to create a blank bar chart. And then I'll just drag that over to the right of our income versus expenses chart. And then, of course, the next step is to select data. So we'll hit Select Data, and then Add Series. And then for our series name, we'll go over to our Spending Summary tab, and we'll select the column header for our total amount spent by category. And then for our series values, of course, we'll simply select the actual dollars spent on each category. And then we can click OK here. And now because we're plotting this data for multiple different categories, we will need to add labels for our horizontal axis. So let's click Edit here. And then we'll go back to our Spending Summary tab. And then just highlight all of those categories. And then click OK. And then OK again. And it looks like our little chart is off to a pretty good start. But let's again see what's available in the built-in chart styles. So let's click here. And then just previewing the various options. I think I like style 4 here. And now that we've added our predefined style, I can go ahead and remove any chart junk. And I think this horizontal axis here really isn't necessary because we don't really need the chart to tell us exactly how much we spent on each category, but rather to tell us how much we spent in each category relative to the others. So I'll select this horizontal axis and then just hit Delete. And then I'll change this chart title to Spending by Category. And finally, I'll resize the chart to make it roughly the same size as our column chart. And also try to maximize, again, the available space we have to make the chart as big as it can be while also fitting within the screen real estate available to the user. And at this point, I think we're pretty much good to go as far as the charts are concerned. So our last step will be to add conditional formatting to our cash balance and daily budget amounts. So I'll select our cash balance and daily budget cells just by holding down Control and selecting both. And then I'll hit our conditional formatting button, and then highlight cells rules, and then less than. And our condition is going to be, we want to conditionally format these cells if their value is less than 0. That is to say, if our monthly income is less than our expenses, so when we subtract the expenses from income, we end up with a negative number. So let's replace this number with 0, and I'll stick with the default conditional format of light red fill with dark red text, and then click OK. And then to make sure this is working, I'll go over to my monthly expenses worksheet and just change my miscellaneous expense to something a little bit bigger. So I'll change that from $100 to say $5,000. And then let's go back to our summary worksheet. And now you can see that both the cash balance amount and the daily budget amount have had this conditional formatting applied. And moreover, if you look at our income versus expenses chart, you'll see that the column for expenses is now taller than the column for monthly income. So to keep our little spreadsheet from being angry with me, let's go back to monthly expenses and change that miscellaneous amount back to 100. And at this point, I think we're done. Okay, so that's it for our budget and expense tracker project for now, but we will revisit it at the end of the next section and add even more features. I'll see you in the next video. Welcome back. So one of the challenges of working with text data, and many other types of data in fact, is simply getting it into Excel in a clean, sustainable, and automated way. Copying and pasting is fine for small data sets and one-off processes, but can be cumbersome and error-prone if we need to perform the same copy-paste operation frequently and downright impossible when working with large enough data sets. The solution to this problem is Excel's suite of tools for working with external data. These tools allow us to perform automated, easily repeatable data import operations on large data sets, far more easily and reliably than copying and pasting. All it takes is a little initial setup. Let's go ahead and see what that looks like. So first up, we're going to import data from an external CSV file into our example spreadsheet here. Now a CSV file is just a type of text file in which data is stored in columns that are separated or delimited by commas. So to pull in data from an external CSV file into our Excel file, we'll go to our Data tab, and from here we could either take a direct shortcut to the menu we'll use to pull in our CSV file, and that would be this From Text CSV button here, or we can go in through the Get Data menu. So just to explore some of the other options available to us in Excel for pulling in external data from a variety of sources, I'm going to go in through the Get Data menu. So right away we see that there is a whole host of options when it comes to external data sources that we can pull data from into Excel. First, there are external files, for example, an Excel workbook, a text or CSV file, XML, JSON files, PDFs, and so on. You can also pull data directly from a database, like Microsoft SQL Server, Access, and so forth. And honestly, this is just the beginning. Considering all the additional options we have under the From Other Sources heading, chances are, no matter where your data is stored externally, you can probably get it directly into Excel through one of these menu options. But I digress. For now, we're going to stick to pulling from an external file, which will be a text or CSV file. So the first thing that pops up is actually a File Explorer window, because the first thing we need to do is select the actual file we're going to import. Now here I already have a folder where I have a couple of files that we'll use as our import test dummies, so to speak. So first I'll select my CSV data file and then click Import. And then we'll wait just a moment while Excel establishes a connection. And now Excel gives us a preview of how it expects the data to look once it's imported. Now this is all based on the delimiter that Excel perceives the data to have. Right now you can see that Excel is correctly guessing that our data is comma delimited. But if I were to change that delimiter to, say, a colon, now our preview is completely messed up. So the point is, this import process is heavily dependent on choosing the correct delimiter when you're importing this type of data. So we'll reselect comma. And at this point, all we have to do is just click the Load button. And again, wait a moment. And just like that, Excel has loaded the entire contents of our external CSV file into a new worksheet on our workbook. It even named the worksheet the same name as our CSV file, which was CSV data, although we can certainly rename that if we wanted to. So next up, I'll demonstrate how to import another type of text file, this being a tab delimited file as opposed to a CSV file. So first I'll close this little Queries and Connections window that automatically opens when we import an external file. And then I'll go back to my Data tab on the ribbon. And this time I'll go in through the From Text CSV shortcut. And now instead of selecting my CSV data file, I'll select my tab delimited data file instead. And then click Import. And here again, Excel accurately guesses that our delimiter in this file is a tab. And I chose this delimiter for the data for a reason. It's extremely common that external data stored in text files will either be stored in a file with a .csv extension, in which case the data will be comma delimited, or it will be stored in a file with a .txt extension, that is to say a text file, in which case the data will most commonly be tab delimited. And in this case, our data is in fact tab delimited. And since Excel did correctly guess that, we'll just go ahead and click Load. And once again, after waiting a few seconds, Excel has loaded the contents of this file into a new worksheet as well. So at this point, you might be wondering, what is so much better about this process than simply copying and pasting data from an external file? Well, one thing right off the bat is that your computer's ability to handle copy and paste operations starts to break down once you deal with extremely large data sets. Depending on how much memory your machine has, you may not be able to copy 100 or 200,000 rows of data from a text file directly into Excel. But more importantly, every time you need to perform that operation, you have to copy and paste all over again. You have to follow those same repetitive steps. Whereas with this process, once you set up the import once, all you have to do to get the most updated data from your external source file is to simply refresh the data set. So how do we do that? Well, to refresh a data set from its source, all you have to do is click anywhere in the data set, and then select the Data tab, and then click the down arrow under this Refresh All button on the Data tab, and simply choose Refresh. And then after waiting a few seconds, our data will refresh and we'll have the most up-to-date version of whatever file we've imported from Excel. Now, don't believe me? Tell you what, I'll prove it to you. I'll go into our two external files and delete the first row from each, and then run this refresh operation one more time. So first I'll open our CSV file. And I'll simply delete that first row, and then hit Save and Close. And then I'll open up my tab delimited file. And again, I'll delete that first row and save and close. And at this point, I have an opportunity to demonstrate the difference between refresh, which is the command we used before, and refresh all, which refreshes all external data connections in the entire workbook. So right now, if we toggle between our two worksheets, we see that both of them have that first row. Now let's see what happens if I click anywhere inside of my CSV data, and then instead of choosing refresh all, I again just click refresh. After waiting a few seconds, we see that that first row has now disappeared. But if I go back to my tab delimited data worksheet, we'll see that that first row is still there. But now if I go back to my CSV data worksheet, and instead of hitting refresh, I hit refresh all, which I can do, by the way, without even having clicked inside of my data set. If I just click refresh all, then all external data connections in the entire workbook will refresh, which means once this completes, the first row should be gone from this worksheet as it was before, but should also be gone from my second worksheet as it in fact is. So one thing you've probably already noticed that I haven't pointed out just yet. When we click anywhere inside of one of our fancy new data sets, a new contextual menu appears on the ribbon. This one for something called a table. Now, a table is an Excel feature that provides a ton of extra goodies for data sets organized in a tabular fashion. That is to say, in rows and columns where each column contains a distinct type of data. Some of these things, like filtering and sorting, you're probably already familiar with. And sure enough, if we click the filter button for our call duration column, just as an example, you'll see that we have all the normal sorting and filtering options. You may have also noticed that some nice formatting was applied automatically when we imported this data. That's another feature that comes standard with a table. And in fact, if we go to our Table Design Contextual tab, and then explore this Table Styles menu on the right side, we can just hover over all of these predefined sets of style configurations until we find one we like. Personally, I tend to favor this one, so I'll just select this one for now. But sorting, filtering, and these canned formats is just scratching the surface. Tables give us tons of additional features that a simple range of cells just can't compete with. We'll explore more of these in the next video. I'll see you then. Hey, welcome back. For the next several videos, we're going to explore some Excel techniques that can be used to process, transform, manage, and manipulate large, structured data sets, the kind typically produced by corporate information systems and databases. This type of data is everywhere in the real world, and fortunately, Excel gives us a number of powerful tools for working with it effectively. The first step when working with this sort of data, of course, is actually organizing it into the rows, columns, cells format that Excel is built around. Now, extracts from databases and information systems often come in the form of text files, in which rows of data are separated into columns by some kind of delimiter. Say, for example, a comma or a space, as opposed to being formally organized into a grid, as with Excel. If you try to copy and paste such a data set, like the one we see here, directly into Excel, you'll end up with a single column of text values, no matter how many actual columns are in the data. Our example data set here contains a number of call center statistics produced by a call center information system. But because this data was exported from the system as a text file, each row of data is scrunched together into a single cell, with the individual values separated by commas. So what we need to do is split this single column into as many columns as there are metrics in each row of data. The trick here will be to split the columns along each delimiter, in this case, a comma. And fortunately, Excel has a built-in tool to help us do just that, text to columns. So let's see if we can use text to columns to transform this dataset into something we can work with. So our first step towards splitting this data into its constituent columns is to select the entire column by clicking our column header A here. And then I'll go to my Data tab on the ribbon, and then over to the right side of that tab, I'll click the Text to Columns button. Now that launches a wizard that will give us a series of options for how we want to split this data. We're first asked if our data is either delimited, which means the values are separated by a character like a comma, or fixed width. Most of the time, the answer will be delimited, and in our case, we know that our data is delimited because we see these commas separating the values. So we'll go with that and click Next. Next, we actually have to tell Excel what the delimiter is. So by default, Excel is guessing that a tab character is our delimiter, but we know better. We know that our delimiter is actually a comma. So we'll uncheck tab and then check comma. And after we select comma, if you look down to the data preview section, you'll see that our data is now split off into columns. So we'll click Next once again. And here in the last step, I can optionally apply formats to the different columns that I'm importing. But that's also something we can do once the data is split off into its constituent columns. So I'll go ahead and click Finish to complete the process. And there we have it. We have successfully split our data into the 6 columns it was originally composed of. So lastly, I'll just highlight these columns and then auto-fit their widths, and our data set is mostly good to go. The last step I could take is formatting our call timestamp from this serial number here to an actual date time format, which I'll go ahead and do. And it looks like we're good to go. Now in certain situations, text to columns can also be used as an easy, user-friendly alternative to complex combinations of nested text functions. For example, if we wanted to split the names on this worksheet into separate columns, with the first names in one column and the last names in another, we could use some combination of text functions like left, right, find, and mid to get the job done. But if you're not a formulas and functions guru, or you just like a good shortcut, you can use text to columns to get the job done in a snap. So the steps will look just like before. We'll select the entire column and then hit our Text to Columns button. And our data is in fact delimited, but this time by a space. So we'll leave delimited selected and choose Next. And then instead of specifying a comma as our delimiter, we'll instead choose a space. And then we'll click Next and then Finish. And in just a few mouse clicks, we've successfully split our first and last names into separate columns. But there is one wrinkle here. You'll notice that for our one person with a middle name there on row 5, their middle name is occupying the last name column, column B, and their last name has been pushed all the way over to a third column. Since there was a second space in that name, Excel automatically split the value into 3 columns. Not a huge deal to clean up manually on a small dataset like this, but could become potentially more of an issue on a larger dataset. An intricate enough combination of text functions could account for middle names in a case like this, so it's just something to keep in mind when weighing text to columns as a shortcut versus text functions. Okay, now that we know how to wrangle the kind of text data commonly produced by large information systems, we'll next turn our attention to some built-in tools for bringing this kind of data into Excel cleanly and efficiently, with no copying and pasting required. I'll see you then. Welcome back. In the last video, we barely scratched the surface of all the features Excel tables have to offer. Tables allow us to store our data in a structured way, but also make the process of entering and retrieving that data far more efficient. Let's take a look at some of the ways tables can help us manage our data with speed and precision. So here in our example spreadsheet, we actually have the same data set that we imported from an external text or CSV file in the last video, but it is not yet structured as a table. So when you import data from an external source into an Excel spreadsheet, it's formatted as a table automatically. But in this case, we just have a raw data set that Excel does not recognize as a table. So how do we convert data sets like this into a table to take advantage of all the features tables have to offer? Well, the easiest way is to first select the entire data set, and to do that most reliably, I'll typically select the top left cell in the range, and then scroll all the way to the bottom of the data set, and then holding down my Shift key, I'll then click to select the bottom right cell of the range. This ensures that all the data within the range I'm interested in will be selected. Then, with all the data selected, you can either convert this range to a table by going to the Insert tab and then clicking the Table button. But as you can see, if we hover over that button, there's actually a keyboard shortcut that makes the process a lot simpler. So I'll just hit Control-T, and now Excel produces a dialog box that asks us to confirm that we really want to create a table from this range. And crucially, it also asks us to confirm that our table has headers. Part of the structure of an Excel table is that the data must have headers, so if we say that our table doesn't have headers, Excel will add them for us. But of course, our data does have headers, so we'll leave that box checked and then click OK. And now you see that the data is formatted as a table like we saw in the last video, with filter buttons and that alternating background color from one row to the next that helps each row stand out. So aside from sorting and filtering and these special built-in formats, what else can tables offer us? Well, for one thing, they make the process of entering and editing data in our ranges not just faster and easier, but also more structured in a way that makes the data entry process less prone to errors. So for example, let's say I want to add a new row to my data set here. Well, first I'll hit Control down arrow to navigate to the bottom of my data set. And now if I want to add a new row to this table, let's say I'll start by adding a called ID of 98976 to continue the series, and then hit Enter. You can see right away by the formatting in the row in which I just entered that value that Excel now considers this new row part of that table. And just to make this even clearer, I'll enter one more row, 98977. And now it should be even clearer that as we enter data in rows directly beneath our table, Excel will recognize that that data is intended to be part of our table and automatically extend the range of cells to which all these table features apply to include the new data we've entered. So if, for example, I wanted to include these new values in any filtering or sorting I perform on the table, these new values would be included automatically without me having to reselect any cells. Now, one thing to note about tables, especially if you come from a background of working with databases. Tables are designed to replicate some of the functionality in database tables, but one thing they won't do is enforce data integrity. For example, most database systems won't allow you to enter date values and text values in the same column. The structure of tables is designed to encourage you to follow the good practice of entering the same type of data in any given column, but they won't force you to do this. So if I just type the word text here in my call timestamp column, Excel allows it. So to some extent, it is up to you to enforce data integrity, but the structured layout of Excel tables definitely encourages us in that direction. Now let's say we want to delete this row that I just entered that word into. I could just delete the entire row from the Excel spreadsheet, but tables offer us a different way that doesn't impact any other cells on the spreadsheet outside of what's just in that table. So if I right-click in this row and then hover over Delete, instead of simply having the option to delete the entire row, I can just delete the table row, or alternatively, the table column. So I'll choose Table Row, and now my row disappears. And I'll go ahead and do that with my other new row as well. Now, just as tables make it really easy to add new rows, they also make it easy to add new columns to our data. So navigating back to the top of my data with my Control up arrow command, I'll select the cell immediately to the right of my rightmost column in my table, the Call Abandoned column, and then I'll just type the name of a new column. And I'll call this Call Duration in Minutes. Now, as an aside, this data set that we have here is extremely raw. By itself, with no additional columns added, it's going to be very difficult to provide useful reporting and analytics just from the fields we have here. For example, our call duration and wait time numbers are all in seconds. And it's going to be very difficult for most people to translate a large number in terms of seconds in terms of something more intuitive like minutes. So it will help us produce useful reporting to have a column that converts that call duration in seconds into minutes. So here in cell H1, let me type call duration minutes. And now if I hit enter, you'll see once again that Excel has automatically extended the range of the table, and thus all the features that the table offers, to include this new column. I didn't have to go in and manually change the range of the table to include this new column. It was added for me. All I had to do was just type a new column header adjacent to my existing table. So now I'll auto-fit that. And now I'm going to type a formula that converts my call duration in seconds to minutes. And obviously that's some pretty simple math. I'll just divide the call duration in seconds by 60. So I'll type equals, and then I'll select my value over here in C2. And what is that? Instead of my formula reflecting the actual cell reference C2, it instead displays this strange naming convention in which the name of the column follows an ampersand, all within brackets. Well, it turns out that while you can reference individual cells in tables, tables want us to look at things in terms of columns, just like data is stored in databases. So when we see @call duration, what Excel's doing here is automatically pointing to the cell in the call duration column that is in the same row as the cell our formula is in. So for our formula in cell H2, this @call duration construct references the value in the second row of the call duration column, column C. But this same construct, @call duration in row 3 of column H, would reference the number 486, the value in row 2 of the call duration column. So without further ado, let's divide this value by 60 and then hit enter. And you see that not only does our formula work, it automatically autofills all the way down to the end of our data set without us needing to do that. So by now you can probably see that tables are optimized for fast, efficient, and accurate data entry, and also column level calculations like the one we just did. And just to underscore once again how these formulas work, if I arrow down through the different cells in our new column, you see that the formula never changes because that @call duration construct is dynamic. It recognizes the row of the table that it's in, and it references the value in that same row of whatever column we're referencing. But the great thing is you don't need to memorize the syntax. You don't need to memorize that you have to put an ampersand before the name of the column and then surround that with brackets. If you just select the cell, Excel does the rest of the work for you. Now before we go, I'll add another derived column, similar to the last one, called wait time minutes. And it'll work just the same way. So I'll type wait time minutes. And of course, Excel will automatically recognize that as a new column in our table. So again, I'll type equals, and then I'll select the value in the same row of my wait time column, and then divide that by 60. And once again, in just a few clicks and a few keystrokes, I've generated a valuable new derived column in my data set. At this point, I hope you can see how all the features that tables provide us make the process of adding both data and calculations to our data sets more structured and more efficient. But even still, we're not done with tables yet. Up next, we're going to look at how tables can be used as a dynamic and superior alternative to named ranges. I'll see you then. Welcome back. So one of the most important features that Excel tables have to offer is that they are also named ranges right out of the box. And we can reference tables and the ranges of cells within them by name rather than as fixed cell references, just like we can with named ranges. Except, unlike named ranges, the scope of the data that our table refers to can grow dynamically without us having to manually edit the range of cells that the table refers to. Now, this has some important implications for how we can reference tables in formulas, charts, and other areas of Excel. So one obvious application of tables is as lookup tables. Lookup tables are where you can store reference information about a particular type of entity and then look that data up from the lookup table into a larger data set. So our data set here is quite raw and unprocessed. Even with the calculated fields we added in the last video, there's just not enough to go on here to create meaningful reporting or analytics. For example, it's quite common to want to break down numbers like these by individual employee performance. And while we have an employee ID field, we don't have any more information about those employees. We don't know their names, we don't know their managers, what team they belong to, what site they work at. But if we had another table, a lookup table, that had all of those data points about each individual employee, we could then use the VLOOKUP function to VLOOKUP those additional data points into this table. Now, as it happens, I actually have those data points in another worksheet on this example file, our employees worksheet, where for each employee ID, I have that employee's name, the site they work at, and their manager. So we can use this data as a kind of lookup table to add these fields to our main data set. Now, of course, we could use the VLOOKUP in the conventional way, and that would be fine, but I'm going to show you how these types of functions can work even more smoothly when you're referencing a table instead of just a conventional range of cells in Excel. So to do that, I'll first convert our range of cells here to an actual table. Now, because this is a relatively small range of data, and I can confirm just by scrolling down that there aren't any gaps in the data, instead of selecting all the data myself and then converting it to a table, I'm just going to use that Control-T shortcut, which will prompt Excel to automatically guess the range of my data. Now, Excel has not checked this My Table Has Headers box, so we'll want to check that because our data does in fact have headers, and then we'll click OK. And right off the bat, this table is in fact already a named range, and you can actually see the name that Excel automatically gave it up here under the Properties section of the Table tab. But Table 3 honestly is not a very good or descriptive name, so we're going to change that name to be Employees. So before we start VLOOKUPing fields into our master data set, I really quick want to show you how formula references to tables work. So let's say I want to do a count of my employee IDs in column A of this table. So if I type equals count, and then I just select the values in column A of my table, you see that Excel has a special syntax for referencing just the values in the column of a table. It's first the name of that table, which we named employees, followed by the name of the column in brackets. So if I close my parenthesis and hit enter, we got a 0 because count only counts numeric values. But if I change my function to an count A, now we have 63. But what happens if we include the column header in this? So if I do count A, and then I select the entire column, now Excel specifies all before the name of the column. That's basically saying we don't just want to count all the values in the column, we want to count the header as well. Now honestly, this is a much less common scenario than just wanting to work with the values in the column versus the header as well. So from now on, we're just going to select entire columns within the table, but not include the headers. One last thing I'll point out is that if you don't select all the values in a column, but just a subset, Excel isn't able to use this nice, clean syntax where we simply reference the entire column of the table as opposed to referencing a fixed cell range. So if, for example, I typed equals count A, and then I only selected the first 10 rows of the table, Now we just get an old-fashioned range composed of cell references as opposed to the name of the column within the name of the table. So the lesson here is you need to select all the values within the column of the table to get that nice modified syntax. So at this point, I think we're ready to go ahead and start VLOOKUPing these fields into our master data set. So we'll start with employee name. So first I'll add an employee name column to our master data set, and then autofit that. And then I'll start my VLOOKUP function. And then my lookup value is just going to be the employee ID. And now my table array obviously is going to be my lookup table. So I'll go back to my employees worksheet. And then as my table array, I'll select all the values but not the headers in my table. And if you look at the formula bar, you'll see that instead of our table array being a range of cells or a list of columns, it's just the name of our table, because we basically just selected the entirety of the data in the table. So then for my column index number, my name value is in the second column of the table, so I'll just type 2, and then false for an exact match, and then enter. And this being a table, the formula autofills all the way to the bottom of our master data set. Now you'll note that there's an error here in our fourth row, which basically means we weren't able to find this particular employee ID in the lookup table. We'll look at adding that in just a moment. But first, we'll add the rest of our fields from our lookup table. So I'll scroll over just a bit, and then I'll add the site field. So I'll first add that field to our master data set, and then I'll add my VLOOKUP. And again, I'm going to VLOOKUP based on the employee ID. But this time, I don't even have to bother selecting my table array. I know that my table is named employees, so if I just start typing employees, that pops right up. This is yet another advantage of being able to reference a range of cells by name instead of the top left cell to the bottom right cell. As long as I can remember the name of our table, which we intentionally made very easy to remember, all I have to do is just start typing that name and then hit tab to autocomplete, and I'm ready to continue typing my formula. And now site, I believe, was the third column over in that lookup table, so I'll type 3 as my column index, and then false, and that looks like it worked fine. And then my last field was manager name, so that will work just the same. We'll add the column, we'll type our VLOOKUP, employee ID is our lookup value, employees is our lookup table, and this time we're looking at the fourth column over, and that worked as well. Now just to round this out, I'm going to add one more field from a different lookup table, this one on my call types worksheet. So it turns out that at our call center, there are 3 types of calls that we get generally: sales calls, billing calls, and tech support calls. But in our master data set, those descriptions aren't listed. Instead, we just get this call type ID that tells us what type of call it was. So if we want to tie in that description, we'll have to pull it in from our lookup table. But the first step, of course, is to convert this range to a lookup table. So again, I'll hit Control-T. And because Excel accurately guessed that my table has headers, I can click OK. And now I'll name my table here call types. And now back in our master worksheet, I'll add a field called call type description. And now I will VLOOKUP in our call type description. So this time I'm going to be keying off the call type value in my master data set as the lookup value. And then for my table array, I'll just type out the name of the table that we just created, call types. And there were only 2 columns in the data set, so the value I'm looking up must be in the second column. And then finally I'll add false as my last argument. And there we are. Now we have successfully pulled in the call type description from our second lookup table. Now the last piece here is figuring out what to do about these errors we're getting from our first lookup table on our fourth employee ID. So clearly we're missing data for this fourth employee in our employees lookup table. So what we need to do is add a new record to our lookup table so that our VLOOKUPs can find this value. So let's go back to our employees worksheet, and I'll control down arrow to get to the bottom of my data. And now I did cheat just a little bit prior to the video. I actually created a record for this missing employee so I wouldn't have to type all these values out while you're watching. So I'm going to copy that and just paste it right below our table. And because we appended this data directly below a row that belonged to a table, Excel automatically extends the range of that table to encompass the new row. So any formulas we had that were pointing to this table are now pointing to this new row as well, without us having to reselect or expand the range of cells that our formulas are referring to. So what I'm getting at is, I think when we go back to our sample data worksheet, that we will now see matches in our fourth row for this particular employee instead of errors like we were before. So let's see. And there we have it. Our VLOOKUPs are now working, and we were able to do that without having to go into the formula and manually change our table array to include the new row that we added. Since our VLOOKUP is referencing the name of the employee's table, and because that table automatically expanded to include that new record that we added, we don't even have to touch our formulas. So I hope you can see the implications of this. Basically, we can continue adding to our lookup tables as needed without ever touching any of our VLOOKUP formulas. Our formulas that reference these tables, which are also functioning as named ranges, will continue to just work. And this has applications beyond just formulas and functions. Take, for example, charts. So looking at a previous example where we have a chart pointed at a range of data, the data range that the chart is pointing at is a static fixed range of cells. So if, for example, we were to append a new data set to the bottom of this range, our chart would not change. And just to prove this to you, I'm actually going to copy a second data set I have in this workbook directly beneath the one we're referencing in the chart. And if we look at our chart, we see that nothing changed. But if we convert the range that our chart is pointing to a table, this actually will work. So first I'll delete the data that I just pasted in, and then we'll convert this data to a table using my Control-T shortcut. And then I'll name my table call stats. And thus far, our chart is unaffected, which really is what we want. We weren't trying to change anything just yet because our underlying data hasn't changed. But what will change, we hope,